Subscribe now and press the bell icon. Never miss an update.
Hey guys, in this lesson, we're going to be taking a look at one of the other big announcements at WWDC in 2019, which is Project Catalyst. Now, Project Catalyst used to have the code name of Marzipan, which is where you might have heard of it on blog posts and on the internet. But the idea is that there are so many iOS developers making wonderful iOS apps that work on the iPhone and the iPad, but the Mac App Store is a little bit lonelier. So why not bring UIKit, which is the big framework that lets us build iOS apps, and bring it over to the Mac? So this way, you should be able to simply check a tick box in Xcode and be able to create a macOS app from your iOS apps that you've already developed and be able to run it as a Mac app. So that's what I want to show you in this lesson. So let's get started. Now, I'm going to take the Hacker News app that we developed in the last lesson, and I'm going to turn it into a Mac app. And the first step is we have to go to the settings of the app. So clicking on the Hacker News blue icon project in the file inspector, and then going to the targets in this left-hand side pane. And now we're going to click this magical checkbox, and as it notes here, you have to be on the latest version of macOS Catalina for this to actually work. So let's click on this and go ahead and click Enable. And now we have to go to our signing and capabilities, because whenever we want to deploy an app to a physical device, such as an iPhone, an iPad, or in this case, our Mac, we have to provide a signing certificate. So go ahead and sign in with your Apple ID. And you should now be able to select your team in the team drop-down list. So now that I've signed my app and I've checked off my Mac capabilities and the Mac has been selected as the target up here, I can go ahead and click Run. And here it is. Here's what it would look like on the larger screen size of a Mac app. I've got all of my news pieces loaded up on the left here, and if I click on one of them, it brings it over to the detail view on the right hand side here. And once it loads up, you can see that I've got my web view showing the actual article. So pretty neat, huh? Now, if you're wondering if this is only possible for apps built with SwiftUI, fear not, it's not. The underlying mechanism actually relies on UIKit, and it's through porting UIKit over to the Mac that allows us to run and build our iOS apps onto the Mac. So here I've got the Klima project that we created a little while ago. And I'm going to show you that we can do exactly the same thing. So again, I'm going to check off the Mac tick box, click Enable, click Signing and Capabilities to select my development team, and now I'm going to click on Run. And once it runs, as long as you've still got all of your constraints set up properly, it should try and fill the screen even though it is a different size and aspect ratio. So you can adjust your window as much as you like, and you can see that we've got our Klima app and our Klima apps menu, such as file, edit, format, although none of these things really do very much in our app at the moment. But you can see that if I search for the weather in Paris and hit enter, it will automatically change and update our weather, still using all of the underlying capabilities that we built with UIKit. And you can even see that it's put the app icon into the dock using that same icon that we provided for iOS as the macOS app icon. So this is a really cool piece of technology because it makes it so easy for us to build apps for iPhone, iPad, and the Mac, or just using a couple of checkboxes. So I hope you enjoyed working with SwiftUI and learning from these lessons. As new things come out, I'll update the code and notify you guys about any breaking changes. But that's all from me in this lesson, and thanks for coming along with me on this ride. I'll see you on the next lesson. So way back at the beginning of the course, we introduced you to Git and GitHub as a part of the I Am Poor challenge. And that was just to show you how Git works, and how you can use GitHub or our repositories that are hosted on GitHub in order to download the skeleton projects and to follow along with the tutorials. Now in this module, I want to introduce you formally to how Git works and how you can use it to achieve various powerful ends. And I'm going to be talking about and showing you how you can use Git both inside Xcode and on the command line to do things such as version control, or how to clone repositories, how to fork, make pull requests and merge repositories, and a whole bunch of really exciting things. So once you're ready, let's get started and let's start learning about Git. So let's talk about version control in its simplest form. Let's say that I create a new code file and I write a few lines in it. Now I decide to put it under version control using Git, and let's say that I call this save point as number 1. Now this is my first version. So later on, as I progress, I write maybe a few more lines of code. And at this point, I decide to make another save point, and I call this my second version. So further down the line, I accidentally screw up my entire code file, and it's irreparable, and I get to the point where I would rather burn my entire code file rather than having to try and fix it. You do get into these situations because very often your code is interlinked and each class depends on another, and sometimes you can screw up in a way where, all hope is lost. And I simply just want to roll back to the last save point. I can do that using Git. I can do that using other tools as well, but the most popular tool, and the one that we're going to be talking about, is Git. So you can either compare your current code file, so the current mess that you've made, against a previous version, so at any of the save points before. Alternatively, you can simply just roll back to a previous version. And it doesn't have to be the one that was immediately previous. You can go as far back or as far forwards as you like, as long as you know which version you want. So in the next lesson, I'm going to show you version control using Git locally on your computer, and we're going to use the command line to do this. So I'll see you there. Now the first thing we're going to do is open up Terminal, and inside Terminal we're going to navigate to our desktop. So if you're not familiar with the command line and you haven't watched the module on the command line, then I recommend you to take a look at it now, because we're going to be using a lot of the commands to create directories and navigate around. So if you're not yet familiar, then it's a good time to take a look at that. So the first thing I'm going to do is I'm going to cd into my desktop. And here I'm going to create a new directory called story. Then I'm going to cd into this story directory, and if I show you with ls, you can see that it's completely empty. And similarly, inside Finder, I can show you the same thing. So let's go ahead and create some text files. So I'm going to use touch to create a file called chapter1.txt, and then I'm going to open chapter1.txt. And you can either do this by simply writing open, and it will open it inside the default application, which is TextEdit on a Mac. Alternatively, you can use a text editor within the terminal, for example, Vim. Now, this is only for people who are really familiar with this, so it's totally up to you what you decide to use. But if you are not familiar with using terminal-based editors, then it's probably a good idea to just stick with the open command and use TextEdit. So let's go ahead and open chapter 1, and let's write something inside, shall we? Okay, so there's my masterpiece done. I'm going to go ahead and hit save, and I'm going to quit TextEdit. So that was our first chapter done. So now let's create a Git local repository and start tracking some of these file changes. So to initialize Git, we simply write git init, And as you can see, it's initialized an empty Git repository inside the story directory. Now, if you have a look inside Finder, you actually can't see this .git at all. But, as we learned before, if you use ls-a, you can see all the hidden files, and you can see that .git is right there. And it's going to be used to track all your changes, to commit your changes, and to perform version control. So we're currently inside the story directory, and you can also call this the working directory. So as I mentioned before, using Git and learning about version control, it comes with some of its own terminology and language. So I'm going to try and debunk and simplify a lot of these terms that you'll come across, just so that we can all be on the same page and we all understand what's going on. So currently, we are inside the working directory, which is the story directory. And here, in order to start tracking the changes of my files, for example, chapter1.txt, then I need to add this file to what's called a staging area. And that is basically an intermediate place where you can pick and choose which files inside your working directory that you want to commit. So to see what's currently inside your staging area, you can use the git status command. And it shows you that there are untracked files which will be shown in red. And this is something that's simply inside your working directory, so inside here, but it's not yet in the staging area. So in order to add it to the staging area and to start tracking changes in it, then we have to use the command git add. So we're going to type git add, and we're going to type the file name. So in this case, it's chapter1.txt. So go ahead and hit enter, and then if we try using git status again, you can see that that file has been added as a new file, and it is now green. So this is now in the staging area, and it's ready to be committed. So let's go ahead and commit this under version control. So the command is git commit, and I'm going to use the -m flag to add a commit message. So the commit message is really, really important. It's something that helps you keep track of what changes you have made in each commit. So when you create a new save point, you want to be as explicit as possible about what changes were made between the last save point and this current save point. So for our initial commit, we can use something very simple like initial commit. And this shows that this is our starting point. Alternatively, if you want to be slightly more specific, because in our case, we've actually completed chapter 1. So you can write complete chapter 1. Now, the thing that you'll realize is that usually with commit messages, they are written in the present tense, and this is the best practice. So whereas it would probably make more sense, I guess at least in my head anyways, to write completed chapter 1 as this save point, it's actually by convention that you should always use the present tense. So it's like you are doing it now. You're submitting your changes now. So let's go ahead and hit enter to make our first commit. And you can see what commits you have made by using the git log command. So you can see that this commit was made at this time by this person, and it also has a hash, and this hash uniquely identifies this particular commit. And then right at the end you see this commit message of what this save point was all about. So now I'm going to go ahead and create 2 more chapters. So let's just create chapter 2.txt and chapter 3.txt. And now we have 3 chapters, and I'm going to go in and change some of these text files. So let's say okay, so that's chapter 2 done. And finally, let's go ahead and just open chapter 3 and edit that as well. Alright, so all 3 files have been changed, and over here in Finder you can actually get a quick peek at what the contents are, which is going to be really useful for me to be able to demonstrate to you what Git is doing behind the background. So now let's go ahead and add these 2 new files to our staging area. So again, if we use git status, you can see that there's 2 files that are untracked, which are only in the working directory and not yet inside the staging area. So we can put it into the staging area by simply adding each of them as we did before, git add, and writing something like chapter2.txt and then doing git add chapter3.txt. But as you can imagine, if you have quite a few files, then it can get incredibly tedious having to do this one by one. So of course there is a better way. So instead of adding these files one by one, we can actually simply just say git add and then use the dot to specify everything inside this current directory. So everything inside the story directory. So now if I go ahead and hit enter, and then let's go to git status again, you can see that there's 2 new files that have been added to the staging area. And now we're going to commit those 2 files to a new commit, to a new save point. And you know what to do. If you're following along with me, go ahead and give it a go. Alright, so how was that? If you remember, the command is git commit, and we're going to use the M flag to specify a commit message, and we're going to write a message that is in the present tense. So let's say complete chapter 2 and 3. So that's everything I've done between the initial commit and this commit. The only difference is the fact that I've completed now chapter 2 and chapter 3. So let's go ahead and hit enter. So again, let's check it out using git log. We can see that we now have 2 commits, both with different hashes because they are unique and they are different. So the initial one was complete chapter 1 and it was done at this time. And then later on, about 5 minutes later, I completed chapter 2 and 3, and that was the second commit. And this is where we are at right now. So you can see by the head, by this word head, this is the position or the current state that we are in. So I just want to quickly recap what we've just done. So we created a file in our working directory inside our story directory. So the working directory is the folder or the directory where you initialize your Git repository. When we said git init, we did that inside the story directory. So that becomes our working directory. And from now on, Git is going to try and track the changes that it sees between the working directory and the local repository. So in the beginning, we created a file inside our working directory, inside story, and then we used git add to push it to the staging area. Now, the reason why there is this intermediate staging area, because you might wonder, why not just go from the working directory straight to the repository? Why do we need this extra step? Well, sometimes you might not want to add all of your files to be tracked or all of your files to be committed. So the staging area is a good place to try and figure out what are the things that you want Git to ignore and what are the things that you want to be tracked. So once we've used git add, we've put our file into the staging area and we're happy with the changes that we are going to commit, then the next step is to go ahead and commit it using the git commit command. So now our file is inside our local repository, so that .git, and that version is given a name through the commit message. So that means that even if we've messed up our file, we can still use the last version that's under version control, and we can use a special command called git checkout to revert back or roll back to the last position in our local repository. So let me show you what that looks like in the command line and how we would do that in practice. So at the moment, I've got 3 nicely written chapters, and I have a feeling my book is going to be a big seller. So now let's say that I have been working on chapter 3 and I have completely messed everything up and just, fell asleep on my keyboard. And I happen to have saved my file, and now if you have a look at it, it's now just mumbo jumbo and I've ruined my masterpiece. But fear not, because we have version control and we have Git enabled, so we have nothing to worry about. I can actually revert the changes that I've made locally in my working directory. So at this point, you can use git status to see that we have modifications in our chapter3.txt file that have not yet been committed or added to the staging area. So if we wanted to, we can actually revert this back to its previous glory. But before we do that, we can use a git command to check out what are the differences between the current version of chapter 3 and the last save point in our Git repository. So to do that, you can use the command git diff, so the difference, and we'll give it the chapter 3 file name. And if you hit enter, you can see that this is the part that was deleted, so the part in red. And then this was the part that was added, which is our gobbledygook. So now, if I've looked at these differences, it might just be that, there's only a few mistakes in my new version of chapter 3, and I just want to maybe copy some things over or have a look at how I did certain things previously and change my current file. But other times, it might be that, it's just you want to torch the new file. You just don't want anything to do with it, and you would much rather roll back to the previous version. So if you want to do that, then there is a command called git checkout that is going to be really, really useful for you. So git checkout, and then we're going to specify the name of the file that we want to check out, which is chapter3.txt. And if you just watch over here, which is the preview of the current version of chapter3.txt, once I hit enter on this command, that basically asks to roll back this chapter 3 to the last version that was committed in our local repository. So if I hit enter, you can see that almost immediately my chapter 3 has been restored to its previous glorious state. And this is the version of chapter 3 at the last checkpoint at which I committed it. So that was this one, which is completed chapter 2 and 3. So whereas in this lesson, we've looked mostly at local implementations of Git, so saving these versions on our computer locally, in the next lesson, I'm going to talk about GitHub and creating remote repositories. So I'll see you there. Alright, so whereas in the last lesson, we were looking at local implementations of using Git and version control, in this lesson, we're going to talk about how you can create a remote repository. So a repository that's hosted on somebody else's server or somebody else's computer by using GitHub. Now, most people would have heard of GitHub, and certainly by now, you would have used GitHub many times in order to grab the skeleton projects that we've provided for some of the tutorials and challenges. So if you haven't yet set up an account on GitHub, then this is the time to do it. So head over to github.com and simply fill out this quick form to create an account on GitHub. So it's completely free, and all you need to do is just confirm your email so that you can access it. Once you've done that, go ahead and sign in. So once you've signed in, you should be looking at this page, and what we're going to do is we're going to create a repository inside the browser-based GitHub. So if you navigate to this top right corner and click that plus arrow, then you can select new repository. And I'm going to call my repository, same name, I guess we'll call it story, and let's give it a description. Let's say my masterpiece. Now, by default, all repositories that you create on GitHub are public. That means that anyone can see all of the files inside your saved repository. So everything that you commit to your remote repository or to your GitHub repository will be public. So if you don't want that, then you can select private, which requires a subscription on GitHub. But in most cases, if you're not doing anything that's top secret, or if you're not developing technology that is completely brand new, then having a public repository is not such a big problem. And on the other hand as well, you can see loads of other people's public repositories, and you can see, for example, how they structure their code, what is their style, and you can see how people do things. So, for example, on GitHub, there are whole repositories on things like Swift Flappy Bird. So it's the entire implementation of Flappy Bird in Swift, and you can run it in your simulator, or you can also look through their code base to see how they did this. So this is the beauty of open source code, and as you develop in your journey of becoming a developer, then you might find that you want to contribute to other open source projects, help them out a bit, and work in a virtual team to try and contribute your knowledge and your programming skills. Okay, so now once I've selected public, the next thing is that I'm going to leave this part empty. I'm not going to initialize a README for my repository just yet. So the next thing is that I'm going to go ahead and click the big green button and create my repository. So now you can see that there are two ways that they tell you can set up your repository. You can either set it up in GitHub for Mac on desktop, their desktop client, which I am not a big fan of, but instead what we're going to do is we're going to use the command line instructions to set up our repository. So we are going to push an existing repository that we've got locally onto this remote repository. And to do that, we need to copy the address of our GitHub repository. And we're going to use these two lines of code in order to transfer or push our existing local repository from the command line. Alright, so I'm currently inside my story directory, which also happens to be the working directory for this particular project. And here I am going to, again, take a look at git log to see what previous commits we've got. And you can see that we've got 2 previous commits, and I would like to push both of these commits onto GitHub. So to do that, the first thing is creating a remote. So it's telling my local Git repository that I've created a remote repository somewhere on the internet, and I want to transfer all of my commits over there. So the command that we're going to use is git remote add origin. Now, origin is simply the name of your remote, and you can theoretically call it anything you want. You can call it bacon if you want, but by convention, and it's highly recommended that you simply keep the name origin. And the reason is because most programmers are used to the conventional naming, and that means it'll be much easier for them to understand what's going on in your project when they have a look at it, instead of you doing something completely different, which will be very surprising, and it'll be a lot harder for people to understand what's going on. So git remote add origin, and then we're going to paste the URL of our remote repository on GitHub, and then we're going to go ahead and hit enter. And now that remote is created, so we can push our local repository onto our remote repository, which is called origin. So we're going to say git push -u origin master. And what this line of code does is that it pushes your local repository to the remote repository using the U flag or the U option, which basically links up your remote and your local repositories. And then we're going to push it towards the remote that's called origin, and we're going to push it to the branch that's called master. So the master branch is simply the default branch or the main branch of all of your commits. And later on, when we cover branching, then we're going to talk more about what is a master and what is a branch. But for now, we're just saying that we're going to push our local repository onto this origin remote, and we're going to push it to the master branch. So let's go ahead and hit enter. And there's going to be a little bit of work being done in the background because it's actually going to have to upload your local repository to the remote repository on GitHub servers. And depending on the size of your local repository, this can take various amounts of time. So now, once we see our prompt, so the flashing cursor or the $sign, that means that our push is successful. And as you can see, it says branch master set up to track remote branch master from origin. Sounds really confusing, but if you head back over to GitHub, and if you're on the same page, all you have to do is hit Command R to refresh, or just press the refresh button. And you can see that all of our files are now hosted on GitHub, and it's complete with all of our commit messages. So if you go into Insights, Graphs, and go into Network, you can actually see our master branch, which currently only has 2 save points or 2 commits. And if you hover over them, you can actually see the commit messages of each of these. So as you build out your project, as you add more commits, either locally or pushing it remotely, or probably doing both, then you can see the progress of your files in your GitHub repository. So now you can see all of the code, if it's code file, or in our case it's just a text file, hosted on GitHub, and you can point anybody towards this. And there are actually cases where people do a lot of story writing using GitHub, just because it's so good at tracking your save points and being able to revert to previous versions in the past. So for example, if you head over back to the main page and you go to your commits, you can see both of those commits, when they were committed, and also if you click on it, you can see the version, you can see the changes that were made at those time points. So if we have a look at chapter 1, you can see this is all we had at the point when we made our first commit. So previously we said that we have a working directory, which is the directory where we initialized Git. Then we can push our files to a staging area where we can pick and choose which files we want to commit. Then once we're ready, then we can commit our files or our save point to our local repository. So once you've done a few commits, then you actually have this timeline of various commits. And this is called your master branch. So the master branch is your main branch of commits or save points, and it is sequential, and this is usually where your main progress is saved or committed. Now, later on, we then introduced this idea of the remote repository. The important thing to note is that you can have a local repository completely in parallel with a remote repository. Check the differences between them, but you can also sync them so that they are the same. But you can also sync them or push things from your local repository to your remote repository. So in our case, the local repository is the Git file that we've got inside our story directory, and the remote repository is the Git directory that we've got inside our story directory, and the remote repository is GitHub, which hosts our code and also hosts all of the changes that were made in between the different commits. So we have this master branch of various commits, first commit, second commit, third commit, in our local Git repository. And when we performed the command git push, then that effectively pushed all of those commits, all of those various versions and changes and code pieces to our remote repository on GitHub. So that's what git push does. Now in the next lesson, I want to talk about using git ignore and how you can avoid uploading sensitive pieces of information such as API keys or passwords to your remote repositories, for example GitHub. So all of that and more on the next lesson. See you there. Alright guys, in this lesson we're going to be talking all about the git ignore and how you can set rules to prevent committing certain files to your local and remote Git repositories. So first things first, let's bring up terminal. And what we're going to do is we're going to cd into our desktop, and we're going to create a new directory here called project. Just say that we have this brand new project. And now if we go into our project and we create a whole bunch of files to simulate this example project. So let's say we've got something called file1.txt, and we've got a whole bunch of other ones, file2, file3, and we've also got something called secrets file. So we've now got 4 files, and just to illustrate the use cases of when we might want to have a git ignore file. So say if you have this file that has some, secret passwords or API keys, basically stuff that you don't want to be committed. Especially you don't want it to be hosted on an open platform like GitHub. There have been horror stories of people having their apps on AWS secret keys in their projects, and that getting pushed to their remote on GitHub. And within seconds, their entire AWS account has been basically used up and wiped clean. So it's really, really important to think about some of these things and to be aware of what you're putting onto this public platform. So let's say that we've got this secrets file and we've saved it. Another type of file that you might want to add into a git ignore, or you might want to not upload to GitHub, are files that are to do with your local settings or your user preferences. And there's a whole bunch of these types of utility files that you don't really want another person to have to download and copy into their project folder if they're cloning or if they're forking your project. So a really common example that people tend to add to their git ignore files are what are called dsstore files. So dsstore files are basically a settings file that saves certain things like, how you like your icons to be arranged in a particular project folder. So let's say if we go in here and we just have a look at arrange by none, and then I'm going to move my files around. And let's say that this is just my preference for how I want my files to be shown inside this project folder. Now, the dsstore file is a hidden file, so you won't be able to see it inside your Finder. But of course, we as command line experts know that we can simply do a ls-a to see all of the hidden files that are inside our project folder. And you can see there it is, dsstore. So that's not something that's going to be of any use to anybody else, and we don't want to have to clutter our GitHub remote repository or anybody else's computer with that file, so we're going to add that to our git ignore as well. So getting on to the point of using and creating and using a git ignore file, the first thing you have to do is to make it, right? And to do that, we're just going to create a hidden file, so using the dot in front of the file name, and it's going to be called git ignore. Now the case and the wording matters a huge deal because we're using Git and it's looking for this specific file. So make sure that when you're using it, it looks exactly like this. So let's create that file, and of course it doesn't appear because it's a hidden file, but we can see it using ls-a. And we can also open it in the terminal by simply saying open.gitignore, and that opens it in your default editor, so for example text edit. And here is where we add the files that should be ignored when we commit our project to Git. So let me first show you what happens when we don't have anything inside our git ignore. So I'm just going to save it, it's completely empty, and I'm going to go through the normal process of setting up Git and committing it. So first, if you remember, I have to use git init to initialize an empty Git repository inside my projects directory, and then I'm going to use git add dot to add all the files that are currently inside this directory to the Git staging area. So hit enter, and we can have a look at what's been added by using git status. And you can see that all of these files are added into the staging area and they're going to be committed if I go ahead and do git commit. So that's not what we want. And instead, I don't want to commit the DS store, and I also don't want to commit my secrets.txt file. So first things first, I'm going to basically undo what I've just done. So I'm going to remove all of these files from my staging area, and then I'm going to add them later on once I've got my git ignore set up. So basically we're just undoing the last step. So to do that, I'm going to write git remove --cached, and I'm going to use the R flag for recursive, and I'm going to use a dot to say that everything inside the current directory should be removed from the staging area. So now if I hit enter, you can see that all of these things have been removed from the git staging area, and if I do a git status again, you can see that all of these files are no longer tracked to be committed. So now this is the point where we're going to use that git ignore file, and we're going to add the file names that we want to be ignored when we're adding and committing to git. So in order to add individual files, you can simply specify the file name on each and every new line. So for example, if we wanted to ignore the DS store, we can simply write DS store. So exactly the same upper and lower casing as the name of the file. And if we wanted to ignore the secrets.txt file, then all we have to do is just to specify it in here on a new line. Now with git ignore, it has certain rules. So for example, you can use the # to comment. So for example, you can say, pod files, right, to be ignored. Another thing you can do is use wildcards. So if you use the asterisk and you say asterisk.txt, that means that when you commit your project, all of the files that have a text extension will be ignored. Alright, so I'm going to get rid of that because I do want to commit the file 1 and file 2 and file 3 to my to git, but I want it to ignore the DS store and the secrets.txt files. So now we're ready to add our files to our staging area. So let's again use git add dot and use git status to see what's been added. So you can see that the only files that are added are the git ignore, the file 1, 2, 3, but the DS store as well as the secrets.txt are ignored as per the specifications in our git ignore file. So now if I go ahead and commit this as my initial commit, then the only files that are going to be put onto my local commit are going to be these 4, and similarly if I push this to GitHub, it will also be only these 4 files. So now let's create a new Xcode project, and let me show you how you would add a git ignore file for your Xcode projects. So let's just call this test, and I'm going to create it inside my desktop. And now let's just make a few changes. Let's drag on an image view onto our view controller. And now I'm going to save and exit Xcode, and I'm going to clear my terminal and cd into my root, and also I'm going to open this new test folder that we've created just now. So let's cd into desktop/test so that we are right here, and I'm going to create a git ignore file. Then we're going to open our git ignore, and in here I'm going to add some of the files that will be ignored for our Xcode project. Now, if you go to github.com/GitHub, so this is a repository owned by the GitHub team, they have a repository called git ignore, and it's basically a pre-made collection of useful git ignore templates. And if you have a search in here, you can find that you've got Swift and you've also got Objective-C. So we're going to go inside the Swift git ignore file, and you can see that this is a pre-built template for some of the files that you probably won't want to upload to GitHub or any other remote repository. So these have the file extensions for things that are user defaults or user settings, for example, PBX user, and it's basically all pre-made for you. So you can simply just copy all of this and put it into your gitignore file that you created earlier on. So just straight up paste. And if you remember from earlier on, we said that the lines that start off with a £sign are the comments, and these ones are extensions that you would ignore. And you might want to add things like DS store into here as well. So you can have something like project wide. So for example, the DS store that we mentioned earlier on. And if you hit save, now if we go into terminal and we're inside our test folder, so we're going to do a git init, git add, git status to see what's going to be committed, and then we're going to say git commit -m initial commit. There we go. And now, once you're ready to commit and add all of this to your remote, then it will ignore all of these common user-related files that are not going to be useful to your collaborators or anybody who wants to contribute on GitHub. So that was just a quick tidbit about using gitignore. And I know that some of you guys have been asking about, where should you put your API keys? Where should you put your sensitive data? And you have to make sure that when you're uploading your projects with these secret keys and passwords, to make sure that you set up a gitignore file and to include those things in there. Alright, so that's all for this lesson. Now, in the next lesson, I want to talk about git clone and how to clone various repositories to your local system. So, all of that and more in the next lesson, so I'll see you there. So, in the last lesson, we looked at how we can push our local repository to a remote repository on GitHub. Now, in this lesson, I want to talk about cloning a remote repository to pull it into your local machine. So this is called cloning, or the command would be git clone. And that is a way for you to pull down all of the commits and all of the versions of a particular remote repository and to store the files inside your working directory. So let's give it a go and see how it works in practice. So inside GitHub, if you search for open source iOS apps, you can actually see a collaborative list of really awesome open source iOS apps. So this is a place where you can browse by category and you can look at all the projects that people have made open source on GitHub. And you can maybe learn from how they format their code or how they write things. And it's a really, really good resource that I would recommend you to bookmark. So let's take a look at one of these projects so we can see their commit history so that we can clone it to our local machine. So this is a really cool repository. This is the game 2048 that this guy, Austin Jung, has created, and we can port it onto our own system and we can have a look at the code or simply run it and give it a go. So let's try and do that. So the first thing we're going to go to is this button where it says clone or download. Now, previously, when we've been asking you to download our skeleton project, because we haven't yet covered Git or GitHub, we've always asked you to simply download the zip and unzip it. Now, this is not as great an option as using git clone. So that's what we're going to do. So if we copy the URL of this particular repository, then we can go back into our terminal and clone it to our desktop. So at the moment I am in my desktop, and all I'm going to do is I'm going to use the command git clone, and then I'm going to paste that URL that I copied earlier on. So now if I hit enter, then it's going to clone into my very own local working directory, Swift 2048. And it didn't even take that long because it's actually quite small. So now if I have a look at my desktop, I can see this folder. So this is the project that I've just cloned down from GitHub. So if you double click on it, then you can see all of the project files inside Swift 2048, as well as the Swift Xcode project. So let's go ahead and double click it to launch it. And let's see if it works. So I'm actually going to try and run it locally on my simulator. So I'm not going to change any of these things. Now, if you wanted to run this or anything that you clone from the from GitHub, then you obviously have to change your bundle identifier and also change your team. But right now, I'm not going to mess with it because I'm just going to run it in my simulator. So these things don't matter so much. Alright, so here's the app, and I can already hit Start Game. So you can click and pull down to swipe down, and click to right to swipe right. And you can see that this is a beautiful implementation of the 2048 game. So it works absolutely perfectly. And if you decide to go ahead and change the bundle identifier and also add your team, then you can actually run it on your phone and play with it. But more importantly, you can have a look inside the code files and see how exactly did they achieve this, you know, what is their coding style, what are some of the things that they used to create this game. So that was a quick demonstration of Git clone. And the other thing that you should realize is that once you've cloned a project and you CD into it, so let's go inside that project, you can also use git log to check out some of their previous commits. And you can see they've got all these commit messages that tell you what each commit was all about. Alright, so that was a little bit on Git cloning. So in the future, when you need to grab any of the skeleton projects from our GitHub repository, then you'll know what to do. Then you'll be able to use git clone to grab it and download it onto your local system. So in the next lesson, I'm going to be talking about something slightly more advanced. I'm going to be talking about forking, making pull requests, and merging repositories. So all of that is yet to come, so I'll see you on the next lesson. Now, in the last lesson, we spoke about some of the more basic variants of version control. Now, in this lesson, I want to talk about branches and branching. Now, let's start off with a simple example. Say if we had version 1 and 2, so 2 commits that were made to our local repository. Now, at this point, we realize that we want to maybe try out something different, maybe build a new feature, or just to mess around with a new idea or concept. So what we can do is, instead of continuing to commit to the master branch, which is the main branch that you see here, we can also create a side branch. So we can create as many branches as we like. So after the second commit, we create a new branch, and we start committing to this new branch, or this experimental branch. We add some features and we write some code. Now, simultaneously, we can continue working on the main branch, putting out all those essential updates or bits of code that are maintaining our main project. But at the same time, we can continue to update and work on this experimental branch, trying things out and committing our experiments to this experimental branch. So now we have 2 branches that are parallel to each other, and they can be developed simultaneously. Now, if at some point in the future that we decide that that experiment was really fruitful and the feature that we built in it was really, really great, and we'd like to merge it back to the main branch or to the main project, then that can be done really easily as well by simply placing a merge request in. And we can bring all of those changes that we experimented with, that we messed around with, back to the main project and check to see if there's any conflicts with the main branch code. And if not, or if after a little bit of editing, then we can bring all of those changes into the main working master branch. And then we can continue working from here onto the next commit, or we can make more branches. And very often what you see in practice is that there'll be multiple branches being worked on at the same time for any given large project. And the reason is because sometimes you're developing new features, sometimes you are fixing bugs, and all of these things may break your main project. So you don't want to do it on the master branch. You only want to put it onto the master branch once you've tested, once you know that everything is working fine, and then you can bring your code back to the working copy ready for shipment and deployment. So let's take a look at how this would work in reality. Now let's say we navigate back to our story directory. And inside here, we've still got our previous 3 chapters, and they are under version control. So if we just have a look at git log, you can see that this is currently the most recent commit, and it's also mirrored in our remote. So let's try and do this locally first. If I decided that I want to create a new branch, you can simply just write git branch and specify the name of your new branch. So I'm going to add a space related plot to my story. So let's call our branch alien plot. Hit enter, and now you can check out what branches you have by just writing git branch without the name. And you can see that you've got one branch called alien plot and another one called master. And the asterisk shows you which branch you are currently on. So we're currently on the master branch. We can switch to the alien plot by simply writing git checkout alien plot. Okay, so as it says, we have now switched to the branch called alien plot. Now it is inside this branch that I'm going to make some changes to my chapters. So let's try doing that. Now I'm going to make some completely nonsensical modification to my files. So let's change chapter 1, let's change chapter 2. Okay. There we go. Okay, so we've made some modifications to chapter 1, chapter 2, and we've decided to change some of the pre-existing written text to integrate a space-themed or alien-themed plot. So let's go ahead and commit that. So remember, we have to do git add, and then git commit -m, and our message is going to be modify chapter 1 and 2 to have alien theme. Okay, now hit enter, and we've made our commits. So now if we do a git log, we can see that we have 2 commits made on the master branch, and we have 1 commit made on the alien plot branch. So now let's say that we go back onto our master branch. So whenever you're confused where you are, you can always do a git branch to check and see where the asterisk is. And the asterisk is obviously where you are. So let's do a git checkout master to go back to the master branch. So you can see that our master branch is unchanged with respect to the space or alien plot that we did just now. Nothing has changed over here. So while on the master branch, I'm going to create a new file. I'm going to call it chapter 4.txt. And inside chapter 4, let's add something. Okay, and hit enter and save. By the way, I have no idea what I'm typing. I'm now making up and destroying, probably in the process, a masterpiece. But it's okay. So we now have a chapter 4 on our master branch, and I'm going to go ahead and do a git add and git commit. Now, there's ways of combining add and commit together in the same command, but I think if you're new to Git, it's always good to really know in your head exactly what's going on. So I recommend actually separating those 2 bits out. So let's go ahead and give it a commit message, add chapter 4. Okay, so git log, let's see, what have we got? So we are currently only looking at the master branch, and we have 3 commits. This is the position of our remote. So on our GitHub repository, this was the latest commit that it could see. But on our local Git repository, this is in fact the latest commit, the one that we just made where we added chapter 4. And you can see that if I switch between the branches, say if I go over to alien plot branch and hit enter, you can see that our local files actually changed as I switch branches. So let's just say that I'm quite happy with the changes that I've made in terms of my alien plot addition, and I would like to merge these changes back into my master branch. So I've done a little bit of experimentation on a separate branch. I've messed with a few things, and I think it was a great experiment. So I'm going to put it back into our main master branch. So in order to do that, what you have to do is go back to the master branch. So git checkout master. And while we're on the master branch, we're going to merge the changes inside the alien plot branch. So we use the command git merge, and we're going to specify the branch name, which was alien plot. Hit enter. And this opens up Vim, which is a text editor. And this allows you to add a merge message if you wish. And alternatively, as we're going to do here, we're just going to leave it empty. And you're going to write $Q exclamation mark to save and quit. And you can see now I've actually absorbed those changes from the alien plot. So I'm on my master branch, and you can see that because if I do git branch, I am on the master branch. So the alien plot branch still exists, by the way. So on the master branch, if you have a look at git log, you can see that I've got some of the previous commits, but I've also got this merge branch alien plot, which was my most recent commit. So now, at this point, let's do a git push to our origin master. And remember to add the -u flag. So that's completed, and let's check it out online. So if we go over to our story repository, you can see that there's now 5 commits. So we modified chapter 1 and 2, we added chapter 4, and we merged the alien plot branch. So if you go into Insights, Graphs, and go to Network, now if I zoom in on this network graph and get rid of the tag, then you can see this is the process that we've gone through. So this is the master branch where we did chapter 1 and chapter 2. And then at this point, after I created chapter 2 and 3, I created a new branch. And while inside this branch, I made a commit that modified chapter 1 and 2 to have an alien theme. And then on the master branch, I continued developing the master branch, adding a chapter 4. But subsequently, I realized that I did a great job adding alien themes to our storyline, and I decided to merge it back into the main branch. So this is basically a graphical representation of what's been going on. Now, you can do everything that I just did inside GitHub itself, and it's actually really easy to do. So let's go ahead and create a brand new repository. And I'm going to call this one Story 2 because that's how imaginative I am. Clearly not suited for story writing. Now, it's really important. We're going to leave our repository as public, but you're going to check this box to initialize your repository with a README. Now, a README is simply a text file that tells other people what your GitHub repository is all about. So if you go on to any repository, let's just, search for something like... And we go over here. You can see that this part that comes below the list of files is the README. And some people format this really heavily so that you can show various flags, but you can also tell people how to use your library, how to incorporate it into their project, basically a whole bunch of useful stuff for anybody who is looking at your repository. So now we've got our new repository. So you can click on the README file and you can make some edits if you wish. But what we're going to do is we're going to go into our main Story 2 repository, and I'm just going to create a new file. So this is going to be, again, chapter 1.txt. And in my new file, I'm just going to say this is a story. I think I'm pretty much given up on writing stories now. And we're going to make a commit. So this is going to be create chapter 1. And we're going to commit directly to the master branch. So commit new file. Okay, so now that we've got chapter 1 and we are on the branch master, at this point I'm going to create a new branch, and let's call this new branch experimental. Okay, so now we have experimental, and it takes you straight to the experimental branch, copying over everything that you had at that point inside the master branch. And now inside this experimental branch, I'm going to make an edit to my chapter 1. So I'm going to click on the file, not over here, but over here. And I'm going to click on the pencil button to edit this file. This is a story. Nothing like a bit of confidence in your story writing to make it better, right? Okay, so now let's commit these changes, and let's say update chapter 1 to be more upbeat. Okay, now we're going to commit, and we're committing, so always check to see where you're committing to, because sometimes when you have a lot of branches and you're switching branches, then it can get quite confusing. So we're committing to the experimental branch, and we're going to go ahead and commit those changes. Now let's switch back to our master branch, and you can see immediately this is reflected, so that new line that we had previously is now gone. So let's go back to our main repository file. You can see that you've already got this little notification here, which is telling you that you've got a experimental branch, and you can compare between your master and experimental and make a pull request. So we're going to talk about pull requests in more detail later on, but basically this is telling you, hey, you've got changes that are not reflected in your master branch. Do you want to pull those changes over to your master branch? So right now, that's not what we're going to do, but instead, on our master branch, so check to make sure that master is checked, we're going to create a new file, and we're going to call it chapter2.txt. And we're going to say this is an even better chapter. Okay, so let's say create chapter 2. And we're committing to the master branch. So commit that file, and then we're going to check out what the structure of our repository looks like now, inside graphs and inside network. So you can see that we've got a initial commit, and then we have our created chapter 1, and then after chapter 1, we decided to make a branch that was experimental, and then we continued where we left off in the master branch. So now what I want to do is I want to go into that master branch, and I want to merge those changes in the experimental branch over. So I want to pull those changes from the experimental branch to the master branch. So in order to pull, you have to be in the place that you're going to do the pulling, which is the master branch. And while we're here, I'm going to say new pull request, and this takes me to the compare page. So here I can say that my base is my master branch, and I want to compare it with my experimental branch. So we can see that the difference is only this line, so plus this line. When it's red, it's an erasure, and when it's a plus, it's an addition. So whereas inside my master branch, this is all I've got inside chapter 1. In my experimental branch, I've got all of this. So I have to say that I prefer this version in the experimental branch. So I'm very happy with what I did in the experiment. So I'm going to create a pull request that is going to merge these two branches. So now, once I've done that, I'm going to merge those two branches. So I'm going to say merge experimental branch to master, and go ahead and confirm the merge. Now you can see it's almost more straightforward doing it on the terminal, but you get used to the interface, and this is not so complex either. So now if we have a look at our network graph, you can see that that experimental branch was pulled back to the master branch and merged. So that was us creating a branch and merging it. Now, why don't you go ahead and have a go and create your own repository, both locally and as well as on GitHub, and, write a story or write a poem, anything you like, and check out the amazingness that is branching using Git. Alright, so we've been doing a lot of stuff in the command line, and it's great practice, and also a lot of developers prefer it. But in the new Xcode 9, there's actually a couple of changes that have been made in terms of how Git version control is implemented, and I have to say it's a lot better than previous versions, almost to the point that I'm tempted to use this instead of using the command line. But of course, you can choose whichever one you prefer, and that's why I'm going to show you how you can do everything that we've just done using Xcode itself, without having to ever touch the command line. So let's go ahead and create a Xcode project, and it's going to be a single view iOS application, and I'm going to call it Udder, which is like an alternative to Uber, but here's my pitch. What if you could get fresh milk on demand through the Udder app? Okay, let me know in the Q&A what you think about this. But anyways, let's go ahead with our example. Gonna go ahead and click next. And it's really important that previously we've not really cared much about this, but given that we're talking about source control and version control, we need to create a Git repository on my Mac using Xcode. And this is the equivalent of using git init in our terminal. So I'm going to save it on my desktop and just make sure that you've got that checked. Go ahead and click create, and here's our brand new project. Now I'm going to do a couple of things first. I'm going to maybe add a UI label to the top of my file, and I'm going to call my app Udder, as I already pitched to you. And I'm going to change the size of it to size 40, make it maybe a dark grey color, and let's just make that resized to the right size, and let's give it a tagline, why not? Fresh milk on demand. Sounds pretty good, right? Sounds like a startup already. Alright, so now that I've done that, the other thing I want to do is add some image assets. So I've got two images, one of milk and one of cow, which is all going to be very relevant in this particular app. So now I am ready to go ahead and make my second commit. So the first commit is on initializing the project, and you can take a look at where the commits are by going to this brand new source control navigator. So if you head over there and you expand these folders, then you can see that we've got a Udder master, and we've got an initial commit that was made when our project was created. So let's go ahead and commit our latest changes. So to do that, we simply go to source control and hit commit, or use the option command C shortcut if you wish. Now, in the left-hand pane here, you can see some of those changes that were made. So we added these two new images, we changed our main storyboard, of course this is all in XML, and you can see that this is showing what the differences are. So for example, I added a brand new label, which previously didn't exist, and also I added a UI image view. So I'm ready to commit those changes, so I have to enter a commit message here. Add label and images. And we're going to go ahead and commit those 7 files to our local repository. So now if you have a look at our master branch, you can see that we have 2 commits that are made. Alright, so now that that commit's been made, let's say we go into our main storyboard and we kind of just mess everything up. Let's just try and mess up our interface and make it something pretty terrible, and let's delete all the useful parts, and now it's pretty much a mess. And our view controller, let's add some mumbo jumbo, which is not code, and let's say we accidentally even deleted our main storyboard. Let's just move it to trash, shall we? Now we've made some pretty big issues. let's delete view controller as well. This is a really common bug, by the way, that a lot of students in our in-person programming bootcamp get themselves into, which is when you think that you've got something selected over here, but actually you've still got the file selected, and if you hit backspace, it'll actually try to move your file to trash. So we've made a mess of things, basically. So of course you can drag them out of the trash because we've just placed them in the trash, but let's say that we've just messed everything up irreversibly. But what we can do is, because we have that last good commit, we can simply go to source control and discard all changes. So this will discard all the changes that we made since the last commit inside our working copy. So if I hit this button, you can see that a little bit of work is done behind the scenes, and ta-da! All of our beautiful work is restored to the last checkpoint, and we will no longer get fired from our jobs. And there are countless stories of Git and source control saving people's lives at work every day. So that was pretty cool. Now, what about another feature of Git? What about branching? Well, it's equally easy to do. So if we head into the master branch and we decide to make a branch at this point, and we can simply just right click and say branch from this particular hash or this particular point, and we can give our branch a name. And I'm going to call this the milk design, and it will all become clear very quickly. So now I have the milk design, but it's important to note that current, or the branch that we're currently on, is still the master branch. So I have to also check out to switch to the milk design branch. So let's go ahead and do that. So we're now on the milk design branch, and I'm going to go into the main storyboard, and I'm going to put a image view onto the screen. And I'm going to place the milk image that I've got in my assets folder on here. Okay, looks pretty good. Okay, so that's my milk branch done, and I'm going to save my main storyboard, and I'm going to commit my changes. So let's say we change interface, change view controller interface. And these are obviously the changes in XML that I have just made. So added that image view, and that includes that milk resource. So let's go ahead and commit that file. So now let's head back to the source control navigator, and let's have a look at our milk design branch. So you can see that the latest commit is in action, change view controller interface. Now I'm going to create another branch. So I'm going to branch from the latest checkpoint inside master. So we're going to branch from here again. I'm going to call this a cow design. So just bear with me here. And I'm going to check out to switch over to the cow design branch. And now I'm going to go to my main storyboard. And remember, because we're currently at the last checkpoint on the main branch, we haven't actually got an image view yet. That's only inside the commit for the milk design branch. So here I'm going to put another image view, and you guessed it, I'm going to put the cow image that I've got in here. So now I have got a cow design and also a milk design. So now I'm going to save my main storyboard. I'm going to go to source control and hit commit. And I'm going to say change interface to incorporate cow image. Now you always want to be precise when you are writing your commit messages, because if somebody else is coming across this and each of your commits are just changes, changes, then that really doesn't help anybody. And I've actually seen this before, but this is bad practice, and this would probably get you fired if you're working in a very Git intensive team. So let's go ahead and commit this file and go back to our source control navigator and check out our cow design. Okay, so we've got the cow images, we've got the milk design, and you know what? I think that I prefer the milk design. So I am going to merge my milk design into my master, and that is going to become my master branch. So all I have to do is right click on milk design, and I'm going to click checkout. And now I can right click on master and say merge milk design into master. So milk design is my current branch that I'm currently on. I'm going to merge it into my master branch. So go ahead and click merge. Now once it's done that, you're going to be reverted back to the master branch because it's now merged. And if you have a look inside your main.storyboard, you can see the milk design is now the accepted design on our master branch. Alright, so that was all very easy. Now, another thing that you can do is, what if you wanted to have a look back at what milk design looked like, or at the code that you made in another branch, or, way back in a random or different commit? Well, say if at the moment we're currently at this point on the master branch, if I want to have a look at what, this checkpoint was like, then I can simply right click and say, check out this particular commit. So if we check that out and we go back to our main storyboard, you can see that everything is reverted to that checkpoint or that commit. Now this can be really invaluable for your code files because sometimes, way back at some, 3 months ago, you might have created some sort of feature that you thought was a little bit crappy, but now you've decided that it's actually a great idea, so you can have a look at what each and every commit looks like by simply checking out the commit. So let's go back to master and check out the main master branch and head back to where we are meant to be. So when you check out one of the earlier commits, you can use it to compare the differences. So currently we're on the master branch, and let's say that we, type some code in here. Let's just add, maybe a view will appear and a comment. So let's go ahead and save that. So this is our master branch and commit, and view will appear. And we're going to commit that file, and you can see this is the difference between this commit and the previous commit in terms of the code. This is the addition. So let's go ahead and commit that file. And then if we head over to one of our milk design, let's say, check out, and in the view controller, you can see that it doesn't have the view did load, but here we're going to delete the did receive memory warning block of code. I'm going to save and I'm going to commit, and I'm going to say delete memory warning code. Okay, so now you can see that this is the latest commit, this is the previous version, and we are removing this block of code. So let's commit that one file. So now what I can do is, if I go into this particular button, which is the version editor, I can compare and contrast my code files. So on the left, I've got my master branch latest version, which has the view will appear and the did receive memory warning. Now on the right, let's say that I've got my milk design latest version. So you can see that the version editor actually highlights the differences between the two code files that you're comparing. So you can compare different commits against each other, either from different branches or on the same branch, but way back historically. And you can check out what are the code changes that you've made and see what the previous code looked like. And this is really invaluable when you screw up or when you mess up your code, because you can always compare and port things over if you realize that you actually do need this. So the last thing that I want to show you in terms of using Xcode for source control is using remotes, and namely GitHub. So Xcode has integrated a really neat feature where you can actually push your project using Xcode to your GitHub remote. So the first thing you have to do is go into Xcode and go to Preferences, and if you go to Accounts, you can click Add an Account, and instead of picking Apple ID, you're going to pick GitHub. So continue, and then you're going to log in using your GitHub account. And once you've done that, And of course you need to be internet enabled for this check to pass, because they're going to log you in remotely to GitHub and they're going to grab your SSH keys and everything that you need to be able to create a remote and push to your remotes. So once you're done with that, you can close that down. And now if we go into the source control navigator, we can head back to master. So let's check out master. And from here, I'm going to create a new remote and I'm going to push my project to GitHub. So if you click on your main repository and you right click, you can create a other remote on GitHub, or you can also add an existing remote. So if you created a GitHub remote already and you just want to add that existing remote, then you can use this. But in most cases, you'll probably be creating a brand new remote on GitHub. So go ahead and give it a repository name, a description. You can see this is very, very similar to what we did when we set up a new repository inside GitHub. And as you can see, the default name for your remote is still Origin, and I would recommend to keep it so. So once you're done, go ahead and click create, and it's going to push your existing repository, your local repository that's managed by Xcode, to your GitHub account. And now if you look inside this remotes folder, whereas before it was empty, you now have a origin, and the origin has the master branch pushed to it. So now if I head over to my GitHub repository, you can see this brand new other repository that's been created for me. And so you can see how incredibly simple it has been to push all of these commits onto my other repository. And I've done all of that without touching the command line, without touching GitHub. So if you are using a remote repository, so from now on, if you make some changes to your code, say let's add a view did disappear, and we save and we go to source control and we say commit, you have the option to push to your remote. You can have more than one remote and you can pick which one you want it to go to. Now, alternatively, if you already committed without pushing, you can also use the push functionality over here as well. So now let me show you something. If we go onto other and we add a readme, now this is going to make our remote repository be different to our local repository. So we're just going to say this is an app that gives you on-demand fresh cow's milk. And let's just say create readme and commit to the master branch. Alright, so that's done, the readme's added, and now you can see that my remote repository now has a new file that my local directory does not have. So now, if I try to go to source control and I said push, then it's actually going to fail. And the reason is because the local repository is out of date. It's basically saying that on the remote repository, we have stuff that we don't have locally. So we're actually behind the remote repository because they have more things or more up-to-date stuff. So in order to make our local repository reflect the changes or be up to date with the remote repository, we're going to use pull. So let's first commit our local changes. So add view did disappear, and we're going to commit that file without pushing, and then we're going to say pull, and we're going to pull from our origin master branch, hit pull, and it's going to pull successful. Great. So now if we have a look inside this file, other, you'll see that it actually pulled down that readme file that we created inside GitHub. So now our other local repository has everything that the remote repository has, and it has some more changes. So at this point, we're going to use push to push that latest change or that latest commit, which is of course the one where I added the view did disappear. So let's go ahead and go to source control, push to origin master, hit push, and now it will successfully push to the GitHub remote. So now if we check under other, check inside view controller.swift, you can see view did disappear now shows up. So that's a little bit of primer on how you can work with GitHub, Git, source control, all using Xcode. So I hope that has been interesting for you. And of course, it's totally up to you which one you prefer, which one is quicker, easier, more reliable. And the whole reason why I showed you both ways of doing it, either using the command line or using Xcode's graphical user interface, is for you to pick and choose. So in the next lesson, we're going to be diving into some slightly more advanced topics in terms of GitHub and Git, and we're going to be talking about forking, pull requests, and merging. So I will see you there. So in the last few lessons, we looked at implementing source control locally using the command line as well as using Xcode, and also remotely using GitHub. So now I want to take you a little bit further, and I want to talk about collaboration using remote repositories and GitHub, because this is one of the best ways to start working in a team of programmers and to contribute your skills to open source projects. So we've seen all of these four areas: the working directory, the staging area, the local repository, as well as the remote repository, and you should be pretty familiar with all four of these areas by now. Now, in the next scenario, let's shift over to just look at the local and remote repository that you own. So let's say that Angela, so myself, I own this repository. I created it locally and then I pushed it to my remote repository on GitHub. Now, let's say that I have an evil twin who's called, I don't know, Bangela. That's a terrible name. Let's say that she also wanted to make changes to my repository. She's looking at my code base and, she wants to add some features or fix some bugs or do something. Now, because I own this remote repository over here, in order for her to work on it, she could make a copy of it that exists on her GitHub account. So remember, this is different from Git clone. Git clone is just grabbing the entirety of the repository and then cloning it to your local work environment. Now, in this case, we're basically just copying a repository that's hosted on GitHub, and we're keeping the copy under our own GitHub account where we can make changes to it. So this, in terms of GitHub lingo, is called forking. Now, once you've forked a remote repository, then you now own it. You have full permissions to do whatever it is that you like with this copy of the repository. Because as you can imagine, it would be pretty crazy if everybody could modify your source code on all of your open source repositories. Because, it would lead to maybe amateurs changing all sorts of things that you don't want them to, or, people making features that are incompatible with what you've got already. Basically, you would only give people who you have a trusting relationship with right access to your remote repository. So say if you worked within a team and you're all working on a product, then everybody in the team probably has both read and write permissions on a single remote repository, and that way they can git clone and work on it locally and then push it and resolve any sort of conflicts that way. But you don't want anybody on the internet having those kind of permissions. So how do you implement this kind of open source collaboration then? Well, it's through forking and making pull requests. So now let's say that evil Bangela, has forked my repository. So on her GitHub account, she now owns a copy of my repository. And from this point, she can then clone that repository to work on it locally. And if she decides to add some features to it, maybe, improve the code base or add some more code or do something crazy or whatever it is that she wants, then after she's happy with that and she's committed those changes, then she can push it to her remote repository. And then if she wants me, or good Angela, to incorporate those changes that she made, then her only option is to make a pull request if she is not within that trusted pool of people who all have read and write access to my remote repository. So say if she only has read access, then she would have to make a pull request. And it's almost like making a suggestion. Here are some suggested changes that I've been working on. What do you think about it? If you okay it, then please, merge it to your remote repository. So the reason why it's called a pull request and not a push request is because the person who has the write permission to the repository, so I have write permission to my own remote repository, which has been forked and duplicated by, my evil twin. If she wants to incorporate those changes, then I have the deciding vote. So I can review those changes and I can pull the changes over. So it's not a push because you don't own the rights to the remote repository that you're trying to push to. In this case, if I decide after a code review that actually those features that she added were pretty great and it seems compatible with my code so far and doesn't break anything, then I would approve the pull request and merge her repository with my own. So the changes will be reflected in a new commit. So let's take a look at this in action. So here we've got our original story repository. So this is a remote repository, remember, because it's hosted online on GitHub. And we've got a number of commits and we've been doing some modifications and writing to write our storyline. Now I'm going to log out of my account. So that was the account that created the story. And then I'm going to sign in using a different account. So right now I'm signed into a different GitHub account. This account is named Guilfoyle is my other name. And now I'm going to search for that repository. So I found the story repository by the user Angela Bauer. So that was the one that we saw earlier on. So I'm going to go into this repository and you can see that all of these lines and files are publicly visible and you can read through all of it, even though you are now not signed in to the account that created this repository. So from here, what I'm going to do is I'm going to fork this repository. So as we mentioned before, forking is simply making a copy or a duplicate of a remote repository and putting it under your own GitHub account. So you can see this user that I've created is called Guilfoyle is my other name. And now I have this repository under my own username. So I've made a copy of it. And you can see it's exactly the same as before. Everything's been copied over, including all of the previous commits that were made. So now from here, I'm going to make some changes. So let's maybe change one of these storylines. So let's change chapter 4. So let's say that this other user, this other person, has some suggested improvements to my code, or in this case, to my writing. They're still keeping the spirit of the original repository alive because we are now converting into a space theme or an alien theme. So I've made my changes to chapter 4 and I'm going to commit those changes saying add more space theme to chapter 4. So that's what I did, and I'm going to commit to the master branch. So this is the master branch of my own forked copy of the story repository. So once I commit those changes, then we can view what it currently looks like under the graphs. So if we have a look at the network, you can see that this is the point where I forked the story repository. And that commit was created by Angela Yu, which basically merged this branch to the master branch. So we did that 2 lessons back, if you remember. So the latest commit, though, is made by this current user. Guilfoyle is my other name. And you can see that I've added it to the master branch of my forked copy of that repository. So say if I now open up a incognito window and I log back in to the Angela account and go over to that story repository, you can see that if I have a look inside my graphs, go into network, that latest change, it's not reflected on my master branch. It's showing up as a separate branch made by Guilfoyle is my other name. And you can see the members who have forked your repository. So this is a great way of collaborating because you can have contributors make edits or add new features to your pre-existing code base or repository. And now what I can do, if I head back to the Guilfoyle account, so I'm just going to flip through these two so that you can see. Right now I'm inside the Guilfoyle account, and this is the Angela Bauer account. So now under the Guilfoyle account, what I can do is I can make a pull request. So we can do that here, and you can see that it's able to merge. And these are the changes. So swapping that word for that word, swapping that word for that phrase. So now all I have to do is hit create pull request and tell the original author, which is Angela Bauer, what I've done, why I think my modifications or my features are worthy to be merged with the original repository, and any other notes, right? Any other comments that I have. Let's just say, always helps to be complimentary. So now let's go ahead and create a pull request. So the pull request is done, but if we have a look back into the story repository, you can see that those changes are not made, right? It's because I don't own this repository. I don't have write access. I only have read access as a member of the general public and not a member of the trusted inner circle. So I can only suggest my changes. Now, if we head over back to the Angela Bauer account, who owns this repository, now, if I have a look under pull requests, I've got a brand new pull request, right? So it previously was 0, but now I have 1, and it's showing as 1 open pull request. And this is added a minute ago by Guilfoyle. And if I look at it, I can see why he thinks that this modification is necessary and what were his commit message. And I can also take a look at the commits that he made and compare the differences. So review those changes. So I could say something like, great job, Guilfoyle. And I can submit this feedback to Guilfoyle and approve merging these changes. So now all I have to do is hit merge pull request and maybe add a merged from Guilfoyle's modifications to chapter 4. Okay, so let's go ahead and confirm the merge. And now you can see that that commit is added to Angela Bauer master. So if I have a look inside my graphs now, you can see that the latest commit was my merge, and you can see where it came from. It came from a fork made by Guilfoyle, which shows up as a separate branch, and then it got merged back into the main branch of the main repository. So some people use GitHub purely as version control for their own projects, and use some of the features that we discussed in previous lessons. But there's also a huge community of awesome coders on here who have created really brilliant projects. And if you can see ways of improving it or contributing to it, then it's a great way of starting to learn how to work in a team of programmers, which is a really essential skill when you're working for a startup or for a company. So, for example, if we have a look at the Alamo Fire repository, which is something that we've been using for quite a while, if you have a look at the contributions, you can see that there have been loads and loads of other users who have looked at the code and done things, or made suggestions, and to steadily improve this framework that, everybody else is benefiting off, right? You can see that a total of 4,300 forks have been made. And there's currently 4 open pull requests, but 559 pull requests were closed. So let's have a look. So for example, in this case, this guy updated the README to the current version. So that's obviously just editing a text file, and that's pretty much within anybody's capabilities, right? And then it got merged by somebody who owned this repository, and you know, they gave him a bit of feedback, right? But there's other things like, you know, code additions or code deletions or modifications that people have made. So this guy made some fixes, and you know, he's documented what were the goals, what were the implementation details, what were the tests that he performed, and then the guy who owned the repository said, hey, just, you know, maybe one thing that you need to change, have a look in here, and then once it was changed, then it was approved and merged with the master branch. So have a look around on GitHub and see what are some of the cool projects that you could maybe get involved in. So to begin with, you know, some of these things that we've been using, for example, Progress HUD, right? We've been using inside Quizlet. You can actually have a look inside the code files and see, you know, what are the things that you would change about it. Obviously, Progress HUD is written in Objective-C. Maybe choose one that is written in Swift. But have a look at the libraries that you've been using, and if you want, you can build on top of it, either for your own goals and purposes, but also, you know, if you're building on top of somebody else's open source code, then it's a nice thing to contribute back to the open source world by forking and making a pull request to offer your improvements or bug fixes or new features. So as I said, it's almost like a social network for programmers, and you can make a lot of great friends on here, and you can also get a lot of help on here in your development journey. So the last thing that I wanted to say was that in this module, I've mentioned a lot of different GitHub or Git commands, and it can be quite difficult to remember all of it just by watching these videos once. So remember, you always have these videos, so you can always come back and listen to my terrible jokes, but also the information again, so you can always rewatch it and refresh yourself. But I've actually made a PDF cheat sheet of some of the most common Git and GitHub commands that you'll be using. And I've laid it all out in terms of arrows that we've explained before so that you'll know what I'm talking about. And you can download this PDF inside this lesson. So I hope you enjoyed all of that, and I will see you on the next lesson.
Subscribe now and press the bell icon. Never miss an update.
Alright, so welcome to a brand new module. And I'm going to show you what you will be making by the end of this module. The app that we're going to be building and improving upon throughout this module is a to-do list app. And it's inspired by one of my favorite to-do list apps, which is the Clear app. And what it allows you to do is to create new to-do lists, for example, your travel to-do list, and it shows up as individual colored to-do lists, and you can select one of them to go into that particular list and add new items to it. For example, I don't know, buy apples, buy pears. And you'll see that as you add new items, your to-do list starts taking on this beautiful gradient, going from lighter to darker as you add new items. Now, you will be able to check these items off, but you'll also be able to swipe to delete them. Now, you'll be able to search your to-do list. For example, let's search for something like apple. Hit search, and you see all the to-do list items that contain that word. And the best part of all is that all of this data is saved and persisted locally on the simulator or on your physical iPhone device. So that means that if you go ahead and terminate your app, say if your app got updated, or if your iOS version got updated, or if you bought a new phone, then all of your user's data is persisted on the device with no internet connection required. And if we have a look inside shopping list, we still have all of our items. So that is what we're going to learn all about in this module. And in the process, you're going to learn about all the different ways that you can persist data locally, including user defaults for small bits of data, or things like Codable, where if you want to tap into the Documents folder inside your iPhone and be able to save items there. And you're also going to learn about using core data with a SQLite backend database, and you're going to be creating a relational database of your own to power your to-do list app. And finally, I'm going to show you how you can do everything that you can do with core data by using one of my favorite services, which is called Realm. And by the end of this, you will have created a relational database as a backend, and you're going to learn about how you can code up the front end to make it look as beautiful as we have here. So I hope you're excited, because I'm really excited. So once you're ready, get started over on the next lesson. To start building the Todoist app, we're going to first clone the starting project. So head over to the course resources link and click on the Todoist starter project. That should take you to our GitHub repo, and then click on clone or download and copy the URL. Now head back into Xcode and click on clone an existing project, or go via source control and click clone. Now let's paste in that URL, click clone. And now go ahead and save it any way you like. So I'm going to put it on my desktop for now. Now, once that's done, you should end up with a pretty much blank project. You won't find much code in the view controller, and main.storyboard also has a blank screen. So effectively, this is just a blank project, but it's been set up to be compatible with iOS 12 and 13. The first thing you have to do is head over to the Todoist project and change the bundle identifier to something unique. For example, just change that London Appery to your own name. Now we can start by designing our app in the main.storyboard. And I'm going to drag on a table view controller. Now this is a normal UI view controller, which we've been working with thus far, but now I'm going to use a table view controller. And once I drag it on, you can see that there's some important differences. The table view controller comes with a table view linked up, as well as prototype cells, and all of the delegates and data source is already linked up and ready to go. So for the keen-eyed amongst you, you'll realize that this is a little bit different from how we implemented a table view in Flash Chat. And this is on purpose so that I can show you there's actually many ways to skin a cat, or in more pet-friendly lingo, there's many ways of doing the same thing. But I'm going to delete this view controller. Now, before you delete it, if you remember, there's this little arrow here, which points to the initial view controller. So that's the view controller that is going to show up on screen once the app has first loaded up. Now, what we want to do is we want to use this arrow and move it to our table view controller. This is now going to be our initial view controller, because we are going to delete this view controller. Now, if you forget this step and you accidentally got rid of this view controller with the arrow along with it, then it's not a problem. You can simply select the table view controller, go to the attribute inspector, and just click this part where it says is initial view controller, and you see that arrow come back. So both ways do the same thing. Basically show this view controller as the first screen when the app loads up. Now you'll notice that this view controller is not linked with the viewcontroller.swift file here. And that was in fact linked to that view controller that we just deleted. So in order to create a bond between this viewcontroller.swift file and our main.storyboard, the first thing we have to do is to go into the view controller and change its superclass, or the class which inherits from, and change it from UI view controller to UI table view controller. Not UI table view, but a UI table view controller. Hit enter, And now I'm also going to change the name of this view controller to something else so that it's a little bit more clear. So I'm going to change the name of this to to-do list view controller. Now it might give you this little warning here, this little pop-up saying that to-do list view controller could not be saved. The file has been changed by another application. And all you have to do is just click save anyways, and it will get rid of that little pop-up. Now, because we've changed the file name of this view controller, it's also a good idea to change it here as well. So we're going to change it to to-do list view controller and make sure that it's capitalized because it's the name of our class. So now if we hit save and make that not gray, then we can go back to the main storyboard, select the table view controller and go into its identity inspector and specify the custom class. You can see that at the moment it doesn't have a class associated with it because we haven't specified one. So if you click here, and you can either click the down button or you can start typing, but basically the one we want to link it with is the to-do list view controller. Now just before I add that, I want to show you how you can tell that it's not linked up. When you select this view controller on the left and you've got automatic selected, it should show you the Swift file that's linked to this view controller in the main.storyboard. Now, in our case, it's not because this view controller is not yet linked with any Swift file. So let's go ahead and do what we planned on doing, which is select to-do list view controller and hit enter. And now you can see automatically to show the corresponding Swift code file with this view controller. So now this is how we can tell that it's all linked up. Now we've got one warning here, which is telling us that prototype cells must have reuse identifiers so that we can identify them in our code file. So let's go ahead and do that. Let's select that cell and go to the attributes, and you can see it's got a reuse identifier here, which is blank, and we're going to call it to do item cell and hit enter, and now that warning will go away. And I'm going to hit Command S to save the main.storyboard as well. So while we're here at the main.storyboard, I'm going to design it a little bit and modify its UI a little bit more. Now, the first thing I want to do is I don't really want an app that's just a table view. I want my app to have a nav bar at the top. And to do that, I have to select the view controller and go to Editor and Embed In. And I'm going to select Navigation Controller. The Navigation Controller comes with the top bar, and the tab bar comes with the bottom bar. So this is the one that we want in this case. So let's arrange it nicely, and you can see now our table view controller and everything else subsequently will inherit this top bar. Now the top bar doesn't yet say anything because it doesn't have a title, so let's give it one. So you can either select it here or you can select it in the document outline over here. So the title is going to be To-Doey, and you can see it shows up over here. So we can set the background color of the navigation bar by selecting it in the document outline and heading over to bar tint. And we can select a nice color, maybe a nice blue. And the next thing I want to do is change the text color. So I'm going to change it from black to white. So that's looking pretty good. So I'm pretty happy with the design. Now the next thing I want to do is to set up the code file. So let's go over to to-do list viewcontroller.swift, and we've already inherited UI table view controller. So whereas before in FlashChat, we kept the view controller as a subclass of UI view controller, in which case we needed to add the whole self.tableview.delegate, and we need to link up those IB outlets. By simply inheriting a UI table view controller and adding a table view controller to the storyboard instead of a normal view controller, all of that is automated behind the scenes by Xcode, and we don't need to link up any IB outlets. We don't have to set ourselves as the delegate or data source. It's all taken care of by Xcode. Now, the first thing I'm going to do is I'm going to delete this did receive memory warning to declutter our code a little bit. So I'm going to create a brand new item array. And in this array, I'm going to create some hard-coded items to be listed in our to-do list on startup. So obviously you can put any to-do list items you want here, but I'm going to go with the Stranger Things theme, and I'm going to list some to-dos. So I've got 3 strings in my item array, and they are going to be the text for cell 1, cell 2, and cell 3 in my table view. So now, at this stage, I want to set you the challenge of creating the table view data source methods. So if you remember, there are 2 methods that we created in FlashChat, which allowed us to specify what the cells should display and also how many rows we wanted in our table view. So you can pause the video and complete the challenge, and if you've done it right, once you run your app, you should be able to see these 3 items listed in 3 cells on your table view. So go ahead and do that. Alright, so how did that go? So the first data source method that we're going to add is the number of rows. So if we just start writing table view, then you can see that we've got this whole big selection of different things that we might want to include. And the one that I want is number of rows in section. So I'm going to go ahead and click enter, and it's expecting an output in a return statement that will be the number of rows. So I'm going to simply return the item array dot count. And that is going to create 3 cells for me in my table view. Now the next data source method I want is another one beginning with table view, but this is going to be self a row at index path. And I think it's this one. Ask the data source for a cell to insert in a particular location of the table view. So that sounds pretty much like it, and it's table view self a row at index path. Okay, so perfect. Now here, firstly delete the placeholder. Next, we are going to create a cell that is going to be a reusable cell. So we're going to use table view. And you can see that there's 2 table views that come up that looks pretty much identical to each other. But the only difference is this little symbol on the left here. Now, if you want to know what all of these symbols mean, I'm going to include a link in the resources for this lesson to a list for the geeky ones out there who want to see what each and every symbol mean. And this is called CodeSense. And it's a whole bunch of symbols that help you make sense of what it is that Autosuggest is recommending. So this is a really good reference if you want to understand that a little bit more. So on the top, we've got what's called a local variable. And at the bottom, we've got the global variable. So where do these 2 come from? Now, this global variable is what we get by subclassing this UI table view controller. It's the same as if we created an IB outlet from the table view on the main storyboard and called it table view here. It's just the default name that's given to that table view outlet. Now the local variable here comes from this method as one of the parameters. Now in this case, it doesn't actually matter which one you choose because they're both going to refer to the same thing. And once you click enter and you hit dot, then you're going to be able to tap into DQ reusable cell with identifier for index path, which is the method that we want. So the identifier is of course the identifier which we gave to our prototype cell, which was to do item cell. And we can paste that in here. And the index path is going to be the current index path that the table view is looking to populate. So once we've got our cell DQ'd, the next thing to do is we're going to set the text label, right? This is the label that's in every single cell. And we're going to set its text property. And we're going to set it to equal the items in our item array. And at the index path, that we're currently populating, dot row. So the current row of the current index path. And finally, we're going to return our cell, as this method expects an output. And that cell that's been created using our reuse prototype cell and that has been populated with text for the current row is now returned to the table view and displayed as a row. So let's go ahead and hit run and see what it looks like. Alright, so you can see that we've now got 3 hard-coded items that's populated our table view, and you can drag up and down, but there's not really much else to see. So if you managed to get this far all by yourself, then that's great. If you didn't and anything seemed confusing, then make sure that you have a look back at the parts where we coded up the table view and where we did the animated explanations of table views in the Flash Chat module. Because table views is part of the bread and butter of any iOS developer. So it's really, really important that you know how to get it right. Now, this table view that we've created in this case is a lot simpler than the one that we had in Flash Chat, because Flash Chat was all about table views, whereas it's only going to be a very little part of this app. So we're using as much help as we can get from Xcode and using a lot of the template code that they can provide for us. By subclassing this to-do list view controller as a UI table view controller, we've gotten a lot of stuff for free. We didn't need to create our IB outlet. We already have access to this thing called table view, and we also didn't need to say table view dot delegate equals self or table view dot data source equals self, and that's all because of this one single powerful subclassing that we've done here. So this is a good time to review table views if you're at all confused. Otherwise, we're going to continue on to the next lesson, and we are going to start making our app work as a to-do list app. So I want to be able to click on these cells and to be able to know which cell I clicked on. So I'll see you in the next lesson. Now, in the last lesson, we created our table view and populated it with 3 hard-coded items for our to-do list. Now, in this lesson, I want to be able to select each of these cells and have it printed in my debug console. And then I want to be able to give it a check mark every time I click on each cell, and then uncheck it if I click it again. So to code this up, the first thing that we need is some table view delegate methods. So as a challenge, I want you to create the table view delegate methods below this pragma mark, and it's going to be the one that gets fired whenever we click on any cell in the table view. Now, you've used this method before, so either have a look back or have a quick Google and see if you can work it out. So pause the video and complete the challenge. Okay, so do you remember what the method was called? So as with all table view delegate and data source methods, the easiest way is just to start writing table view and see what auto-suggest comes up with. And the one that we want is did select row at index path. And as you can see, it tells the delegate, which is this current class, that the specified row is now selected. So that's exactly what we want, right? So let's go ahead and delete that code placeholder, and we're going to print the index path dot row. So this is going to print a number into the debug console when we select one of the cells, and that number is going to correspond to which cell we selected. So let's give it a go. Okay, so let's try the first one. So I get 0, 1, 2. So that's working pretty well. Now, the next thing I want to do is, what if instead of printing out the row, I want to print out the corresponding item in the item array. So pause the video and see if you can do that. So all you have to do is to add item array in front, and then we're going to select the one at 0, 1, or 2. Great, so that's working perfectly. Now, there's one thing that I don't really like about the user interface, and it's the fact that whenever I select it, it always highlights the cell in grey, and it doesn't look like how a normal to-do list would function. It would maybe flash grey and then it would disappear and go back to white. So we can achieve that by simply writing table view dot deselect row at index path, which is the current index path, animated true. So now you'll see the behavior looks a little bit different. So now when I select it, it flashes grey briefly, but then it goes back to being deselected and goes back to being white, which looks a lot nicer in terms of user interface. So the next thing we want to achieve is I want to have a check mark next to the cells which I have selected. And in order to do that, we're going to use something called an accessory. So if you go to your main.storyboard and you select your prototype cell, not the content view, but the actual cell, then in the attribute inspector, you've got this property called accessory, and it's by default set to none. But you can see that there's a whole bunch of different things you can have. You can have a disclosure indicator, which indicates to people that if you select this cell, it'll take you somewhere else. Or a detail disclosure, so it has a little info button. Or in our case, what we want is the check mark, which ticks off the item that we have selected. So let's send it back to none so that they're not selected by default when we run our app. And let's add a method inside our didSelectRow at index path method so that we give the cell that was selected a check mark as an accessory. So let's comment out our print statement and use what we've done here in order to add a check mark. So let's select the table view dot self of row at index path, and this is grabbing a reference to the cell that is at a particular index path. Now, which index path are we going to specify? Well, obviously the one that's currently selected. So that's the local variable here called index path. So the cell at this index path in our table view is going to have an accessory type of dot checkmark. And now if we run our app, you'll see that every time I select a cell, it gets a check mark. But we haven't added any code to remove the check mark. So when I select it again, it doesn't change anything, because all we're saying is add a check mark whenever a cell gets selected. And if it gets selected more than once, then we don't have any way of deselecting the cell. So how can we remove the check mark when it's already been selected? So if you want to think about this problem and figure it out, then this is a good point to pause the video, because I'm going to show you the solution. So what we need is a conditional. We need an if statement. We need to say that if the table view's current cell at the current selected index path already has an accessory that is a check mark. So if we copy that here, but instead of having the single equals, which is the assignment, we have two equals, which is checking. So check to see if the current cell that's selected has an accessory type of check mark. And if so, then we want to change it to none. But otherwise, i.e. if it doesn't have a check mark, then we want to say add a check mark. So we can now safely delete this line of code, and let's run our app to see if that worked. Okay, so now if I click on one of them, I get a check mark, and if I click on it again, then my check mark disappears. So it's all looking pretty good, right? So now we've added our table view delegate method that detects which row was selected, and we use that information to check to see if the selected row has a check mark already, and if it does, then we're going to change its accessory to none to remove the check mark. Otherwise, i.e. if it doesn't have a check mark and we selected it, then it's going to have the check mark accessory. So at this point, we've got a very, very simple but barely functioning to-do list app. In the next lesson, we're going to add some more functionality to our app so that instead of just having hard-coded items, we can actually add new items to our to-do list. So all of that and more in the next lesson. I'll see you there. So up till now, we've created a brand new table view controller that's embedded inside a navigation controller. So we have this top bar here for our To-Do app. We've added items that have been hard-coded, and we're able to now select them and add a check mark, or deselect them and remove the check mark. Now let's go back to our to-do list view controller and add some more functionality. We wanted to be able to have a button on our app that allows us to add new items to our to-do list. So the easiest way of achieving this is by adding a bar button item to our to-do list view controller. So if we go ahead and search for a bar button item, and we can drag it up to the top right here of our top bar. And I'm going to change the system item to add to get this nice little plus sign. And I'm also going to change the tint to white so that it matches my current palette. So now that I've got that going on, I'm going to link this into my file as an IB action. So I'm going to scroll down all the way to the bottom. Going to make a new pragma mark, and this is going to be the add new items section, and then I'm going to create my IB action right here. I'm going to change from outlet to action, and let's call it add button pressed. Change it from any to more specific UI bar button item, and hit connect. So now I've got this brand new IB action where I can add code to determine what should happen when the user presses that add button. Here, what I want to happen is for a pop-up or a UI alert controller to show when I press the add button, and to have a text field in that UI alert so that I can write a quick to-do list item and then append it to the end of my item array. So let's create a brand new alert. So let alert equal UI alert controller, and it's going to be the one with title, message, and preferred style. So the title will be something like add new to-do item, and the message I'm actually going to leave blank, and the preferred style is just going to be alert, the default style. And then I'm going to create an action. So this is going to be a UI alert action, and this action is going to have a title, a style, and a handler. So the title will be add item. So this is going to be the button that you're going to press once you're done with writing your new to-do list item. The style is going to be default. And the handler, I'm just going to select this placeholder, so make it blue. I'm going to hit enter to create a completion handler or a closure. So the action, I'm going to name action, and I'm going to delete the code placeholder. And here is going to be what will happen once the user clicks the add item button on our UI alert. So now let's add the action to our alert. Add action. The action is called action. Now this is all very well and good, and we can check to make sure that it works by saying print success. And finally, we need to show our alert. So we're simply going to say present, and it's a view controller that we want to present, and the view controller to present. And the view controller is, of course, our alert view controller, animated true, and completion nil. Now let's hit run and see what we've got so far. So we've got this brand new add button as a bar button item, and when we click on it, we activate this IB action, and we've created this brand new alert. So now when we click add item, all we get is just success printed to the debug console and nothing else. Now, what I want to happen next is instead of just having a simple UI alert, I want to include a text field in this alert so that I can get the user to write a new to-do list item, and then when I click add item, I'm going to print what they wrote into the debug console here. In order to add a text field to our alert, it's very similar to adding an action, but all we have to do is say alert.add text field, and in the completion handler, we're going to select this placeholder, make it blue, and then hit enter to insert that closure. We're going to call the text field that we create alert text field, and in the completion block, we're going to set up the alert text field. So we're going to say alert text field dot placeholder. So this is the string that's going to show in gray, and it's going to disappear when the user clicks on that text field. So placeholder is going to say something like create new item, and then we're going to print whatever text is inside the alert text field. So alert text field dot text. So let's go ahead and run this and see what happens. So let's click the add button. You can see now we have a UI alert that has a title, a new text field, and also a button. So it's got that placeholder there where it says create new item, and as soon as we start typing, that placeholder is going to disappear. So let's say our new item is save the world. And if I click add item, that disappears. And the problem that we have is that the point at which we click that button, we can write some code that specifies what should happen once the user clicks the add item button on our alert. But the alert text field is created as a local variable only inside this closure. So how do I grab what exists in here and print it once the user presses the add item button? So this is a bit of a tricky question, and you can have a think about it and see if you can figure it out. Then this is a good time point to pause the video. But if you want to follow along with me, then I'm going to show you the solution. So essentially what we need is a local variable inside this IB action. So inside the scope between these two curly braces that's accessible to all of these other completion handlers. So currently, I've got this alert text field that has the scope of just this closure. And if I want to change its very, very limited scope, i.e. being available just inside here, then I have to create a local variable within the scope of this add button pressed. So anywhere that's outside of one of these closures. So what we can do is we can create a text field up here, which is going to be a UI text field, and we're going to initialize it to an empty UI text field. Now this text field has the scope of the entire add button pressed IB action and is going to be accessible inside here as well as inside here. Now, at this stage, what we can do is we can set this text field with a wider scope to equal the alert text field that has a slightly narrower scope because it's only available inside here. So if you write alert text field, you can see the auto suggest come up here. But if you tried it outside the closure, alert text field, nothing happens because it doesn't exist outside the scope of this closure. So we're extending the scope of that alert text field to this add button pressed. Now, the sequence of events matters a great deal. You might think that you can simply write print alert text field dot text, but the reason why this is not going to print you what the user has typed into that text field is because this closure only gets triggered once the text field has been added to the alert. So it's at this time point when it happens. And what we can do is we can print something to our debug console to see when this closure gets triggered. So if I hit run, and let's just move that over here and make our debug console a little bit bigger. Now I'm going to click add, and you can see that this line here, where it says optional empty string, refers to this print statement. It's trying to print the text that's currently inside the alert text field, which is of course empty. And we get the now printed at the point when our text field is added to the alert. So when it shows up here. But when we type something in here and we click add item, nothing happens. There's no print statement that happens because that time point is covered by this completion block. When the user clicks the add item button, this is the place that we're going to get something happening. And we can show that by just using a print statement here. So you can see that as soon as I press the add button, that's when the now gets printed. But when I click the add item, that's the point where we get the add item pressed printed, because this is the completion block that gets called once that add item button gets pressed. So we can solve that timing problem by simply storing a reference to that alert text field inside a local variable that's available to everybody inside the add button pressed. And this text field is what we're going to print inside here. So we're going to say print text field dot text instead of this print statement. And I'm going to delete that print now as well, and I'm going to hit run. So now when I press the add button, I don't get anything printed in here other than not very useful messages from Xcode. But if I now write something in here and I click the add item button, I get whatever I typed into that text field printed out here because of this print statement. If that seemed confusing, it might be a good point to review the lessons on scope that we covered earlier on. Now, it's really important that you understand where these local variables are available and how you can use them to store data and read data. So instead of this print statement, what we actually want to happen is we want to add whatever text the user created to our item array and append it into this array at the end. Now, before we can append an item to our item array, we first have to change this array from being immutable, because it's a constant, to mutable by getting rid of that let and changing it to a var. So now what we can do is we can say item array dot append, and the new element that we want to append has to be a string, and it's going to be text field dot text. And we're going to force unwrap that because the text property of a text field is never going to equal nil. Even if it's empty, it's going to be set to an empty string. Now you can add some more checking code in here to maybe prevent the action from going forwards if the text field was empty, or add some more validation code. But for now, we're just going to say that if the user entered nothing, we'll just simply have an empty cell. Now, it's not ideal, and there's quite a few workarounds to this. For example, we can give it a default value if it was nil. So we can say if textfield.text was nil, then simply append the string new item. Now, that doesn't really look much better than an empty string, so that's not a great solution. A more sophisticated solution would be to prevent the action from going through if the textfield.text was empty. But that's going to take a lot more lines of code, and right now we want to focus on our objective here. So itemarray.append textfield.text, and because I'm inside a closure, remember the in keyword, I have to specify self to tell the compiler explicitly where this item array exists, i.e. in the current class. So now if I run my app, you might expect it to work because we're appending whatever the user adds in the text field to this array, and our table view self row at index path uses this array. But as you'll shortly see, if I click on the Add button and I add a new item, and I click Add Item, nothing changes in my table view. The table view hasn't changed one bit, despite the fact that we've added what the user wrote in the text field into our item array, and our cell's text label is created from the item array. But if you'll believe me, I can tell you that it's definitely been added to this item array. So why is it not showing up in our table view? If you don't want to believe me, that's also perfectly valid. It's always a good idea to test and not trust. So what I can do is I can put a breakpoint at this line where we've appended that item, and I can stop the app and run the app again. I'm going to add a new item. And once I hit Add Item, same as before, but we now enter our debug session because our breakpoint is triggering it. So at the moment, before this line is carried out, and I print in my debug console the current value of item array, and I hit Enter, you can see that it's only got 3 items: Find Mike, Buy Egos, Destroy Demogorgon. Now, if I choose to step over this instruction, so carry it out, now if I hit Print Item Array, hit Enter, you can see I've now got 4 items, and that item has been added to my array, item array. So now I hope you'll believe me. But what do we do about this? How can we get it to show up in our table view? And the magic method is reload data. And this reloads the rows and the sections of the table view, taking into account the new data that we've added to our item array. So now if I hit Run, and I add a new item to our to-do list, and I hit Add Item, then it reloads the text field, taking into account the new array, and now it populates my table view. So in this lesson, we looked at a couple of things. We added a new bar button item, we created an IB action, we create an alert that has an action as well as a text field, and once the user clicks the Add Item button in our alert, then we add whatever they wrote in the text field to our item array, and then we reload the table view to show that data. So in the next lesson, we're going to be getting on to our main topic, data persistence. What can we do to persist the data? I'm going to show you the problem that we currently have, that we're not yet aware of, but you're going to see it very soon. And then I'm going to show you one of the easiest ways of persisting data. So all of that and more on the next lesson. Alright, so in the last lesson, we managed to get this far. We've got a to-do list where we're able to add items through the UI alert controller, and we've also got this table view that allows us to check and uncheck items in our to-do list. Okay, so I mentioned in the last episode that I was going to show you how we actually have some bugs in our app, and the problem occurs when your app actually disappears from the memory of the phone. So if we have a look inside app delegate, now we've not really talked about many of these delegate methods, but this is a good time to do so because we're going to use it to show what's actually happening when your app is going into the background. So the first thing here, this method where it says did finish launching with options, this is a place, this gets called when your app gets loaded up. So it doesn't matter if the rest of your app is going to crash. This is the first thing that happens, and this happens before the view did load inside the first view controller or the initial view controller. So if we make a print statement here and says did finish launching with options, so that we can see when this gets called. And the next thing is this one, which is application will resign active. And this tends to get triggered when, say, something happens to the phone while the app is open, i.e. in the foreground. So say if the user receives a call, this is the method where you can do something to prevent the user losing data. So for example, say if they were filling in a form in your app, and in the middle of it, they get a call from somebody. Now, it would be really annoying if by the time they get back to your app, that your app's actually been terminated and they've lost all of their data. So that's another time point. Now, this is another one that we're going to look at today. Now, this is application did enter background. And this happens when your app disappears off the screen. So when you press the home button, for example, or when you open up a different app, it's like a deck of cards. There's another card that's being placed on top of the deck. So your app is no longer visible and it's entered the background. Now, the other one that is super important is the application will terminate. And this is the point where basically your app is going to be terminated. Now, this can be user triggered or it can be system triggered. So say if the user has pressed the home button to quit your app and they decide to go into a different app, if this app happens to be a really resource intensive app, say a game like Hearthstone or something, then it might reclaim a lot of the resources that are being hogged by your app. Even though it's in the background, it might still have processes that are running and is using up the precious memory of the iPhone. So in those cases, when the resources gets reclaimed from your app, then it goes from being in the background to being terminated or assassinated basically by the operating system. Now let's run our app again and see when each of these messages gets triggered. So the first thing that happens is did finish launching with options, and that happens at the moment when your app first loads up. And then the next thing is that if we press the home button, your application goes into the background. And similarly, if I double click and go to a different app, your application also enters the background because it's no longer the thing that you see on the screen. So the next one is, how do you terminate your app, right? Well, this can happen because the operating system triggers it because it needs to reclaim those resources, that precious memory, or the user might trigger it themselves by force quitting your app. So if you double click on your home button, now sometimes it doesn't work very well in the simulator, so just bear with it, but try it a few times and you should get to this type of screen. And this is a place where you can browse through all of the apps that are still in the background, but you can also hit it and swipe it up to quit, to force quit that app. And that's the moment where you'll get application will terminate. And that is this delegate function. Now, some of the logical things you might want to do, for example, is that, in your form filling application, you'll probably want to add some save methods to application will terminate, or even better, to application did enter background, because it's such bad user experience to go back into your app and find that all of the data that you've been entering for the last 5 minutes has just now disappeared. It's a sure way to get bad reviews. So your app has a distinct life cycle where it goes from being launched to being visible on the screen to entering the background and finally being destroyed and the operating system reclaiming the resources from it. So just as we have life cycles, we were born, we live, and we die, so do apps. So now that we've cleared up what most of these delegate methods do, I want to show you where the problem lies in our app. Now, I know that in previous modules, I tend to get rid of the bezel because that allows us to have a bigger screen. But in this case, because we're using the home button quite a few times, so if you want your bezel to come back, you can always go to Window and Show Device Bezel to toggle that. Okay, so here's our app as it appears when it first loads up. And I'm going to add a new to-do item. And when I hit add item, you'll see it appear in our table view because we're adding it to our array and we're reloading the table view. Now, if I hit the home button and my app enters the background, it still keeps a hold of that data in the memory of the phone. So when I reopen it, you can see that it still exists. Now the problem occurs when the app doesn't just enter the background, but actually terminates. So all the scenarios where this might happen is your operating system trying to reclaim resources because the user is trying to use like a really memory intensive app. Second option is if the user force quits your app. Third option, if you installed an update to your app. Fourth option, if the user updated their operating system. There's so many cases where your app is probably going to end up terminating. And when that happens, so let's try that again. Let's terminate our app. Application will terminate, right? So now it's gone from the memory of the phone. And if we click on it again, you can see that new item that we added is now gone. And this is because we don't have any form of persistent data storage. We're only adding and appending to our array, and that array is only going to be held in memory for as long as this to-do list view controller exists, and it's going to disappear and be destroyed if the application gets terminated. So this is why we need persistent memory storage, but there's actually quite a few options you have in terms of how you want to persist your data. So in the next lesson, we're going to talk about one of the easiest ways of persisting small bits of data, and that's through using NS user defaults. So I'll see you there. Alright, so in order to use user defaults, we have to create a brand new object. So let's call it defaults, and we'll set it to equal user defaults, which is an interface to the user's defaults database where you store key value pairs persistently across launches of your app. That's exactly what we want. So let's hit user default, and we're going to set up a standard user default. So now that we've got that set up, we can go down to the part where we add a new item to our to-do list, and we append it to our item array, which is this thing here. Now what we can do is we can save that updated item array to our user defaults, and we can do that in a single line of code by writing defaults.set, and we're going to use value for key, which takes any object, and in this case it's going to be an array, or rather self.item array, because remember we're inside a closure here, and the key is going to identify this array inside our user defaults. So let's call it to-do list array, and of course because we're inside a closure we have to add self to our defaults as well, and see if it works. Alright, let's go ahead and add a new item. Hit add item, shows up in our table view, but as you'll see, if I delete our app and reopen it again, it does not show up. And the reason is not because our code didn't work or that we didn't manage to save our item array into our defaults. The reason is because we haven't used our saved item to load up the table view. It's still getting all of that data from our item array, which does not persist, remember? But we can actually view our data inside our user defaults, and we can prove that the data has been saved. Now, user defaults get saved in a plist file, and that's why everything you put in there has to be a key value pair. So you always need a key that you're going to use to retrieve the item, and then you add the value. It could be anything. It could be an array, it could be a dictionary, string, any data type in there, and you can grab it back using this key. So how can we find our user defaults file so that we can see our data? In order to do that, we need to grab the file path of our sandbox that our app runs. We need to get the ID of the simulator And we also need the ID of the sandbox where our app lives in. Now, it sounds a little bit complicated, but it's actually quite simple. Let's go into our app delegate at the did finish launching with options delegate method, which we know always gets called. And here we're going to write a little bit of code in order to print out the path for our user defaults file. Now, at this point, if you want to follow along with me and see this file path, make sure that you ran your app inside the simulator and not a physical device, and also that you've added a new item to your table view. So let's go ahead and print this search path. So it's ns search path for directories in domains, and the directory is the document directory, and the domain mask is the user domain mask, and expand tilde will go for true, and then we're going to get the last item in this array, and we're going to print it as a string. Now, don't worry too much about this line. I'm just using it to print and to prove to you that our data has been saved somewhere, even though it's not showing up. So let's run our app again. And as soon as our app launches, we can see this file path here. Now we can use that file path to go into our Finder and try and locate this plist file that stores our data. So this starts off in our root, which is our Macintosh hard drive. And then we're supposed to go into users. And this is my username on this laptop. And then we're going to go into library, developer, Core Simulator, Devices, and we have to search for this 8D49, looks like that one. So this is the device ID. So this is called a UUID, and it identifies our device uniquely. So that could be our simulated device, or it could be a physical device. So this corresponds to this particular simulator instance that I've got launched here. And then I have to go into data, containers, data again, application, and then I have to search for the application. And that refers to the unique ID of this To-Doey application that I've launched earlier on, where I saved my data. So now we're entering the sandbox, essentially. And this is going to be called E5. So let's look for something that is E5. Now, a much easier way to do this would actually be sorting this or searching it, but I found it right there. So E50. This is basically our app To-Doey. Now, it would be easier if they called it To-Doey, but then that wouldn't be unique. So here's our app sandbox, and once you've gotten here, you're going to look inside library and preferences. And now, finally, you get to your plist. And if we expand it, you can see that it says com.londonlibrary.todoey.plist. Now, if we double click on it, it'll open by default inside Xcode, and you'll see that we have this key that we used earlier on, where we said save it under the key to-do list array. To-do list array here, that's the key. And the value is an array. So Swift is clever enough to figure out that our item, the data type, was an array data type. And if we expand this, we can see that there's 4 items in there, and our latest item was in fact saved. So why is it not showing up in our table view? Well, it's because we haven't used it to retrieve the data. Now, all we need to do in order to retrieve our data is we can go into View Did Load, and we can set our item array to equal the array inside our user defaults. So item array equals defaults dot array for key. The key is, of course, to-do list array. Let's just double check because it's a hard-coded key. Just make sure that it's exactly spelt the same. Yeah, looks good. And we're going to cast this as an array of strings. So that's all very well and good if our to-do list array actually exists. But if it doesn't, then our app is probably going to crash. So to prevent this, instead we can write this as a if let items equals defaults.array for key as array of strings. And if that works, then let's say item array is now equal to items, and we can get rid of that forced downcast, make it an optional. So now let's run our app and see if it works. Well, hey, so our last item that we saw inside the plist now exists inside our table view, and also if I add any new items, then it also shows up in our table view. And you can see it appear both in the user default plist as well as when we terminate our app and reopen it. So that was a quick intro into how we can use user defaults to persist data. Now, in the next lesson, we're going to talk about user defaults in a little bit more detail and talk about which scenarios and situations should you be using this. So all of that and more on the next lesson. See you there. Now, throughout your journey as an iOS developer, inevitably you will come across user defaults, and you'll probably use it in quite a few of your projects because it's really simple to use, very flexible, and doesn't take very many lines of code. Now let's have a look at some of the things that you can do with user defaults. Let's establish a default and we'll call it. Now remember, when you create property names or variable names, you can't call it certain words like default or class. And you can tell because it highlights it in a different color, in this sort of pinkish color. That tells you that this is a keyword that's reserved for certain uses. So let's create a new user default called defaults, and we'll set it to equal user defaults.standard. And let's see what are some of the things that we can set into our user defaults. So we can write something like set URL for key, set value, which is type optional any for key, so we can use optionals. We can set booleans, doubles, floats, integers. So one of the scenarios that you might find yourself using user defaults is saving user preferences inside your app. So for example, if you had an app where you allow the user to set the music volume, you might say something like set 0.24 for key volume. And that means that at a later date, you can say let volume equals defaults dot float for key volume. Then you can use that persisted data for volume to always set your games or your app's volume to 0.24, which is what the user prefers. Now, aside from floats, you can also use set on booleans. So, for example, we'll set true for the key music on, so that every time they open up your game, you always have the music on or the music off, depending on their preference. And there's a whole bunch of other ones I'm just going to quickly run through. So you can obviously set strings, right? So for example, you might have player name. You can also track user behavior by using defaults like set use any. We'll use the current date by just tapping into a new object of date, and the key is going to be app last opened by user. And you can see that when you try to retrieve this, let's app last open equals defaults dot object. Now we're using object because we're not trying to grab a float, an int, or a string. We're trying to grab something that was saved using optional any. So we should try and get back using the method that grabs us an optional of any data type. So let's hit object for key, and I'm just going to paste that incredibly long key into here. And now you can see that app last open is set to equal the time when this default was set. And of course, every single time I run the app, it's going to change that time just by a little bit. Cool, so we've seen some pretty standard data types being saved. Now, if you want to get really fancy with your defaults, you can also save collections, like let array equal 1, 2, 3. And we can say defaults set value of optional any to array. And for key, let's call it myArray. And there's a special method that allows you to get that array back by using defaults.array for key string. And it's going to be myArray. Now, you can either let Swift infer what's the data type of the objects contained inside the array, because if you option click on this array here, you can see that when we use defaults to retrieve an array out of user defaults, the return type is actually an optional array, and it doesn't know what is the data type that's contained inside the array. So if you want to be more explicit, you can downcast the array into an array of integers. And we can do that safely because we saved it here, and we should know what the data type is that went into that default for the key myArray. And similarly, you can do the same thing for dictionaries. And let's just say let dictionary equal name, modular, and we'll say defaults.set, and of course we're using any again, and we're going to put our dictionary in there, and we'll call it my dictionary. And then we can retrieve it over here by using defaults.dictionary. And we'll put the key back in. Now, the spelling of your keys matter a great deal, and if you get the case wrong, or if you spell it even slightly wrong, it's probably going to crash your program. So it's usually a good idea to create a constant at the top when you're trying to access these things, like for example, dictionary key, and we'll set it to equal my dictionary. So that way, instead of putting my dictionary as a string in all of these places, you can simply use your dictionary key in all the places where you need to access it. And this way, if you do need to change your key, then you can do it in one place. And also, if you do have any errors, it's much easier to trace and debug. Alright, so that's a little bit of an overview of user defaults and what you can do with them. As you can see, they're really flexible, really adaptable, and that's one of the reasons why they're prone to abuse. Now, you should only really be using user defaults to persist small bits of data. Anything that's a few kilobytes, like a volume here and there, or a boolean, or maybe the player names. The danger is once you start getting into saving arrays or dictionaries, that the data starts getting really, really big, really unwieldy, and unmanageable. Now, the reason why we say that is because user defaults is not a database, and it should not be used as a database. As we saw earlier on, all of these key value pairs get saved into a plist, and that entire plist of your user defaults has to be loaded up synchronously, so all of it gets loaded up before you can access any of the values contained inside the keys. So that means that if you're looking for something really small, like the volume that was saved, which is going to be just 0.24, which is a very small piece of data, even to grab that small piece of data, your iPhone or your simulator or whatever device you're running your app on has to load up the entire user defaults plist. So everything that you store in it has to be loaded up. And that means that it can be very time consuming if you start saving large bits of data in there. And certainly across the internet, you'll come across various implementations on Stack Overflow or GitHub where people are basically trying to use user defaults as a database. But just keep in mind, it's not a database and it shouldn't be used as one because it's going to have significant impact on the efficiency and the speed of your app. Now, one of the things that people always find really mysterious about user defaults is, how is it possible that I can simply use user defaults across all classes and objects and I still get back the same item? And the reason for this is because it's quite special. It's what's known as a singleton. And in the next lesson, I want to show you what singletons are, and it'll go some of the way towards understanding how user defaults actually works. So I'll see you there. Now, in quite a few places, you'll see these things. For example, user defaults, or For example, shared URL session. These are all what are known as singletons. And what's special about singletons is that there is only one copy of it that can be shared across all of your classes and objects. Now, let's say we create a new class that's called car. And by default, I'm going to give it a property called color that's going to be set to equal red. Now, say later on we create some objects. We create my car equals car. And we're going to set my car's color property to blue. So say my favorite color, right? Now, let's say we create another object of car and we call it your car. Now, if we try to print your car's color property, can you guess what the value of it will be based on our code? So the value of it is red. And that's because it's a new object that has nothing to do with this object, my car, and it's getting its color from the default, which is the color red. Now, let's try and do the same thing, but this time we're going to create a singleton. So let's create a new class, and I'm going to call it exactly the same. I'm going to call it car, and I'm going to have a property called color, which equals red. Now, the special thing inside this class is that I'm going to create a singleton. I'm going to use the static let keywords, and I'm going to call my singleton car. And this is going to be set to equal a new object initialized from its own class, the car class. Now, instead of creating a new object of car in this file, I'm going to create a new constant that holds a reference to our singleton. So let's use the same name. Let my car equals car dot singleton car. And I say my car dot color equals blue. Now later on, let's create another reference to our singleton. Let's call it your car. And we say car dot singleton car, and we try to print the value of your car's color. Now in this case, we get blue, because it doesn't matter how many constants or variables or different ways that we point towards this singleton car, it's always going to be the same copy. So I can use it in different objects and different classes. So let's say class A. So where when we initialize class A, we set car dot singleton car dot color to brown, and class B we print car dot singleton car dot color, and we initialize A and B as new objects. You can see that even though we're affecting the color of this singleton car in completely different classes, it's still tapping into the same thing in the entirety of this file. Every single time we're trying to change, or rather get and set our singleton car, it's always been the same object. And when we think back to our user defaults, it's exactly the same. We're using that user defaults dot standard as a singleton to this user default. So you can see that this line and this line look structurally the same. And that's because inside this class called user defaults, there is a singleton called standard. And this points towards the same plist every single time we tap into the user default. So we're always retrieving and saving to the same file. And it stays the same across all of our classes and all of our objects. So singletons exist in other programming languages aside from Swift. So if you've programmed in other languages, this concept might not be new to you at all. But if this is the first time you've ever come across the singleton, or how it works, or what it's all about, it might be worth having a read of the Swift documentation, which I'm going to link in the resources for this lesson. And if you want to learn more about user defaults in terms of all the different default values that you can store and you can retrieve, then have a look at the documentation, which is really good on this. So our app is looking pretty nice, but up till now, there's always been a really serious bug that we haven't yet discovered in our app. Now, if you've been playing around with the app quite a bit, you might have discovered this bug already. But if you haven't, let me show you what it is. Now, I'm going to add a whole bunch of new items into our item array so that when I run my app, I'm going to have more than 3 cells. In fact, I'm going to have more cells than the table view can possibly display. So when I scroll, you can see that even though the table view is at J, if I keep going, it goes all the way down to O, right? So now, if I click on the first cell, and it checks the first cell, and I scroll down to the bottom, you can see that for some bizarre reason, our cell, that's called N, is also checked. And if I uncheck it, and I scroll back, my first cell is no longer checked. So what on earth is going on here? And what is happening with all this strange behavior? Well, the answer to this lies in the fact that table view cells gets reused. And that's what this line means when we're calling DQ reusable cell, right? We're saying that go and find that prototype cell called to-do item cell inside main.storyboard and generate a whole bunch of it that we can reuse. So that means when the first cell gets rolled off the table view and it's no longer visible, it actually goes all the way around and comes back underneath as a new reusable cell. So how can we prove that this is true? Do you remember last time when I asked you as a challenge, why is it that we need this tableview.dq reusable cell method instead of something like let cell equals a new object of type UI tableview cell, and we say the style is, say, default, reuse identifier is the same as we've got here, so that reusable prototype cell that we had. I'm just going to comment that out and let's run it. Now, if I check the first object and I scroll my table view until my cell disappears off the screen and I pull it back, you'll see that that check mark has disappeared. And that's because the checking or unchecking, I'm setting a property on the cell. And once the cell disappears off the screen, it gets deallocated and destroyed. And when I scroll it back, I'm actually getting a brand new cell that's getting this message put in. Now, on the other hand, say if I use DQ reusable cell, then in this case, when I check the first cell, I scroll it up, and at the point when that cell disappears off the screen, it comes around the table view and gets reinitialized at the bottom as a new table view cell. And because it's being reused, that property, that checked accessory, is still present here. And that's why we're getting this rather odd behavior. It's because we're reusing our cells. So we found the problem, and the problem is that we need to associate a property, not with the cell, but with our data. So in order for us to assign a check mark or no check mark to each of these items, we need a way to be able to associate each item with a property, checked or unchecked. Now, how can we do that? We certainly can't do it using just a plain old array, but if you pause the video and have a think about how you can associate a property with each of these items and see if you can come up with the solution. Alright, so some of the solutions that you guys might have thought of were maybe instead of using an array, is maybe to use a dictionary where you can have key value pairs. Or, and a much better solution, would be creating a model. And we've spoken about MVC in the past when we did Quizlet. And now this is another scenario where you start to see the beauty and the reasons why we need to start separating our models, our views, and our controllers. So let's go ahead and build a data model where each of our items are objects that can have properties, including the title of the item, and also a done or not done Boolean. So this is a good time point to pause the video and build a new class called item, which we can use to store two properties. One property is a string called title, which is where we're going to save the titles of our to-dos. And the other one is called done, which is a Boolean property where we're going to save whether if the item was checked off or not. So pause the video and give that a go. Alright, so let's go over to File, New File, and let's create a brand new Swift file. Hit Next. We're going to call our file item, and we're going to put our item into its own folder, so new group from selection. And the folder is going to be called Data Model. And we'll make a new group with our to-do list view controller, and we'll call it controllers. And we'll also, while we're at it, might as well put main.storyboard into a views folder. Alright, and finally, I'm just going to put the assets and the launch screen together as a group, and I'll call it supporting files. That just gets rid of it and declutters and makes our structure a little bit more clear. Alright, let's head into item, and we're going to create a new class that's called item. Now, of course, you don't actually have to name your class the same as the file name, but in 99.999 recurring cases, everybody does this, and it will be very, very odd if these two are not the same, and it's very confusing. So try to keep these two exactly the same. Okay, so we'll have a property called title, and this is going to be a string. And by default, we'll say it's just an empty string. And then we're going to create another property called done. And this is going to be a Boolean. And by default, all items will start off as being not done. So we'll set that as false. So let's go ahead and hit save and go back to our to-do list view controller. And we can start creating some of these items. So I'm just going to comment out this line. And I'm going to create a new item, and I'm going to use our item class to do that. And our new item is a new object of the type item, and new item.title is going to be equal to this. And instead of having an array of hard-coded string objects, I'm going to turn this item array into an array of item objects. And so none of what we've done so far should be new to you, because we've done all of this and more inside Quizlet. So if you're at all confused about MVC or models, views, controllers, then be sure to have a look back at the Quizlet module where we go into this in much more detail. So now we can say item array dot append, and we're going to append the new element, which is called new item. So I'm just going to go and copy and paste this for time's sake, and I'm going to amend the code so that we end up with new item 2 and new item 3. In addition to that, in order for our code to work, we need to fix it in a couple of places, because we're changing from an array of strings to an array of item objects. So if we go down here, item array.count is still valid because we have an array that has this property .count. Doesn't matter if it's an array of strings or an array of objects. But this part where we set the cell text label .text property, we need to change, because item array at index path row is going to return an item object. And what we need to do is we actually need to tap into its title property using the dot notation. And we also need to change the code where we're adding new items. So here, where we're saying self.itemarray.append textfield.text, that doesn't really work. Instead, we have to create a new item that is of the class item. And we're going to say new item dot title equals text field dot text. And then we can say self.item array append, and the thing that we append is now going to be our new item. And now if we hit run, let's see what happens. So our app is now working using item objects instead of a hard-coded array, but we still haven't fixed our checkmark problem because we haven't yet changed the done property when we toggle the checkmark. Also, we've not updated the code for our add button yet. In fact, if you click on the add button now, the app will crash. But let's do one thing at a time. Let's fix the done property first, and we'll tackle the add button in one of the upcoming lessons. So inside did select row at index path, let's set the property of the selected item. So we can tap into item array, and we can tap into the item at index path dot row, i.e. the current item object that's selected, and we can set the done property to equal the opposite of what it used to be. So if it used to be false, then we want to change it to true, and if it used to be true, then we want to change it to false. Now the long way of doing this is by saying if item array at index path dot row dot done equals false, then in that case we want to set the item array at index path dot row dot done to true. Otherwise we're going to say item array at index path dot row dot done equals false. And that sorts out the toggling, right? And we can add a bit of code to our self of row at index path, which, if you remember, is the delegate method that figures out how we should display each of the cells. And we can say if item array at index path dot row dot done equals true, then in that case we're going to set the cell dot accessory type to equal checkmark, and otherwise we're going to set the cell dot accessory type to equal none. So that means we can get rid of these 3 lines of code. Now our code is incredibly wordy at the moment, but it's good to have it like this when we can test it and see if it works before we start refactoring and making things look a bit simpler and cutting down our lines of code. So now when we select our cells, you can see that we've actually broken our app, because while it's selecting and deselecting, it's not changing the checkmark one bit. Now why might that be? The reason is because self of row at index path is called initially when the table view gets loaded up, and at that time point none of our items are done, so none of them get an accessory mark. So if we changed one of these, let's make the first one, for example, new item dot done equals true, then you can run your app and confirm to yourself that your code is actually working. This part, or we say if item array index path dot row is done, then make the check mark. It's working, because you can see when we first load up our app, you see that check mark there. So the problem that we have to solve then is, how do we get this delegate method to trigger again once we've changed the item's done property? So the magical method here is tableview.reload data. And we've seen this before, and we've used it before in Flash Chat. But what it basically does is that it forces the table view to call its data source methods again, so that it reloads the data that's meant to be inside. So if we go ahead and put a print statement here, cell for row at index path called, you can see that it got called 3 times, iterating through our array of items when the table view first loaded up. And now when I select one of these cells and I trigger the did select row delegate method, and we've set our done properties, and we get to this line where it says tableview.reload data, then we're going to see it called a couple more times. So watch as I select one of these. And you can see that we've got 3 more printouts of self-arrow index path because the table view is refreshed, and it's called that delegate method self-arrow index path 3 more times for every single item we have in our array. And now our check marks also work, right? Brilliant. So now let's check and make sure that we've solved that bug that we had earlier on. So if we go underneath the 3 items that we carefully initialized and appended, I'm going to paste in just a whole bunch of appends of our new item 3 to the end of our item array. And that just adds way more items so that we can actually fill up our table view. So now, say if I check these first 2 cells, and I scroll down to the bottom, you can see that we no longer have that cell reuse problem. And it's because in every single one of these cells, we're checking to see what is the done property for each item, and we're displaying the check mark depending on what that property is, whether if it's true or false. So now that we've confirmed we've solved that bug, let's go back and refactor our code. And I'm going to get rid of all of this. Let's go back and refactor our code so that everything is more succinct. So the first thing that I want to change is all of this. And this is very, very inelegant. And I'll show you why. Because instead of doing all of this, what I could have said is item array at index path dot row dot done property equals the opposite of item array at index path dot row dot done. So that single line replaces all of these 5 lines of code, and it does exactly the same thing. It sets the done property on the current item in the item array to the opposite of what it is right now. If it's true, it becomes false. If it's false, it becomes true. And it's all using this not operator, basically reversing what it used to be. Because booleans can only have 1 or 2 states, true or false. So if we put the not true, then it becomes false. If we put not false, then it becomes true. So we can go ahead and delete all of that. Now the next thing that I want to address is I'm going to delete these 2 lines because we don't need it anymore. And here, instead of using item array index path dot row so many times, I'm just going to create a new constant called item, and I'm going to set it to equal item array at index path dot row. So this item is now the item that we're currently trying to set up for the cell. So then instead of writing this, I can simply write item dot title. And instead of writing this, I can simply write item dot done. But we can go even further than that to make this bit of code a lot shorter and a lot more elegant. And in order to do that, we're going to use the ternary operator. And this is, again, something that's not unique to Swift. It's seen in a lot of programming languages, but it's a really neat way of cutting down some code when we don't want to be so wordy. So to learn all about the Swift ternary operator, I will see you on the next lesson. So in the last lesson, we said that we were going to shorten these 5 lines of code using the Swift ternary operator. So the way that the ternary operator works is that we have a condition, just as we have conditions in if statements. We have this condition, and we check to see if it's true or if it's false. If it's true, then we set this value to a particular value if it's true. And if it's not true, then we set it to something else. So let's try and convert our 5 lines of code to this format. So the value in this case is the cell.accessory type. And we're going to set it to equal the condition, which is the same as what's between our if statement and our opening bracket. So whether if item.done is equal to true, and if it is true, then the cell.accessory type is going to be set to dot checkmark. But otherwise, i.e. if it's not true, then the cell.accessory type is going to be set to equal dot none. And that's a 1-line expression that does exactly the same thing as all of these lines. And we can make it even shorter by getting rid of this check. So this line now reads, set the cell's accessory type depending on whether the item.done is true. If it is true, then set it to .checkmark, and if it's not true, then set it to .none. So depending on how much you've used this ternary operator or how much you've seen it used, you'll begin to get comfortable with this expression. And admittedly, when you first see it, it looks like magic, right? It just doesn't look like real code because it's so short and it's, some would argue not as explicit as this. Now, because we've come such a long way, and a big shout out to everybody who's been following along up till now, you've amassed a lot of knowledge. And previously in my code, I've tried to make the code as explicit as humanly possible, even though sometimes it's very, very cumbersome. Now, as we're getting into the intermediate and advanced stages, I want to make sure that you learn and you can understand some of these ways that programmers will express their code to cut down on the number of lines and make their code look more succinct and more elegant. So when you come across something like this in the future, you'll no longer be confused as to what it means. So now I can safely delete all of that. And if we run our app, let's see if, despite deleting something like 10 lines of code, whether our app still works exactly the same. Let's just confirm. So I can safely confirm that our app works exactly the same as before. Even though we're making everything super short and super succinct, it's still behaving exactly as we want it to. So now that we've confirmed that our refactoring works as we expected, the next step is to reintegrate our app with user defaults so that we can try and persist our item objects using user defaults. So now let's delete this line of code where we were using to debug previously, and let's reactivate our defaults to try and retrieve our items out of our item array. So before we do that, we have to make a few fixes, of course, because we're no longer retrieving an array of strings, but we're retrieving an array of items. Now, there's nothing to change here when we're adding items because, of course, self.defaults.set can take any object, right? Or at least theoretically. So let's see what happens when we try to run our app. Now, I'm already hinting at what's going to come, but theoretically, at this point, we are creating a new item using our class item. We're setting its title property. The done property is set to false by default here. And then we're appending the item to our item array. And then we're setting into our user defaults using the key to do list array. And then when our app loads up, we use our user defaults to pull out an array. And if you remember, user defaults.array can be an array of any type, at least theoretically, and we're using the same key as we saved it, and we're trying to pull it out as an array of items. So if that succeeds, then we set our item array to equal items. Let's go ahead and give our app a run and see what happens. So that's all working fine because we're initializing new items inside view.did_load and we're appending them to this item array. Now, the part that's interesting occurs when we first press the add button and add a new item. So let's press the add button and let's add a new item. Now, once I hit add item, something dramatic happens, and of course you can see we've got signal, sigbart, which doesn't say anything at all, but by now you should have seen it often enough if you're coding along, because this means that our app has crashed. And if we scroll to the top of our debug console, as always, we'll find something that's trying to tell us why our app crashed. And the reason that it's telling us is attempting to set a non-property list object using user defaults. So what does that mean? Well, do you remember how I said that user defaults is a property list? It has a whole bunch of key value pairs. So, for example, you could have a key, which is to-do list array, and the value is an array of strings. But in our case, we're trying to save an array of custom item objects. Remember, our item array is an array of our own item objects. And we're trying to save that into user defaults, which it's rejecting. And it probably should reject, because by the time that you're trying to save an array of your custom objects, then you're probably misusing user defaults. So this is the extent where we can get to with user defaults. And we have to start considering a slightly better solution than using user defaults to persist data, which, if you remember, is only really intended for small pieces of data. And it's massively inefficient because it has to load up the entire plist before you can use or read any of the properties inside it. So we have to abandon ship and stop using user defaults. So I believe that it's always better to show rather than tell. And I can of course warn you, don't use user defaults. It's not going to be very efficient and it's not going to work in lots of cases. But I think it's better to show you when we actually try to implement it and reach its limits. So remember, don't use user defaults for anything other than basically that, right? User defaults. So volume on, volume off, volume high, volume low, these kind of small tidbits. For bigger pieces of data and for saving data into databases, we've got better tools for that. So in the next lesson, we're going to be learning about one of those tools, which is NSCoder. So I'll see you there. Now, before we talk about NSCoder and how we can start saving our custom objects to files, we first have to understand a concept known as sandboxing. Now, here's a scenario. Say if I have two apps which are running on the same phone, and one of my apps, say inside Klima, I have some malicious software, and I try to infect the other apps on the same phone. And maybe my code's intention is to mess up the other apps, or maybe I'm trying to get secure data from the other apps. And if your weather app starts stealing data from your banking apps on the same phone, then you have a huge problem. And so in iOS, this problem is solved by something known as sandboxing. So imagine that all of your apps on your phone live inside their own sandboxes. And a sandbox is nothing more than just a sheltered environment, or maybe you can consider it as a little mini prison for your app. So each of the apps has their own folders to store files and documents that are associated with the app. And so when your to-do list app needs to save or retrieve data, it can do so by reading and writing to that documents folder. But it can't get access to another app's document folder. Instead, what happens is that every time your phone syncs with iCloud, or when you plug it into your laptop and you sync it with iTunes, then all of these document folders get backed up either online or locally to your laptop. So say if you go out and buy a brand new phone, any data that your app has saved to that documents folder doesn't get deleted. Instead, it will constantly sync with iCloud or with iTunes, and it will remain available for you to be able to read and write to it and grab the data that's been stored in it throughout the lifetime of the app. So in other words, because you have this backed up permanent storage solution, it doesn't matter if you change phones, if you update your operating system, if you download new versions of the app, you still have your personal data safely stored somewhere where the app can get access to. Now, sandboxing doesn't just apply to individual apps. It also means that apps themselves can't affect the operating system's code. So you can't write a malicious app to grab the secure data from the operating system. For example, the user's fingerprints or their contacts. And this is also one of the reasons why the iPhone is considered to be far safer and more secure when compared to other phones and other operating systems. But it also means that sadly, you can't make cool apps that changes the operating system settings. So for example, one of the apps that I really wanted to make is an app where when I turn my phone to be face down onto the table, i.e. when the proximity sensors detect that it's occluded, then I want my app to automatically switch my phone into do not disturb mode, because it usually means that I'm either having a conversation or I'm having dinner or I'm trying to work on something, and that would be really awesome. But without jailbreaking the iPhone, which is really not recommended, there's no way of implementing this on iOS. So there's benefits to sandboxing and there's also costs to sandboxing. But this is something that we have to work with as an iOS developer. And in the next lesson, I'm going to show you how to get access to your documents folder inside your apps and how to start saving your custom objects to that directory. So for all of that and more on the next lesson. So previously, we got up to the point where we used NSUser defaults to save our data. And then we created a data model that represented each and every to-do list item so that we can associate each item with not only just a title, but also whether if they have been done or not done. So this way, every single time we reload the table view, we'll always be able to correctly assign a checkmark or no checkmark to each and every to-do list item. Now, previously, where our app fell down was when we tried to save data that is of a custom data type to our to-do list. And the reason we mentioned was because we're using NSUser defaults, which can only take standard data types, not any custom types or custom objects that we have created. So in this lesson, we're going to address this by using a different method for saving our data and persisting it on the device. So the first thing that we need to do is to delete this print statement inside our app delegate did finish launching with the options so that we don't get confused between our print statements. And then we're going to go into our to-do list view controller and we're going to create a file path to the documents folder. So just after super.view did load, we're going to create a constant called data file path. And this is going to be set to equal file manager, which is an object that provides an interface to the file system. And then we're going to use the default file manager, which is a shared file manager object. So this, you should now recognize, is a singleton. And this singleton contains a whole bunch of URLs, and they're organized by directory and domain mask. So the search path directory we need to tap into is the document directory. Now be careful here, you're not looking for the documentation directory. That's something entirely different. We're looking for the document directory. So have a scroll through what other things you can tap into, and once you're done, go ahead and enter .document directory. And the location where we're going to look for it is inside the user domain mask. So this is the user's home directory, the place where we're going to save their personal items associated with this current app. And because this is an array, we're going to grab the first item, and then we're going to print this data file path. So let's go ahead and run our app and see what we get back. Now, if we have a look inside our debug console, we can see that we've got this optional printed, which doesn't really matter because we haven't unwrapped the optional URL. But this is what we want. This is the file path that we need. So let's go into Finder and navigate to this location. So if you want to navigate up the directory, you can always use Command Up button, and you can go up the hierarchy until you get to the root, which is your Macintosh hard drive. Now, starting from here, we're going to go into Users, then My Current User, which is Angela Yu, and then we're going to go into Library, and we're going to go into Developer, and inside Developer, we're going to go into Core Simulator, and we're going to look for the device that is 8D49. So you can always click on date modified so that it sorts by last open or last modified. So here we go, 8D49, and then inside data, inside containers, inside another folder called data, there's a folder called application, and we finally get to our application, which is this one, 53A. And you can see here we've got a plist that represents our NSUser defaults. Now, inside our app, instead of using NSUser default and grabbing that singleton and saving our data to that address, we're going to create our very own plist file. So all we need to do is go to the part where we created the file path to our documents directory, and then we just need to use the dot notation and tap into the appending path component method. And here we can add a path component. You can call it anything you want, but it's good to name it something that makes sense. For example, in this case, maybe we'll call it items.plist. Now, if I run the app and chase down that file path, And you'll see that we haven't yet got the items.plist. We've merely created a path to this new plist that we are going to create right now. So let's head back into Xcode. And let's modify our code. So instead of using user default, we're going to create our own plist at the location of our data file path. So the first thing that we have to change is this line where we set our item array for the key to-do list array into our user defaults. And because our item array is an array of our custom item object, then this line fails, and this is when our app crashes. Now, instead of doing this, so I'm just going to delete that line, I'm going to now create something called an encoder. And the encoder is going to be a new object of the type property list encoder. And I'm going to initialize it. Now, what I can do is I can say, let data equal encoder. So that's that property list encoder that I just created, which will encode our data, namely our item array, into a property list. So we're going to use our encoder, and we're going to use the method encode, and the value that we're going to encode is our item array. So once I hit enter, you'll see a couple of problems, namely that the encode method can throw an error. So we know what to do. We first have to create a do block, and then we need a catch block. And finally, we need to mark this method with a try. And because we are inside a closure, i.e. the part that gets triggered once the user presses the add item button, then we have to mark all our properties with a self. Now, once we've encoded our data, the next step is to write the data to our data file path. And this is also a method that can throw errors, so we have to mark it with a try also. So try data.write, so writing the data to a location, and the location is of course going to be our data file path. So in order for us to access it there, we have to put it out here as a global constant. And so now we can say data file path. And inside the catch block, we're going to print error encoding item array, and we're going to print out the error that triggered it. And finally, we have to mark this with a self because we are again inside a closure. So the last thing we have to do before this is going to work is we have to go into our item class, and we have to mark our class as conforming to the protocol's encodable. And this means that the item type is now able to encode itself into a plist or into a JSON. And for a class to be able to be encodable, all of its properties must have standard data types. So things like strings, booleans, arrays, dictionaries, they all work, but not if you have a custom class in here. So let's hit save, and let's fix that one last issue. And let's just comment out this line so that we can address it later. Now, if we run our app, let's see what happens. Alright, so let's add a brand new item. So all three of these items got initialized because we hard-coded them and added them to the item array, which is what we're loading up inside our table view. Now, in order to test out our code and see if our encoding worked, we have to press the add button, and we're going to create a new item. And once I hit add item, you can see that I've got no errors. My debug console didn't pop up telling me that my app has crashed, and my app is continuing to work, and it now contains that brand new list item. So if we go back to Finder and check out that previous location that we found, but do you remember last time when we checked in here, there was nothing inside, it was completely empty? Well, now that we've actually saved something, but now that we've actually encoded our item array and wrote that data to that data file path, we now have this plist. And if we have a look at it by double clicking, you can see that we've got a whole bunch of items that have been organized and encoded automatically using our Swift encoder. Now, it's important to note at this point that previously, when we were talking about user defaults, and I explained why it is that we're unable to save an array of custom item objects, it's because the plist can only accept a limited number of data types, and they're pretty much the standard or foundation types. But if you take a look over here at our encoded items.plist, you can see that firstly, it's an array with 4 items, whereas user defaults is a dictionary or a bunch of key value pairs. And that's what we always said about user default. But if we expand this root, we can see that our encoder has very cleverly encoded each of the properties into a dictionary, and the individual properties still conform to all of the basic data types. And this is why, even though they're both plists, our items.plist is able to save our custom item objects, but the NSUser default is not. And it's all down to the encoder. And if I have this live next to my app, if I add another new item, that's really imaginative of me, you can see that it shows up here, but it also shows up here, right? But there's one bug. When we try to check our items off or uncheck it, this done property is not updated in our items.plist. So let's have a look at why that might be. So I'm going to stop the app and we're going to look at the part where we try to save that property. So you can see here, this is where we've got that delegate method did select row at index path, and inside this method, we toggle the item at the current index path, its done property, to the opposite of what it used to be. So this is only reflected inside our item array. So how can we save this information to our item.plist? Well, we have to use the same process, i.e. let encoder equals property list encoder, encode the data, then try and write the data to that data file path, and if there's an error, print an error, and then reload the data. Now, instead of copying all of this and pasting it over there, this is a good time to think about creating a save data method. So let's go ahead and create a new function called save items underneath our IB action. And inside this function, we're going to copy all of this code. We're going to cut it and we're going to paste it inside save items. So now, because we're no longer inside a closure, we can get rid of these selfs in front of our item array and data file path. And we can also simply call save items, both when we add a new item using the alert controller, but also when we toggle the check mark. And we can delete this as well because it exists inside save items. So now let's hit run and see if our app works. And now if we check on the first cell, which is a find mic, you can see that this automatically updates inside our items.plist, and all the changes are reflected live. But there's still a bit of an issue here. Namely, where are the items that we saved earlier on? Where's the save the world item? Where's the add a new item item? Why is it not showing up in our to-do list? Well, that's because even though we've written the saving part of the code, which encodes our item array, we haven't yet written the code to decode our items.plist in order to populate our table view. So that we're going to tackle on the next lesson. Now, those of you guys who are looking closely, you might have noticed that in the last lesson when we ran our app and tested whether if our checking and unchecking was persisted into our plist, as soon as we checked off the first item, the last 2 items in our item.plist got erased. And the reason for that is because we're calling save items when we toggle the checkbox, and that will overwrite the current item.plist file. So let's go ahead and add it back in. So why does our app do that? Well, the problem is that we're not yet loading up our data from our items.plist. Instead, we're loading it up by hard coding the items and appending them to this item array, which we know does not get persisted. So, whereas previously we loaded our items from the user default by using these lines, now we've commented out, and so we have to replace it with some more code that loads up our item.plist. So, instead of writing our code here, I'm just going to call a method called loadItems. And it doesn't exist yet, so Xcode is going to complain, but not for long, because I'm going to create the function here, and I'm going to call it loadItems, just as I called it above. And inside here, we're going to tap into our data by creating a constant, and we're going to set it to equal data created using the contents of a URL. So this method. Hit enter, and the URL is of course still going to be our data file path. And this is again a method that can throw an error, so I'm going to mark it with a try question mark, which will turn the result of this method into an optional. So then I'm going to use optional binding to unwrap that safely. So now, just as above, we created an object that was an encoder using the property list encoder. In order to decode our items, we have to create a decoder. And you guessed it, it's property list decoder. So let's hit enter, and we're going to create a new object of that class. Once we've got our decoder, we're going to set our array up here, item array, which contains an array of items. So item array is now going to be equal to decoder.decode. So this is the method that's going to decode our data from the data file path. But we have to specify what is the data type of the thing that's going to be decoded, because Swift isn't able to reliably infer the data type. And this is one of those rare cases where you actually have to tell it what is the data type. So the data type is of course an array of items. And because we're not specifying an object, in order to refer to the type that is array of items, we actually also have to write .self here. And the data is of course that data that we safely unwrapped above. And this method again needs a try keyword in front of it. So we're going to wrap this inside a do block, and we're going to catch the errors by printing out. Now let's just make sure that we called load items correctly inside viewDidLoad, and we can safely delete all of this hard-coded item initialization because, as we can see, we've already successfully saved all of those items into our item.plist, so we don't need to initialize it all over again. Now, before we run our app, there's one last thing that we need to do with decoding that we did with encoding. We need to say that our item class is not only encodable, but it's also conforming to the decodable protocol, i.e. this is a type that only contains standard data types, and it can be decoded from another representation, which in our case is a plist. Now, it's a little bit silly having encodable and decodable, and since Swift 4, you can replace it with just the word codable. And this specifies that a particular class and all of their objects conform to both the encodable and the decodable protocols. So let's hit save, and let's check that we've called load items in viewDidLoad, and let's run our app. Cool, so we've now managed to successfully load up all the items that currently exist in our items.plist. And you can see that if I check on one of these items, that the done property updates live. It's cool, right? So we've now managed to successfully do what we weren't able to do before, which is save an array of custom objects into persisted storage and retrieve it at a later date. So now if I go ahead and terminate this app, if I open it again, all my check marks still exist in the right places and all my items still get loaded up. So in this lesson, we use the NSCoder in order to encode and decode our data to a pre-specified file path. And our code converted our array of items into a plist file, which we can then save and retrieve from. Now, does encoding and decoding make sense to you? Not yet? Alright, let's think about it from a different perspective. When you encode data, you're essentially converting one data type into another. It's almost the same as converting your music into a vinyl disc. And what this machine does is that it takes music and it etches into a vinyl disc all the grooves that correspond to the music. So we're using the encoder to turn music into a vinyl disc. And that is our encoder. Now our decoder takes that same vinyl disc and plays it or turns it back into the music. And this is exactly the same as what we're doing here. we're encoding one type of data, our array of custom objects, into data that can be written into a plist. And then when we need that data, we use a plist decoder to take out that data in the form of an array of items. So this gives us way more flexibility over our NS user defaults. And when we save data to our NS user defaults, they all went into the same plist. But in our case, we can actually initialize different plists. For example, if we had different categories to our to-do list, we had one to-do list that was for home, one to-do list that was for work. Instead of loading up a large plist that contains all of our items, we can actually separate it out into individual plists for each and every category, reducing the loading time every time we want to read and write to that plist. So have a play around with the code. And in the next lesson, we're going to make our persistent storage even more flexible and even more scalable by using core data. So I'll see you there. Up till now, in order to persist our data, we've essentially only been using single tables, right? If you think about how we save data using user defaults or using our plist and the codable protocol, we were still saving things into a single table that had a key value pair. Now this is equivalent to your tables inside Excel, for example. So in order to explain the next step of persistent data storage solutions, let's use an example. Let's say that you own a small bakery, right? And in order to keep track of your orders, your ingredients, your cost, you have to make a table, right? People would probably do this normally inside Excel. And inside this single table, you list all the things that you can make. So you just make cookies, brownies, and cakes. And you have columns where you can write down what are the ingredients, what's the cost for each of these products, and how many orders you're getting, say, every month or every week. And this can be easily done using our plists or using our user defaults. But what happens if, say your cookies get featured on the Cookie magazine, right? And you end up being the best chewy chocolate chip cookies in the world. What are you going to do? Well, then your sales are going to massively explode and people are going to be queuing around the block to buy your cookies, right? Now, I just want to take a moment and pause and reflect on the fact that it took me about half an hour to find the perfect cookie image to illustrate this slide. And given the fact that I've been trying to cut all sugars in my diet for the last year, I just want you to know how much of a sacrifice I've just made for you guys, looking at a million chocolate chip cookie images that I can't have. But anyways, let's continue. So your business explodes and you now have loads and loads of orders, including big supermarkets and big brands, and they all want to buy your cookies and all of your bakery goods. So your single table inside Excel is not going to cut it anymore because you now need to keep track of a lot more things. So for your products, for example, you need to be able to track the ingredients, the cost, the shelf life of each of them, what are the nutrition details, because all of these big shops, they all want to know, right? So you have to test that and you have to update the products table. But in addition, you might want to keep track of your buyers, right? Say Walmart, Tesco, and Whole Foods, they're all regular buyers of your stuff. And now you need to know what is their address, what are their phone number, what are their bank details, who do you need to contact in order to invoice them, whole bunch of details about your buyers. So you need another table. And then in addition to your products and your buyers table, you also need to keep track of your orders, right? So for example, this month, Walmart wanted 2 batches of cookies, Tesco's wanted 12 batches, and Whole Foods wanted 10 batches of your brownies. So you need to match up the items from the products table to the buyers table in order to know who to invoice, who to send which details about which products, a whole bunch of data. And you now have 3 tables. And the tables are related to each other. They have relationships, right? They're not just single tables. Because when you have an order for 2 batches of cookies to Walmart, you need to pull out data from the products table for the cookies, and you need to pull out data from the buyers table for Walmart. So you now need to establish relationships between the tables. And this is when you will need a database. And in the coming lessons, we're going to be talking about 2 database solutions. that are way more sophisticated than the single tables that we've been working with using plists and user defaults. And they'll allow us to establish relationships between our tables or between our classes so that we can perform far more complex tasks like querying our database to find a particular item or linking two tables together using relationships. Now, let's just quickly review some of the methods that we've come across to persistently store our data on the local device. So the ones that we've seen and that we've used are user defaults and codable. So the first section here, the ones in blue, are essentially tables. They're plists or they're individual tables that tracks a small amount of data. Now the three solutions in yellow are databases or database solutions, and they allow for more complex data and apps with more complex needs in terms of data storage and data retrieval. So let's go from the top. So the first method that we saw and we used in order to persist our data, which is probably the easiest way of doing it, is user defaults. And this allows you to quickly persist small bits of data, things like what is the top score of the user, what is the player's chosen nickname, or whether if you want music on or off. These are really small bits of data, and that's what you should use user defaults for. Once you start trying to put objects into user defaults, then you know that you're probably doing something a little bit wrong. Now, that's when we moved on to the codable protocol, which allows us to save many individual plists that contain our custom objects. So you can see it almost as taking an ice cream and dehydrating and storing it as astronaut ice cream, which tastes terrible, by the way. I don't know who came up with this, but it's a good analogy for the item saved with the codable protocol. You're basically flash freezing your custom objects into a plist, and then when you use it, you have to retrieve the entire plist or load the entire plist into memory before you can use any of the items or objects contained within the plist. So again, it's memory intensive to load up an entire table when you only want one or two items inside it. And this is why the codable protocol saving your custom plist to file, again, should only be used for small pieces of data, so less than 100 kilobytes, for example. Then we've got something that we haven't seen yet, and it's called the keychain. And this is an API that allows us to save, again, small bits of data inside a table, but allows us to save it securely. And Apple takes care of a lot of the heavy lifting of keeping the data that you put into the keychain secure. So this is for things like, usernames, passwords, things that you probably want to keep secure for the user. And then we cross the threshold and we move into the database solutions. And the first one that comes to mind is SQLite. So pretty much all of your iPhone apps, their backend or the database that stores the data on the device is mostly using SQLite. And SQLite has been around for a long time. If you're familiar with relational databases like MySQL or SQL, then you are probably familiar with SQLite. It's meant to be a lightweight, easy to use relational database that will help you to persist large amounts of data, and it has efficient ways built in order for you to query data from it. So for example, when you're trying to sort a SQLite database, you don't have to load up your entire database on your tiny iPhone and then try to sort everything inside. No, people have come up with really efficient solutions so that it's quick and it's not so intensive on memory. And if you're familiar already with the querying language and SQL databases, then this might potentially be a solution that you want to use. Now, the next one in the list is core data. And this can use SQLite as the database. And whenever people talk about core data, you'll hear them hesitate to call it a database. And the reason for that is because while you can use core data to work with a relational database, it's so much more than that. It allows you to convert these individual tables inside your database into objects that you can manipulate easily using code. It gives you efficient methods to query the database using a more natural language. It can also do a lot of things that you can't do with SQLite. For example, monitor for changes in the database, and a whole lot more. I could probably talk about core data by itself for 40 hours. So we're only going to be looking at the most fundamental things that you can do with core data, which is basically create, read, update, and destroy. And that's the base functionality that you'll need for pretty much any database you want to use. And we're going to look into all of them. Now, the last one in the list is something called Realm. And this is an open source framework that is a much faster and easier database solution than Core Data. And it's fast becoming one of the most popular ways of persisting data locally on device. So we're going to be looking into that as well. So when you're looking to save data from the user inside your apps and have it persist across, app updates or iOS updates, then you should consider maybe one of these 6 methods. So if you want to persist just a tiny amount of information, like a small key value pair, then consider something like user defaults. If you want to save a small amount of custom objects, then think about using Codable and encoding your data into a plist. If you want to save secure data, like user passwords, then use something like Keychain. And if you have a large amount of data and you need to be able to query the data to pull out specific entries inside, then you want to think about one of the database solutions. If you already know about SQLite, or you already have data stored in the SQLite database, then you might want to use SQLite with a wrapper. If you're setting up your data from scratch, then Core Data might be a good solution. There's a lot of help online for Core Data. A lot of people use it. Most iOS developers are familiar with it. And finally, if you want to be able to do, I would say most things that you can do with Core Data, but faster, quicker, and have a more efficient database solution, then you might think about something like Realm. So let's get started looking at firstly Core Data and then looking at Realm, and you can make your own decisions when it comes to creating your own apps. In the last lesson, we managed to use the Codable protocol to save our to-do list items into a plist, and we were able to retrieve it and add new items as we pleased. The next step is embark on a new journey and a new way of persisting our data. For this lesson and a lot of the coming lessons, we're going to be diving into Core Data. And I'm going to walk you through how we can perform all of the CRUD operations using Core Data. But first, we need to learn how to set up and configure our Core Data data model in order to use it in our projects. Now, the first thing, if you remember, is that when we choose a template to create a new project, there's this checkbox here that says Use Core Data. Now, for our current project, I asked you not to check it because we were going to be looking into various different methods of persisting our data before we come to this module. So if we have a look, let's just create a Core Data test app, and I'm going to check Use Core Data, and we're going to hit Next. And I'm going to save it onto my desktop. And don't worry about creating a Git repository. We're just going to have a look at this test project to see what automatically gets created by Xcode when you check that tick box. Now, the first thing that you notice that's different from your normal templates is that you get this Core Data data model. And inside here is where we set up all of our data and structure it for use with Core Data. The other thing that Xcode adds is inside the app delegate, it adds a whole bunch of helper code, which you're going to need every single time you use Core Data. So they've just given it to you for free when you tick that checkbox. So what are we going to do in our project? Are we going to have to rewrite it from scratch and tick that checkbox? I mean, there's a lot of cases when you make an app, and you don't know that you need to persist your data using Core Data. Maybe, initially you thought, it's going to be a really small amount of data, I'm just going to persist it using plists. But then at some point you realize that it's actually become this behemoth and you now need some sort of formal data model manager. So that's why we created this project to DOI without checking that Use Core Data checkbox, so that I can show you how you can add Core Data to any project, even at a later date. So the first thing that we're going to do is we're going to add that Core Data model. So we're going to go to File, New, File. And we've normally been playing around with this section, which is the source. But now I want you to scroll down to the section that's called Core Data, and we're going to create a new data model. And hit Next. Now we're going to call this data model. I know it's not very imaginative, but it makes sense to most people. And I'm going to drag it out of controllers and put it inside data model, where it fits in much better. Now, if we go back to that Core Data test app where we checked using Core Data, we can actually just simply copy and paste all of this code up to and including application will terminate. And we can paste it into our project. So I'm going to delete application will terminate, and I'm going to paste what we copied over instead. Now Xcode is going to complain because it doesn't know what persistent containers are unless we of course import the core data framework. And one thing we have to check to make sure is that the name here, where it says the persistent container name, has to match with the name of our data model. And if you remember, we called ours data model with a capital D and a capital M. So we have to make sure that when we copy this code over, that we have to change this to match our data model name. So now at this point, our project for Todoist is exactly the same as if we checked that box to include core data. So we can now close down this core data test project and we can delete it because we're not going to need it anymore. We've already gotten all the code that we got given from Xcode and we've incorporated it into our current project. Now let's head over to our data model and we're going to create a new entity. So you'll notice that when you start working with core data, it's almost like we're in a different world. They use different words for things that we already have a good grasp of. So for example, entities are pretty much equivalent to classes, and each entity has a whole bunch of attributes, and those attributes are almost like our properties that we've gotten used to. But you can also consider that each entity is basically like a table of data. So for every single Excel sheet that you have, you might have a single entity inside your core data model. So let's get started and we'll explain as we go along. So we're going to go over here and we're going to click on Add Entity, which gives us this brand new entity, and we're going to rename it to something that makes sense rather than just entity, right? So you can do that either by clicking here, or you can also just edit it in the attribute pane. So now inside our right hand pane, you can see that we've got this new icon that looks to me a little bit like a welding mask. I don't know why it represents core data, but it just does. So this is the pane under which we're going to edit all of our properties related to our entities and our attributes. And it's also here that we can change the name of our entity. And we're going to call ours item, because that's what this class or entity is going to represent. It's going to represent individual items, just as we did here using our class. And if you look at our class, you can see that it has two properties, which we now know are called attributes in core data. So we need to add these two attributes to our item entity. And we do that by clicking this plus arrow here. So the first attribute we're going to call title, and the type of it is going to be string. In the attribute pane, there's this checkbox called optional, and we want to make sure that each and every item must have a title, because, otherwise what are you saving, right? If an item doesn't even have a title. Now, so we have to uncheck that box where it says optional and make this a required attribute. Now, there's other attributes to these entities that might be optional, for example, like a due date for each item, but the title is not. So let's go ahead and add that. Now, the next thing that we're going to add is the done attribute, and this is going to be a Boolean. So we can select that down here, and we're going to make this attribute non-optional as well. So now you can see that we've essentially replaced our item class with our item entity and all of its attributes. So we can now safely delete our item class and move it to trash, because we've essentially replaced what it does using core data. Now, there's one last thing that we need to do inside our data model inspector, and that is to change the module from global namespace to current product module. Now, this is something that probably won't break our project at this stage, but it's something to be aware of. Once your core data project gets more and more complicated, especially if your app requires multi-threading, you might end up with weird errors if you don't select this as current product module. Now, the other thing that you'll notice here is that there is this property called CodeGen. And if you click on it, there's three options. Now, let's go through what each does. So the current and the default selection is called class definition. And what this does is that it converts your data, your entities and your attributes into classes and properties. So you can use them and manipulate them just as you would if you had created a class with these properties. Now, the slightly mysterious thing is that when Xcode automatically generates these classes, it doesn't show up in our project navigator. So we can't actually view it unless we're really determined. So if you are really determined to find it and have a look at it, then you can follow along with me. Alternatively, you can just watch me show you where it is and trust that your code file is also automatically being generated as long as you've got that class definition checked. Now, in order to locate those files, all we have to do is head into Finder, and we're going to navigate right into the root. So if you have difficulty finding your Macintosh hard drive, then all you have to do is just on any given folder, hit Command and hit the up arrow, and this will take you all the way up until you can no longer go up any further, and you should be at your Macintosh HD, which is your root. From here, you're going to go into the users folder, and then you're going to find your current logged in user username, and then we're going to go into library. Now, if you don't see a library inside your users folder, then all you have to do is just open up terminal and type chflags no hidden ~library and hit enter, and that will make your library folder unhidden inside Finder. And inside library, we're going to go to developer, and then Xcode and derived data, and then in this folder we're going to find our Todoist app. So it should be called Todoist with a whole bunch of jumbled letters afterwards. And here we're going to look for a folder called build, and inside build we're going to go into intermediates, and then Todoist.build, and then debug, Todoist.build, and then we're going to go to derived sources, and finally core data generated and data model. So it's a long path to chase down, but eventually you get here, and what do we find? We find 3 Swift files, which is the name of your entity, and properties, and your item, and your core data class. So if we double click on it, it should open inside Xcode, and we can have a look at what they look like. So the 2 most important files that Xcode generates for you is your item class and your item properties. So the item class file gets generated once, and it doesn't get modified unless you've deleted the entity or you add a new entity. But this file, the core data properties for your items, this gets regenerated many times. So if you try to write any code in here, it simply gets wiped and replaced with whatever Xcode wants to put in here. So these are both not good places for you to put your own code. If you wanted to put in your own custom initializers or custom functions for your item class, then instead of using the default, which is class definition, you'll want to use category/extension. And if you have this selected, then you need to create your classes that are identically named to your entities, and Xcode will automatically link them up to allow you to use core data. Now, the other option here is manual or none, where there is literally no code generation at all. There's no linkages behind the scenes, and you have to do all the work yourself. And this is probably the one that's least used in practice, and the class definition is probably the one that's least effort, quickest to set up, and easiest to understand. But the one that's actually most used that you'll see in the wild is actually the category extension, because sometimes developers might want to add in some custom code, and so you'll see that used pretty often. But I would say that a lot of people do use class definition as well, just because it's so easy to implement, and that's the one that we're going to use. So if we have a look back at the Swift file, where Xcode automatically generated this class declaration for our item entity, then you'll see that our item entity inherits or subclasses NS managed objects. And NS managed objects are basically core data model objects. It's similar but not quite the same as our standard objects. But by subclassing NS managed objects, it allows us to manage this class using core data. So if you do create your own custom classes and you go for the option of category/extension, then you'll also want to inherit from NS managed objects in order for your code to work. So now that we've seen the automatic code that gets generated behind the scenes, let's take a look at the code that we got inside our app delegate. So if you remember, this was the code that we copy and pasted from a new project that has the use core data checkmark checked. And what we get is a global variable called persistent container and also a method called save context. So I'm just going to get rid of all of this commenting that Apple has meticulously added, just so that our code is a little bit shorter and we can see it all on one page. I'm also going to delete the comments inside application will terminate, and I'm also going to delete all of these methods excluding did finish launching options. So now in your app delegate, you should have did finish launching with options, as well as application will terminate, inside which you call self.saveContext, which is that method that Apple gave us for free. And we've also got this lazy variable called persistent container. So the first question you might have is, I've never seen this keyword before. What does lazy do? Well, you know how there's some people who, if they need to get to work at 9, they'll wake up at 6, they'll spend half an hour doing yoga or some crazy stuff like that, and then do a whole bunch of prep work, eat a proper breakfast. And those people are not lazy. But then there's another category of people, myself included, which most people would categorize as lazy. And they're the sort of person who, if you need to be out the door by 8:30, you'll probably wake up around 8:20 and try to get everything done in 10 minutes, just so that you can have that extra hour of peaceful sleep. So this is kind of similar to what lazy variables are. When we create a variable that we declare as lazy, then it only gets loaded up with a value at the time point when it's needed, i.e. when you try to use this thing called persistent container. That is when all of this code is going to run, and it's going to have a value set. So whereas the lazy person gets a lion benefit, the lazy variable gets a memory benefit. So you're only occupying the memory when it's needed, rather than having everything set up beforehand. So inside this lazy variable, we're creating a NS persistent container. And this is basically where we are going to store all of our data. And even though it's called an NS persistent container, which sounds kind of fancy, it's actually going to be a SQLite database. So for those of you guys who have worked with databases, SQLite, then this is basically what the NS persistent container is. Now, the reason why it's called persistent container and not just your SQLite database is because you can use different types of persistent containers. So for example, you can use XML instead of SQLite, but that's a whole other topic. Just remember that your default persistent container is going to be a SQLite database. Now, we create a constant called container that sets up this new persistent container with the name of our data model. And these two have to match so that all the behind the scenes setup and the relationships gets created properly. And then we're going to load up this persistent store, and we're going to log if there were any errors. But if there weren't any errors, then we're going to return the container that we loaded up, and we're going to set it as the value of this lazy variable called persistent container. And we'll be able to access it inside other classes in order to persist and save our data into our SQLite database. Now, there's this other helper method called save context. And this just provides some support to saving our data when our application gets terminated. But here you see this thing called a context. And we're going to look into the context a lot more later on. But essentially, the context is an area where you can change and update your data, so you can undo and redo until you're happy with your data. And then you can save the data that's in your context or your temporary area to the container, which is for permanent storage. So if you remember our lessons on Git and GitHub, the context is similar to that staging area, that temporary area where we can change things and update the things that we want to commit, and then only once we're ready do we actually commit the data to source control. And in this case, it's exactly the same. So the two things that you need to understand from this code is that we create a new NS persistent container using our core data model. And this persistent container is the database that we're going to be saving to, and it's a SQLite database. The second thing is that we have this thing called a context, which is what's called a scratch pad or a temporary area where you can update, change, delete your data until you're happy with the format it is, and then we basically commit it to permanent storage. So these concepts are core to understanding core data and how it works. So we're going to be revisiting it quite a few times. So if you don't get it right now, don't worry, because I'm going to be repeating the concept here a few more times until we get it. So now that we've seen how we can configure and set up core data to be used inside our To-Do project, in the next lesson, we're going to look at the first letter of CRUD, which is how do we create or how do we save our data using core data. So for all of that and more, I'll see you on the next lesson. So now that we've had a look at what's the code inside our app delegate, this is a good time to go back into our to-do list view controller and fix all of these errors that we've got by switching over from a custom class that's saved usingplists to our core data model. And in the process, we'll learn about how to create, or rather save, data using core data. So the first thing that we need to change is that instead of creating a new item as a new object of item, we actually need to initialize our core data object a little bit differently. So if we say let new item equals item, which if you remember is our core data class. So if you hold down option and click on it, you can see it's an object of the type NSManaged object. And if we open a round bracket to initialize it, then we get to specify the context where this item is going to exist. So what is that context? Well, it's basically going to be the view context of our persistent container. So while we're inside the same class, it's easy to access this variable called persistent container. But if we're inside to-do list view controller, how do we create that context? We can't just say let context equal app delegate dot persistent container dot view context. And the reason why this doesn't work is because app delegate is a class. It's not the object of app delegate. So remember, when we refer to the to-do list view controller, for example, we won't try to call its methods or grab its properties by calling the class. Instead, we need to get the object of app delegate. So this would be the blueprint, and we need to get the object that's created from the blueprint. So this, again, is where our handy singletons come into use. And instead of calling app delegate, I'm instead going to tap into UI application.shared, and this is a singleton app instance. And at the time point when our app is running live inside the user's iPhone, then this shared UI application will correspond to our live application object. And inside this shared UI application object, there's something called delegate. And this is the delegate of the app object, alternatively known as the app delegate. And we're going to downcast it as our class app delegate. So let's just give you a bit more space to see that whole line as it is. So we're tapping into the UI application class. We're getting the shared singleton object, which corresponds to the current app as an object, tapping into its delegate, which has the data type of an optional UI application delegate. We're casting it into our class app delegate, and because they both inherit from the same superclass UI application delegate, this is perfectly valid, and we now have access to our app delegate as an object. So we're able to tap into its property called persistent container, and we're going to grab the view context of that persistent container. So we can now say our context is this context. Now, the next error that we have is inside save items. And because we're no longer using the encoder, we can delete that, and we have to delete all of this as well. So what we ultimately need to do inside our save items method is we need to be able to commit our context to permanent storage inside our persistent container. And in order to do that, we need to call try context.save. And that basically transfers what's currently inside our staging area or our scratch pad, that's the context, to our permanent data stores. So inside the do block, we need to be able to say context.save. Now, where are we going to get our context? Well, it's going to be exactly the same as this. So we can either copy and paste it over here, or whenever you're copy and pasting the exact same pieces of code, then it's a good time point to evaluate. Maybe we should make it a shared constant up here. So now, instead of having this long line of code here, we can simply say let new item equals item, and the context is going to be self.context because we're inside a closure. And down here, we can simply say context.save and mark it with the try keyword. And inside the catch block, we're going to print and say error saving context with this error message. So all that we've done so far is to set up the code to use core data for saving our new items that have been added using the UI alert. So I'm going to comment out the load items function, and I'm also going to comment out the part where we call that function. And if we want to be able to use item, which if you remember is an NS managed object, so it's something that only exists in the core data framework, then of course we also need to import core data. And now those errors will go away. So if I run the app now, you're going to see that we're going to come into an interesting bug. So when I hit add, let's create a new item. And once I hit add item, you can see it show up inside the table view, but that's only because it's being added to an array. And if we drag up our debug console, we'll see the reason. And it gives us an error with a code, and it says error saving context. So that of course refers to this line here, and this is the error that we're catching because we wrote this error saving context, remember? And the error message is the operation couldn't be completed because if we have a look at our data, we've got this item called done and it's equal to nil. So because our item done is not optional, we have to provide it with a value when we create our new item. So over here, in addition to adding a title, we're going to set the done to false for every single new item that we add into our table view, which makes sense, right? Because everything starts off being not done. So let's run our app again and see if this now works. So let's add a new item. And now you can see that the item has been added to the table view, and we don't get any errors in our debug console from that catch block. So the problem though is that right now we haven't yet got code that loads our items from our core data model. And if I terminate this app and I reopen it, you can see that we have no items in here. But we did save our data using core data and we didn't get any errors, so it succeeded. So how can I prove this to you? Well, in the next lesson, I'm going to show you how you can view your SQLite database and see the items that get saved into it. So for all of that and more, see you on the next lesson. So in the last episode, I promised you that we're going to be able to view our data, but at the moment we don't have the code set up yet so that we can see it in our table view. So how can we do this? Well, we first need to locate our file. And even though we don't need this data file path anymore because we're not using it to save our plist, we can still cut it, put it into our view.did_load, and we're going to print the file path for our document directory under the user domain mask. But without all the appending and the first and all of that, we just want to get a path to where the data is being stored for our current app. So if we run our app right now, we'll see that file path pop up in our debug console. So let's follow the clues. We're going into user, Angela U, library, developer. Instead of Xcode, which is where we found our automatically generated code, instead we're going to go into our core simulator, and then we're going to go to devices, and our current simulator is 8D49 something something something. We're going to go into data, containers, data, and then we're going to go into application, and the application for our current to-do app is 5BF something something something. Now, inside here, instead of going into library preferences where we'll find our plist, instead we're going to go into library and application support. Here is where you're going to find your data model.SQLite file. and this contains our database. So whereas I've got this little icon that shows me that I've got an application that's able to open this file, you might just see something like this, which means that your operating system doesn't know how to open the file. And we can solve this easily by going to the App Store, and we're going to search for SQLite. So it's SQLite. And here you can see a whole bunch of different applications that can help you manipulate, add, delete, or view your SQLite databases. And one that I quite like is Datum. And they've even got a free version, which will be more than enough for our purposes in order to view our core data. So just go ahead and download and install Datum free, and you can follow along with me in the next steps to view our core data. Now, this is not the only option. There's a whole bunch of other applications, and you might already even have an app that allows you to manipulate SQLite databases. If you have a preference, then just go with whatever you like. We're using it for the most basic functionality. But if you've never used an application to open SQLite databases, or you've never even heard of what SQLite is, then just go with the free option. So once we've got that application installed, we can simply double-click on our datamodel.sqlite, and I'm going to use Datum free to show you how it works. So you might see some of these pop-ups, upgrade now, not now. I'm going to try it for a little while I show you how this works. And inside here, we've got this table called Z-item. And here, if you scroll to the right, you'll see one attribute called Z-done and one called Z-title. So if you ignore the Z, you can see that these are the names of our attributes. And done is set to 0, which is false, and title is set to save the world, which is what we added just now into our app, even though we're unable to load it up if we terminate our app. But you can see that the data is, in fact, being persisted. And right now, if I add a new item, let's say buy Eggos, and hit add item, then you see it showing up in the table view because it's being loaded up from the array. But if we have a look over here to our item table, and we refresh our data, then you can see that it's also being saved and persisted in our SQLite database. So up till now, we've seen how we can create a new core data model, how we can save new items or new managed objects into the core data model, and how we can view it using a SQLite application such as Datum. In the next lesson, we're going to review some of those concepts that we've come across so far. And we're going to talk about some of these tricky things like persistent containers and view context, and we're going to learn some of the fundamentals of core data. So for all of that and more, I'll see you on the next lesson. Now, we've come across a lot of new words that actually all describe the same concepts that we're already familiar about. So, for example, in the object-oriented programming world, we have something called a class, and that in the core data world is known as an entity. And when you think about databases, that's simply just a table that represents your data. And in the other case, when we talk about properties in object-oriented programming, it's actually similar to an attribute in core data. And in your database, that would simply just be a field or a particular column of your table. So if we look at one of our tables from our bakery, for example, the buyers table, the table itself is a class. And if we're using core data, then the table would be called an entity. Now, each of these columns that have headings like address, number, who to invoice, or the buyer name, these are fields in our database. And if we created the table as a class, we would call them properties associated with the class. But in core data, they're known as attributes. So every single row here is a core data attribute. So the address would be an attribute to the buyer's entity. Now, if we fill up this table, and we give each of these properties a value, then every single row we have in our table would be a brand new NS managed object. So there's a lot of new terms in core data, but just remember, when we're talking about entities, we're talking about the class, or we're talking about the table. When we're talking about attributes, we're talking about the properties of the class or the columns in the table. And when we're talking about NS managed objects, then we're simply talking about every single row in our table that is filled with data. So let's zoom out and have a look at our three tables that we saw in the beginning of this module. We have a buyer's entity, we have a products entity, and we have a orders entity. entity. Now, if we put all three entities or all of our tables into permanent storage, then that becomes our persistent container. And this container is simply a SQLite database that stores all of our tables and all of the relationships between the tables. Now, when we're writing our app, we can't simply interact with the persistent store directly. We have to go through an intermediary, which is known as the context. And this context, as I said before, is kind of like a temporary area where you might create new pieces of data that you want to add to your database, or read data in your database, or specify the things that you want to update in the database, or specify the things that you want to destroy in the database. So this is what's known as CRUD. And when people talk about databases, they tend to use this word quite a lot. But it simply just means all the things that you tend to want to do with a database, right? Create, read, update, destroy. And the important thing to remember is that in core data, you do this inside the context. You don't do this directly to the persistent container. And inside this intermediate area, what you can do is you can undo the changes or redo the changes. You can simultaneously add and destroy and update. And only once you've decided that you're happy with what you've done inside the context, do you save the context. And the core data framework takes care of committing the current state of data inside the context to your persistent stores. So as I said before, this is really similar to the Git example. When we used Git, we first had to add the things that we wanted to commit to source control to a staging area. And that's when we used the add command. Only when we were happy with what we wanted to commit did we then use the commit command. So in core data, we have a persistent container, and our app is not allowed to interact directly with a persistent container. Instead, it has to go through this temporary area, which is known as the context. And when you're happy with what's in the context, do you then save the context, which basically commits those changes to our permanent container. So let's review our code. So far, we've only implemented the C in CRUD, or the create, inside create, read, update, destroy. But in order to do that, we've actually had to come across all the things that we spoke about earlier on, including the context and the persistent container. So the first thing we create is a constant called context, and this goes into the app delegate and grabs the persistent container. And then we grab a reference to the context for that persistent container. So if we have a look inside our app delegate, we have this lazily loaded persistent container, so it only gets loaded up once we actually retrieve it or try to use it. And it's basically a new container that we create that's of the type NSPersistent container, and it's created using the structure that we've specified inside our data model over here, which has one entity called item, and item has two attributes, a done and a title. Then we load the persistent store and get it ready for use. Now we access the persistent store's context, which is that temporary area, if you remember, that our app is going to talk to. Next, when we add a new item to our table view, we create a new object of type item. And remember, this class gets automatically generated when we create a new entity with that name inside our data model. And that class already has access to all the properties that we have specified as attributes, title and done. So we create our new item, and that item is an object of type NSManagedObject. So if you remember, we said earlier on, NSManagedObjects are essentially the rows that are inside your table. And every single row will be an individual NSManagedObject. And then we fill up all of its fields, so the title field and the done field. And once we've done that, we save our items. And inside the save items function, we have this method that can throw an error, so it's marked with a try, and we try to catch the errors if there are any issues. But what it does is that it looks at context, that temporary area, which we edited over here by creating our new NSManagedObject inside that context. and then we save the context so that we can commit unsaved changes to our persistent store. So I know there's quite a lot of new words and new concepts that are being presented in this lesson, so it might be worth watching this lesson a couple of times, and also to finish watching the core data module and coming back to review some of these concepts once you've done it yourself. So at this stage of the course, you're going to start to see a lot more new concepts coming at you, and the learning curve is going to ramp up. So you might find that a lot of the knowledge here needs some time for it to soak in, or some repeated practice for it to really make sense. In the next lesson, we're going to look at how we can address the R in CRUD, or rather reading items from our persistent container. So for all of that and more, I'll see you on the next lesson. Now, we still have a rather fundamental problem with our app, and that's when we open up a new app, we don't get anything loaded up in our table view, despite the fact that when we add items, we're actually able to save it successfully into our persistent container. So let's fix that by targeting the next word in CRUD, which is read. So how can we load up items from our persistent container? So let's go into our load items function and let's uncomment it, but we're going to delete everything that's inside because we're using something that's completely different from encoding and decoding. But instead, we're going to create a new constant called request, and we're going to specify its data type as NSFetchRequest that is going to fetch results in the form of items. So in Swift, there's very few cases where you actually need to specify the data type. In most cases, you specify the data type because it helps you, the programmer, or people on your team to be able to easily see what is going on in your code. But in the majority of cases, Swift is clever enough to figure out what is the data type just based on the value that you give it. But in this case, it's a little bit different. You actually have to specify the data type, and most importantly, the entity that you're trying to request. So we're going to say, let request be of data type NSFetchRequest, that's going to fetch a whole bunch of items. And then we're going to tap into our item class or item entity, and we're going to make a new fetch request. And of course, as always, our application have to speak to the context before we can do anything with our persistent container. So we have to say context dot fetch. And the fetch that we want to make is our current request, which is basically just a blank request that pulls back everything that's currently inside our persistent container. Now, the problem with this is that, similar to context.save, context.fetch can also throw an error. So we need to mark it with a try, and then we have to make it happen inside a do catch block. And if there were errors, then we'll print error fetching data from context, and the issue will be printed using error. And finally, you can see that this method actually has an output, and it returns an NSFetchRequest result, which we know to be an array of items. So as you can see, there's quite a lot of logic to trace, and that's why Swift tells you that you must specify the data type here. If you don't, and you try to run your app, then you're going to get an error that says ambiguous use of fetch request, which, to be honest, is quite an ambiguous error by itself. But just remember that you need to specify what is the data type of the output. So we know that the output for this method is going to be an array of items that is stored in our persistent container. So what have we been using to store all of those items in the interim? Well, of course, our item array. So we can say item array equals try, using the current context, to fetch this broad request that basically asks for everything back. And once you do, then you're going to save the results inside our item array, which is what we use to load up our table view data source. So before we run, let's make sure that we uncomment this load items inside view.did_load, and let's run our app. So as you can see, when our app loads up, it's already fetching all of the items inside our database. And if we go into our database and we do something, say, let's just delete the last entry, hit the minus button, delete row, yes. And now if we terminate our app and open it again to reload view.did_load, then you can see that it's reflected over here as well. Now, the reason why it doesn't update automatically is because we manipulate the data inside the database directly. There's no way for us to be able to reload the data in the table view because we can't call tableview.reload data from the database, right? And later on when we talk about deleting items, then we can look at how we can update that automatically. But for now, we've assured ourselves that our load item function works and it fetches all of the results that are items from our permanent stores through our context. So the next thing that we might think about addressing is the U in CRUD, right? Updating. How do we update data inside our database? So that's what we'll do on the next lesson. In the last few lessons, we've managed to make our app be able to create data in our database, as well as read the data that exists in our database. And now we're going to tackle the U, that's updating data into our database. The perfect place to look at this is, of course, the part where we update that done property. And that's when we click and select each item. Now, currently, what we're doing is that we're tapping into the current item by using the indexPath.row property. So, for example, if I clicked on this first row, then the indexPath.row would be equal to 0, and I would go inside the item array, which we know is an array of NS-managed objects, and I would retrieve the first item inside that array, and then I would modify its done property or done attribute to be the opposite of what it used to be. So true turns to false, false turns to true. And then I commit those changes by using the save items method, which simply commits the current state of the context with that updated attribute to our persistent container. Now, there's other methods that you can use. For example, let's grab the current selected NS-managed object, and we can say dot set value for key. So if we know that the key that we want to change was the title, for example, right? And we want to change the title to completed for every single completed task. So maybe your task used to say save the world, but when you click on it, it now is going to read completed. Then this is a method that you can use to update your NS-managed object as well. But remember that no matter how you decide to update your NS-managed object, you still always have to call context.save. And that's because we're doing all of our changes, all of our creating, updating, reading, and destroying inside our temporary context. And it's only once we're happy with all those changes that we call context.save and commits those changes to our permanent container. So I'm going to keep my code here as it was before, because it's more succinct than using a whole bunch of if-else statements and trying to use set value for key. This does exactly the same thing, but in far fewer lines, and it also looks a lot neater. So in the next lesson, we're going to talk about the last item in CRUD, which is how do you delete items from your database using core data. So for all of that and more, I'll see you on the next lesson. Alright, so we are now on to the last item in CRUD, which is how do you delete data from your persistent container using core data? So let's try that out over here as well. So what if instead of checking items off by just having the accessory show up, what if instead we just remove the item from our persistent container? So I'm going to comment out this line, which is of course toggling the done attribute from true to false. And instead, I'm going to tap into that item array, and I'm going to use the method remove at a particular index. And the index is, of course, indexPath.row, which is the current selected index. Now, remember, this line does nothing for our core data. It merely updates our item array, which is used to populate our table view, so that when we reload the table view, we're able to refresh the latest items. Now, the method that we'll need to remove the data from our context is context.delete, and we can specify an NS-managed object to delete. And that is, of course, going to be item array at indexPath.row. So the NS-managed object at the current selected row here. Now, just saying delete to our context is not enough, remember. This is the temporary area. And unless we save that context and we commit those changes to our persistent container, then this line would have done nothing at all. So now we're going to save that context using that same save items method. And that's going to take the current state of the context and it's going to try and commit it to our persistent container. And at the end of all of that, it's going to reload the table view and show us the latest data. Now, the order at which you call these two methods, one is removing the current item from the item array, which is used to load up the table view data source, and the other one is removing the data from our permanent stores. The order matters a huge deal, and if we run our app, we'll see what happens when we don't take care of that. If we run our app as it is right now, and we click on the last item in our table view, so remember that our item array at the moment only contains 3 NSManage objects, and they're at index 0, 1, and 2. Now, when I click on the third row here, or index equals 2, the first thing that's going to trigger is that I'm going to remove that item from our item array. So now I only have 2 items in our item array. And if I click here, then our app is going to crash because indexPath.row at the moment equals 2. And once we remove the item at index 2, and then we try to access it to try and delete it from our context, then this is why we have an index out of range error. And if we try to run the app without clicking on the last item, if we try to click maybe the first item, then you can see that our app also behaves rather strangely, and it removes the second to last item. And this is all because of the order of our methods. So what we have to do is we have to call context.delete first to remove this NSManage object from our context before we try to remove it from our item array. Because we're using the item array here to try and grab that object. So now if we run our app with this new order, then you can see that when we try to delete something, our app works as expected. So all of these work exactly as we want it to. So I think deleting our items outright when we click on it is a little bit dramatic. And to be honest, I think I prefer the user experience where we have a check mark next to the ones that are done. So I'm going to comment out these 2 lines. But before we end this lesson, it's a good point to remind ourselves that to delete items from our context, all we need to do is just call context.delete and then specify the item that we want removed. But that's not enough. As with everything using core data and trying to do CRUD on it, we have to also save the context and commit the current status to our persistent containers. So other than read, everything else, create, update, or destroy, basically whenever you need to change the data inside the persistent store, you always need to call context.save to commit those changes. Now when you're reading, or as we've done inside load items, we don't call save items or context.save here because we don't need to change the persistent container. And instead, we're just fetching it and looking at the current version. Now in the next lesson, we're going to see some more fancy stuff that we can do using core data. And I'm going to show you how you can query items using core data so that we can create a search bar inside our to-do list app. So that if we have a whole bunch of to-dos, like 20, we can search and look for the ones that we're interested in. So for all of that and more, I'll see you on the next lesson. Alright, so far we've looked at all 4 of the CRUD capabilities that core data offers. So we've looked at creating, reading, updating, and destroying data using the context. And once we're happy with our changes, then we've committed those changes to our persistent container. So in this lesson, I want to talk about how you can query items using core data. So in order to do this, we're going to give our app a little bit more functionality. And the functionality that I want is having the search capability and adding that to our table view. So I want to be able to type in part of or completely a to-do list item. I want our table view to update to show me all of the items that are related with that search term. So for example, I could have something like, buy milk and buy eggs, and I just want to search for buy to see what I need to get from the supermarket. So in order to do that, we're going to go into our trusted object library and we're going to search for a search bar. A little bit circular there, but the one that we want is the search bar, not the search bar and search display controller, because we're going to implement a really simple search bar. So I'm going to drag it onto our table view, and I'm going to place it just below the navigation bar, so above the table view. So the next thing is to set our view controller as the delegate for the search bar, so that whenever there's any changes inside the search bar, like say when somebody hits the search button, then this is the class that's going to be informed, and we're going to deal with whatever they type in there inside our to-do list view controller. So I'm going to say UI search bar delegate. Now, previously, every single time we've declared our view controller as a delegate of something, we also had to make an IB outlet for our search bar, and then inside view.load say something like search bar.delegate equals self. So we're familiar with these two steps, adding the protocol in the class declaration and also setting the outlet's delegate as self. Now, this is optional, so you can either do it in code, or the alternative is you can simply hit Control, drag, and point to this little yellow icon, which represents the view controller. And if you let go, you see that there is a delegate for this outlet that you can set as the view controller, which, remember, the yellow icon represents. So make sure that you're actually originated from the search bar rather than from somewhere else, like, say, the table view, right? Because in this case, it's got a data source and a delegate, and you can see that they're already set up to be our view controller class. So it might even be easier going from the document outline and dragging it to the yellow icon and then hitting delegate. So the next step, if we go back into our to-do list view controller, is we need to add some delegate methods in order to make the UI search bar delegate work, right? So what we can do is right at the bottom below load items, we can add the delegate method, and it's called search bar. Usually, so for a lot of these methods, as long as you're aware they exist, you can pretty much guess what you should start typing in order to get this list of suggestions come up. And you can scroll through them looking at the information text as to what each one does until you find the one that you want, which is, in my case, search bar, search button clicked. So this tells the delegate that the search button was tapped, and that is the point where we want to reload our table view using the text that the user has inputted. So let's hit enter and insert that delegate function in there. Now, some of you might wonder, if we have so many of these delegates, say, we have UI search bar delegate, then at a later stage we decide to add like a picker view, UI picker view delegate, then we decide to have one which is UI image picker controller delegate. If we have all of these stacking up because we need all of them in our app inside the same view controller, inside the same screen, then it's going to start getting pretty cramped up here. And you've also got different delegate methods that relate to each of these bits of functionality. For example, the search bar or the picker view or the image picker controller. And should they really all be crammed into the same class? I mean, it seems like it's going to get a little bit tight on space, right? Well, the alternative that we can use that you're going to see in a lot of projects that you download from GitHub or out there in the wild is this is the closing brace for our class, and everything inside is our to-do list view controller class. Now, if we go outside of the last curly brace and we create an extension, then we can extend the functionality of our to-do list view controller, and we can set it to be a UI search bar delegate. So the advantage of this is that we can split up the functionality of our view controller, and we can have specific parts that are responsible for specific things. So for example, this extension extends our base view controller and gives it the extra power or the extra functionality of being able to handle search bar methods. So the other advantage is that when you look up here, you can see that we've got the base class here and we've got our extension down here. And one of the downsides of MVC, or the model view controller pattern that Apple is such a big fan of, is that your C starts getting really, really big, and it basically becomes like tiny M, tiny V, and massive C, you often see this gigantic view controllers, especially when you look at Apple's example projects, and they just start getting really, really big. So it's really important that you modularize and try to split up the functionality as much as you can, not just for code organization, which is handy, but also so that when you come to debug it, you can narrow down on which section you need to look at instead of going through the entire page, right? So for example, if we had issues with our search bar, then we can navigate straight down to our extension that deals with all of the search bar functionality. And we can read only, maybe 10 lines rather than 100 lines of the page. So far, we've been using these mark comments in order to be able to look at our view controller and have this quick breakdown of what are the different sections and what are the methods in each section. But now we have this extension, and even though the extension unfortunately doesn't allow you to rename it, you can still put a mark above it so that you can see it as a separate section. So we'll call this search bar methods. And when we go into our file now, we can see our main class as well as our extension class, which is responsible for the search bar methods. So this is a very Swifty kind of pattern, and you're going to see this pretty much everywhere. And usually, as a rule of thumb, whenever I want to create a new protocol here, in the class declaration line, I tend to create a new extension and group the protocol methods together. Like we're going to do now. So inside our to-do list view controller extension, where we are extending the functionality with a search bar and some search bar methods, we've got this delegate method, which is going to be triggered once the user presses the search button on the search bar. So this is a good point for us to query our database and try to get back the results that the user is searching for. So as always, in order to read from the context, we always have to create a request, and we have to declare the request data type. So ns fetch request, and it's going to return an array of items. And we're going to set this to equal item dot fetch request. Now the next step is we have to specify what is going to be our filter, right? What is going to be our query? And we do that using something called an NS predicate. But before we do that, let's first have a look at what is the data that we get back when the user clicks on the search button in the search bar. So let's go ahead and just print out the search bar dot text. And let's go ahead and run our app. Alright, so the first thing that we see is that we now have a search bar. Yay! That was pretty easy, right? And the first thing I'm going to do is I'm going to hit Command K or go to Hardware and Keyboard and Toggle Software Keyboard. So Command K does exactly the same thing, and it basically pops up and pops down the keyboard on screen. And then I'm going to, for example, type save in order to pull up all the items that contain the word save in their title. And then I'm going to hit search. And this is the point where our search bar search button clicked, delegate method gets fired, and it runs everything that's inside. And so our print statement prints out what the search bar dot text at this point is, and it's the word that we entered, which is save. Okay, so that worked pretty nicely. It's always a good idea to check along the way to make sure that all your presumptions are right and all your setup, especially with these UI elements, have not gone awry. So we now have this request, and we need to modify it so that we tag on a query that specifies what we want to get back from the database. So in order to query objects using core data, we need to use something called an NS predicate. So we can say, for example, let predicate equals NS predicate, and we're going to initialize it using a format. So the format, as you can see from the placeholder, takes a string. And the string is a little bit scary because you're now typing in free text. And in our case, what we would do is we would say title. We're going to look at the title attribute of each of our items in our item array. And we're going to check that it contains a value. So this is the argument that we're going to substitute into this percentage at sign. And I'm going to talk about why all of this looks so different from what we've been doing in Swift in just a moment, but let's just set it up first. And the argument is, of course, what we printed out in our print statement, which is the search bar .text. And so when we hit the search button, then whatever we have entered inside the search bar at that time point is going to be passed in to this method into this part and replacing this percentage at sign. So then our query becomes, for all the items in the item array, look for the ones where the title of the item contains this text. So this is pretty unfamiliar if you have only been working with Swift. This part might look quite familiar to you if you've ever used or looked at Objective-C code. And the reason is because NSPredicate is basically a foundation class that specifies how data should be fetched or filtered. It's essentially a query language, which is like some sort of weird love child between the SQL where clause and a regex or regular expression. It's meant to be similar to natural language, like how you would speak in English, but there's a whole bunch of modifiers and logical conditions that you have access to that you can put inside this format string. So let's take a look at those. So a really good resource is actually on the Realm blog. And even though we're not using Realm yet, we're actually still using core data. When you query items inside Realm, they also use the same thing, which is NSPredicate. So they've made this beautiful PDF that is essentially an NSPredicate cheat sheet, which you can download from this link here, which I'll include in the resources for this lesson. But essentially, you can have a look at how the string is structured, right? So remember that the percentage at sign substitutes any sort of argument that you want to pass in, and you can use most of your basic comparators, like left hand is equal to right hand, or left hand is greater than or equal to the right hand, as well as everything that we've been using so far. But it's also got some of these special words in all caps. For example, the word like between, right? The left hand expression is between or equal to the right hand expression. And you can compound your predicates together by using the and, or, and not. So you can say that the age is equal to 40 and the price is greater than 67. I don't know in which case you would have to look for something that has age over 40 and price over 67. Oh, maybe wines, I guess that works. I don't know why I was thinking about humans or pets. It's really bizarre. Anyways, so it's also got things like string comparison operators, which is what we use, which is the contains, because our title is a string, and we wanted to check to make sure that the titles of each of those items contains, i.e. it can partly contain the text that we're searching for, because we're not going to enter the exact word that we're looking for. If we're looking to try and pull up the items like buy milk and buy bread, then it's not very useful just searching for buy milk so that buy milk pops up, right? We want to look at all the things that contains the word buy. Now, if you wanted an exact match, then you might use something like matches, right? So that it exactly equals the right-hand side. So when you're dealing with strings, then these are some good ones to work with. For all the other data types, then usually you'd be using these basic comparators when you're working with numbers especially. So this is a brilliant cheat sheet. Have a look at it, study it if you're going to be querying your database, and you can do a lot of really sophisticated stuff with it, and it's still relatively short and easily readable. And they've also got some tips, tricks, and examples which work with core data as well. It's basically how you search your databases using Realm or using core data. And another good article is this one on NSPredicate written by Matt Thompson, who was one of the creators of Alamo Fire that we've been using so far. So a really good article on this if you want to read up more on it. And one of the things you need to remember about string comparisons using NSPredicate, as you'll find in this article, is that string comparisons are by default case and diacritic sensitive. So case obviously means upper or lower case, and diacritic refers to these little marks above your letters. So for example, in French you have the circonflexe and the grave accents, or in German you have the umlauts. So these are the diacritics. And, you know, for us to implement search, do we really want it to be case sensitive and diacritic sensitive? Probably not. So you can modify that by just adding the square brackets and including C and D. So C stands for case and D stands for diacritic. And it makes it basically insensitive to these two things. So let's go back to our code and modify it with our new knowledge. So we can add it after the contains, and we're just going to add CD to it. So now we have structured our query, and we're going to add our query to our request. So we can say request.predicate equals predicate. Alright, so now that we've created our predicate, which specifies how we want to query our database, the next thing that we can do is we can actually sort the data that we get back from the database in any order of our choice. So we can create a sort descriptor that is a NS sort descriptor, and we can say that we want to sort using the key that's the titles of each of the items, and we can sort it in alphabetical order by saying ascending equals true. So now we can add the sort descriptor to our request by saying request dot sort descriptors. So it's really important that you notice here that this property is actually plural, and that's because it expects an array of NS sort descriptors. But in our case, we actually just want to specify a single sort rule. So we're going to say sort descriptors equals an array of sort descriptors, but it only contains a single item, and that's perfectly valid code. So now all we have to do is to run our request and fetch the results, right? So if you have a look in our load items method, you can see that we've got a block of code that does exactly that. So we can copy and paste it over here so that we can try using our context to fetch these results from our persistent store that satisfy the rules that we've specified for our request, which is namely the title should contain whatever is in the search bar, and the results should come back with their titles assorted in ascending alphabetical order. So then we assign the results of that fetch to our item array, and we now need to reload our table view so that we re-trigger the self_arrow_at_index_path method, and we update our table view with the current item array, which contains the results of the search. So now, as I always say, whenever you find yourself copy and pasting large chunks of code, then it's probably a good trigger for you to think about whether if you can refactor your code so that it's more succinct and you're not repeating yourself, but instead keeping our code dry. But before you refactor your code, you should always make sure that you test your assumptions and make sure that the current code works. So let's do that now. Let's run our app and see if it works. Alright, so I've added a whole bunch of items that all contain the word save. So there's 4 items that contain a capitalized save. There's one lowercase save, and there's one save with a diacritic. So if we go into our search bar and search for the word save with a capital S, we're going to look inside all of these items and look for the ones that contain the word save, and our query is case and diacritic insensitive. So let's go ahead and hit search, which of course triggers the search bar search button clicked delegate method and executes all of this code. And what we get back is all of the items that contain the word save, and it's case and diacritic insensitive. So now that we've proven that our code works, then it's a good time to refactor our code. So one of the first things is that we probably don't need this constant, right? We can simply replace it with request.predicate. And we can delete this line. So 2 become 1, and we can replace this let's sort descriptor with request.sort descriptor. Now, before we can delete this line, we have to realize that sort descriptors expects an array of NS sort descriptors. So we have to add these square brackets around this line on the right-hand side in order to make it equivalent to this. And now we can finally delete that line. So now we've gone down from 4 to 2. And finally, as I said before, we've got this do catch block that's repeated inside our load items method. So I want to be able to call load item rather than having to write out all of this code again. So what I can do is I can comment out this code, and I can modify this function to take a parameter that is the request. So this is going to be of data type ns fetch request, and it's going to return an array of items. So now, instead of repeating this do catch block, I can simply say load items, and the request that I want to make is this modified request, which contains the query and the sort descriptors. So I can say load items with request, and the request is this one. So the only problem here is that load items request doesn't really make a lot of sense in English, right? And what you notice with Swift is that it's really pro natural language. So you want to have your method calls sound almost like they make sense in English. So having request is kind of confusing and doesn't make a lot of sense. So we can modify this parameter to also have an external parameter. So this is the external parameter and this is the internal parameter. So the internal parameter is going to be used inside this block of code, and the external one is the one that we're going to use when we call the function. So now that reads a little bit better. Load items with request, right? Now what's happening is we're creating a new request, then we modify it with our query and our sort descriptor, and then we pass that request into our load items function over here as an NSFetch request, and then we perform that request by saying context.fetch. So we can now delete this do catch block, and we can also delete tableview.readLoadData because it's already inside load items. And we now have a shorter and much sweeter block of code. Now, because we're passing in the request, and then we're creating a new constant called request, it's a little bit confusing which one is used here. And in fact, we don't really need this line if we're going to pass in the request. We don't need to reinitialize a new request, right? Now, there's just one problem, and Xcode is actually notifying you of it using this little error here. And it's saying, right at the beginning, when we perform view.did_load, we also call load items. And this is where we want to load up all of the to-do list items from our persistent container. And at this point, we're not really interested in querying it or sorting it. We just want every single to-do list item so that we can show it in our table view. But now, this load items method actually expects a parameter. So what can we do? Well, we could maybe copy this line of code and paste it up here. So we can say let request equals just fetch all of the items from the persistent store, and we can now pass it in as a parameter, say load items with request. But this is not really ideal, and it's not all that succinct either. So we can actually shorten this code even more by providing our parameter with a default value. So we can say that the request is of type NSFetchRequest, which should fetch an array of items, that's the data type. And if, when we call this function and we don't provide a value for the request, then we can have a default value that's simply item.fetchRequest. So now we can delete this line of code, and we can be safe in knowing that when we call load items with request and we provide an argument, then that's the one that we're going to fetch from our context. But if we call our load items without a NSFetchRequest item, then we can simply use the default value, which is item.fetchRequest. And what this allows us to do is up here, when we call load items, we can simply call it as we did before without giving it any parameters. And we can also delete this line of code. So this method is a little bit complex because we have an external and an internal parameter, but also it has a default value in cases where we call load items without giving it any parameters. So it's a good idea to have a play around, maybe in playgrounds, at creating methods that have internal and external parameters, just to see how it works, and also to create methods that have default values, so you can see how you can call them and how you can create them. Now, there's just one problem with our search bar, And it's the fact that we can't actually get back to our original table view. What do we do once we're satisfied with searching for the word save? And we actually want to go back to seeing all of the to-do list items. It doesn't help if we try and click the cross and delete all the search. We can't get back, right? And that's because we haven't written any code to do that yet. So that's what we're going to do in the next lesson. We're going to address that bug and we're going to fix our table view so that we can return to our original state. So for all of that and more, I'll see you on the next lesson. So in the last lesson, we managed to successfully implement our search bar, but now we want to be able to go back to our original list of all of our items. For example, when we click on the cross button, right? That's the normal behavior that users have gotten used to when they clear the search bar. So let's go into our to-do list view controller extension, which is the part that deals with our search bar methods. And let's go and create a new delegate method here. And the method that we're going to use is, of course, relating to the search bar. And we're going to look for the delegate method that is search bar text did change. So this triggers the delegate method when the text inside the search bar has changed. So that means every single letter I type in here is going to trigger this delegate method. But also, when I go from a whole bunch of text to no text, this delegate method is also going to be triggered. Now I can isolate that particular instant by checking inside this delegate method. So whenever there are any changes inside the text of the search bar, I can see if the search bar dot text dot count, which looks at the number of characters in the string or the search bar text, is equal to 0. And because of where this if statement exists, it means that text inside the search bar has changed, but it has also gone down to 0. So when we first load up the app and the search bar has no characters inside, this delegate method is not going to trigger because the text has not changed. And it's only when the text has changed and it's gone down to 0, which pretty much describes the time point when I click that cross button, does this part of the code inside this if statement get triggered. So inside here, I'm simply going to call load items, which, if you remember, has a default request that just fetches all of the items from my persistent store, just as we had up here in our view did load. So now if we run our app and let's try and check it out, let's search for save, hit search, and then we're going to click the cross button, and you can see that we are now reverted to our original list of items. Now there's just one niggling thing. The fact that our keyboard has not dismissed itself and our cursor is still flashing in the search bar. Now how can we get it to go back to the original state where the search bar doesn't have a cursor and the keyboard is dismissed? So in order to do that, we need to call upon a method called resign first responder. So telling the search bar to stop being the first responder. Now we're going to do it inside here after we call load items, and we grab a reference to the search bar that we've got, and we're saying resign first responder, which notifies this object, i.e. the search bar, that it has been asked to relinquish its status as the first responder in its window. Now that sounds pretty dramatic, right? It's like, you're being overthrown or something. But actually, all it refers to is that it should no longer be the thing that is currently selected. So no longer have the cursor, and also the keyboard should go away because we are no longer editing it anymore. Basically, go to the background, go to the original state you're in before you were activated. Now, whenever you're writing methods to affect the user interface, you tend to want it to happen in the foreground. Now, if we run our app and have an active session, if I click on the pause button here in the debug console, you can see that we can trigger a debug session. And it's at this point that you can see that we've got actually multiple threads that are running, but only one of them is the main thread in our queue. So for example, if I decided to make a network call to, say, a Firebase database, on the main thread, then it means that it has to go over the internet, grab the data back, and no matter how long that process takes, it's going to freeze your app until it completes. Which is why we tend to complete those tasks in the background using another thread, which means that our user interface is not going to freeze up while we're waiting for that process to complete. And on the background thread, once that process is complete, then the data gets delivered back and we can update the user interface using the main thread. But in our case, while background tasks are happening, we need to grab the main queue so that we can dismiss our search bar even if background tasks are still being completed. So in order to do that, we have to tap into the dispatch queue. And this is the object that manages the execution of work items. So it's almost like when you're submitting an application for a visa, right, to an embassy. And you have somebody at that embassy who is prioritizing who should be processing your visa. So, for example, if you were a diplomat or you paid for, extra fast service, then your passport might get sent by the manager to the guy who's, working 24/7, stamping visas, so that your visa processing happens immediately. However, if you are just a standard person trying to get a visa to, somewhere exotic for the winter, then you might get shuttled to, the guy who only works 1 hour a day. And they have so many tasks lined up that it might take you a week before you get your visa processed and get your passport back. So the dispatch queue is that manager who assigns these projects to different threads. And we're going to ask it to grab us the main thread. And this is where you should be updating your user interface elements. And then we're going to tap into a async method. And inside this block of code, we're going to insert our search bar updating code. So whenever you're trying to move code inside Xcode, it's a little bit tricky because it's a matter of timing. You have to click on it and wait for the arrow to appear and the cursor to disappear before you start dragging. And now you can move your code. So now we're saying ask the dispatch queue to get the main queue and then run this method on the main queue. So now if I run my app and we hit search, then we get back all the items that has the word save. But when we dismiss the word save, then our keyboard pops away and our cursor disappears from our search bar, all because of this line of code being run in the foreground. Now, in the next lesson, we're going to take core data much further, and we're going to learn about one of its main features, which is establishing relationships, or what we might call graphs, inside core data. And we're going to turn our simple to-do list into one that's more like a real-life to-do list by having a separate to-do list for various categories. So for all of that and more, I'll see you on the next lesson. Now, when you look at most to-do list apps out there, it's very rare that you'll come across a to-do list that only has a single list, but unfortunately that's currently all that we've got. Most to-do list apps will have categories, so for example, cleaning, bills, miscellaneous, grocery, and you'll be able to tap on them to view those lists. And this allows us to classify and categorize so that we can organize our to-do list items in a more logical way. So that's also a good feature for us to add to our To-Do app. And in order to implement it, we'll get to learn all about relationships and how we set them up using core data. So the first thing I'm going to do is I'm going to make some UI changes. At the moment, we've got a single table view controller that is embedded inside a navigation controller. Now, in order for us to have a category screen, then we need to drag on another table view controller. So I'm going to place that between the navigation controller and our to-do list items table view controller. Then I'm going to delete this link between the navigation controller and the to-do list controller, because this link specifies which is the root view controller, i.e. if you have a navigation stack, like a stack of cards, what is the controller that's at the bottom of the stack? And when you say something like pop to root view controller, that's equivalent to the first screen that's embedded in the navigation stack. So let's go ahead and click on this link and delete it. And then I'm going to replace this category view controller in between our navigation controller and our to-do list view controller. And then I'm going to click on the navigation controller. So I get this little yellow button here, and I'm going to control drag it to point it towards our brand new table view controller. And instead of using show or creating a segue, instead I'm going to create a relationship segue and specify that this is now the root view controller, because we first have to see the category table view, and only then can we select one of the categories to take us to all the items that are classified under that category. So that means we also need to set up a segue between our category and our to-do list items by control dragging, and in this case we're going to go for a show segue. And if you remember, every single time we set up a segue, we also have to specify an identifier. So we'll just call this go to items. And we currently now have this free floating table view because it doesn't have a view controller class that's associated with it. So let's go ahead and create a new one. And instead of creating a new Swift file, we want a new Cocoa Touch class. So hit next. And this is going to be a subclass of UI table view controller because we want all of that freebie code that comes with it. And then we're going to call this class the category view controller. Make sure language is selected as Swift and hit next. And then we're going to save it inside the controllers folder or group and making sure that it targets our To-Doey app. And then we're going to hit create, and we now have a category view controller. So I'm actually going to drag that on top so that it makes more sense, because we first go to category, then we go to the to-do list for each category. So now if we go back to our main.storyboard, we can specify the Swift file that is going to be responsible for managing this particular view. So if you don't do this step and you head over to the assistant editor, when you select the to-do list item view controller, you see that under automatic, we've got to-do list view controller.swift. But when you select this new table view controller that currently is not associated with any Swift class, then you can see that under automatic, you only get a UI table view controller file. And this is also not a Swift file. This is actually an Objective-C header file. So that's not what we want because we can't link up our outlets and we can't do anything. So we have to specify the identity of this view controller. And inside the custom class, we're going to say category view controller and hit enter. So now, automatically, our assistant editor has updated to the corresponding class with our view controller. Before we leave the main.storyboard, is we want to give this prototype cell a identifier. So select the prototype cell either on the canvas or select it in the document outline, but we're going to call it category cell and hit enter. So now that we've got our view and our class linked up, we can now create a add button or bar button item rather, and we can drag it to the top right corner of this new view controller. And again, this is going to be a system item of add, and we're going to change the tint to white. This is going to allow us to add new categories to this table view so that we can organize our to-do list. And once you've done that, we're going to control drag over to our category view controller.swift file, and we're going to create a new IB action. And this IB action is going to be called add button pressed, and it's going to be of type UI bar button item. And hit enter. And the last thing I'm going to do here is select the navigation item here, and I'm going to give it a title called To-Doey. And then I'm going to change the title here to items. And that is all we need to do inside the main.storyboard. So let's head over to the category view controller. And the first thing I want to do is when you set up a new Cocoa Touch class that subclass is UI table view, you get a whole bunch of free code, but you also get a lot of comments. And, you know, we're now pro enough with table views to not need all of this help and guidance. So I'm going to delete all of this code up until view did load. And then I'm also going to delete all the comments inside view did load. That cleans up our view controller a little bit and allows us to work on it without all of this distraction. So now that we've set up our view and our controller, we're going to go and figure out what we're going to do with our data model. So up till now, we've been editing our entities and attributes under this table view format, but you can also switch to the graph view. And this presents each entity and all of their attributes as a little table. And for those guys who've been working with databases, then this might seem quite familiar to you. So it's under this format that we're going to add a new entity. And this new entity is going to be called category. And once you hit enter, then you'll see this new table show up that's called category, which has no attributes and no relationship. If you select the category entity and click add attribute, then you're going to get a new attribute. And we can click on it to modify its properties inside the data model inspector in the right-hand pane here. Now, for some reason, I have no idea why, the icon for it is like a little welding mask, but some designer somewhere thought that this was a good idea to represent a data model. But hey, let's not argue with Apple designers, right? Okay, so we're going to change the attribute name to be called name, and this is going to refer to the name of each category that we're going to add. And we're going to make the name non-optional, so it has to have a value for it to go into our data model. And you'll see this little error here, and it won't go away until you change the attribute type from undefined. It cannot be undefined. It must be specified. And our name for the category is, of course, going to be a string. And once you do that, then Xcode is all happy with you and all the errors go away. Now, in addition to having a single attribute for the category, we're also now going to set up a relationship between our category and our item entities. And to do that, all you need to do is control drag from category to item, and now you have a relationship. Now, it's not very useful having a relationship called new relationship, so we need to rename that. So click on it, and that'll allow us to edit it in the data model inspector. We're going to change the name to something that makes sense. So each category can be associated with many items, right? If you have a category called shopping list, then you might have 10 item objects that refer to all the things you need to buy. So we can call this relationship items, because that's essentially what it's referring to. And we should change the type from to one to too many, because each category can have many items associated with it. Now, the inverse relationship refers to what would you call the category that the item is associated with. And that should probably be called the parent category. And each item can only have one parent category, so this type should remain as to one. It would be really confusing if each of your items have two categories. Say, your buy milk belongs in shopping list as well as another category. That doesn't make any sense logically. So we've now created a new entity called category, and we've also started creating our graph, which specifies how categories relate to items. And this might be a good time to remind yourself of when we first started talking about databases in this module, when we were talking about our bakery having a products table, a buyers table, and an orders table. And in order to manage all of the complex data, we need to set up these relationships. So now, when we create a new category, we can link it with many item NS-managed objects. And every single item object, we can look up its parent category. So this now gives us access to more complex things that we can do with our data, including setting up this new view controller and having a whole bunch of categories that each have their individual to-do lists. Now, all we need to do is head back to our category view controller, and we need to set up some code to use our data model. So in order to do that, we'll need to import core data. And we'll also need to have some table view data source methods, as well as table view delegate methods. And then we'll need some data manipulation methods. So I think you're probably getting the hint. I'm not going to do this for you. I want you, as a challenge, to think back to what we did inside our to-do list view controller. How we set up an array of items, how we tapped into the context that we're going to use, and then how we set up our table view to load our data from the context for all of those items. And then we used our IB action, add button pressed, to add new items into our table view. And then we used the save items function to persist that items inside our container. And then we loaded those items from our persistent container using our context. Now I want you to complete this challenge and be able to set up our category view controller in a similar way to what we did with items, to use our core data model, and to be able to add new categories and to be able to show those categories inside our table view. So all you need to do is set up the data source so that we can display all the categories that are inside our persistent container. Set up the data manipulation methods, namely save data and load data, so that we can use CRUD. And finally, to set up the add button pressed IB action in order to add new categories using our categories entity. And the part that I want you to leave for now is the table view delegate methods. So that refers to what should happen when we click on one of the cells inside the category table view. So I know that these challenges are getting more and more challenging, but if you've come this far and you've followed along with everything that we've been talking about with core data, this is a good time to really test to see if you understood the concepts and use what you learned to set up your very own table view controller that has a persistent data store using core data. And if you have completed the challenge successfully, then you should end up with a blank table view with the title to doing. And you should be able to click on the add button to add new categories to your table view. And when you double click on the home button and terminate your app, now I really recommend you to give it a go yourself. And it might require quite a bit of struggling, but struggle is good. And once you struggle through it and get it to work by yourself, then you'll feel this immense sense of achievement. But if you do get stuck and you do have any issues, then you can always head over to the next lesson where I will walk you through how we can do this. So pause the video and give it a go now. I'll see you on the other side. Alright, so how did that go? I hope you gave it a go and you now have a working category view controller that works as you expect it to. Now, I know I'm repeating myself, but if you haven't given it a go, do it now. Don't watch the solution video first, because then you can't prove to yourself that you really do understand it. So I'm going to presume that you've given it a real good go, and you're just here to check and make sure that you've got it right. So if we have a look at our to-do list view controller, the first thing we have is this variable item array that contains an array of NS-managed objects created using the item entity. Now over here, we'll need something similar. So let's create a variable called categories that is going to be an array of category objects. And we'll initialize it as an empty array. The next thing we need to do is we need to grab a reference to the context that we're going to be using in order to create, read, update, and destroy our data. And this is going to be the thing that's going to communicate with our persistent container. So the context is going to be equal to our UI application, and we're going to grab the shared singleton app instance, and we're going to tap into its delegate property, and we're going to downcast this as a app delegate object. And then we're going to tap into our app delegate's persistent container variable, and then we're going to load up the view context for that persistent container. If any of that was confusing at all, make sure that you have a look back at when we first wrote this line of code, and also the animations where we walk through how this worked. Now the next thing is to set up our table view data source methods. So we should know the required ones by now, right? It's table view number of rows in section, and we're going to return, of course, the number of items in our categories array. So return categories dot count. All right, so on to the next obligatory table view delegate method, which is table view self arrow at index path, which is here, self arrow at index path. So here we are going to dequeue a reusable cell with identifier for index path. So this creates a reusable cell and adds it to the table at the index path. So the identifier is a string, and let's just go back and check what we called it. And we called it category cell. So I'm just going to copy and paste it into here as the identifier. And the index path is, of course, the current index path that the table view is trying to load up. Now, once we've created our reusable cell, we got to set the cell's text label.text property. And we're going to set it to equal categories at indexPath.row. And we're going to tap into the categories name property or name attribute that we created earlier on. That property gets automatically generated because we added it as an attribute. And finally, all that's left to do is to simply return the cell and it will be rendered on screen. Now, the next thing I'm going to work on is the add button pressed IB action. And here we're going to create a new alert, which is going to be created from a UI alert controller. And I'm going to use the initializer that takes a title, which we'll call add new category. Message will leave blank, and the preferred style will just be alert. And then I'm going to create a action equals UI alert action. And this also takes a title, which is going to be the word just add. That's going to be the name of the button. The style is just going to be default action. And I'm going to select the placeholder for the handler and hit enter so that it creates this completion handler for us. I'm going to name the alert action just action. We're not really going to use it. And I'm going to delete the code placeholder. Now, inside this completion block or closure is where we're going to specify what should happen once the user clicks that add button. But before we do that, we're going to say alert.addAction, and the action we want to add is the one that we created just now. And we're also going to set up our text field. So we do that using alert.addTextField, and we're going to hit enter on the configuration handler, and we're going to call our text field just field. And once that new text field has been created and added to the alert, we're going to store a reference to it by creating a variable called text field, which is going to be a new UI text field object. And then we're going to set that text field to be equal to the field that is created inside our alert. And then we're going to set the text field's placeholder to maybe something like add a new category. And finally, we're going to say present view controller. To present is the alert view controller. Animated true, completion nil. Okay, so now it's time to address what should happen when the user clicks on the add button inside the alert. Well, this is where we have to create a new NSManaged object, and that is going to be a new category. So let new category equal category. Now, notice how there's also a type alias called opaque pointer that also has the name category. So make sure you don't pick the opaque pointer. Pick our category instead. And also double check the data type by option clicking on category afterwards. And we have to create our category by specifying a context. We've already created a reference to our context at the top of our file, so that's the one we're going to use. And by the way, if when you option click on your category and Xcode tells you it's a opaque pointer data type, just surround the word category with backticks like this, and that should solve the problem. But because we're inside a closure, remember, we have to write self.context in order to refer to that variable. Now we're going to set up the new category. New category.name is going to equal to the text field.text. So whatever the user entered into that text field inside the alert is going to be the name of the new category. And then we're going to grab a reference to our array of category objects by saying self.categories.append. And we're going to add this new category to the array. And finally, we're going to call save categories. And this method, of course, doesn't exist, which is why it's not being highlighted. So this is a good time to go into our data manipulation methods section over in the middle here and add that function, save categories. And now Xcode reminds us that, of course, we need the self in front of save categories because we're inside a closure. And then it changes color to reflect the fact that it recognizes what we're talking about and which method we want to use. So inside our save categories method, I'm going to try and commit our context to our persistent container by saying context.save. Now, because this throws, then I'm going to hold it inside a do catch block, and I'm going to log or print any errors that it catches. So, error saving category, and the error is error. Alright, and finally, once we have saved successfully, we're going to call tableview.reloadData so that our table view updates with our latest data. Now, the last thing that we have to do is we need to call a method called loadCategories when we first initialize our category view controller. And that also does not exist, so we need to add that over here. We're going to create a function called loadCategories. And inside here, we need to read data from our context. And to read data from our context, we need to specify a request. And we need to specify the data type of the request as a NSFetchRequest that is going to return an array of category items. And this is going to be equal to a broad request. So we want to grab all of the category objects. So we're going to say category.fetchRequest. So we get back all the NSManage objects that were created using the category entity. So now we're going to say try context.fetch, and we're going to fetch back all the results that fit our current request. And if our fetching of our request succeeds, then we're going to save the output, or whatever gets returned from this method, into our categories array. So we can say categories equals try context fetch request. And because this method can throw, then it's a good idea to trap it inside a do catch block, where we're going to print and say there was an error loading categories, and this was the error code and error message. So now all we have left to do is we have to tell the table view to reload the data using our latest version of categories after fetching all of the category objects. So let's give our app a go and see if all of that code worked. Cool, so we're bringing up a blank table view because currently we still don't have any categories. And you can confirm that if you go into the SQLite database. But if we add some new categories, let's say, I don't know, shopping list, maybe another one called home, and one called work, and maybe one called miscellaneous. Okay, so we now have 4 categories. And we can check to make sure that they are indeed being persisted using core data by double tapping the home screen, terminating our app, and going back into our app. And as you can see, they are still exactly where we left them. So our code has succeeded. So if you had any problems setting up your code up to this point, then it might be worth going back to your code and seeing if there's any errors or bugs that you can fix. Now, in the next lesson, we're going to set up our table view delegate methods, namely what should happen when we click on one of the category cells. Because when I click on home, I want it to take me to a table view that contains all of the to-do list items that are associated with the home category. So for all of that and more, I'll see you on the next lesson. So now we need to add some code that allows us to click on one of these categories, and it should take us to the to-do list view controller and populate the table view in the to-do list view controller that are all the items that are under this shopping list category. So let's get going with that. So in order to do this, we'll need our table view delegate methods, and we can put that under the data source methods here. And the method that will be especially crucial will be table view did select row at index path, because this will trigger when we select one of the cells. So when this delegate method triggers when we select one of the cells, we probably want to trigger that segue that we set up earlier on here. That takes the user from the category view controller to the items view controller. And that segue we called go to items. So that's what we're going to call here. We're going to say perform segue with identifier go to items, sender is self. But before we trigger the segue, we need to do a little bit of prep for the next view controller, because right now, this to-do list view controller, when it gets loaded up, it's just going to pull out all of the items that we've ever saved, which doesn't achieve what we're trying to do. So in order to do that, we need to initialize this item array with all of the items that belong to the category that was selected. So as always, we need to do the prep work inside the delegate method, prepare for segue, because this is going to be triggered just before we perform that segue. So here we're going to create a new constant that is going to store a reference to the destination view controller. And we can grab this by using the segue.destination property. And we're going to downcast this as a to-do list view controller, because we know where that segue is going to take us to. And if we had more than one segue originating from our category view controller, then we might also add an if statement just to check if the segue has identified go to items, then do this. But in our case, we've only got one segue, so I'm going to shortcut that for now. So the next thing that we need to do is to grab the category that corresponds to the selected cell. And to do that, I first need to know what is the selected cell. While I have access to that inside the table view did select row at index path delegate method, I can't tap into that local variable inside the prepare for segue delegate method. But I can say let index path equal table view dot index path for selected row. And this is the index path that is going to identify the current row that is selected. But this, if you option click on it, you can see is actually an optional index path, because it might just be that at this point there's actually no row that's selected. Now that's not likely to be possible because we're only triggering our segue when we do select a row. But just in case, let's wrap that inside an if let. And if the index path is not nil, then we're going to tap into the destination view controller and we're going to set a property. And we're going to set a property in the destination view controller called selected category. Now, this does not yet exist, but we're going to create it very shortly. So Xcode is going to complain, but it's okay. We know why. But we're going to set this selected category to our array of categories at our index path, not the one with the capital I, but the one that's lowercase that we created here, dot row. So now, in order for our code to work, we need to create this property called selected category inside our to-do list view controller. So just under our item array, I'm going to create a new variable called selected category. And this is going to have a data type of an optional category, because it's going to be nil until we can set it using this line of code. But once I do set that selected category, then that's the time point when I want to load up all the items that are relevant to this category. So something that I can do in Swift is I can open up a set of brackets after the selected category variable, and I can use a special keyword called didSet. And everything that's between these curly braces is going to happen as soon as selected category gets set with a value. And this is the perfect place to call load items. And we can delete it from our view did load. So that means when we do call load item, we're certain that we've already got a value for our selected category. And we're not calling it before we actually have a value, which might crash our app. So now, if I turn this icon from gray to white by hitting Command S and saving it, then if I head back to my category view controller and hit Command B to hit Xcode with a stick and refresh this code, then the error should go away. Now, Xcode is notoriously buggy, especially given how long Apple's been working on it. And sometimes it just doesn't work as smoothly as you want it to. But we have gotten rid of all of our errors. Now, there's just one last thing that we need to do before we can run and test our app. And that's inside our to-do list view controller. In our add button pressed IB action, at the point where we create a new item. Now, not only do we have to specify the title of the item, whether if it was done, but we now also have to specify its parent category. And this property, parent category, is available to us because we created that relationship that points to the category entity. And because we've already set the selected category that is powering the current to-do list view controller, then we can just simply say new item.parent category equals selected category. And of course, because we're inside a closure, we just need to add the word self in front. So let's give it a go and run our app. Alright, so here's all of those categories that we created earlier on. And I'm going to select one of these categories, and I want you to predict what is going to happen when I click on this. So, was this what you expected? We have loaded up all of the previous items that we have saved into our to-do list before we even established the relationships or the categories. And in fact, when we created any of these items, none of them actually had a parent category associated. So, why is this happening? Well, this is a bug and we need to solve it. If you think about it, we need to figure out how is our to-do list view controller loading up all the items in the table view. Well, the items come from the item array, right? And the item array comes from the load items method, which simply fetches all of the NSManage objects that belong in the item table or item entity. But in order for us to only load the items that have the parent category matching the selected category, we need to query our database for it, and we need to filter the results. So we need to basically create a predicate that is a NS predicate and initialize it with the format that the parent category of all the items that we want back must have its name property matching the current selected category .name. And then we need to add this predicate to the request. Request.predicate equals predicate. But now we have a bit of a problem, because if we set the predicate here and we set the predicate property on the request to this new predicate, then the ones that we set before, say for example in our search bar, is not going to be valid anymore and it's going to be overwritten. And you can see this if I run our app in its current state. So if we hit shopping list, we do in fact go into an empty list because we haven't yet created any new items that have the parent category as shopping list. But if we add a few items, and we now try to search these items, you can see that our search fails, and all we get are just the same items, but now they're sorted in alphabetical order. And the reason is because when we press the search button, we create a request, we add the filter or how we want to query our data, and then we say that we want to sort it in alphabetical order, and then we run load items using this current request. But once that request reaches here, then we override the predicate using a new predicate, which is simply that the parent category must match the current selected category, which is not very useful. While we do want every single item that's loaded up in the table to have a parent category that is the current selected category, we also want our search to work. So how can we fix this? Now this is almost a bit like a brain teaser, but you should already have most of the components, and with a light bit of Googling, it shouldn't be too difficult to fix this. So if you want to take this optional challenge, then this is a good time to do it. Now if you don't, then I'm going to run through how we can fix this. So what if we add another parameter to our load items? And it's going to be the predicate, or whatever search query we want to make in order to load up our items. So this is going to be of data type NS predicate. So that means that we can create request and we can create predicate, and then we can say load items with request, and the predicate being this format, i.e. the title of the to-do list item must contain what's inside the current search bar. Then we can come over here and we can create a compound predicate. So this is going to be set to an NS compound predicate, and we're going to initialize it using subpredicates, which include the predicate that we get passed in as an argument, and also the category predicate, which makes sure that we filter and keep only the items where the parent category matches the current selected category. So then we have an array that contains the category predicate and the predicate that gets passed in. And instead of setting the request.predicate to simply a single predicate, we can set it to the compound predicate. So now there's just one last problem, namely these errors that we've got, because load items, while we have a default value for the request, we don't yet have a default value for the predicate. So it's expecting that predicate argument in our method call. But in both of these cases, all we want is to load up all of the items that fit the current selected category. So we can also set this predicate to have a default value of nil. And we can turn this NS predicate into an optional. So that means that we can still call this load items without providing any parameters, because both parameters have a default value. Now, we just need to make sure that we create our compound predicate using both the category predicate as well as the one that's passed in through as an argument if this is not nil. So we can rewrite these two lines using optional binding to make sure that we're always safe. So we can say if let additional predicate equals predicate, so making sure that it is not nil. Then we're going to say that the predicate for our request is going to be a NS compound predicate created using the subpredicates, namely the category predicate and the new unwrapped additional predicate. But if this is not true, i.e. else, then our request.predicate is simply going to be equal to the category predicate. And now we've successfully replaced these two lines of code using optional binding and making sure that we're never unwrapping a nil value. So now let's try our app out and see if it works as expected. So I'm again going to go into the shopping list to-do list, and I'm going to search for apples. And when I hit search, all I get are apples. And when I click on the cross, then I go back to the original to-do list. So we are introducing a lot of new concepts, and it might take a little while for it to sink in. But you can help it by going back and reviewing some of these new concepts that we've talked about in this module. So those new concepts include using extensions to separate out bits of functionality inside your view controller, using the did set to specify what should happen when a variable gets set with a new value. How can we create, update, read, and destroy data using our context, and how we can commit the current state of the context to our persistent container using context.save. How we were able to access a singleton, that's the shared application, and get its delegate property as an app delegate in order to tap into this persistent container lazy variable. So if you want to understand any new concept, you have to put it into practice. So this is a good time to create your own app using the concepts that we've learned and that I've demonstrated inside this app. So it might be that you want to create a notepad-like app that persists everything that you save into your notepad using core data, But no matter what you do, it's really, really important that you try these concepts out by yourself and struggle with it a little bit until you make it your own knowledge and you finally understand it. Because this is not something that you're going to be able to just passively soak in. It is complex and it is difficult. So it needs practice and it needs repetition. So enough mastery wisdom. In the next lesson, we're going to look at how we can use this open source library called Realm to do everything that we've done so far using core data, but with far less code, and create a persistent relational database that is far more efficient than just by using core data. So for all of that and more, again, I'll see you on the next lesson. Alright, so in this module, we're going to look at how we can use Realm to persist our data instead of using core data. If you have never come across Realm, then it's a good idea to familiarize yourself with it by going to realm.io, and they've got a whole bunch of educational resources, as well as tutorials, example apps, and also really, really good documentation. So what we're going to be using is their Realm database, which is an alternative to SQLite and core data. And it's also open source, which is great because if you wanted to dig in and look at how they implemented their core, then you can do that. So we're going to head over to Products, Realm Database, and we're going to pick our language as Swift, and this takes us to the Swift documentation. So if you wanted to look at the source code, then you can go to Realm Swift and you can dig through all of these files, but I'm going to show you how to get started. So in order to install Realm, there's 3 ways. You can either download the framework, or use CocoaPods, or use Carthage. And I, as always, favor CocoaPods. Look at how short it is compared to everything else. And so this is what we're going to be using. So let's head over to our project. We're going to close it. We're going to open up Terminal. And we're going to locate our Todui folder, so the one that, of course, contains the Todui.xcode project. And then we're going to cd to it. And if you're interested in speeding up your workflow, you can actually chain commands in the terminal together by just using a semicolon. So we're going to change directory to the Todui folder. And then we're going to perform pod init at that location. And then we're going to say open pod file in the application called Xcode, and we're going to hit enter. And now it should go through and perform all of those things, bringing us to our pod file. So now I'm going to uncomment this line so that we're targeting platform iOS 9.0 and above. And we are going to use frameworks. And the pods that we're going to incorporate is one called Pod Realm Swift. And this has dependencies, so we'll also pull in the Realm framework as well. So we're going to hit save, close that down, and go back in here and say pod install. Alright, so after a little bit of waiting, you can see it's now done. And it's installed the latest versions of Realm and Realm Swift by just simply saying pod Realm Swift. Now currently the latest version of Realm Swift is 3.0.2, and that is the version that we're pulling in through CocoaPods as well. So just check and confirm, and then we can close down Terminal, and we're going to go back into Finder and open up our Xcode workspace file. Alright, so here's our brand new Xcode project with those pods incorporated. And let's just expand all of our folders so that we can see it clearly. And as you can see, as soon as we install Realm, we've got this warning in our status bar here, and it says that your pods, including the Realm and Realm Swift, need to be updated to recommended settings. This is not a problem though, because if we just click on this warning, then it will update all of these things automatically for us. We're going to hit perform changes and it's all good to go. And that's it. Alright, cool. Okay, so the first thing that we're going to do is we're going to go over to our app delegate, and we're going to try and create a brand new data entry in our Realm database. So inside here, the first thing that we need to do is we're going to have to import Realm Swift. And as always, usually with CocoaPods, it might not recognize your modules when you first open up your Xcode workspace. So if it does this and you can see for sure that there it is, then you can simply go and hit Command B to build, and it should get rid of that error for you once build completes. Now, we're going to write our code inside the application did finish launching with options delegate method. And here, we're going to first create our brand new realm. So you can imagine realms as almost like different persistent containers. And we're going to call it realm. So let realm equals a new object from the realm class. Now, that would be great if that just worked as is, but unfortunately, the initialization of a new realm is actually marked with throw, so it can, in fact, throw an error. So we have to mark it with a try, which means that we probably need a do catch block. So now that's a little bit safer, we're going to use it to save a new piece of data. So Realm allows us to use object-oriented programming and persist objects. So let's go ahead and create a new Swift file, and let's call it just data. And it's going to be grouped inside the data model folder. And inside data, we're going to be using Realm. So I'm going to import Realm Swift, and then I'm going to create a new class. The class is, of course, going to be called data, and it's going to subclass something called object. And object is a class that's used to define realm model objects. So it's a superclass that we're going to use to enable us to persist our data class. And the code inside is going to be where we're going to declare our properties for the data class. So say if the data that we needed was a variable called name, and it was of type string, and it starts off with a value of an empty string, and another one called age, and it's of type int, and it starts off being 0. So under any normal conditions, if we weren't subclassing object and we were just creating a new class to represent our data, then this would be fine. However, because we're using realm, we actually need to mark our variables with the keyword dynamic. And there's a long and short answer as to what dynamic means. So the complex answer is that dynamic is what's called a declaration modifier. It basically tells the runtime to use dynamic dispatch over the standard, which is a static dispatch. And this basically allows this property name to be monitored for change at runtime, i.e. while your app is running. So that means if the user changes the value of name, for example, while the app is running, then that allows Realm to dynamically update those changes in the database. But dynamic dispatch is something that actually comes from the Objective-C APIs. So that means that we have to mark dynamic with @Objective-C to be explicit that we are using the Objective-C runtime. Now, the simple answer as to why we just added these two keywords in there is that we need to add these two modifiers basically so that Realm can monitor for changes in the value of this property. And this is what will allow us to do it while the app is running. So let's go ahead and add that to our second variable as well. So they are now both compliant with how Realm properties should be declared. So whenever you're declaring a new property that's any of the basic data types, you will need these two keywords in front of it. Okay, so now we can go into our app delegate and we can create a new piece of data that is going to be an object of the data class. And we can set its properties by saying data.name equals Angela, data.age equals, I'm not going to say my real age here, right? Let's say I'm 12. All right, so let's go ahead and add our new item, i.e. create in CRUD, and we're going to commit the current state of our RAM. So just as we did with core data, we basically created a new piece of data, then we used the context to commit the current state to our persistent container, or in this case, it's our realm database. So in order to do that, we can move this down here. And after we've created this brand new realm, we can then say realm.write, which means commit the current state persistent storage or to our realm database. And then we can say realm.add a new object. And the new object is going to be our data. So as with initializing a new realm, realm.write can also throw. So we have to also mark it with the try keyword, which is why they're both kept inside this do block underneath where we created our data. So now all we have to do is run our app so that our application did finish launching gets called and all of this gets implemented so that we'll be able to save our data to our realm database. All right, so that worked without any issue. But how do we view our data? Because we're not using it to populate any of our table views. This is still using core data, remember? And all of our code is inside the app delegate. But if we have a look in our debug log, we didn't get any errors coming back, right? So that means our process probably completed successfully. So our data did get saved into our realm. So in order to locate where our data is stored or where our realm database is, we can use a print statement. We can say print realm.configuration .default configuration .file URL. And this is the location of the realm file. And now, if we print that out, we'll be able to locate where our realm database exists. Now, because we're not unwrapping it, it's going to get printed as an optional. And there it is. So that's our file location. But before we can view this file, you can see that the file is actually something called default.realm. So it's a realm file. So in order to see the data that exists inside, we need to download a piece of software from the App Store. And it's a free Mac app called the Realm Browser. So if you search for Realm Browser inside your App Store, then you'll come across this Mac app made by the Realm team, and it's free to download, and it's quite a small piece of software. Only 5.9 megabytes, and you can simply download it onto your local machine. But once you have done so, then you can open up your Realm browser and you can click on the Open Realm file. So now it's going to take you into your file browser, and we're going to have to navigate to that location that we printed out earlier on. Now, previously, I've always shown you the sort of bog standard way of navigating to a location in your file directory, which is chasing the directories, right? But it's a little bit painful. So let me show you how you would do it as a shortcut. So if you hit Command-Shift-G, then you can actually go straight to the folder or the document. And all you have to do is take this string that says file something and all the way down to realm without copying any of the round brackets. Hit Command-C to copy, and then we're going to hit Command-V to paste. Now, if you navigate to the front of this string, if you delete the file ::, so you only end up with a /user/Angela Yu. This is your file path that will help the Finder to navigate to this location. And you can go ahead and simply hit go. And it takes you straight to that location. Now, you might think I'm a little bit sadistic for making you guys go through this process many times previously. But it's always good to know how it's done manually before you learn about shortcuts, because a lot of people learn the shortcuts first, and then when you get stuck or when something doesn't work, then it's always very confusing. So there's always the long path to fall back on, but to save your sanity and your precious life, then it's a good idea to use the file path to navigate. And you can do this in any Finder, not just in the Realm browser, by the way. So if you're inside any sort of Finder window and you're trying to locate something, you can simply hit Command Command-Shift-G, and you can go straight to that location. Now that we're here inside the Realm browser, we can simply select our default.realm database, and we can hit open. And Realm will need access to this path, so we're going to have to click allow, and you might even have to enter a password every now and then. So we ran our app twice, first time to check that it worked, and the second time to get this file path. And that means that our application to finish launching with options got called twice, which means that we saved 2 pieces of data, both with name Angela and age 12. And you can see that the Realm browser is this really simple interface where you can see your models, so our data model, and you can see your properties, name, which is a string, age, which is an integer, and we've got our pieces of data. And it even shows you the minimum, average, maximum, the sum, and some simple bits of analysis on your data. So that was pretty pain-free, right? And compared to how much work we needed to do in order to set up our data model using core data, I hope you can see that this is a very useful tool. And we're going to dive deeper into Realm in the next lesson so that we can start working on how to do CRUD using Realm instead of core data. And you're going to see all of the ease and the shortness of the code and all of the beauty of this new way of doing things. So for all of that and more, I'll see you on the next lesson. Alright, so in the last lesson, we looked at how you can install, set up, and configure Realm to be our method of persisting data. Now, in this lesson, I'm going to delete all of this so that we don't keep adding the same piece of data into our Realm. And I'm also going to delete this try Realm write. Now, I'm going to leave this do catch block where we initialize our brand new Realm. And let's not worry too much about these warnings for now. So I'm going to go ahead and delete this data class that we created, that we used as just as an example. And I'm going to replace this core data model with a class called category and a class called item. So let's go into our data model folder, hit Command N to create a new Swift file, and this is going to be called item, and we're going to hit create, and then I'm going to create another one called category and hit create. So now we have both of our entities, or in this case classes, and we're going to use them to represent all the properties and relationships that we've specified inside core data. So inside item, I first have to import Realm Swift in order to use it, and then I'm going to create a new class called item, and the superclass is going to be a Realm object, and it's going to have 2 properties. One, which is the title, which is going to be a string that's going to start off as empty. And the other one is going to be the property done, which is going to be a Boolean. And this is going to start off as false. And remember, in order to create properties using Realm, we have to add the @Objective-C modifier and also the dynamic keyword. So let's go ahead and add that to both of our properties. And now this is a complete representation of our item entity using properties instead of attributes. Now you'll see that it gives you an error saying that this is an invalid redeclaration of item. So it's saying that there's already a class called item, but where is it? I don't see another class called item. What's going on here? Well, do you remember that we said when you create a new data model using core data, if you select the entity and you select CodeGen as class definition, then it's going to create a class called item with these properties, or much the equivalent to that. So you can either select CodeGen, manual, or none in order to not generate those class definitions, or in our case, we're actually just going to delete our data model because it's not going to be the one that we're going to use from now on. So I'm going to right click and hit delete. So now it no longer exists, and if we hit Command B to build and essentially refresh, then that will get rid of that error where it says that this item class is a redeclaration. Now we'll end up with more errors because remember, for most of our view controllers, we're using our core data NS managed objects, and now we're switching it to realm objects. So there's going to be a little bit of fixing in there, but let's first finish creating our data models. So we've done that for item, and now we have to move on to category. And I'm actually going to just change the order here because it's category then items, and that makes a little bit more sense to my brain. So as a challenge, I'd like you to set up your category data model to include a property called name, which is going to be of data type string, and it's going to start off with the value of an empty string. So go ahead and pause the video and give it a go. Alright, so that is a pretty simple task. All we have to do in order to use Realm is of course import Realm Swift, and then we're going to create a new class that's called category, and it's going to inherit the object class, and the code in here is going to be an Objective-C modifier and the dynamic keyword, and then we're going to say var name of the category, which is going to be a string, and it's going to start off being an empty string. Alright, so that's it. That was done. Did you manage to get that? Now, in addition to having these properties, if you remember, our data model using core data also had relationships where we could specify that categories point towards items and items point back to categories. So let's go ahead and see how we can do that using Realm. Now, the forward relationship is the easiest, and it's as simple as creating a constant called items, and it's going to be set to a collection type called list, and this is something that comes from Realm, and it's basically a container type, just as array or dictionaries are container types, but this is something that they decide to call list, which is very, very similar to arrays. Now, if we create a new list, we also have to specify what is the data type of the items inside the list or inside the array, and in our case, it's going to be a whole bunch of item objects. So this syntax may or may not be familiar to you, but when we create new arrays, so let's create let array equals, 1, 2, 3. This is one way of declaring the array. So this uses type inference, right? But the other way of doing it is we could also say that this is an array of integers, and we're going to initialize it as an empty array. And the other way still is that we can simply say the array is going to be of type an array of integers, and it's going to be equal to 1, 2, 3. That's perfectly valid. Now, a method that we haven't seen so far is we can also declare this as the type array and say that it is going to contain an array of integers. Now this and the previous syntax are both valid. So if you wanted to declare an empty array of integers, you could also do it like so by simply initializing it as an empty array of integers. Now this is exactly what we're going to do here. We're going to create this constant called items, and it's going to hold a list of item objects, and we're going to initialize it as an empty list. So I'm just trying to show that this is not some foreign sort of syntax. It's actually something that's perfectly Swifty. And the only thing that's foreign is this class list, which is something that comes from our Realm framework. So this essentially defines the forward relationship, i.e. inside each category, there's this thing called items that's going to point to a list of item objects. Now in Realm, the inverse relationship is not defined automatically. Instead, you actually have to go inside the item class and create it yourself. So let's do that now. So we called our inverse relationship parent category, and it's going to be set to an object of the class linking objects. And linking objects are auto-updating containers that represent 0 or more objects that are linked to its owning model object through a property relationship. Now that sounds really, really complicated, but it's actually not. It's simply defining the inverse relationship of items. So each category has a one-to-many relationship with a list of items, and each item has an inverse relationship to a category called the parent category. And we have to initialize linking objects with a type and a property name. So the type is going to be whatever object that we have, dot type. So if we simply wrote category, then this is just the class. It's not actually the type. In order to make it the type of category, we have to say dot self, and that becomes the category type. And then the property that we need to specify is what is the name of that forward relationship, which is of course items. So all we have to say here is specify a string called items that points to the forward relationship. So now we have the forward relationship, each category having a list of items, and the reverse category. Each item has a parent category that is of the type category, and it comes from that property called items. So now we're ready to go and fix all of these errors and use our RAM data model instead of our core data model. So let's head over to category view controller, and we're going to first initialize a new RAM. So we're going to say let RAM equals try to initialize a new RAM. Now, I know that we've always been cautious with exclamation marks, as you should be, but not all cases of try exclamation mark are bad. So this is what you would call a code smell or a bad smell. And it's something that indicates or hints at possibly bad code and maybe a deeper problem. But not always. So just as while you're walking around and you smell something that smells really bad, could be a dead body, or it could be just the trash, right? And in this case, it's actually not an issue. The reason why this initialization throws or can throw an error is because according to RAM, the first time when you're creating a new RAM instance, it can fail if your resources are constrained. But in practice, this can only happen the first time a RAM instance is created on a given thread. So if you look at the RAM documentation, then this is a perfectly valid way of declaring and creating a new RAM. So if you're interested in that, then I'll link to the documentation and you can have a deeper read. Xcode is still giving us this error saying use of unresolved identifier RAM, and that is because, of course, that we forgot to use RAM instead of core data. So I'm just going to replace that, which is going to create more errors for me, but we're going to go and fix those steadily, one by one. Let's go into the parts of our code where we create a new piece of data inside our database. And that is, of course, inside the add button pressed. And more specifically, it's in this closure when we press the add button in that UI alert. So whereas currently we're creating this new category, which was initialized using a context because we were using category as a NS managed object, but now our category is just going to be a straight up object from the category data model. And the new category also has a property called name because we defined it over here. And that's going to be set to equal the text that's currently inside the text field of the UI alert. And finally, all we have to do is change this save categories method, because at the moment it tries to save the context. Whereas what we needed to do is to try to write to our RAM. So try ram.write, and we're going to try to say ram.add category. And that is going to be the new category, right? So that will need to be passed into this method. So let's replace this method to be called save, and it's going to take something called a category, and that is going to be of type category. And that will then get passed in here. And we now have to fix the part where we call that method. And we're going to say save category is going to be the new category that we just created over here. So now if we hit Command B to refresh and try to get rid of some of the errors that don't actually belong here, then our IB action is looking pretty clean. Now we've still got some other errors in this code and also in our to-do list view controller, but I'm going to simply comment out all of this, and I'm going to go into the to-do list view controller and find those errors, and we're also going to comment that out. And I'm going to comment out this particular function as well as this entire extension. And finally, we're going to also comment out the load items, and I'm going to hit run to see if we can build our app. Okay, so currently all that our code should be able to do is when we press the add button pressed, we should get a UI alert, and if we type some text into the UI alert, then it should create a new object from the class category, and we should be able to save that category into our realm container by using realm.write and realm.add. So let's give it a go. Let's press add, and let's create a new category called home, and add one called work. And if we have a look inside our Realm browser, then you can see that we've got 3 data models now. So data is a little bit of a relic back from when we created it in our app delegate. And item is empty because we've yet to implement any code inside the to-do list view controller. But our category model has 2 new objects, one with the name home, one with the name work, and they have an associated list of items. Now the list currently is 0, but as soon as we start assigning some items to that list, then these will be populated, as we'll see a little bit later on. But what we can confirm is that our code worked, and we were able to save and persist our categories. So now all that's left to do is to load our data, not from our context or core data, but from our realm. So for all of that and more, I'll see you on the next lesson. So in the last lesson, we looked at how to perform create in CRUD using Realm, and we were able to successfully add new categories that we created inside our add button pressed IB action and save it to our Realm persistent data store. Now in this lesson, we're going to tackle the next letter, which is read inside CRUD, and we're going to look at how we can load up our categories from our Realm database rather than from core data. And so the first thing I'm going to do is I'm going to delete this thing called context because we no longer need it. So the place where we read from our database is inside our load categories method. So if we scroll down to find it, you can see that we've commented all out. So instead of having this request, which is a fetch request, or try context.fetch, we can replace all of this code with just a single line. We can say let categories equal realm.objects, and then we just specify the type, which is all of the category type objects. And this will pull out all of the items inside our realm that are of category objects. And that means that we can delete all of these lines of core data code replaced with just this one line. Now at the moment I'm creating it as a local variable, but if we wanted to use it elsewhere, then we can use our variable categories. Now what you'll see is that I can't straight up just assign it to this variable called categories. It's going to give me an error. And the error it says is that it can't assign a value of type results to type array. So what it's saying is that the data type of the object that we get back is result, which is a container type that comes from Realm Swift. So this is equivalent to list or array, but it's a different data type and it's not very easily converted. But what we can do is we can change the data type of our categories property to the results data type. So we can say that categories is of data type results, and results is basically just an auto-updating container type. So container types are things like arrays, dictionaries, results, lists, and it comes from Realm, and it gets returned from object queries. So that means whenever you try to query your Realm database, the results you get back is in the form of a results object. So we can specify our categories, which is what we're going to get back when we query our database, as data type of results, and it's going to contain a whole bunch of category objects. And I'm going to first unwrap that, and we'll go with that for now. So now, this line of code is perfectly valid because the data type that we get back here is results containing a whole bunch of categories as the element inside the results, and then categories is also the same data type. So that matches, and that's now allowing us to proceed, but we get this error down here where we say self.categories append new category. Now because this result data type, as we found out earlier on, is an auto-updating container, we don't actually need to append things to it anymore. It will simply auto-update and monitor for those changes. And so now, with just one line, we've managed to place 4 or 5 lines of core data code that does exactly the same thing. So let's give it a go and run our app and see if it works. So there you go. Those are our 2 items that we saved earlier on into our Realm browser, as you can see here. And if I terminate the app and go back into it, you can see that it's still able to persist and load up or read from our Realm database, just based on those 2 lines of code. Now, let's address the issue of force unwrapping this particular property. It's not ideal because what if, say, we forgot to load up our categories, and this was in fact nil when we force unwrap it and try to use it to populate our table view? Well, then we're going to have an issue, and you're going to see it when I run our app. There we go. Thread 1, fatal error, and unexpectedly found nil while unwrapping this particular optional. So let's stop our app and let's make our code safer. So instead of making it a forced unwrapped, I'm going to add a question mark to this data type and make categories an optional. So now, instead of saying categories.count, I'm going to say if categories is not nil, then return categories.count. But if it is nil, then just return 1. So this is a new bit of syntax. And this, in Swift, is called the nil coalescing operator. What it means is that this could be nil, because categories is an optional, and we're only saying get the count of categories if it is not nil. But if it is nil, then this is going to be nil, right? But if that happens, then the nil coalescing operator will say, then use this value instead. So if categories is not nil, then we'll return the number of categories we have. But if it is nil, then we're going to just return 1. So our table view will have just 1 row. And down here, if categories, the optional, is not nil, then we're going to get the item at the indexPath.row, and we're going to grab the name property. But if it is nil, then we're simply going to say the text is just going to be equal to no categories added yet. And finally, I'm going to add a question mark here to say that the selected category of the destination VC will be set to the category, if it's not nil, at the indexPath.row that was selected. And that gets passed into here as the selected category, which is an optional category. And only when it is set, i.e. it's not nil, do we actually call load items. So we're still okay over here. So now, even though my load categories is still not commented in because it's not active, and this categories will be nil when we try to run our app, you'll see that our app no longer crashes and burns, and instead it actually has a slightly different but better user experience. So now you can see that the app has not crashed even though this categories property is now nil. And that's because it has some default values. And the default value when categories is nil is to produce a single table view cell, and for that cell to have the text of no categories added yet. And that makes our app so much safer and has a much better user experience. Now, the add button is still going to break when we try to add new categories, and it's not going to show up, and that's because we need this load categories method to be called so that we start auto updating our categories using the objects inside our realm. So let's go back and uncomment this method call and run our app again, and you'll see that we still have all of our items showing up and persisting. So we've now managed to use our realm database to add new items and save them to our realm. And we've also managed to use it to load up our realm objects using a single line of code. And now all we have to do is to fix the same things inside our to-do list view controller. So we are passing over the current category as a optional category, and it's going to land over here as the selected category. And when that happens, or when that does get set, then we're going to call this method called load items. And we no longer need our context, so we're going to delete it. And we also no longer need core data, so I'm going to instead import Realm Swift. And of course, because we're using Realm, we have to create a new instance of Realm. Let Realm equals try Realm. So now, when our selected category does get set from our categories view controller coming over from the segue, then we're going to call load items. Now, load items is an unresolved identifier because we commented it out before in order for our app to be able to run without any errors, so that we can fix it now. So I'm going to uncomment this method, and inside here, I'm going to delete all of this and all of this. And instead of all of those lines of complicated core data code, I'm instead just going to say item array is equal to selected category dot items. Remember that relationship that we're going to use now? So all of the items that belong to the current selected category, and we're going to sort it by key path and ascending. And the key path is just as we've done before, sorted by the title of each item, and we're going to make it ascending true. So key path is called title. So that's the title of each of the items that come back into the item array, and ascending is going to be true. And because item array at the moment is an array of item objects, we need to change the declaration at the top to be this results container containing item objects data type. So let's do the same as we did before and delete that, and instead declare its data type as results, the auto-updating container containing a whole bunch of item objects. We're going to make it an optional. So now we can replace all of this code with just a single line like this. Now, it no longer really makes sense for this to be called item array, because it's now no longer an array, right? It's actually a results container containing a whole bunch of items. So we probably should change the name of this variable. Now, I can either go around finding all the places where I used item array, item array, item array. In fact, the errors actually help to guide me all the places where I need to change its name. But a slightly simpler way of doing this is you can simply hit Command F to find all the places where item array exists, and you can replace it with a new name. For example, something like to do items. But this is still a little bit clunky. Xcode actually gives you a really nice way of being able to rename your variables and not have to worry about changing it everywhere it's used. Now, you might get some errors if you try to do it just like this, because remember, we changed the data type of this variable, and in all the places where we used it in the context of an array of items. So if you get any strange behavior trying to rename, then you can actually revert this back to an array of item objects. and you can initialize it to an empty one. And we can simply hold down Command and click on Item Array. And if you scroll down, there's this thing called Rename. And it'll go into this accordion view, where it'll only show you the lines of code where you use this variable called item array. And you can select or deselect the ones that you want to change. So for example, the comments are by default not included in your renaming, because as you can see, our comments come from our old code. So we can leave those alone. But all the ones highlighted in blue will get renamed as we type in here. So I'm going to call it to do items. And I'm going to hit rename, and it's now updated it in all of these locations. So now we can change this back to our previous results containing a whole bunch of items, and it's an optional. And we managed to rename all of those places which used to read item array. So now, because to do items is an optional, we're going to have to either unwrap it or do something about it. So we're going to do the same as we did before. We're going to use optional chaining to say, if to do items is not nil, then return the count. But if it is nil, then return 1. And down here, we're first going to use optional chaining to say that if to do items is not nil, then grab the item at indexPath.row. And if all of this works and it's not nil, then in that case, we're going to change all of our accessories based on the item.title and the item.done properties. But if it is nil, or if it fails, i.e. else, then we're going to say cell.textLabel.text is going to be equal to just a simple string, and it's going to be no items added. And we're going to return the cell whichever state it is in, depending on this optional binding check. Now, all we have left is this error. And for now, I'm just going to comment it out, because in order to persist this data using Realm, we actually have to do it slightly differently than this. And we'll tackle this in the next lesson, when we learn about update in CRUD using Realm. So let's leave that for now, but we do have to change our save item data. So as a challenge, I want you to be able to fix these lines of code and change it to use Realm instead of using core data as we are here. Now, when you complete this challenge, I want you to ignore this function called save item. In fact, just go ahead and delete it. And I want you to do all of your saving just inside this closure. So I want you to create a new item from our data model item, and I want you to save it here as well. So pause the video and give it a go. Alright, so how did that go? Let's go ahead and uncomment these few lines, and we're going to update it in order to use Realm. So we no longer have a context, so let's delete that. We're just initializing a new object of the item class, and the title is going to be the current text that's inside the text field. Done doesn't need to be specified anymore because it is already here as a default. Now, because our selected category is of data type optional category, we have to somehow unwrap it or use optional binding in order to make it work. So if we say if let current category equals self dot selected category, and if that's not nil, then we're going to say let new item equals item, and new item.title is the text field.text. And instead of setting the new item's parent category property here, instead we're going to go the other direction. We're going to tap into the items that belong to the current category, and we're going to append this new item to that list. So we can say current category dot items, which is a list of item objects, dot append this new item. And that takes care of these two lines and replaces them. Now, as we said, instead of calling self.saveItems to do our saving down here, we're going to do all of it up here. And so we need to be able to say try realm.write right? And what we're going to write is all of this. So create a new item, give the new item a title, and append it to the items in the current category. And this, of course, has to happen after we've unwrapped our self.select category. So it needs to go in here. And because this can throw, then we need to wrap it inside a do catch block. And because we're inside a closure, we'll use self.realm.write. And we can delete this call to save items. So, did you manage to get that? It's a little bit convoluted in terms of the logic, but you can clearly see that this is far less code. And to me, it's way more human readable, and the logic is easier to follow than using core data. And the last thing we need to do here is that once we have written this new data to our realm, we need to call TableView.reloadData so that we call those data source methods again and update our table view with the new item, because we've gotten rid of our save method. So now all that's left to do is to run our app and see if it works. So as you can see, we've got all of the 4 categories that we added on earlier. And if I go inside shopping as a category, then you can have a look inside the Realm browser as well. You can see that shopping does in fact contain a list of item objects, but it's currently completely empty, i.e. there are no items associated with shopping. So let's go ahead and add one. Let's say buy apples. Hit add item, and you can see that firstly, the item model gets incremented with a single new object, but also inside category, inside that link, you can see that when you click on this item, it takes you to that particular item, and it's now equal to 1. So as we add more, you can see that firstly, they're getting fetched back in alphabetical order because of that sort that we specified here. And they're also showing up over here, and you can hover over it in order to see it at a glance. So in the next lesson, we're going to look at the next letter in CRUD, which is U, and how you can update your data inside Realm. So for all of that and more, I'll see you on the next lesson. So now that we've managed to make our to-do list app work using Realm to create new items, to save new items, to read the data from our Realm database, it's time to tackle updating data in the database. And you'll find that similar to core data, updating data is very, very similar to saving a new item. And we're going to be using realm.write to do the same thing. So the place that makes the most sense to update our realm is again inside our didSelectRowerIndexPath method. And this is the place where we select a cell inside our table view in order to check or uncheck it by toggling this particular done property. So we're going to leave all of this commented out, and I'm going to show you how you would do this using Realm. So what we can say is we can say if let item equal the to-do items, which remember is a container that contains a whole bunch of items and it's fetched from our Realm, then we're going to grab the item at indexpath.row, so the current selected row. And if this is not nil, then we're going to be able to access this item object. And we can say try realm.write, and we're going to write item.done equals the opposite of item.done. And because this can throw, then again we're going to wrap it inside a do catch block. And if there is an error, then we're going to say error saving done status. And let's just indent this for clarity's sake. And now we have replaced this code. So just to run through it, we're checking to see if to-do list items is not nil, And if it's not, then we're going to pick out the item at indexPath.row and set it to equal item. And then we're going to try and write the updated property of item by toggling whatever it used to be before. So if it was false, it becomes true, true becomes false. And the last thing we need to do is, of course, call our trusty tableview.reloadData method to call this self-arrow at indexPath method again and to update our cells based on this done property and give it a check mark if it's done and remove the check mark if it is not done. So all that's left for us to do is to run our app and see if it works. Alright, so let's head into our shopping category where we know we've got some items, and let's select and say that we're done with buying peaches. And you can see that we've got our check mark showing up, and we can toggle these as we please. And if we have a look inside the Realm browser, you'll see that as I check these, they get updated in real time and really, really fast as well. But when I check them over here, they will not get reflected in our table view because, as you remember, we cannot call reload table view from a different application into our app. So it has to happen over here. So that is how we can update our data using Realm. In the next lesson, we're going to talk about how to delete data using Realm. So for all of that and more, see you on the next lesson. Now, in the last lesson, we looked at how we can update our Realm database by simply using realm.write and including inside those brackets whatever changes we want to make to our Realm database. Now, in this lesson, we're going to talk about how we can delete items. So I'm going to do that in the same place in the didSelectRow at indexPath method, where we click on one of the rows and we look inside our to-do items to find the item at that particular index, and we pull it out. And instead of trying to update it and toggle the done property, instead I'm going to comment out this line, and I'm simply going to say realm.delete, and I'm going to call the delete method on our Realm to delete the object that I specify. And that object is obviously going to be our item that we picked out. So realm.write updates our database, and the changes that it's going to make is it's going to delete this item from our Realm database. So again, we're going to go inside our shopping to-do list where we've got all of our items. So currently they're all unchecked, and when I click on any of these rows, I'm expecting to look at that index path of the row and look inside to-do items to pick out the item at that row. And then I'm going to update my Realm by deleting that particular item from my Realm database. So let's see if it works. Buy apples, buy peaches, buy pears. Everything is gone every single time I click on it. So this is how easy it is to delete and update your Realm. And I think it's far more readable for a human as well. Realm.write, realm.delete. None of this context and persistent container business. But again, it's totally up to you which one you prefer. But I'm going to uncomment these two lines of code, and I'm going to delete this line of code because I prefer the checking functionality as the user experience for our app. And I'm also going to delete all of these commented out lines of code. So now we're able to load new to-do list items when we select any category. We're able to add new items, and we're also able to update and delete items in our Realm database. So in the next lesson, we're going to query our database and sort out all of these lines of code that correspond to our search bar methods. So for all of that and more, see you on the next lesson. Alright, so now that we've looked at create, read, update, and delete, it's time to look at how we can query our Realm database. And so we're going to be working within the search bar methods. So let's go ahead and uncomment our extension. And we're going to remove the parts that are core data, and we're going to instead make it work using Realm. So let's comment out all of these parts that use NSFetchRequest or NSPredicate or NSSortDescriptor. All of those NSs come from our core data framework. So instead, what we want to happen when the search bar gets clicked is we're going to filter our to-do list items. So we have our to-do items, which is the array of results that consists of items, and we're going to set its new value to be equal to its previous value dot filter. And you can see that this filter method from Realm takes an NS predicate as an input. So all we're saying here is that update to do items to equal to do items filtered by this predicate. And we can specify the predicate format and arguments that we want to use for our filter. So if we hit enter, then the format is going to be the same as this format, which is of course the fact that the title of the items contains and be case and diacritic insensitive to the argument that we're going to pass in. And the argument is going to be the search bar dot text. And that is basically the equivalent of these two lines. And we can tag on this sort by simply adding a dot and write sorted by key path and ascending. Key path is going to be title, so that's what we're going to sort our results by, and ascending will set to be true, so it's alphabetical order. And that replaces all of this code, and we don't even need to call load items, because we've already loaded our to-do list items from the selected category, and we're now just simply filtering those items based on our search criteria and sort criteria. So we can go ahead and delete all of that. Now the other part we need to fix is what should happen when we dismiss the search bar. So when the search bar.text goes down to 0, we want to simply call load items. And load items, again, looks at the current selected category and pulls out the items sorted by the title in ascending order. So there's actually nothing to change here. So that is how easy it is to query our Realm database. We can simply take a list of items and filter them based on a predicate. And as we said in the core data module, you can take a look at the Realm NS predicate cheat sheet and look at some of the tips and tricks and examples as to how you can query your Realm database using these formatted strings. So now, here's a challenge for you. What if I don't want to sort my to-do list items by the title? Instead, I want it to be sorted by something called the date created. And I want the items that were created earlier to show up at the top of the to-do list. So can you fix this line of code, but also you'll need to add a new property inside our item model in order to store that data. And that data is going to be saved when we create a new item. And finally, we're going to apply the sort over here. Pause the video and see if everything that we've done makes sense to you so that you can create this new property and set it. Now, you might need to look up Stack Overflow here and there, especially when you're trying to grab the current date, but it's all very, very easy to find. And I have faith that you will be able to work it out without a problem. So pause the video and give it a go. Alright, so how did that go? So the first thing that we said is that we wanted it to be sorted by the key path called date created. So we have to go inside our item data model and create a new dynamic variable that's called date created. And it's going to be of type date, not data. And I'm going to make it an optional. So once we've done that, then we have to go into our to-do list view controller and look at the place where we create new items. Not only does our new item get a title, but it's also going to get a new date. And this is going to be set to equal the current date at the time when this block of code gets called. So let's go over to Google and let's try and see if we can figure out this problem. So the problem that I want is how to get current date in Swift. Maybe Swift 3, because there's not a lot of difference between Swift 3 and Swift 4. So let's hit enter. And And let's have a look at the first answer that we get back from Stack Overflow. How can I set a label's text to current date in Swift 3? Sounds pretty much like what we wanted, right? And you can see that the top answer with 122 votes and also ticked off as the selected answer has let date equal a new instance of date. And you can format it by specifying a particular date, month, year format. Now, we don't actually care about the format. All we want is just the date. So we can use that line right here. New item.date created equals a new instance of date. And now every new item we create gets stamped with the current date and time. So now when we sort our to-do list items that are filtered, we can say sort by key path date created. And if we want the most recent items to show up at the bottom of the to-do list, then we have to keep ascending as true. And the last thing I need to do is to simply write table view dot reload data. That's it. So now let's run our app and see what happens. So when you run your app, you might get this error, and you can see it's green, which means that it's not quite a crash. And if you read it, it says something like try expression unexpectedly raised an error. Error domain io.realm code 10. Migration is required due to the following errors. Item.date created has been added. Migration is required. So to translate this, what it's telling you is that you're adding this new property called date created. But remember, if you have a look at your previous items, they don't have that property. So Xcode and Realm are both confused as to what they should do with this new property and what they should do with the items that don't have that property. And the solution to this is simply what they call migration. And in terms of Xcode, all you need to do is go to the home, click and hold your To-Do app until it starts jiggling, and then you click the cross to delete this instance of your app. And then you come back here and you run your app afresh. So now, if we go to this new Realm location, so remember we need the first /, and let's go over to our Realm browser, open, and we're going to Command-Shift-G, type in the path, hit go, click open, click allow, and now we find our new realm. So you can see that this new realm that we're using for this instance of our app is completely empty. There's no categories and there's no items. So let's go ahead and add some. Home and work. And now we have two new categories, home and work, but they have no items associated. So let's go to home and add some new items. Mop, floors, buy food. This is always on my mind. Not so much mop floors, but buy food is very important. So we now have two items associated with our home category, and we can view them by clicking on this link. You can see now they both have this date created property associated with them. And you can see that I created mop floors on the 12th of December 2017 at 14:21:01 seconds. And then 4 seconds later, I created buy food. So now if we add another one that contains the word food, so that we'll be able to sort it. So maybe buy food and eat food. Seems pretty logical, right? Why would you buy the food if you're not going to eat it? Now, I don't actually have these items on my to-do list, even though I'm so quick at coming up with them. So now we have buy food and eat food. So I'm going to search for the word food, and when I hit search, then I end up with all the items that contain the word food, but it's also sorted so that the ones that I created earlier gets shown at the top of the table view. Now, if you didn't want that, then you can simply reverse the order by changing ascending to false. But essentially, it's now looking at the timestamps of each of my items and applying the sort order according to that date created variable. So now if I hit the cross button, then I go back to the main table view and I have everything sorted here by alphabetical order. So feel free to have a play around with your code and make your app do whatever it is that you want it to do, and familiarize yourself with how Realm works with regards to CRUD and also how you can query the database. So let's quickly refresh ourselves by going through how our app works when it's using Realm. So let's first go into our appdelegate.swift class, and we can delete core data now. And we can also delete all of these core data saving related code. And I'm also going to get rid of my application will terminate. Now I'm going to leave my Realm initialization here just to catch to see if there's any errors when I initialize a new Realm. And because we're not really using it here, we can simply make this an underscore and delete that let keyword as well. And this print statement is also giving us a warning, and in the future we might need to find out where our Realm file is. So I'm not going to delete it, but instead I'm just going to comment it out. So now we have no warnings and we can safely save our app delegate. Now nothing really happens inside our app delegate, so let's go and have a look at our data models. The category data model is the first one that we created, and it is a Realm object. So by subclassing this object class, we're able to save our data using Realm. And we can specify for our classes what properties it should have. And for the category, it has a name property. It's going to be the name of the category. And this is a dynamic variable, so we can monitor for changes in this property while the app is running, i.e. during runtime. Even if you look at the errors pane, you can see that there's build time errors and there's runtime errors. So this is before you compile, and this is while your app is running. And we've also got this relationship, and it specifies that each category can have a number of items, and that is a list of item objects. And item objects are also subclassing the Realm object, and that allows them to be saved using Realm as well. And the item is a little bit more fancy. It has 3 properties: a title, whether if it was done or not, and also now it has a date created property. And finally, we specify the inverse relationship that links each item back to a parent category. And we specify the type of the destination of the link, and we also specify the property name of the inverse relationship, and that relates to this property. So now we can go inside our category view controller, and we can see that the first thing we did is we initialized a new access point to our Realm database, and then we changed our categories from an array of category items to this new collection type, which is a collection of results that are category objects. And this isn't optional, so that we can be safe. And when our view first gets loaded up, we load up all of the categories that we currently own. So inside loan categories, we set that property categories to look inside our Realm and fetch all of the objects that belong to the category data type. And then we reload our table view with the new data. And that reload data calls all of these data source methods again, and it returns the number of categories as the number of rows. And if this is nil, i.e. if we have no categories, then we simply return one cell. And that cell is going to have a text label depending on whether, again, if we have any categories. If we do, then we look at the categories results collection, and we pick out the one for the current index path.row, and we use the name property to fill up that text label. But if this is nil, i.e. if we didn't have any categories at all, then we simply fill that single cell with the words no categories added yet, and we return the cell. Now, when we add a new item by clicking on the add button, then we create an alert, and the alert has a text field and also an add button. When we click on that add button, we create a new category, that is a new category object, and we give the new category the name based on what the user typed into the text field, and then we call the save method to save this new category to our Realm database. And inside the save category, we pass in that new category that we created here, and we call this function called realm.write to commit some changes to our Realm. And the changes we want to make is we want to add our new category to our Realm database, and we log if there are any errors. Now the next part is what happens when we click on any of our cells. Well, when we click on the cells, we fire didSelectRow@IndexPath, and it performs a segue with the identifier that takes us to the to-do list view controller. But before we do so, we create a new instance of our destination VC, and we set the destination VC's selected category property to the category at the indexPath.row that was selected, which triggered this particular segue. Now that takes us onto the to-do list view controller, and when we set this selected category, i.e. during the didSet block, we call load items, which loads up all of the to-do list items, which again is a collection of results that are item objects, and this gets set to be equal to the selected category dot items. So remember that list of items inside category? Well, in the selected category object, it also has a bunch of items associated with it. And those items then in turn get sorted by their title, and they are listed in alphabetical order. And then we reload the table view to call our data source methods, which specifies that we should have as many cells as we have to do items for our current selected category. But if there are no items for our current selected category, then we just return one cell. And that cell is going to have a text label based on the current item's title. And if the item.done property is true, then we give that cell a check mark. Otherwise, we give it nothing. But if there are no to-do items, i.e. this is nil, then the else block triggers, and that single cell that we created up here gets populated with the text no items added. Now in the to-do list view controller, when we press the add item button inside our UI alert, then we look to see if our selected category is nil or not, because it's an optional, remember? And if it's not nil, then we set it to have this name called current category. And then we try to update our Realm by creating a new item, setting the new item's title, setting the date created for the new item to be the current date and time, and then we set the current category's item property to append this new item to the end of that list. And we commit all of that to our Realm database. And then we reload our table view with all of that new data that we added. And when we select any of the cells, then we grab a reference to the item by looking into that collection of results called to-do items, and we grab the item at the current selected indexPath.row, and then we try to update its value by using realm.write, and we toggle the item.done property to be the opposite of whatever it used to be. And then we again reload the data and deselect our cell. Now finally, when we select the search bar and we type something and we click on the search bar search button, then we update our collection of results called to-do items to a filtered version based on a predicate, which says that the title of the items must contain this argument, and the argument is whatever the user entered into the search bar. And then we sort the items by the date that they were created in ascending order, and then we reload our data. And if we dismiss our search bar, then we call load items all over again, and that basically resets to-do items to all of the items inside the current selected category, and it's now sorted by alphabetical order. So as you can see, by using Realm instead of core data, we actually vastly simplified our code. And I don't know if you'll agree with me, but I think the logic is also simpler. There's no extra classes, there's no hidden classes. All the lines of code are more human readable, like .filter, .sort, and it makes a lot more sense when you're just glancing through the code. So have a play around with Realm, and it's completely your choice how you want to persist your data. And if you prefer core data, then that's an equally valid solution. Don't let me put you off it. But personally, I really like using Realm, and a lot of my colleagues also feel the same. And Realm has other benefits other than just ease of use, and you can have a look through the Realm blog for a lot of these reasons on why. But, in addition to its simplicity, it's also a lot faster than core data or SQLite. So if you have a look at the number of queries you can make per second to your database, you can see that Realm is almost double SQLite, and it's way more than core data. So it has a lot of other benefits as well, and it's well worth looking through the documentation, seeing what other things can you do with Realm, and also look at their example project and see how far you can go with it. So that's all from me for now. In the next few lessons, we'll be styling it up for our To-Do app. Now, those lessons are completely optional because we're only going to be dealing with front-end UI stuff, but we will be coding up and adding some libraries in order to make our app look beautiful as well as work well. So if you're interested, I'll see you for that on the next lesson. Alright, so we've got some really cool functionality inside our To-Do app, and we are now fully persisting all of our data using Realm. So now that we've set up most of the backend and our data storage solution, it's time to think about how we can improve the front end. And we're going to do just a few things to make our app a little bit easier on the eye, because at the moment, truth be said, it is a very lean looking app. And ideally, I kind of need to be able to delete categories if I no longer want them. And at the moment, we don't really have any of that functionality, because inside our table view delegate methods, when we tap on any of the rows, we need to take the user to the to-do list view controller, the next view controller. And so we can't really use that to delete the categories. So what else can we do? Well, we can implement something similar to what you see in your Mail app. You can reveal the delete button, and if you swipe a little bit further, you can actually automatically delete the contents of that cell. So let's think about how we can implement this, and as always, you will usually find that CocoaPods is going to be your best friend. One of the things I regularly do before I program anything UI or front-end related is to just go window shopping on CocoaPods. So other people like going to the mall, I like going on CocoaPods. So let's go ahead and search for something like Swipe. You can look through each of these libraries. So let's have a look at the first one. You can see that it's got a cute little animation where it shows you what the library is capable of doing. And you can see that this is pretty much a copy of the Mail app functionality that we were talking about just now. So this is brilliant. We found what we wanted in just one search. So let's go over to the GitHub page and see how we can implement and use this. So they've got a whole bunch of demos in terms of the different transition styles and expansion styles and requirements, and it also shows you how you can install it pretty easily. So all we need is just to pod swipe cell kit. So we know all about that. So let's go ahead and implement it. So I'm going to close down my project here. I'm going to open up terminal. So let's go ahead and cd to it. So the containing folder is currently on my desktop. So I'm going to say cd towards here. And then I'm going to tag on another command, and that's going to be open pod file -a using the application Xcode. And we're not initializing a new pod file because we've already done so in order to use Realm. So if I hit enter, it should find the right directory and open up my pod file. So the pod that I'm going to add here is going to be pod swipe cell kit. And if you want to minimize typos, then just go ahead and paste it in. And we're going to hit save, and we're going to close this down, and we're going to say pod install. And we'll let that run in the background. Alright, so pods are installed, and now we can open up our Xcode workspace, and we can work on it using our swipe cell kit. So let's go ahead and implement it for our category view controller. So before we do anything, we of course first have to import the library that we're using, which is called swipe cell kit. And Xcode is, again, as always, being a little bit obstructive, but we just need to hit it with a stick by using Command B, and that should allow it to figure out where the files for this swipe cell kit pod exists. Now, even though I've done this a few times, I just want to show you how you might use the documentation of these libraries to learn to use new libraries and new frameworks, and it's really, really simple. So let's scroll down to the documentation. The first thing that it says is set the delegate property on swipe table view cell. And it's given us a little bit of example code, so I'm just going to copy and paste this over here so that we can refer to it. So let's put this over here, and we'll just comment it out in case we mistakenly keep it in there or something. So the first thing that you notice is that they dequeue a reusable cell with a particular identifier, and we've got all of that. And it also wants to downcast it as a swipe table view cell. So let's go ahead and do that as swipe table view cell. There we go. Now I'm going to actually collapse my left hand side so my text doesn't wrap, and you can see it more clearly this way. And then the next thing they have is they set the cell's delegate to self. So let's go ahead and do that as well, and we'll do it down here. Cell.delegate equals self. So that's the current view controller. And you should be reminded that whenever we're setting delegate on anything, we probably have to move up here and do something with the protocol. So let's read on. And as you can see, it says adopt the swipe table view cell delegate protocol. So let's copy that, and let's go over here and paste it in here. Swipe table view cell delegate. Now, as I mentioned before, whenever you find yourself putting in new delegates, then it's usually a good time to put in an extension. So in our category view controller, we don't actually yet have any extensions, so we can go ahead and create a new one. So outside the entire class, we're going to go and create a new extension. So we'll just call it extension, and it's going to extend category view controller. And the reason why we're extending it is because we want to use this swipe table view cell delegate. So this is going to be the section that we're going to deal with all the swipe cell delegate methods. And just above it then, it's a good point to make a pragma mark and say this is our swipe cell delegate methods. And you can see we split up our entire view controller very nicely with these sections and extensions. Alright, so the first error we get is that category view controller does not conform to protocol swipe table view cell delegate. So we adopted this protocol in our category view controller, but we actually don't have the delegate methods that are required. So Xcode will add the protocol stubs if you want, or why don't we have a look back at the documentation and see what else is required. So the next function here is a table view method that allows you to edit actions for row. And this is something that comes from this swipe cell kit. So we can simply just copy this entire method and put it inside our extension. And we now have a delegate method, and that error goes away because this was the required delegate method. So, what does this code do? Well, it's responsible for handling what should happen when a user actually swipes on the cells. And you can see the first thing is to check and make sure that the orientation of the swipe is from the right. And then we have this closure that handles what should happen when the cell gets swiped. And finally, we add an image to that part of the cell that's going to show when we swipe on the cell. And then we return this delete action as the response to a user swiping on the cell. So we don't actually currently have an image called delete inside our asset.exe assets. We actually have nothing in here so far. But no matter, because we can get it straight from SwipeCellKit's example app. Now, you can actually download and git clone the entire app to have a look at their example. But in my case, I'm just going to go into the example folder and then mail example. I'm going to go into their assets.exe assets. I'm going to find the image set called trash. And there is something here called trashicon.png. And here I'm going to right click and I'm going to save image into my downloads folder. So now that I've downloaded this thing called trash icon, I'm just going to rename it to delete icon. And that way it makes a little bit more sense rather than having the space in the name. And you'll see very soon why. And once you've renamed it, then you can safely drag it into your assets.exe assets folder in the left-hand pane here. So we're going to put that in there, and I'm going to adjust it to the 2x position because it's actually a 2x image. Now, the next thing I want to do is go back into my category view controller, and I'm going to change the name to whatever I called it just now. And just to remind ourselves, it's called delete-icon. So I'm going to call it delete-icon. So now what should happen is that when I run my app and I land on the category view controller, when I swipe from the right of the cell, then I should be able to trigger this closure. And inside here, and at this point, I want to print item deleted. Now, obviously nothing's being deleted, but we're just testing our code out here. And when I do swipe, it should show me the delete icon as an image and the delete text underneath that icon. Now, at this point, you might think that you can run your app, but if you do, the app will actually crash. Let's investigate why that is. What's the reason for the crash? When we run our app, you will get this error and it will crash your app. Now, the reason for this is because it says could not cast, i.e. it could not turn a UI table view cell into a swipe table view cell. So how can we fix this issue? Well, let's first stop our app and go into our main.storyboard. So here, what we can do is we can select our category cell and have a look on the right-hand pane. If we go inside the identity inspector, we can specify a class that it should inherit from and also a module where that class is located. So here, instead of having it as a UI table view cell, we can say that it is a swipe table view cell and hit enter. And then we're going to change the module to SwipeCellKit and hit save. So let's go ahead and hit run and see if that fixes our problem. Right, so our app no longer crashes, but it looks exactly the same as what we used to have. But now these cells are actually no longer UI table view cells. They are in fact swipe table view cells because that's what we changed its class to. So if we click and swipe to the left, you can see that we've got this trash icon and the delete message showing. Now, it's a little bit cramped in here because our cell is actually pretty short. So why don't we go back and increase the size of our cell? So let's go into view did load and let's say table view dot row height equals, let's say, 80. So that makes it 80 points high. And let's run our app again and see if we've made it a little bit better. So a lot of UI stuff, you'll find yourself tweaking back and forth, running back and forth, just so that you can see visually whether if you're happy with the effect. So now that looks pretty nice, right? And each of our items get a little bit more space and it doesn't look so bunched up anymore. So, alright, I'm pretty happy with that. So let's test the functionality. When I click on the delete button, I'm expecting this closure to happen and my print line to be executed. And indeed it does. Every single time I click on the delete button, then it gets deleted. Now, it's no good just printing item deleted into the console. The user can't see that. So let's go ahead and replace this print statement with some real code. And as it suggests, handle the action by updating our model with deletion. So as a challenge, I'd like you to pause the video and see if you can figure out how to use the index path that we get back that's going to tell us which row was swiped upon, and inside here, which row was selected to be deleted when the user taps on that red button, and to use all of that information to delete the correct category from our list of categories here. So pause the video and give that a try. Alright, so how did that go? Well, as you know, we're going to be adding the code in here because it says that's where we should handle the action. And this is the closure that gets called when the user swipes on the cell and clicks on the delete button. So inside here is where we're going to use our realm.write in order to update our realm. And the update that we want to make is we want to say realm.delete, and the object we want to delete is the item at indexPath.row, so the row that was swiped on, and we're going to look inside this collection of results that we've called categories and remove the category at that index path. So we're going to say delete categories at indexPath.row. Now, of course, realm.write can throw, so we're going to wrap it inside a do catch block. And then we're going to mark realm.write with a try keyword. So the categories here is, if you remember, an optional. So we have to somehow safely deal with it. So we can use optional binding to handle this. So if we say if let category for deletion equals categories question mark to optional chain indexPath.row, then inside here we can perform the do catch block, and instead of deleting that we can delete the category for deletion. Now, because some of these are global variables and we're using it inside our closure here, then we have to add a self in front of them to explicitly say that they belong to the current class. Now finally, if all of that succeeded, then we can go ahead and make a call to tableview.reloadData, so that we call our data source methods and remove the last cell because it no longer exists inside our realm database. So let's give our app a go and run it to see what happens. Alright, so we are going to add a new category. Not feeling very imaginative today. And go ahead and hit add, and we're going to click and drag and click delete. And there we go. Now it's gone. All thanks to SwipeCellKit and our little bit of code. So you might have noticed in our current version of the app that it's not quite the same as the Mail app, because in the Mail app, when you click and drag, you can actually drag further and just delete the entire cell by that one swipe gesture. At the moment, you have to do two gestures. You have to swipe and then delete. So how can we implement the same thing that we have inside the Mail app? Well, let's head back over to the documentation and continue reading. So it says that optionally, you can implement the edit actions options for row at method. Now that's a horribly named method, but it does allow us to customize the behavior of the swipe actions. And one of the options that we can specify is the expansion style. If we have a look up here at the demos, we can see that the expansion style for destructive is exactly what we want, right? Where if you swipe further, then the delete action gets called without you having to tap on any of the other buttons. So let's go ahead and copy this block of code over to our code. And we're going to put it below this delegate method here. So right here. Now there's two options that were specified in the documentation. One is the expansion style and one is a transition style. So let's have a look at what that border transition style looks like up here. So you can see that in the demo there's 4 different transition styles that they show, and border basically just allows all the buttons to show up and increase in size at the same time rather than drag or reveal. So this is not something that we care about too much right now, so I'm actually just going to delete that line of code. And all I'm interested in is this destructive behavior. Now before we run our app, it's really important to realize this option will try to remove the last row from your table view. So before we can run our app, let's go ahead and delete this reload data that we added previously. Now we're ready to go ahead and run our app and see if it works. Alright, so let's add a new category. Hit add, and then we're going to click and drag a little bit, and you can see that we've got that delete button show up. And then we're going to click and drag it a lot, and you can see the entire cell simply disappears. And our previous behavior still works. We can still swipe it a little bit and then click delete to remove it as well. And it's got a pretty neat animation when the library removes that row, as you can see when you do this, right? It just shrinks it down. So that is all thanks to this destructive expansion style. And all we had to do is put in, 5 or 6 lines of code for all of that to work. So that's pretty neat, right? Now what about our to-do list view controller? What if we could have both the behavior of our checking and unchecking, as well as being able to delete items? Wouldn't that be neat? So in that case, we would be able to click on the cell to check it, and we would be able to click and swipe it to just get rid of it. Because sometimes you want to see the tasks that you've ticked off, and sometimes, you're so done with them that you just want to delete them. So how can we implement that here? Now, you might realize that all that you need is pretty much this extension, right? And you could, theoretically, copy and paste it over here, because it's much the same functionality that we need. But as always, when you're copying and pasting large blocks of code, you should think to yourself, is there a better way of doing this? How can I keep my code more dry? So in the next lesson, we're going to tackle this by creating a superclass that we're going to inherit from. So for all of that and more, I'll see you on the next lesson. Alright, so in the last lesson, we managed to get our swipe cells to work, and we can now swipe on our categories to delete them, and it updates our model accordingly. Now, in this lesson, we're going to talk about how we can copy that functionality over to our to-do list view controller without having to copy all the code. And we mentioned that the way that we're going to tackle this problem is by creating a superclass where both of these view controllers can inherit from. So let's go ahead and do that. Let's hit Command N, and we're going to create a new Cocoa Touch class. And the reason is because we want to inherit from UI Table View Controller, because both of these view controllers are table view controllers, and if we need some of that functionality, then we can inherit it over. So we're going to call this class the Swipe Table View Controller, and we're going to hit Next, and we're going to save it in our group of controllers. And now this is going to be our superclass. And so we need to add all of the swipe cell functionality inside here. So we're going to import swipe cell kit, of course, and we're going to adopt the protocol, which is swipe table view cell, swipe table view cell delegate. And I'm going to delete all of this stuff that Xcode has automatically put in here so that we have a nice and clean view controller to work with. Okay, so now we need to copy over everything basically that's inside our extension. So I'm going to hit cut and I'm going to paste it over here. Now, because this is a separate class that only deals with the swipe cell functionality, it doesn't actually make sense for it to be inside a separate extension, because then our main class would be empty, right? That doesn't make any sense. So we can go ahead and take out our delegate methods from this extension by cutting it and putting it inside our swipe table view controller. And we can delete our extension completely. So now we have both of those swipe cell delegate methods inside our swipe table view controller. But one thing that we can't do in here is we can't delete our categories. Because remember, if we're going to inherit this class inside both of these classes, we can't have any specific code relating to each of these view controllers. So the superclasses are not meant to have any knowledge of their subclasses or their children. So it sounds a bit cruel, but that's just the way it is. If you watch Planet Earth, you'll realize that the world is pretty ambivalent, the struggles of individuals. And in the world of coding and Swift, it's also the same. Sadly, our swipe table view controller is going to have all of these children, category to view controller and to-do list view controller, but it's not going to care or know about it. So there's a little bit of downer for you, but it will be okay. So I'm going to actually just comment out that block of code. And instead, I'm just going to write print delete cell, just so that we know that this is actually being called when we test it later on. All right, so I think that's all that we need to do over here. But let's head back to our category view controller and delete that pragma mark as well. So now, instead of our category view controller inheriting from UI table view controller, we're actually going to inherit from the swipe table view controller. So we can go ahead and delete this and simply write swipe table view controller. And that was our custom class that we created. So because we want to keep all of the swipe cell functionality inside this superclass swipe table view controller, we actually don't really want any sort of mention to swipe cell kit inside this subclass, which is our category view controller. So I want to be able to delete this import statement and to get rid of all of the mentions of swipe cell kit. And pretty much as soon as you do that, we get an error over here that tells us, hey, by the way, you created this cell and you said that it has to be a swipe cell. And also you set the cell's delegate in order to allow the swipe cell delegate methods to trigger and inform this current class. So we don't want either of these lines of code. But the code that we do need is to change the text label based on the categories inside this view. And swipe table view cell cannot know anything about those categories. So how can we square that circle? So what we can do is we can create the superclass table view cell for row at index path, and then we can override it over here and add a little bit more information to that cell. So let's first head over to swipe table view cell, and we're going to add some table view data source methods. And the one that we really do need is the cell for row at index path. And here is where we want to initialize the swipe table view cell as the default cell for all of the table views that inherit this class. So we can go ahead and copy some of this code over. And I'm going to delete this code that we copied over from the swipe cell documentation just to make everything a little bit clearer. So let's head over here and paste that code in here. So you can see that what we did in category view controller is that we created a new cell by dequeuing it using the identifier category cell. Now, we can't have something called category cell if this class doesn't know about its subclasses, right? So we have to change this name to something more generic, like just cell. And for that to work, we have to go back into our main storyboard and change both the identifier for the category cell to cell, and also, because we want both the to-do list view controller and the category view controller to use swipe cells from the swipe table view controller, we're going to rename the to-do item cell also to cell as well. So let's hit save on that, and let's go back to swipe table view cell. You can see that our identifier is now cell, and that will work for either of those subclasses. And then we get onto this line, and this line basically can't exist because we don't know about categories inside swipe table view controller, and we certainly don't know about our data model in here. This is just a front-end UI class. So we're going to go ahead and delete that. And we're going to keep cell.delegate as self, because this is the class that has all of those delegate methods that will deal with the deletions. And then we're going to return the cell. And that is all we need to do inside this superclass. Now we're going to head over to our subclass, which is the category view controller. And we need to fix some issues here, because we need to be able to set the cell's text label.text property to the name of the categories in our data model. But if we're not going to initialize the cell here, then how can we tap into it? So let's go ahead and delete all the bits of code that we've put in the superclass. And we can tap into that superclass by saying let cell equals super.tableView, and the table view is the same as the one we've got here, and the cell for row at index path. So this is going to tap into that cell that gets created inside our super view, and it taps into the cell at the current index path. And then we're going to take that cell, and then we're going to add some more things to it, and that cell is already a swipe cell, but we're going to modify it further by changing the text label to the current category. And then finally, we're going to return cell after all of that work. So when this gets called, the first thing it does is, because we call super, it goes into our super class and triggers the code inside our cell for row at index path. At which point it creates a new cell from the prototype cell called cell, and it gets created as a swipe table view cell. It sets the cell's delegate as this current class, which is the swipe table view controller, to enable all of our delegate methods to work. And then it returns that cell. And that cell, when it gets returned, gets placed into here. At which point we further modify it by changing the text label, and finally we return the cell to our current table view inside our category view controller class. So it seems a little bit roundabout, and it's all in the name of trying to modularize our code and trying to reduce repetition and keep our code dry. So let's go ahead and hit run and see if our app actually runs and produces those cells, or will it crash and burn. So the moment of truth is now. So the first good sign is that we haven't had any errors, and we've got both of our category cells with the text label.text filled out correctly. Now the question is, are these swipe cells? Because if it only used the code here, then they're just going to be normal UI table view cells. But if our inheritance from the superclass worked correctly, then we should be able to click and drag, and there you go. There's our delete button. Now, if you click this delete button at this time point, it will crash your app. And the reason is because it triggers this particular delegate method, which is going to try and remove the last row in our table view. But we haven't removed it from our data source. So the incompatibility is going to lead to this error where it says invalid number of rows in section. So in order for that to work, we have to update our model. Now, because we can't call category inside our superclass, you have to realize that your superclass must know nothing about its subclasses. So we cannot use any of these bits of code. But we can trigger a function call. So let's create a function down here. So we'll call it update model, and the external parameter will be at, so we can call it like update model at this particular index path, but inside the function we'll just call it index path, and it's going to be of data type index path, and inside this function is where we will update our data model. Okay, so now we need to call it over here, so we're going to call update model at the index path, which is going to be the same one that triggered this delete delegate method. So we'll call it index path. And because we're inside a closure, we always have to add the keyword self. And now we can cut this block of code and we can go into our category view controller. Now inside our category view controller, under the data manipulation method section, we've got save, we've got load, and now we're going to create a delete section, and we'll call it delete data from swipe. Now, instead of creating a method inside our current class, I'm going to override and call the superclass method, which we named update models. So override update models at index path, and we're going to override that update model method that was specified over here. So when our delete action happens, it's going to call update models, passing in an index path, at which point not really very much happens, but we can tap into it over here by overriding it. So this is where we're going to paste that block of code, and I'm going to uncomment it and shift it to the left a bit using command left square bracket, and this should take care of updating our model. So let's run our app and see if it works. Alright, so let's add a new category, hit add, and let's just check to make sure that we've got a delete button when we swipe on it. So that comes from our superclass. And now if I hit the delete button, you can see that this delegate method deleted our category from our data model. So this is more of an advanced example of some of the things that we learned on objects and classes and inheritance especially. And it's really, really key that you understand how subclasses, superclasses, overriding, how all of this works. So it's important that you play around with this update model function and also where you override it over here. For example, if we create a print statement here that just says item deleted from superclass, and then we go over to our category view controller, if we run our app as is, we are not going to get that print statement in here. And I'm going to show you by running our app and creating new category, hit add, and I'm going to swipe it to delete it, no print statement. And the reason is because we've overridden how that method should function. But if we made a call to the super update models at index path method, then we will get that print statement. So let's add a new category. And now if I swipe and delete, you can see item deleted from superclass. And that's all because of this call to the superclass method. So essentially what's happening is that our deletion triggers this delegate method. This delegate method has a closure which triggers the update models at index path, and it passes in the index path of the cell that got swiped. That calls this function over here, which has a print statement. But this function is overridden in the subclass. And that subclass can either call the superclass method in order to run all the code that's currently inside here, or it can simply override it without the need for any of the superclass functionality. So if all of that makes sense, then it's time for your next challenge. And that is, of course, the fact that we have a to-do list view controller, which is also going to now subclass the swipe table view controller instead of a UI table view controller. So the challenge is for you to implement that swipe cell functionality inside the to-do list view controller. And you will need to understand subclassing, superclassing, and all of the things that we've done over here in order to make it work and complete the challenge. If you need, it might be worth reviewing some of the lectures earlier on where we talked about objects, classes, inheritance, and having a look at the steps that we went through to update our category view controller to be a subclass of swipe table view controller. But this is quite challenging, and I suspect that it might take you a little while to figure everything out, but if you do get it right, then you'll know for sure that all of these concepts made sense to you. So rather than proving it to anyone else, prove it to yourself that you've understood everything. So go forth and struggle, and I will see you on the other side. So did you manage to complete the challenge? I really hope that you gave it a good go, because it is a really, really good challenge to understand these complex and rather abstract concepts. And I imagine that if you played around with it quite a bit, fixed some bugs and figured out how to make it work inside the to-do list view controller, then you've got a good grasp of how superclasses, subclasses, and all of this works. So, spoiler alert, I'm going to show you the solution now. So if you haven't tried it, then go back and do it now. Alright, so the first thing that we need to do inside to-do list view controller, just as we did inside the category view controller, is to change the inheritance. Instead of subclassing UI table view controller, Apple's component, we're going to subclass swipe table view controller. And if you think about it, the UI table view controller is almost like the granddad of to-do list view controller now, because inside swipe table view controller, it now inherits UI table view controller. So say if this was granddaddy, then this is going to be your dad, and this is going to be you. Now, if it's a little bit upsetting to think of yourself as a block of code, then I apologize for that, but I think it's a good analogy. So the next thing that we need to do is to change our self_arrow@index_path method, because we're no longer going to be dequeuing our cell inside here. Instead, we're going to be using the superclasses cell. So we're going to say let cell equals super, which you can see is the swipe table view controller, dot table view cell for index path. So now that we have this reference to the cell, that is from the method inside our super view controller, so inside here, and that cell is already set up as a swipe table view cell, and the cell's delegate is self. Now, it might be worth just going back and making sure that table view cell is set as a swipe table view cell, and it uses the swipe cell kit module. We did that for the first cell in the tutorial, and this might be something that you would have overlooked. So once that's done, then we've got this reference to the cell from our superclass, and we're going to set the cell's text label, we're going to set the cell's accessory type, and then we're going to return the cell. And we don't have to deal with any of the swipe cell kit over here. Now, the next thing to add in is that we will need to override that function that we've got inside swipe table view cell, which is the update model at index path. So we're going to go over here, we're going to override update model at index path, and we're going to take that index path to delete our data. So we can say if let item equal the to-do items, which is an optional, so we'll use optional chaining to grab a hold of the item at indexPath.row, and this is the index path that gets passed in through our superclass method update model at index path, which gets triggered, if you remember, when the user swipes on a particular cell to try and delete it. So we're going to grab a reference to our item at this particular index, and if this is not nil, then we are going to use our realm.write method to make some changes inside our realm. And the changes that we want to make are realm.delete, and the object that we want to delete is this item object. Now, as Xcode is helpfully telling us, realm.write can throw, so we have to mark it with a try, and therefore we're going to put it inside a do catch block. And now we're ready to run our app. So if we go inside home, you can see that we've got 3 items, and we can still check them off as we did before using our did select row at index path delegate method. But now we have the special power of swiping and getting that delete show up. And if we click on it or swipe all the way, then it deletes it from our list of items. Now, what if we wanted our items to have the same height as the ones inside our categories? Now, we can either copy this row height over to our to-do list view controller, but if we're going to have it the same for both, and we're inheriting from swipe view table view controller, then it makes more sense for it to go over here. And now if we hit run, you'll see that we get that nice expanded height in both view controllers. So, alright, how did that go? Did you manage to get it? If not, make sure that you have a look at the previous lesson as well as this one and try and go and attempt it again. It's really, really important that at this stage that you really try things yourself, and you will fail and you will fall over and you will have to struggle a lot. But believe me, the more that you struggle, the more that you learn. So that's all for this lesson, and in the next lesson we're going to improve the appearance of our app even further by adding gradients to our cells. So for all of that and more, I'll see you on the next lesson. Now our app is looking better and better and it's working better and better, but there's one other thing that I would like to improve to it. And it's the fact that it's a little bit low on the color, don't you think? So nobody likes a plain white app, right? So let's go ahead and implement some nice colors to make our app come alive. So in order to do this, we're going to fall back on our trusty library that we've used before, which is the Chameleon framework. And we've used this previously just simply to tap into their nice colors. But in this case, we're actually going to use some of the other bits of functionality. And it makes way more sense to incorporate this library rather than do it all ourselves. Because there's no point reinventing the wheel. And if somebody else has made a more efficient solution that you can implement in a few lines of code, there's no reason why you shouldn't. It's all about standing on the shoulders of giants, right? So the first thing that I quite like is their contrasting text. So when the background is light, then the text is dark. When the background is dark, then the text is light. And that's pretty cool. The other thing that you can do is that you can actually get a color palette based off an image. Now, we're not going to use it in this project, but it's something that I've used quite a lot in other projects. And it's pretty neat to be able to do this. Let's go ahead and incorporate the Swift 5 compatible version of Chameleon framework into our app. The user helpfully created a Swift 5 branch from the Chameleon project. So we'll copy the Git repository here. And then inside Xcode, we can go to our pod file and start to add the pod, like so. Pod Chameleon framework / Swift. Then we specify the repo we want to use. In this case, WowAnsom's repo. Pod Chameleon framework / Swift, :git, and then it's an =, a right angle bracket, and then it's that URL that we copied earlier. And finally, we add the branch from this repo that we want, which is the Swift 5 branch. So after a comma, we add :branch, =, angle bracket, Swift 5 inside single quotes. Now we can hit Command S to save and close down our project. And I'm going to go to terminal, and if you're not inside your to-do folder, then make sure that you CD over there, and then we're going to perform pod install. It's a super small framework, and it shouldn't take very long for it to be done. And now we can go ahead and open up our project. And of course, make sure that you open up the workspace rather than the Xcode project. Now that we've added our pods, we're going to go and integrate them in the places where we need them. The first UI improvement would be to add some nice colors to our cells, right? At the moment, it's looking very, very plain Jane, and we're going to use Chameleon Framework to do this. And we're going to generate some random colors to color the background of each of our cells. So let's head back to our Chameleon Framework documentation and let's find out how to do that. So if we scroll down to the documentation section and let's go to, for example, UI color methods. So here are some ways that you can pick out a color and use it. And here are some ways that you can generate a random flat color. So the simplest way of doing this is by simply saying set the view's background color to equal a UI color that is a random flat color generated using Chameleon Framework. So let's go ahead and do that in our code. So let's go ahead and import Chameleon Framework. And we're going to scroll down to our table view data source methods. And we're going to go inside self-row at index path. And here is the most obvious place to change the background color of the cell, because we set up a cell using the superclass method, and then we get back that cell and we modify it a little bit further by, for example, changing the text that's inside the text label. And it also makes sense to change the cell's background color here. And we can set it to equal a UI color that is a random flat. And this comes from the Chameleon Framework, as you can see here. So let's run our app and see what that looks like. All right, looking pretty nice, right? Now, because we're adding colors in now, we can actually remove each of these separators between the cells to make the colors bleed right to the edge of each other, and it'll make it look a lot nicer instead of these individual marked cells. And we can do that inside our view.load by simply saying table view dot separator style equals dot none. And if I refresh and rerun, then you'll see that our colors are going right up to the edge with each other, and it's looking a lot nicer than before. So one other problem that you've noticed when I reran our app, the colors for the cells changed. Whereas before, I think home was like a light shade of pink and work was green, now it's completely different. Wouldn't it be nice to keep those colors for each category so that when they do get randomly generated and we, for example, terminate our app, if we open up our app again, it'd be nice if they didn't change all the time, right? So how can we do this? Well, we'll need to persist that piece of information locally. And of course, we're going to do that using Realm. So you might have guessed it, you might have not, but this is going to be your challenge. But I'll give you a clue. You can get the random color, not just as a UI color, which this is at the moment, as you can see here, but you can get it as a string by simply saying random flat dot hex value. And this, you can see, is of data type string, and it returns a hex code for that specified color. And this is useful to tell you because when we try to save pieces of data into our category or our item using Realm, the data type has to be standard data types. It can't be something like a UI color. So with that in mind, the fact that you can grab the string value of the random color, and the fact that you can turn it back into a UI color by simply initializing it with a hex string, like so. And you can put that hex code inside here in order to turn it into a UI color. Now, armed with that information and those hints, and also the power of the Chameleon Framework documentation, I want you to be able to persist the colors that we randomly generate inside our category view controller. So if when I add a new category, say new, and I hit add, and it comes up as a brown or coffee colored, then I want to keep it as that color. So the real litmus test for you is, can you get our table view to have cells with random colors generated using Chameleon Framework? And when you see those colors on screen, if you then go and terminate your app and reopen it, can you get it to have the same colors as it did before? So there's quite a bit of struggle ahead for you and a little bit of digging around, but I am sure that you will be able to figure it out if you give it a really, really good go. So pause the video now and try to complete that challenge. Alright, so I'm putting my trust in you that you've given it a really, really good try and that you're here because you have some bugs or you just want to see how I might choose to do it. Now, in our challenges, I like to say that there's no correct way, there's only different paths. And as long as it leads you to the result that we wanted, then you have succeeded in the challenge. So let's have a look at how we might do this. Let's think about it logically. What we need to happen is that when we create a new category, it needs to be associated with a new piece of data, not just a name or a list of items, but it now needs a color. So in our category class, we're going to have to need to add a new property that is called, say, color. And this is going to be set as a string data type because we're going to save a hex string into this property. Now let's head back over to our category view controller and think about where is the first time point where we create our categories? Well, that's of course inside our add button pressed method. And we need to be in here because when we create a new category, we give it values for all of its properties, including the category's name. And now we'll also need to give it a color when we create it. So we're going to set this to equal UI color dot random flat dot hex value. And this is now a string, as you can see over here. So that string gets saved into that property color and gets persisted when we call save to our new category. Now, once it's been saved, then we'll need to retrieve it, right? So when we retrieve our data when we call load categories inside view did load. And load categories pulls out all of the objects that are of the type category. And it gets put into this array or result container called categories. Now, when do we need to use that information? Well, we use it here to change the text label of the cell. And we're also going to use it here to change the color of the cell. So we're going to set it to equal a UI color using a hex string. And this placeholder is telling us that we need to put a string inside here. So let's go ahead and do that. So what is our string going to be? Well, it's going to be the categories at indexPath.row.color. Now, the first issue we get is that categories is an optional. So we would have to use optional chaining in order to make sure that we don't try to use a nil value. So if categories is not nil, then we're going to grab the category at indexPath.row. And then we're going to tap into the color property. Now, color may or may not have a value. So if it doesn't have a value, then we're going to do the same thing as we did up here. We're going to say, if there is no value, then here is a default value. So the default value that we're going to give as the hex code is we're going to go into our main storyboard and we're going to find that nice blue color that we've got as the title. And we're going to look at that color's hex color inside the RGB sliders under this particular tab. So we're going to copy that code over and we're going to paste it inside here so that we can use it as the default hex color. If your category doesn't have a color yet, then we're going to use a default value for the color. So you can shorten these two lines of code if you wish by saying if let category equal categories, optional chained to indexPath.row, and if that is not nil, then we're going to call these two lines of code. And instead of using categories at indexPath.row, we're simply going to use our new constant called category, and we can replace it in those two places. Alright, so let's give it a go and see if we manage to solve that challenge. So the first thing that will happen when you run your app is your app is going to crash. And that's because if we open up our RAM browser, you'll remember that category already has 3 items. Now, these 3 items don't have the third property color yet, but color is going to be used inside our app. So when this mismatch happens, you get this particular error. Error domain equals io.ram code 10. Migration is required because category.color has been added. So what we have to do, if you remember, is you will have to hold your app, delete it, and rerun your app. And that wipes all of your data so that everything is consistent. Okay, so let's go ahead and add a new category, and let's call our category home, as we did before. Okay, so home is green, and let's add another one called work. Work is brown. Now, you'll see that the contrast between the text and the background is not great at the moment, but we're going to fix that a little bit later on using another of Chameleon's methods. But for now, this is pretty good. We're getting random colors, and here's the litmus test. If we terminate our app and go back into ToDoey, look, home is still green, work is still brown. I completely agree with the color choices that have been randomly generated by my app. So, did you manage to get the challenge? If you didn't, then this is a good time to go back and fix any bugs you might have and try to get it working. So, in the next lesson, we're going to be adding some gradient colors to our to-do list view controller. So if you want to see that, then I'll see you on the next lesson. Now, in the last lesson, we've managed to brighten up our categories view controller by assigning some random colors to the background of the cells. And we're persisting this data so that every single time we open up our app or we add a new category, the color stays consistent for each of the categories. So the next thing I want to do is I want to go to the items or the to-do list view controller, and I want to create a slightly different effect. I want to create a gradient effect so that maybe at the top we've got one color, say blue, right? And it's light blue. And then through a gradient, all the items get progressively darker and darker and darker, and it'll look like a nice gradient transition. So let's try and see if we can figure out how to do that. Now, back in the Chameleon Framework documentation, you can see that they have some methods that allow you to color a shade lighter or darker. So that will probably help us to achieve our goals. So let's go into our to-do list view controller and go to the place where it makes the most sense to change the background color of the cell, which is, of course, inside self row at index path again. Now, the place where we change the cell properties here is inside this if let, and we change the text labels text, and we're also going to change the cell's background color. So we're going to set the background color depending on the current index path. If the index path is, say, 0, like the first cell, then we're not going to darken the color by very much. But if the index path is much higher, say at, the 10th row, then we're going to darken it a lot more. So it makes sense if we can change that darkening percentage based on our item number in all of the to-do items. So say if we had 10 to-do items, then we want the first item to be darkened by 10%, the fifth item to be darkened by 50%, and the last item to be darkened by maybe, say, 100%. So that way we get a nice gradient transition from the top item all the way down to the bottom item. And we can start doing that by setting the cell's background color to, let's just pick one from Chameleon Framework. Maybe something like flat sky blue, right? Looks pretty nice. So we can say that cell's background color equals flat sky blue. And in order to get this color out of Chameleon Framework, we of course have to remember to import it. So there's flat sky blue, and we're going to say darken this color by a percentage. And the percentage is going to take a CG float. So that's a floating point or a decimal number. And the way that this works is it takes a number between 0 and 1, where 1 is basically 100% and 0 is 0%. And everything in between is your percentage as a CG float or a core graphics floating point number. So the percentage that we want to darken our background color depends on two things. One is which item are we currently trying to color up? And the second thing is how many items are there in our to-do list? So let's delete this placeholder and give ourselves a bit of space in order to write out the maths. So the percentage that we're going to darken our cell is going to be the current index path.row. Say if we're currently on the 5th row, right? Let's just imagine one particular situation rather than trying to plan for all the scenarios. Say we're currently on row number 5, right? And there's a total of 10 items in to-do items. So now we're on 5 out of 10, so we want to darken our background color by basically 50%, so close to 0.5. And we can get that number by dividing the index path.row by the total number of items, right? So to do items dot count. Now index path.row is going to be an integer, and to do items dot count is also going to be an integer. So integer divided by integer, that's perfectly valid, but we need to get it out as a CG float in order to satisfy the requirements of this particular parameter. So we can cast it into a CG float, or you might think we can. This line of code will make sense to the largest number of people. But I'm going to show you what happens when we do this, and you might already be able to predict if you are good with the logic and you've been keeping up with what I've been saying. But no matter, this line makes sense to us, right? Take the current index path.row, which is 5, divide it by 10, you get 0.5, and 0.5 works as a floating point percentage to darken our flat sky blue color. Now, all of this code, remember, gets called for every single cell in the table view. So when we are on row number 1 out of 10 items, then this is going to be 0.1. And so we're only going to darken our background color by 10%. Now, the problem, as Xcode is suggesting to us, is that this darken by percentage method returns an optional UI color. But this needs a definite UI color. So what can we do? Well, we can of course use our handy if let, and you can see that we are now building a optional binding pyramid. And this pattern, unfortunately, is a bit too common in Swift. So if let color equal all of this, so let's cut it and paste it. Now, we can, of course, shorten this if we don't want all of that extra commenting. You can see that we can actually make it all fit into one line. At this point, it's telling us that you're optionally chaining to do items here using this question mark. So this is saying, get the count if to do items is not nil. Now, we know that to do items can't be nil inside this current if let, because it's only going to get called if to do items at index path.row is not nil. So this is a place where it's actually safe to simply force unwrap to do items. So if let color equal this darker color, then what we should do is we should set the cell's background color to this color. And now, if we run our app, you'll see something slightly peculiar happen. So let's go into our home category and let's add some items, shall we? Buy food. Eat food. Enjoy food. You're getting a peek into my mindset here. Alright, so Oh, there's still the separators over here, right? So let's get rid of the separators by putting it inside view did load. Table view dot separator style equals dot none. So we'll run that change a little bit later on. But the more pertinent problem is, why on earth do we have the same colors, even though we told our code to darken this flat sky blue color by a percentage depending on which row we're on? So we're expecting a gradient here, right? That would be nice. So here is a fundamental logical or mathematical issue with type conversions. So I'm going to print two things here. I'm going to print, say, version 1. And version 1 is going to be what we've got here. IndexPath.row divided by todoitems.count. And then the result of that division turned into a CG float. And the second version, or version 2, is going to be slightly different. What if we first turn indexPath.row into a CG float by casting it? And then, after we've turned it into a float, do we divide it by todoitems.count? And because we can only do division between similar types, right, as it says, binary operator cannot be applied to different types, then we're also going to convert todoitems.count into a CG float as well. So the important difference between version 1 and version 2 is that version 1, we're doing whole number divided by whole number, and the result gets turned into a CG float. Version 2 is whole number gets turned into a CG float, whole number gets turned into a CG float, then CG floats are divided by CG floats. So let's go ahead and hit run and see what we get printed out for every single row in our table view. So let's again go into home where we've already got 3 items, and let's take a look over here. So version 1, for the first row, index path is 0. 0 divided by 3 is still going to be 0. So both of them are 0.0. Now the differences come in the second row, where the index path.row is equal to 1. 1 divided by 3 is a third, or 0.3 recurring. But that only gets shown in our second version, not our first version. Our first version is still 0. Now, why is that? Well, when you divide a whole number by a whole number, the output here gets rounded into a whole number, and then that rounded whole number gets turned into a floating point. So you can try it yourself inside Swift Playgrounds, but this is essentially the reason why our code does not work. And this is a very, very simple reason why sometimes when you work with floats and doubles and trying to use variables that are integers, you might get unexpected problems. So this is something that happens to a lot of people, and we're simply going to replace that inside here where it says by percentage. Okay, so now I'm going to comment out my print statements because we no longer need them, and I'm going to run our app and we are going to hope for the best. Alright, so let's go inside home, and dun dun dun! Isn't that cool? And as we add more items, I don't know, eat more food. I'm so hungry. Feed me. You can see that our gradient starts building up, and depending on which row we're on, it will darken it by the percentage determined by which row it is in the total number of items. So this is looking pretty neat, right? Now, there's just one problem, and the problem is that this part gets so dark that we can't actually see the text anymore. Yeah, it looks pretty neat and it's pretty, but as we always say, you should choose function over form, right? Unless we can have both. So what do we need to happen in order for our app to work well? Well, we will need the text for the darker backgrounds to be white instead of black, and the text for the lighter backgrounds to be black instead of white. So how can we do this? Well, we can either Google for it and look through custom solutions, or why don't we just see if Chameleon Framework already has a method that does it. If it doesn't, we'll build a custom solution, but if it does, let's not reinvent the wheel. And if you scroll through their documentation, you'll come across this neat little thing called contrasting text. And it means that you no longer have to worry about the text standing out from the background color because it's going to take care of it for you. So let's try and figure out where it allows us to do that. So I'm just going to go for Command F to find contrasting text. Contrasting text, contrasting colors. Ooh, okay. So this contrasting color feature returns either a dark color or a light color, depending on what the Chameleon algorithm believes is a better choice. And we can use it by using UI color, contrasting black or white color on UI color is flat, true or false, or we can just use the shorthand. Contrast color, passing in the current background color, and specifying whether if it should be flat or not flat. So let's go ahead and implement that in our code. So inside the same place where we did the optional binding, where we specify the background color, we're going to change the cell's text label dot text color. And that text color is going to be equal to contrast color of background color. So we're going to pass in our background color that we generated up here and return a flat color or not a flat color. We're going to set to equal true. And now let's run our app and see the magic happen. Nice, right? Looks pretty sweet. Now you can see that they're all white because the flat sky blue is a little bit dark of a color by itself, and the white stands out quite nicely against it. So this algorithm behind the scenes is trying to figure out whether if white or black is the more optimal choice. So if we went for a slightly lighter color from the palette instead of flat sky blue, say something like, I don't know, flat white, right? Let's try that one. Flat white. This is making me want coffee now. Okay, so let's go ahead and hit run. And you can see that automatically the lighter colors at the top were given black text colors and the darker colors at the bottom were given white text colors. So it's pretty neat, right? Now, it's all very well and good specifying a color and getting it darkened by percentage. Wouldn't it be nice if you could carry through the color of the category? So the user will select home, and this will be a gradient of green colors similar to our home color. So what you'll need to do is to somehow change this to the color that we persisted using Realm. So pause the video and try and see if you can complete this challenge. Alright, so this one shouldn't be too hard because if you remember, we passed in the current category using this selected category property. And this is an optional category that contains all the pieces of data in here. So the name of the category as well as the color of the category as a string. So if we go in here and replace this flat white using something like UI color, using hex string, and the string is going to come from our selected category dot color property. Now we've got some problems here because if you click on our arrow, it says that selected category it tells us that selected category, the first little highlight, is an optional category and it's not unwrapped. The other problem is that the output or the return of this initializer, create a UI color using hex string, is also an optional UI color, and it's also not unwrapped. So there's two ways of solving this. You can either go down a pretty steep if-let pyramid. If-let color equals this, then if-let blah blah blah, and then if-let the next one, then if-let the next one, unwrapping each property as you go along. But let's go back to first principles. We're inside this if-let at the moment, and we're checking to see if to-do items at indexPath.row is or is not nil. Now, if this is not nil, then that means that we managed to have items inside to-do items. Then that means to-do item exists. And to-do items comes from our selected category, which must mean that selected category can't be nil either. So sometimes having these warnings forces you as a human developer to think and see if this is safe to be unwrapped. Now we've unwrapped selected category. The next thing we need to tackle is, what if we can't actually get a color from this hex string? What if I just entered some piece of, mumbo jumbo of a hex string and you can't actually get a hex color? And this is a problem you always have when you allow strings, because strings can be free form. It doesn't have to conform to a particular format. Then I could have put in any old string in here, and of course you can't just generate a color from any string. That's not how it works. It has to be a valid hex string. Now, we don't have any validation for that, but what we can say is, if this is nil, then don't go forward with the next method, i.e. darken by percentage. So we're saying, optionally chain this. So if this is not nil, i.e. we got a valid hex code creating a valid UI color, and it's not nil, then go forward and try to darken it. Because if we try to darken a nil value, then this is where our app is going to crash. So we're using optional chaining to make sure that all of this is not nil before we continue with our code block. So let's run our app and see if we manage to carry forward that color from the category to our to-do list view controller. Alright, so here's our home category, which is green. And if we click on it, oh look, isn't that nice? We've got a gradient of green items, and we've got text that's contrasting with the background color, and it looks pretty neat to me, at least. So did you manage to get that to work? If so, then great. If not, then you might need to watch some of the past videos a few more times. Alright, in the next lesson, we're going to tidy everything up, and we're going to change our nav bar to make it reflect the colors that we've got in our to-do list view controller. So for all of that and more, see you on the next lesson. Now, in the past few lessons, we've already massively improved some of our user interface, and it's starting to really come along and look really nice. So in this lesson, we're going to tie up all the loose ends, and we're going to do a little bit more front-end stuff to make our app feel really cohesive and look like it's a real app on the App Store. So the first thing that I want to do is I want to change the nav bar. Instead of having this small nav bar, I want to make it a large title. And in order to do that, there's only one checkbox that we need to check off. So if you go into your main.storyboard and select not the nav bars for your individual view controllers, but the actual navigation controller's nav bar, and you can also select it inside the document outline as well. It's this particular one that you're interested, the actual bar rather than the controller. And if you head over to the attributes inspector, then there's this particular boolean called prefers large titles. And if you tick it, then you can see that our navigation bars become a lot bigger, and the titles get bigger as well, and it looks a lot more like an actual to-do list. And if we run our app, you'll see that it looks a lot nicer in this particular format. It works much better as the heading. So the next thing I want to change is that I want to change the nav bar to be consistent also with the background color of the category, so that everything on this screen is green. And the place where you're going to set this is inside View Did Load. So inside the to-do list view controller, go into the View Did Load, and we are going to tap into our navigation controller dot navigation bar. And then we're going to set not its background color, because this only changes the background color of the bar, but we're going to set the bar tint color. And this will apply it both to the navigation bar as well as the status bar. And we're going to set this equal to the color based on the selected category. So it will be selected category dot color. And of course, remember, this is a hex string that describes our color. So we're going to have to use that UI color method from Chameleon called UI color with hex string. And then we're going to put that hex string inside here. Now, as soon as you do that, Xcode is going to complain. Because we're using optional chaining here, this value is an optional. And this UI color using hex string method needs a non-optional string in order for this to work. So you have the option of either explicitly unwrapping selected category, which is not all that safe, or you can use optional binding. So we can say if let color hex equals selected category question mark dot color. If this is not nil, then we will proceed with this method, and we can replace this part here with color hex. Now, the other assumption that we're making here by using this question mark is we're saying if the navigation controller is not nil, then in that case, we're going to set the bar color for the navigation bar. Now, this assumption is a little bit problematic, and I'm going to show you why by using a guard statement. So I'm going to say guard let nav bar equal navigation controller dot nav bar, and then else, i.e. if it is nil, then we're going to throw a fatal error, and I'm going to pass the message for that fatal error as navigation controller does not exist. So what this line is going to do is it's going to create this constant called navbar and assign it the value of the current navigation bar in the current navigation controller. But if this is nil, i.e. the navigation controller does not yet exist, then we're going to throw this fatal error and we're going to inform ourselves of this problem, and our app is going to crash and we're going to see this message. So let's run our app and see what happens. Okay, so let's go into our to-do list view controller, and you can see that our app is right now crashing. And if we click on this error, then it says fatal error, navigation controller does not exist. So the thing is, when you start off learning how to develop apps for iOS, people tend to be very afraid of app crashes. But as you get more and more experience, you should start to learn that crashes are not bad. They're not a bad thing. What you don't want is for your app to fail silently in the background and your variables and properties having values that are unexpected and undesired, but it's not giving you a warning in any sort of way. So don't be afraid of throwing fatal errors when you have a situation where you definitely don't expect it to break, so that you can catch these problems during testing rather than in the live deployment app on the App Store when your app is not behaving the way it should be and the user has no clue how to report this. So now let's stop our app and figure out what's going on. Why is our navigation controller nil at this point? Why are we getting this fatal error being thrown? Well, the problem is that we know that view did load is the time point at which our view for our current view controller has been loaded up. Now, the problem is that just because the view's been loaded up does not mean that your view has been inserted into the navigation controller. It might not yet be in that navigation stack. So during the process of pushing this to-do list view controller onto the navigation stack to be managed by the navigation controller, view.didLoad will get called. But the thing that you cannot be sure of is whether if the to-do list view controller is already inside the navigation stack, i.e. if that process has completed before view.didLoad gets called. So in our case, it's clear that view.didLoad is actually being called before the navigation controller property has been updated, because at this point it is still nil. So what can we do? Well, maybe consider that view.didLoad might not be the right place to place this code. And if we think back to the lesson on view controller lifecycles, then you might remember that there's another access point that we can use, which was called view will appear. And view will appear gets called later than view did load, and it's actually at the point just right before the view is going to show up on screen. So after the view's been loaded up, after the navigation stack's been established, and just before the user sees anything on screen, this is the time point that we can access using view will appear. And so I'm going to transplant my code here into view will appear. And it's probably also a good time to delete this stray bit of code here if you haven't done already, because we no longer need that. Okay, so inside our view will appear, we're still going to use our guard-led navigation bar. And Xcode is complaining and giving us a warning at the moment that you've guarded and you've created this constant called navbar, but you're not really using it anywhere. So let's use it. Let's replace this navigation bar that uses optional chaining. So this is why our bar tint color didn't change at all previously, because navigation controller is nil. And the way that optional chaining works is that if this is nil, then this code is not going to be continued. So this gets skipped over. So instead, what we want to do is we want to use navbar, and we're guarding against scenarios where navbar is nil by using this guard statement. So let's go ahead and run our app and see if that worked. Okay, so we're going to go into the home screen, and you can see that our status bar, our navigation bar, everything gets changed just by moving our code to a different lifecycle time point. And our app doesn't crash. Our fatal error is not being thrown, because at this point the navigation property has a value. It's not nil, and our current view controller is firmly inside the navigation stack. So the other things that we might want to do here is maybe change the title of our to-do items view controller. It would be nice if this title reflected the category that we selected, right? And it's pretty easy to tap into because we have this selected category property here. So we can simply say something like title, which is a string that represents the view that this controller manages. And this is basically what the navigation controller will tap into to populate the title in the navbar. So we can say title equals selected category. And because we're inside an optional binding block where we've already accessed the selected category's color through optional binding, then we can be pretty sure that selected category does in fact exist and is not nil. So title will become selected category dot name. So as you progress, you're going to be more flexible with these optionals and figure out ways of being safe while being constantly aware of what it is that your code is doing and the places where it can fall down. So let's run our app and see if our title gets populated. And if we go inside home, you can see that our title used to be item, but it now is the title of the category. So looking pretty sweet, right? Now, there's just one other thing that's bugging me, which is, what about the background of the search bar? It looks so out of place with that grey background. Let's change it. So for us to be able to do that, we first have to create an outlet from the search bar into our to-do list view controller. So you can either click and drag from the search bar, just making sure that you've actually selected the search bar and not a table view. Alternatively, and probably a much better way, is to go from the document outline and drag it into your to-do list view controller. And I'm just going to call it search bar and hit enter to create that IB outlet. And then we can go inside view will appear just underneath the line that we wrote previously. So we'll tap into search bar dot bar tint color, and this applies the tint color to the search bar background, and we're going to set it to equal the same color that we specified for our navigation bar. So let's go ahead and hit run and see if that worked. So we're going to go into home, and you can see everything is now more or less green. Now, another thing that you might want to change is the color of these buttons. So for example, this button currently is sort of a light blue, which doesn't look that great. We manually set this button to be white. But what if our navigation bar was set to a really light color, for example, white or something like that? Then in that case, we might not be able to see these buttons, right? So we should do what we've done here, which is set these buttons to contrast the color of the navigation bar. And we can do that just below where we set the bar tint color, because there's another property in the navigation bar called the tint color. And this applies to all of the navigation items and bar button items. So that is the one that we want to change. We're going to set it to the contrasting color of the color of the nav bar, and we're going to return it as flat, which basically means a low contrast color. Now we have a problem here because the output of this particular method is a optional UI color. And that's fine over here because bar tint color takes a optional UI color. But in this case, the contrasting color method requires a non-optional UI color. So we either have to force unwrap it, which is unsafe, or we will have to create another if let. So it'll be if let navbar color equals UI color created with the color hex code. And if that is not nil, then we will set the navbar background, the tint color, as well as the search bar colors. So we're going to paste that inside this optional binding statement. And then we can change this to navbar color. And change this to navbar color. And also we can change this to navbar color because it's going to be the same. Now the next thing that we want to change is the color of the title. And if we have a look through the UI navigation bar documentation, then you can see that there's this section called Customizing the Appearance of a Navigation Bar. And it talks about how you would change the title text differently from the rest of the controls, so the bar button items, for example. And you need to change this title text attributes property by setting the foreground color key. So let's go ahead and do that here. Now we're going to say navigation bar to tap into the current bar. Then we're going to look for the title text attributes. Now it's important that because we're using the large title, we have to change the properties for the large title text attributes rather than just the regular title text attributes, which is the smaller one that shows up in the middle. So let's select large title text attribute property, and it's expecting a dictionary where it takes a key, which is an NS attributed string key, and it takes a value, which is going to be the value for whichever key you choose. So we're going to create a new dictionary, and we're going to tap into that NS attributed string key, and we're going to use the dot notation to find the key that we want. And this is a bit like an enum, where we're looking through and trying to find the value that we want to change. And in our case, it's actually the foreground color that we're interested in changing. The foreground color for the large text title. And this is going to be set to our contrast color, contrasting the navbar color, returning a flat color. And now we're almost ready to run our app. The last thing that we need to do before we can do that is we need to go into our main storyboard and click on that plus button, which we manually set to be white, and we need to change it back to default. And now if we run our app and we go into home, you can see that everything gets colored correctly, and also the background color looks exactly as we want it to. Now there's just one problem. The navigation bar in the category view controller is not behaving as expected. In order to fix this, let's change the navigation bar's background color to blue in the category view controller. I'm going to do this in the view will appear lifecycle method. So the part where it says override function view will appear, I'll add the same guardlet as in the to-do list view controller. So guardlet navbar equals navigation controller dot navigation bar, else throw a fatal error that navigation controller does not exist. Except for this time, I'll change the background color to the UI color with the hex code #1D9BF6. So navbar.background color equals UI color with hex string #1D9BF6. And if we run our app, you'll see that it works exactly as it did before. Now, the very, very, very last thing that I want to fix is the text color inside the cell for the category view controller here, because I can barely read it off that dark background. So we know how to do that. Inside our to-do list view controller, when we did self a row at index path, we had this line of code where we contrasted the color of the background color. So I'm going to go into the category view controller and go into its self a row at index path, and I'm going to set the cell's text label dot text color to be the contrasting color of this color, which came from the category, and returning as a flat color. Now, of course, if you wanted to, you can either use if let or guard let category color to be equal to this UI color created using that category.color hex string. And if that doesn't work, then I'm going to throw a fatal error, because it really should. Now I can set the cell's background color to category color, and I can contrast the color instead of this long string to category color as well. And let's run our app and see if that worked. Alright, nice. That's looking a lot better than before. As you can see, there's so much that you can do with the front end and the UI. You can really go to town if you wanted to. And off the top of my head, I can probably think of even more UI improvements, but we have achieved most of our design aims. We wanted to have different colors for each category, and we wanted that color to be carried over when we go into the to-do list view controller. We have the category as the title of this to-do list view controller, and we've created this gradient effect for each of our cells, and we've contrasted the text with that background. So if you do decide to add even more front-end code and make this even more fancy and even prettier, then be sure to post a video of it or a GIF of it to the Q&A section so that we can all admire your beautiful work. So I hope you enjoyed making this app with me and learning all about, oh my gosh, so many things in this module. The main reason why I created this module was to teach you all of the different ways that you can persist data locally. And we covered user defaults, we covered the codable protocol, we covered file storage locally, as well as core data and Realm, which we've used to create relational databases. And finally, we've wrapped it all up using a nice UI. And we now have this beautiful to-do list app, which you will no doubtly use to add new to-do items, like other new iOS code that you're going to learn about. That's all from me for this module, and I will see you on the next module.
Subscribe now and press the bell icon. Never miss an update.
Hello everyone, it's Angela from the AppBury here again, and in this module we're going to learn all about in-app purchases and how to implement them for our apps to start earning extra bucks for all of the apps that you make. Now, if you've ever played any sort of game on the iPhone, you should be familiar with in-app purchases as well. A lot of apps will push them heavily onto you, and you can buy a whole wide range of in-app purchases, from gems to time to energy to coins, and basically everything that you can imagine. Now, the most important thing to notice about in-app purchases is that they are virtual. So essentially, it doesn't cost you any money when a user purchases one of these in-app purchases. It's only digital bits and bytes being moved around on Apple servers, and it's not something that you have to provide, like an actual physical t-shirt that you're selling them or sending them an Uber car driver who'll drive them around. And this is why Apple has the privilege of charging you 30% of everything you make through in-app purchases. So if you charge £1, they'll take 30p. If you charge $1, they'll take 30 cents, essentially. Now, it's really important that you remember that in-app purchases are only for virtual products, and all virtual products that you sell through the App Store has to go through Apple, and therefore you have to pay them the 30%. It's a little bit like your mafia protection money. But anyways, let's move on. So why do we need in-app purchases anyways? Well, because it's a really good way of increasing conversions on your free apps. So this allows you to put out your apps for free, making it more tempting and easier for users to download your app, giving it a go, and seeing what the features are before you start charging them for, say, premium features or to remove ads. And in-app purchases work extremely well. This is one of the reasons why if you search on the App Store and you look at the top grossing iPhone apps, you can see that pretty much all of them are free to download, but they all include in-app purchases. Every single one of these usually. And that is how they make big bucks. So the best way of implementing in-app purchases, from my experience, is giving the user about 80% of all the functionality of your app for free, and only then put up a paywall where they have to pay to get an in-app purchase to upgrade to the premium version or to remove ads or whatever it is that gets them that last 20% out of your app. This is what has worked really well in a lot of other apps, including one of my favorites, which is called Overcast. It is one of the best podcast apps out there, hands down. And the developer is a really cool guy called Marco, and he's an incredible developer, but he's also managed to implement this 80-20 with a paywall in the middle type of strategy really well. So check out the app and see how he implements these in-app purchases. Now, before we get started adding in-app purchases to our app, there are two things that you have to have before you can actually even run or test the code. First thing is you need a full Apple developer program, and you have to enroll on this program before you can start adding in-app purchases to your apps in Xcode and start testing them. So this means that you start paying them $99 per year, and ideally you are close to releasing your app. Now, the other requirement is that you have to have a physical iPhone device to test in-app purchases. Even if you write all of the code right, it just won't work on the simulator. And it doesn't tell you very explicitly that it's not working because you're running it on a simulator. So just be aware you need a full Apple developer account, and you need to have a physical iPhone device to test it on. It doesn't have to be the latest or the greatest, it just has to be one that can run and sideload your apps. So now let's check out what we'll build by the end of this module. So this is a really simple app which will display a table view of motivational quotes for the user. And they get 6 for free when they download the app for free. And then there's another 6, or however many you want to put in there, that are hidden behind the paywall. And they have to purchase an in-app purchase in order to view the rest of the quotes. So when they tap on buy, then there will be a pop-up and they'll have to enter their Apple ID and password, and once they've been charged, then you give them access to the rest of the content or whatever other content you want to give them. So in the process, we're going to be looking at how you restore in-app purchases, how you make purchases, and how you detect once they've been successful or if there are any errors. And so by the end of this module, you should understand how to implement in-app purchases for any future app that you decide to build, and be able to listen for when the purchase has gone through successfully so that you can enable the premium features in your app and give your users access to more of your app. Alright, so I hope you're as excited as I am about this tutorial. So once you're ready, head over to the next lesson and we'll get started. Alright, so first things first, go ahead and download the skeleton project called Inspo Quotes for this module from the giant course resources list. And once you've either git cloned or unzipped, then you should see this Xcode project. Now, if you want to create this stub by yourself, then that's perfectly fine as well. Just go ahead and create all of the features that we're going to talk about now. So firstly, I've got a table view controller that is linked to a class called quote table view controller.swift. That's that one there. And this contains prototype cells that are named quote cell. And it's also got a right bar button item that's called restore, and this is linked to my quote table view controller.swift file with an IB action called restore pressed, so that we can detect when that button gets pressed. Now, this entire table view controller is then embedded in a navigation controller, and this is our entrance point. And this is the only screen that we currently have for this app. Now, if you head over to the TableViewController.swift file, you can see that the class is called quoteTableViewController, and it's of UITableViewController class. And I've got one variable here called quotes_to_show that contains 6 quotes, which we're going to give the user for free. And then I've got a constant called premium quotes, which contains a further 6 quotes that we're going to expose to the user once they've successfully paid for the in-app purchase. I will explain a little bit shortly why this one's a var and this one's a let, so don't worry too much about that for now. Now, the rest of this file contains a whole bunch of code that you get for free whenever you create a new table view controller. So remember that you can create a new object of anything by simply hitting Command N and then creating a new CocoaTouch class, and then we just change the subclass to UI Table View Controller, renamed it Quote Table View Controller, and we get all of this slightly junky code for free. Now, I'm going to be deleting most of it, but I just wanted to show you this is what it looks like when you create a new UI Table View Controller from scratch. And finally, at the bottom, we've got that IB action that's linked to the restore button so that we can detect when it gets pressed. And that's all that I've done in the skeleton project. So if you want to save time, then go ahead and use my skeleton project. If you want to do it from scratch, then feel free to recreate everything that we've got here. And in the next lesson, we're going to get started setting up our account on the Apple website. So see you there. Alright, so once you've created your very own version of the skeleton project, or you've checked out the skeleton project that I created, then we're ready to get our in-app purchases set up with Apple. So we don't need Xcode for this step, so I'm just going to switch it to the background, and I'm going to go over to my browser, and we're going to head over to developer.apple.com/account in order to log in to the developer portal. Now, once you have logged in, this is the page that you should see, and here we're going to go over to certificates, IDs, and profiles, and you're going to go into identifiers and click on app IDs. Now, this is a table that lists all of your app IDs, and you can just go ahead and click the plus button to add a new one. So now it takes you through the process of registering a brand new app ID, and this will register your app on Apple's central database. So the name of our app is going to be called Inspo Quotes, and then we're going to make sure that explicit app ID is set here, and then we're going to set our bundle ID. Now, if you have a look back over to Xcode, you can see that this is the same as our bundle identifier in the Inspo Quotes, General tab, and Identity section. So I'm just simply going to copy this over to here. Now, remember, bundle IDs have to be unique on Apple's databases, so you won't be able to use this exact bundle ID. So I recommend using a reverse domain name. So if your domain is www.londonappbury.com, then com.londonappbury. Now, if you don't have a company that has a website, then you can just do com.your full name, so whatever it may be, making sure that you try to keep it as long as possible, because remember, it has to be unique, and then putting in the name of the app at the end. Now, it's really important that this matches exactly with what you've got here, so if it's easier, change it here, and then simply just copy and paste it into here, because all of the capitalizations matter a huge deal. Okay, so next thing is to scroll down to the App Services section, and you can see that the Game Center and in-app purchases services are ticked by default. Basically, whenever you create a new app ID, they will automatically include these two capabilities to your app. So we don't even have to do anything, and we just have to click Continue. And now all you have to do is click Register, and then click done. Now, don't worry if these green lights aren't switched on when you're clicking on register and done. They take a little while to come on, and you can view it at a later date and you'll see it switch on after you've clicked done. So this information is going to propagate through Apple's servers and databases. So while it does that, let's do a couple of checks to make sure that we have as smooth a ride as possible. Now, first of all, if you've published any apps onto the App Store, then you'll know all about App Store Connect. This is the place where you put in all of the details for your app and push it onto the App Store. Now, if you've never published an app and this is the first time, then I'll take you through it step by step. So first things first, head over to appstoreconnect.apple.com and then go ahead and just log in. Now, once you're in, this is what you should see. There's a whole bunch of icons, and most importantly, at this stage, we want to make sure that up at the top here, you don't see any red text. So usually if there's something that you need to sign or you need to check or you need to read, Apple will routinely on a weekly basis, it seems, update their contracts and legals and a whole bunch of things. And you just need to make sure that you've made all of those go away by signing the things that you need to sign, okaying the things you need to okay, and checking the things that they want you to read. So another good place to check while you're here is to head over to Agreements, Tax and Banking. So this icon over here. Now, if you haven't set up your Agreements, Tax and Banking, then it might say something like Request Contracts. And you'll have to click the Request button and fill out all of the information and submit it. And it might take some time for the agreements to be processed by Apple. So even after you submit it, during the time before it gets approved, you won't be able to test your in-app purchase products. So if you see any buttons under the Agreement, Tax and Banking that says Request, make sure you fill it all out and submit it. And at the point when you see Paid Applications as a contract type under the contracts in effect, then you are good to go. And that is when you've made sure that all your agreements, tax and banking is all in tip-top condition with Apple. And you can go ahead and click done. Now, the final thing to make sure is that when you head over to developer.apple.com, make sure that they haven't got any pop-ups for you that says, accept the latest Apple Development Program license agreements. But if you do have any agreements that you need to sign or read on developer.apple.com, it will usually also show up at the top of App Store Connect. So making sure that you don't have any red boxes over here is a pretty surefire way of knowing that you are good in the eyes of Apple, which obviously is very, very important if we want to make in-app purchases work. So now that we've dillied and dallied around here, hopefully all of our information when we registered our app ID has now been propagated through Apple services, and we are ready to create a brand new app. So again, inside App Store Connect, go ahead and click on My Apps. And once you're here, just go ahead and click the plus button to create a new app. Now, we're going to fill out this form to create our brand new app. And don't worry, nothing's going to be released or put onto the App Store without you being able to okay it. So just go ahead and select iOS for your platform. Now, the name of the app for me is going to be Inspo Quotes. Now, you won't be able to have the same name that I've got, because they have to be unique across the App Store. So if you want to call it something around Inspo Quotes, just add your initials or add, your birthday or a special number or something until this form actually lets you submit. Next thing is to choose your primary language, which is going to be English. And then we're going to leave bundle ID until the last. The next thing is the SKU, which stands for Stock Keeping Unit. So this is a unique ID that you give to your apps so that you can identify it amongst your app catalog. Now, in our case, we tend to prefix it with Lab, London Appbury, and then we'll just list the app number that it is. This last one, Limit User Access, we're going to keep it blank. And finally, we're ready to go ahead and click the drop-down list for our bundle ID. Now, as I said before, it takes a little bit of time for the data that you entered previously when you created a new app ID to propagate through Apple servers. So if you don't see that bundle ID show up here, then just wait a little bit, get a cup of tea, eat some biscuits. I really like ginger biscuits. but you can eat obviously any biscuits you want. I don't know why I felt the need to tell you this. Once you come back, after a little while, then you should be able to see the bundle identifier that you inputted previously, which in my case was com.londonatbreed.inspo quotes. And in the front, you've got the name of the app. So select that into the bundle ID, and we're ready to create our brand new app. So now you get onto the app information and your listing details page, and this is where when you publish your app, you're going to add your title, subtitle, your information, like which category should it go in, or what should be the price of the app that you're going to set, and also uploading your Xcode project to it. But for now, we're just interested in testing in-app purchases. So you're going to head over to the Features tab over here, and you're going to be inside in-app purchases. And we're going to click on the plus sign to create a new in-app purchase. Now, you can see here that there's several options that you have. And Apple gives you really good examples of when you would use each. So the 4 types are consumable, so an in-app purchase that gets used once, and after which it gets depleted and you have to purchase it again. So for example, if you had a fishing app and you had fish food that you need to lure the fish, then this will be consumed every time they use it. Commonly, this is used inside games when you need extra in-game currency, coins or energy or whatever that may be. Now the next one is non-consumable. So this is something that gets purchased once and does not expire or decrease with use. So for example, this would be, say if you had a app that had ads and you charged the user 99 cents to get rid of the ads, this would be a non-consumable in-app purchase, because once they've gotten rid of the ads, you shouldn't ask them to buy it again to get rid of the ads, right? That would be really, really bad. So the third one is a auto-renewable subscription. And this, for example, could be Spotify, right? If they were charging it through the in-app purchases, then they could charge you $10 a month to continue to get access to their music catalog. And this would auto-renew every month or every week or whatever it is that you set. And the final one is something that very few people use, which is a non-renewing subscription. So this, for example, gives you a 1-year subscription where you're charged every single month, but after that, it doesn't renew automatically. So in our case, we're going to choose a non-consumable in-app purchase because we want to be able to give users access to the premium quotes that's locked behind the paywall, and they only have to pay once in order to get access to the rest of the content of the app. So this is one of the most frequently used in-app purchase types, and we're going to go ahead and click create. So now we have to enter a little bit of information for our brand new in-app purchase. Now the first thing is a reference name, and this is just a name for you to be able to identify it on App Store Connect. It doesn't appear anywhere in the app, and in our case, we're just going to call it Premium Quotes, just to make it really clear. Now, the product ID is really, really essential. The product ID is going to be your bundle ID. So whatever you had in here that you also gave to your app, and then at the end, I usually just tag a dot and then the name of my in-app purchase. So in this case, it'll be Premium Quotes without a space in between. Now, you can capitalize it or not capitalize it any way you wish, but make sure that you copy and save this string somewhere, because we're going to be using it in order to test and implement our in-app purchase a little bit later on, because we're going to say inside our app that we're going to point towards this product ID, and that is the one that we're going to try and get the user to purchase. And once it's been purchased successfully, then we show them the premium quotes. All right, so next is pricing. So you have to choose a pricing tier, and it goes all the way up to $1,000 or £1,000, but in this case we're just going to choose tier 1, which is 99 cents or 99p, as currently I'm registered in the UK App Store. Now the next part, if you scroll down, is the localizations, and this is the name that the user will see when they view the in-app purchases of your app on the App Store. So you want to give it a name that makes sense to them. So if you want, you can also use premium quotes, because that kind of makes sense for us. And for the description, I'm also going to just write premium quotes because it saves a little bit of time. Now, when you're actually doing this for your actual app, then you might want to put a little bit of thought to what you want to tell the user about this in-app purchase. You know, maybe give them a little bit of sales pitch. Now, if you want to add other localizations, so for example, users on the Chinese App Store, what they should see, because say if they can't understand the English very well, then they'll be confused about the in-app purchases, then you can add as many localizations as you wish. So for our purposes, we're just going to have the one. Yours might say English US if your native store is the US. Mine says UK. It doesn't really matter, as long as you provide the name and description of a single localization as a default. Now, this is where you can put an image for your in-app purchase, again, a little bit later on, but it's optional, so we're going to skip it. And finally, this is the last part, which requires a screenshot of your in-app purchase in action. Now, we haven't implemented it, so we're just going to skip it and click Save. Now, because we've entered and filled out all of the fields that need to be filled in, then it'll allow us to do this, but it'll give you this little warning saying missing metadata. And that refers to this section here, so that when you're ready to submit your app to publish, you should add a screenshot of your in-app purchase being triggered in your app, and I'm going to show you what that will look like just a little bit later on. But as far as we're concerned, we're completely ready to get going and start writing some code and testing our app. So in the next lesson, we're going to get started creating our Inspo Quotes app, and once you're done over here, I'll see you on the next lesson. Alright, so now that we're all done with App Store Connect, it's time to head back into Xcode. And first things first, just check to make sure that your bundle identifier here is exactly the same one that you used when you created your app ID. And you should be able to see that on your developer.apple.com/account under the app IDs here. So once you've checked that, the next thing is to give that capability to your Xcode project. So having the Inspo Quotes app selected, go into the Capabilities tab, and we're going to switch on in-app purchases, which is over here. So we can just toggle this switch to on, and Xcode is going to do some magic behind the scenes, and once all the checkboxes are ticked, then we are ready to go. Now, if at this point you don't actually see an in-app purchase listing under the Capabilities tab, then just quickly check to make sure that when you go to Xcode Preferences and when you go to Accounts, that you've actually got the same account that you used to set up the app ID as the one that you've got logged in to Xcode. So remember that if it's a paid developer account, the role should say something like agent and not user. And again, also checking under the General tab, make sure that you've got that team which has that same developer account checked as the team for your project. And then coming back to Capabilities and trying to find that in-app purchases. So if you have multiple Apple IDs, it can get a little bit confusing. So just double check that you are logged in using the same developer Apple ID inside Xcode. So after all of those checks and balances, next step, we are ready to actually write some code. So if you have a look inside main.storyboard, we've got this table view that is going to be used to list our quotes. And our first job of the day is to show each of these quotes inside a separate cell in our table view. So I'm going to go ahead and firstly delete all of these comments that Apple has added inside view.load. And the next thing is I'm going to edit our table view data source, which is under this pragma mark here. So we're only going to have one section in our app, so I'm just going to delete this number of sections data source method. But the next one we will need, because this specifies the number of rows in section. So this all should be very familiar to you, given that you've done ToDoey and FlashChat. And if you haven't, I strongly recommend that you complete it, because table views are a big topic, and I'm not going to go into it in detail here because we've already spoken about it in excruciating detail on the previous tutorials. So I'm just going to go ahead and set this as a challenge for you. Given that you have this variable called quotes to show, which is an array that contains 6 strings, so 6 quotes, I want you to be able to set up the table view so that you see all 6 of these quotes inside the table view. Now, just ahead of time, just to mention, some of these are very long, and if they don't fit in the cell, don't worry. We're going to fix that very shortly, but just make sure that you can write some code that makes your table view display 6 cells, and each cell should have one of these quotes. So pause the video now and complete that challenge. Alright, so first things first, we know that the number of rows we want is 6 because we have 6 quotes. Now, we're not going to put that in by hard coding a number 6 here because that's very, very inflexible. Instead, we want to give it as a dynamic number by calculating the count of this variable quotes to show. So instead of returning 0 here, we're going to return quotes to show dot count. And I'm going to delete this warning comment here, just to clear things up a little bit. Okay, so now we're going to have a table view with 6 blank cells with this line of code. The next thing is to specify what is the data that should go into each of those cells. So I'm going to uncomment this template code that Apple has included in here, which is the table view cell for row at index path method. And this is the one that actually populates the cells. So firstly, we create a reusable cell with an identifier. And remember that the identifier I gave the prototype cells, and check what you gave your prototype cell if you created this from scratch, is over here under the attribute inspector. So I had a quote cell, and I'm just going to copy and paste that into here as the reuse identifier. So I'm going to create a whole bunch of cells reusing that prototype cell called quote cell, and then I'm going to configure the cell where it tells me to configure the cell. So firstly, I want to change the cell's text label dot text property to the text that we've got in our quotes to show variable. So it's going to be equal to quotes to show, and I'm going to pull out the item at the index of the current row. So I grab that by using indexPath.row, and because we've done this millions of times, this shouldn't be hard at all. So now let's go ahead and hit run. And I'm just going to launch that on the simulator because we're not yet testing the in-app purchase part, so it doesn't really matter where we do it. All right, brilliant. So here's our Inspo Quotes app, and it's now got 6 cells, each with a quote from over here in this array. Now, as I mentioned before, each cell can only take 1 line of text at the moment, and it's truncating each of these quotes because they're longer than what can be fitted into each cell. So how can we fix this? Well, normally, when we create a label that we want to have multiple lines of text, then we can set a property called number of lines. And we can do the same with this text label because at the end of the day, it's just a label, right? So if you take a look at UI label, then you can see it's got all of these attributes, or what we call properties. And one of this is number of lines. And it specifies the maximum number of lines the label will use to render the text. And you can set it to 0 to use as many lines as required. So that's the property that we're going to be changing. So let's close down this documentation, and then we're going to say cell.textLabel.number of lines is equal to 0. And now if we run our app again, everything is taking up as many lines as it needs to in order to display. So for example, this one is taking up 3 lines, this one's taking up 2, and nothing is cut off anymore. So brilliant. The basic functionality of our app is already there, and I've kept it really simple in terms of the styling and all of the other fancy, flashy parts. I've tried to resist adding them in because I just want us to be able to really understand what's going on with the in-app purchasing code. So hopefully at this point, all of the code that we've written is very simple and you understand it completely. If you don't, please take a look at the Flash Chat module or the To-Do module where we talk about table views and all of these delegate methods in more detail. Ideally, I want you to be really comfortable with all of this code and you should be able to type it blindfolded before we proceed. So if there's any reviewing you need to do, go ahead and do that now. But otherwise, in the next lesson, we're going to get started adding in the in-app purchasing code. So I'll see you over there. Alright, so now that we've added the basic functionality to our app, which is simply displaying some text from array into a table view, the next step is to set it up so that we can start making some in-app purchases. Now, in order to do that, I'm going to add a cell at the very bottom of all of our quotes that says buy more quotes. And when I click on that cell, it's going to trigger the in-app purchasing process. So first things first, currently we're only loading up 6 cells because we're looking at quotes to show and we're looking at the count, which is 6. Now, if we want to add that extra cell, then all we have to do is just add 1. And now we'll always have 1 extra cell on top of all the cells we need to show the quotes. So now that we have 7 cells, but we only have data for 6 of them. So what we can do here is we can add an if statement that checks if the index path.row of the cell that we're trying to render the content for is less than quotes to show dot count, then we're going to populate it with text from the array that's quotes to show. But if it's greater than that number, namely if we've hit that last cell where index path is equal to 6, so remember we start counting from 0, so this one has an index path.row of 0, 1, 2, 3, 4, 5, 6. And that one is going to have a special cell text. So cell.textlabel.text is going to equal get more quotes. And this is going to be our main buy button. So in order to show that it's different from the rest of these cells, we're going to change its text color. So cell.textlabel.text color equals a blue color. And we're going to use a color literal here. So if you start typing color, and you can see you've got color literal being suggested, go ahead and double click on it, and you'll get a little square. And now if you double click on the square, we get a color picker, including our recently used colors. So I'm going to stick to the color that I've got in the theme of this app, which is that kind of green, bluey, turquoise color. I'm not very good at describing colors, but that one. And you can, of course, choose whatever it is that you wish, but make sure that it's visible. And then we're going to change the cell's accessory type to something called a disclosure indicator. And this has a control shaped like a chevron, so like a little right angle bracket, and this control indicates the user that tapping the cell triggers an action. So that means that we can use this to indicate to the user that you can actually press on the cell and something will happen. So let's go ahead and run our app and see what that looks like so far. So we currently have 6 quotes, and the very last cell is this button that says get more quotes with our little disclosure indicator and our text color being the same as this one, which looks pretty neat, I think. Alright, so now that we're done with that, the next step is to detect a touch on that cell. So I'm going to go ahead and delete all of the rest of this comment and template code that Apple gave us because it's not very useful, and we're going to write it ourselves. So currently we've got a pragma markup here, that's the table view data source method, and I'm just going to copy it and create another one down here, which are going to be the table view delegate methods. And one of the main delegate methods that we use all the time is, of course, table view did select row at index path. And you can see that you've got two methods being suggested, and they look pretty much identical on here. Now, they are actually not identical, because if I hit enter on the top one, you can see that I get a normal function being auto-suggested here. And I will also get an error saying that I need to put the override keyword. Now, whereas if I chose the one that is the second one in that list, then I get that override keyword for free. Now, if you remember, the reason why we need that override keyword is because we're inheriting from UI table view controller. And that class already has the method table view did select row at index path. And we're overriding its functionality to provide our own functionality. So this is the line of code that we need. So inside here, we're going to check to see if the row that was selected has a index path dot row of the last item in this table view. So that is again going to be number 6, because 0, 1, 2, 3, 4, 5, 6. And that is going to be equal to the number of quotes to show. So if index path dot row is equal to quotes to show dot count, then in that case, we're pretty certain that this button got pressed, and then we're going to do something special. Before we do anything special, let's just check to make sure it works. Let's write print by quotes clicked, and let's hit run. And now if I click on this one, you can see by quotes clicked. Perfect. So it's now working. If this line of code is at all confusing to you and why we're using quotes to show dot count, then make sure that you haven't skipped any of the lectures before and that you have completed all of the previous modules before you got to this current module. I know that it's really tempting to just go straight for the one that you really need right now, but without understanding everything, it's very difficult to implement this into your own app. So I recommend going through all of the modules in the order that they are in the curriculum. It's really important. I can't stress enough that you don't skip the modules. Okay, either way, we've now determined that the last button got clicked and we can delete this print statement. And now this is the place where we are going to implement the buying of our in-app purchase. So I'm going to call a method called buy premium quotes. And this method doesn't yet exist. So let's go ahead and create it down here. Now, in order to create it, I'm going to create a new section. So I'm going to create a new pragma mark, and this one is going to be called the in-app purchase methods. And here I'm going to create that function called buy premium quotes. And let's just make sure that we've spelt it right by checking to see that this actually changes color and we don't get any errors by hitting Command B to just force a build and compile of our code to make sure that everything is working. Okay, so now when the user clicks on this button, then this part triggers and this function will get called. Now there's just one slight problem here, and that's when you press on this button, the cell does not get deselected automatically. And it looks a bit weird because normally when you click on a cell, it should turn grey and then quickly turn back to white. That looks a lot better than having it permanently selected. And we can of course get rid of that by simply adding a line of code that says table view dot deselect row at index path, and that's of course the current index path, animated true. And now when we select that cell, it will deselect itself automatically with a quick animation, and that just makes it so much nicer in terms of the user experience. Okay, so in this lesson, we have set up our cell that has the text of get more quotes. We've changed its color and disclosure indicator to make it look like it's clickable. And we've also got a delegate method that gets triggered when it gets pressed, and we're using it to trigger a function called buy premium quotes so that we can start processing their in-app purchases. Now, in the next lesson, we're going to be looking at StoreKit and the StoreKit API in order to query the Apple databases and implement the code to buy our premium quotes in-app purchase. So for all of that and more, I will see you on the next lesson. Alright, so now that we've created the delegate method for our table view so that we can detect when the user presses that last row that gets more quotes, we can call our function called buy premium quotes. And it's in this function that we're going to trigger the in-app purchase. So first of all, we're going to create a new constant that is going to be called our product ID. And that ID is the same as the ID that we put into App Store Connect. Under Features, In-App Purchases, we've got that product called Premium Quotes, and this is the product ID that we want. So I'm just going to copy it over to our code here, and I'm going to put it in just as a simple string. Now, this is the ID that we're going to use to hit up the Apple App Store to tell it what we want to buy, and so that the user gets charged the right amount, namely whatever it is that we've put in here, and that they can purchase, and that the funds go towards ourselves as our developer account. So now that we've got what we want to purchase, how are we going to purchase it? Well, in order to implement in-app purchases, the framework that we're going to be using is something called StoreKit. And StoreKit has all of the functionality that we'll need to implement in-app purchases for virtual products. So once we've added StoreKit, then we'll be able to tap into all of its functions and attributes. So inside our buy premium quotes function, the first thing we need to check is whether if the user can actually make a purchase. Because if they're on a phone that has parental controls enabled, then we won't be able to get them to make any sort of in-app purchases. And this is the way that Apple tries to keep your kids from running up the credit card bill and buying thousands of dollars worth of in-app purchases in Clash of Clans, for example. So the way to check for that is something called SK Payment Queue. And this is the queue of payment transactions to be processed by the App Store. And it has a method called canMakePayments. And this method returns a Boolean, so true or false, as to whether if the user is allowed to make payments. And that's exactly what we need to know. So if this returns true, then in that case, the user can make payments. And if it returns false, or rather else, then can't make payments. So it's a good idea while we're testing our app to just put in a print statement that says user can't make payments. There we go. But if they can make payments, then we can go ahead and trigger the next step of our in-app purchase request, which is to create a new request. So we're going to use a let to create a constant called payment request. And this is going to be a new object created from the class called SK Mutable Payment, which is a mutable request to the App Store to process payment for additional functionality, namely an in-app purchase. So this is where we're creating a new in-app purchase request, basically. And we're going to specify that this payment request is for the product with product identifier of whatever it is that we had up here, which is saved under this constant called product ID. So we're saying that we're making a request to purchase a new in-app purchase, and the product that we want is the one that has the product ID that we've specified. And finally, we tap into that SK payment queue again, and we grab the default payment queue, and we add this payment request to the queue. So payment request goes in there, and that's it. That's all the code that we need in order to implement our in-app purchase. Now, this is not the end of the tutorial, however, because we still need to figure out how we can detect when a payment has been successful, so that we know that we can give them access to the extra information, or that when a payment has failed, so that we don't accidentally give them access to all of our premium features, even though they haven't paid for it. So in order to do that, we need to read a little bit about this payment business. So if you hold down Alt and click on SK Payment Queue, there's a quick doc of how this all works. So the summary is that this is a queue of payment transactions to be processed by the App Store. So of course you can add multiple payment requests to this queue. So you can purchase, 5 in-app purchases in the same go if you wanted to. And the discussion part says that the payment queue communicates with the App Store and presents the user a user interface, so a pop-up, so that they can enter their password and authorize the payment. Now, to process a payment, first add at least one observer object, which is called SK Payment Transaction Observer, to the queue. And then add a payment object, which is what we've done here, for the item that the user wants to purchase. And after the payment is fulfilled, the queue updates the transaction object and then calls the observer so that it tells us that the transaction has been updated and whether if it failed or succeeded. So the next thing that we need to implement is this SK Payment Transaction Observer. And this has a delegate method. So we have to add the protocol of SK Payment Transaction Observer, which contains a set of methods that processes transactions, unlocks purchase functionality, and continue promoted in-app purchases. So that basically means that when we add this observer, then once the payment goes through and the user types in their username and password for the App Store and it was successful, then we'll get a message back telling us that it was successful, or if it failed, then we'll get a message saying that it failed, or a whole bunch of other things. So as soon as I add this protocol, you can see we get an error, and it says that in order to conform to this protocol, you have to add the delegate method. So let's get it to add it automatically. And the only delegate method that's required is this one, which is payment queue updated transactions. So this delegate method will inform us when the transactions have been updated in the payment queue. So let's move this down a little bit to the part where we've got our in-app purchase methods. And we're going to put it over here. And I'm going to just delete this placeholder that says code. Now, remember that whenever you add a new protocol and you want to use a delegate method, you have to declare a class as the delegate. So we want to declare this current class, the quote table view controller, as the delegate who's going to receive the messages from the SK Payment Transaction Observer when the transaction status changes. So inside view.did_load, we're going to add ourselves as the delegate. And the code for this is simply SK Payment Queue.default, which is the default queue that we're using to process our payment request, .add. And this adds an observer. So notice that when I write .add, there's actually two methods that this object has. One is add an observer, and the other one is add the payment to be processed. Now, the only difference they have is the names of the parameters. And in Swift, this is perfectly legal. You can have the same method name, but as long as the parameter names for the methods are different, then they are treated as completely separate methods. So if you're coming from other programming languages, for example, C or C++, this should be familiar to you as well. So the one that we want is to add an observer. And this takes an object that is a SK Payment Transaction Observer. And by declaring ourselves as conforming to this protocol and implementing the required delegate method, then we are qualified to set ourselves, or this current class, as the observer. So now, whenever any changes happens to the payment transactions, it's going to contact our quote table view controller, and it's going to try and find this delegate method to trigger an update. Now, if you alt-click on this payment queue function, or search for it in Google or Stack Overflow or Apple Docs, you can see that we have a summary which tells an observer, which is this current class, that one or more transactions have been updated. So it gets triggered every single time the transaction status changes. But not only that, the application should process each transaction by examining the transaction's transaction state property. So this is the transactions that we get back, and it has a property apparently called transaction state. And if we click on transaction state, it tells us there's a whole bunch of transaction states we can get back. Namely, one is purchasing, being purchased by the App Store, purchased, so successfully processed payment, the money's going to hit your developer account and you are ready to release the premium product, failed, so the transaction failed and you can check the error property to see what happened, or restored, which is where, say, if a user buys a new phone and they download the apps all over again, they want to be able to restore the previous in-app purchases that they've made. So we're going to check for each of these cases in the transaction state inside this delegate method. Now, remember previously I said that the payment queue can contain any number of transactions. So if you were to purchase 3 in-app purchases all in one go, then all the transactions will get piled into this array of SK payment transactions. So in order to check each of these transactions, we're going to have to loop through it. So we're going to say for transaction in transactions, and that transactions comes from here. This one is just the variable we're creating to loop through these transactions. And for every transaction in all of the array of transactions, we're going to check if the current transaction that we're looping through dot transaction state is equal to dot purchased. And that means that it was a successful purchase. So user payment successful. Now, else if the transaction dot transaction state was actually something like dot failed, then in that case, something bad happened and payment failed. Now, this can also include if they clicked the cancel button and they didn't want to go ahead with the payment anymore. So now we have 2 if statements, one when it's successful and one when the transaction failed. So let's go ahead and add a print statement to show in the console when we test our app which case it is. So print transaction successful, print transaction failed. So now we're ready to test our in-app purchases. And remember what I said before, that you have to test it on a physical iPhone or iPad device. It can't be in the simulator. It doesn't work. And it won't tell you that it's not working or give you any logical errors. You just have to know that you have to use a physical device. Now, the other problem is that I've set this in-app purchase for my premium quotes to be 99 cents. And I don't really want to pay 99 cents every single time I want to test my app, right? So I don't want to use my normal Apple ID. So what's the workaround? Well, we can create a sandbox user that's just for testing these payments. So in the next lesson, that's exactly what we're going to be doing. And we're going to be testing our app and seeing whether it worked. Now, in the last lesson, we've written the code that's required to trigger a payment request in the payment queue to the Apple App Store. And we've specified the product that we want to purchase, or the user wants to purchase. And we set up this payment queue updated transactions delegate method, which observes for any changes in the payment queue and lets us know when a transaction is purchased and successful or when it's failed. So now we are going to create a sandbox user in order to test this without having to pay every single time we test it. So let's go into, again, App Store Connect, and we're going to go to Users and Roles here. So just click on this drop-down list to head over there. And if you head over to Sandbox Testers, then you can create some new testers by clicking on this plus button. Now, rather awkwardly, Apple actually enforces very strong data validation in this sandbox user creation, and I really wish they didn't, because often I'm forced to create 10 or 20 of these users, and for every single one of them you have to fill out pretty much every single field. So it doesn't really matter what you give the first name or the last name. I usually just write something like test, but the email has to be unique, and it has to be a real email, which is quite difficult if you're not a professional spammer. How would you have access to even 10 emails that you own? So here's a trick. If you have a Gmail address that is, say, angela@gmail.com, this unfortunately is not my email because I wasn't there fast enough. Need to be an earlier adopter. But if, say, this was your email, then Gmail actually has a really neat thing called address alias. And what it allows you to do is just before the @ sign, you can add a plus, and you can write some things like newsletter, right? And you can use this email for all of the newsletters that you sign up to, and you can filter on this incoming email address in your Gmail inbox. But even though it looks a little bit weird, it still goes to your email address, your inbox. So angela@gmail.com's inbox in this case. Now, what I often like to do is sometimes when I sign up to something that I'm not really that sure about, say if I sign up to American Express, right? I will actually sign up with my email plus the address that I signed up to at gmail.com. And this is a really easy way to know which businesses are selling your emails for money and to just protest. But this is a really neat trick, and this is helpful in our case because now you have an infinite variety of unique email addresses. So you can just keep creating new aliases for every single one of your testers. Now, there's just one caveat. The main email for your email alias cannot already belong to an Apple ID. So say if you sign up to your Apple ID with this email address, you can't use an alias on it. It doesn't work. But if you haven't used this email, this Gmail address for any Apple IDs, then you can do this quite easily. Now, another option, if you don't have many emails that you can use for your sandbox testers, is to use something like maildrop.cc. And this allows you to just generate a random mailbox, and it will be able to receive messages, and you'll be able to verify the account, but you obviously don't monitor it, and it doesn't have a painful creation process. But what it does mean, though, is that it is a public account. So if you go to some of the ones that somebody might already used, say john@maildrop.cc, then you can see that this has all of the stuff that they've previously signed up to, and there's a lot of spam in here, right? So if you use any of these accounts on maildrop.cc, remember that it's completely public. Do not sign up for anything that has your private details in it using this service. But if you're using it for just testing, then it doesn't really matter because there's nothing sensitive that's going to be sent to it. So in my case, I'm just going to generate a new email address on our website domain that is called tester134@londonappbrewery.com. And the password, rather awkwardly, also has very strict security rules. So you need one capital letter and some numbers, and it needs to be quite long. So come up with some sort of combination for that. And the secret question and secret answer, you can take it very seriously if you want to, but I tend to just write tester Q, tester A, because it has to be more than 6 characters or something like that. And date of birth, of course, just some random numbers. And App Store territory, you should choose the App Store that your testing device is currently signed into. So for example, I live in the UK, so my app store, my native app store that my testing device is normally set to is the UK territory. So I'll go and find United Kingdom and add that in there. If your device is normally signed into United States territory, then be sure to select that. And once you're done, go ahead and click save, and you'll have this brand new sandbox user ready to go. So now we are ready to run our app onto our physical device, which is the phone. And we're going to make sure that the team is selected so that it will sideload. And I'm going to plug in my phone through USB, and I'm going to select my device as the destination and run this app. So now while the app is running, I'm going to click on the home button and I'm going to go into settings. And inside settings, I'm going to scroll down to iTunes and App Store. And I'm going to scroll all the way down to the bottom where it says Sandbox account. And here I'm going to click on it and sign out of any previous Sandbox accounts you've got going on. And I'm going to sign in with that new user that I just created. He was called Tester134 at londonappbrewery.com. And I'm going to enter the password of that user that I set up just now and click sign in. So now my Sandbox account is showing that my Tester134 is now signed in, and I'm going to go ahead and relaunch that app in Spoke Quotes. Now you can rerun it from Xcode, but as long as you haven't force quit the app, this is still a active session. So now if I click on get more quotes, then you can see I get this pop-up, enter your password to confirm your in-app purchase of 1 premium quote for 99p. So I'm going to enter my password for my test user, and I'm going to click buy. And now we wait for a little bit, and you can see that I get a pop-up that says you are all set, your purchase was successful in the app, and in the debug console I get that print statement, transaction successful, which means that if you look inside Quote Table View Controller, the part where that transaction successful gets printed is inside this if statement. If transaction state is equal to purchased, so a successful transaction, then print this. So now you can see that we can change the code inside this block to give the user whatever it is that they paid for, extra coins, extra fish, extra quotes in this case. Then we can implement that right here. So hey, it's actually working. Now, there's just one thing to remember, that if you make a purchase that's been successful with a Sandbox user, that user won't be able to make the same purchase again if your in-app purchase is a non-consumable product. So remember that when we created our in-app purchase of premium quotes, we created it as a non-consumable product because the user shouldn't need to buy it multiple times. They should only pay once to get rid of the ads or pay once to get the extra quotes and never again. And the way that Apple implements it is that your Sandbox users can only purchase a non-consumable product once in their whole lifetime. They can restore purchases that they've bought before, but they can't keep buying the same non-consumable product. So this is why you end up creating loads and loads of test users and Sandbox accounts. And this is also why you need some alternative emails in order to do this. So now we have written the code that implements the basic functionality of creating a new payment request and adding it to the payment queue to ask the user for their password and to purchase that in-app purchase. And we've got this delegate method that listens for when that's successful and when it's not. And we've created a Sandbox user that can allow us to test these payments without having to cough up, and we can activate blocks of our code when the transaction is successful or when the transaction has failed. Now, once the payments have been successful or they have failed, we need to end our transaction so we're not still holding on to the same transaction. So inside the if statement, when our transaction has completed, we're going to write skpaymentqueue.defaultqueue.finish transaction. And the transaction that we want to terminate is the current transaction that is in question. And we're going to copy that code over to here as well. And finally, even though we are checking to see if there was an error, we're not actually being very explicit with what the error was. And with SK Payment Queue and StoreKit, we can actually get a really accurate description of what the error was, so it can guide our debugging if we do get any problems. So let's use optional binding to say if let error equal transaction dot error. So if there was an error, if it's not nil, then let error description equal error dot localized description. So instead of just printing transaction failed, I'm going to move that down here, and we're going to print transaction failed due to error, and I'm going to insert that error description into here. So now that's a little bit more comprehensive, and that will be really useful when we do have some payment issues that we're testing. So that, in a nutshell, is how you implement in-app purchases. In the next lesson, we're going to enable the user to be able to access the rest of the premium quotes in addition to the free quotes after the purchase has been successful. So for all of that and more, I'll see you on the next lesson. Now, in the last lesson, we looked at how we can implement in-app purchases and how we can test it using sandbox users. Now, in this lesson, we're going to enable the user to access whatever it is that they purchased, namely the premium quotes, once we get a successful transaction reported back to us from the payment queue. So in order to do that, we're going to add a method here that calls show premium quotes. And then I'm going to create it down here. Function show premium quotes. And that error should go away now. Now, how do we show premium quotes? Well, currently they have access to these quotes, and we want them to have access to these quotes in addition. So we can append this array, quotes to show, with the quotes inside the premium quotes, so that we add all of these quotes to this array, and we render all of that in our table view. And that is why quotes to show is a variable and premium quotes is a constant. So let's go ahead and do that inside here. So once the transaction is successful, we're going to trigger show premium quotes, and we're going to find the array that is quotes to show, and we're going to append, not a new element, because that takes a single string, so that's like adding just one string item to the end of the array, but this one, append contents of sequence. So this allows us to tag on the contents of our premium quotes array into the quotes to show array. So let's go ahead and hit enter, and the content that we want to tag on is called premium quotes. And this line of code will add all of these quotes to the end of all of these quotes. And now we have a giant quotes to show that we're going to render in the table view. So because our table view is already calculating how many cells to show based off this dynamic variable, the number of items inside quotes to show, which now equals to 12, then we don't actually have to change any of this code, nor this code, because it's also rendering all of the items inside quotes to show based off the current index path.row that needs it. But what we do need to do is to call reload data on our table view, so that these two methods get triggered again, and that we get the updated data and the updated number of cells rendered. So now let's test it on our app. Now remember that because we've bought this product with our last sandbox user, we're going to have to use a new sandbox user. So I'm going to go into settings, and again iTunes and App Store, and I'm going to sign out of my previous tester, and I'm going to sign in with a new tester who hasn't bought this item before. And now I'm going to run the app again, and I'm going to click on get more quotes. And I'm going to enter that password for that sandbox user once more. And now I get the confirmation that my transaction was successful, and I've got all of the rest of the quotes. Now, at this point, you might notice that there's something a little bit weird. Why is it that every so often you see some of these cells becomes lightly blue colored and they have the disclosure indicator on it, like the one that we implemented for the very last cell? Well, the reason is because our cells are getting reused. So every time I push the cells off the table view, they come back at the bottom. And equally, when I scroll them down off the table view, they come back at the top. So in order for this to not happen, we have to explicitly set the cells that are meant to be normal quote cells to have a black text color. So cell.textLabel.text color is equal to a color literal that is just going to be black. And the cell should have an accessory type of none. So remove all of its accessory types. And now if we rerun our app and click Get More Quotes, enter our password, then we'll restore the items that we bought before. And now you can see it doesn't do that anymore. The parts that are meant to be black are black, and the part that's meant to be blue is blue. Now, the next thing we need to address is when a user opens up the app, we should check to see if they've already purchased the in-app purchase, in which case we'll show them the premium content, or if they haven't yet purchased it, then we'll keep it exactly the same as before. Now, in order to keep hold of that data, of whether if they purchased the in-app purchase or not, then we can use our user defaults that we learnt about in the To-Do module. Now, in order to do this, whenever a successful transaction goes through, in addition to showing the premium quotes and ending the transaction, I'm also going to tap into the user defaults.standard object, and I'm going to set a Boolean. So in this case, the value is a Boolean for a key. And the Boolean is going to be true because the key is going to be our in-app purchase. So the key is going to be this product ID here that relates to the item that they purchased, namely premium quotes. So at a later date, I want to be able to tap into the user defaults and use my key of my product ID and check to see whether if that product was purchased or not. So now that we've set that user default, we can now create a function called isPurchased. And this function is simply going to return a Boolean, so a true or false. And we're going to use this function whenever we need to check whether if the user has purchased the premium quotes or not. So let's say let purchase status equals user defaults dot standard dot bool for key. So we grab the Boolean for the key that is our product ID to check to see if they purchased it or not. If this went through successfully once at some point in the lifetime of using our app, then this Boolean will be true. And we can now use this purchase status to check if purchase status is true. So you can either say is equal to true, or the shorter way, then we can simply just say if purchase status is true, then we can print previously purchased. And we can also return true for this method of is purchased. Now else, i.e. if it wasn't ever purchased, then we'll print never purchased and we will return false. So now we have this method in order to check whether if the user has purchased this set of premium quotes or not. So in our viewDidLoad, we can already call this method. We can say if is purchased is true, then in that case, we're going to straight away show premium quotes. And that means that whenever the user launches the app, say if they force quit it before, or the app was closed and shut down, then whenever they open up the app and view did load gets called, we'll check to see if they've already purchased the premium quotes, and if they have, we'll straight away show them the premium quotes. So let's again test this in our app. So even though previously we have successfully purchased this in-app purchase, because we didn't set that user default last time, we need to set it now. So you'll need to go into Settings, iTunes and App Store, and again, get a new ID for your Sandbox account, and log in to that new ID, the person who's never bought your in-app purchase. So in my case, it's tester2@lab.com, and I'll just enter the password and hit sign in. So now that I'm signed in, I'm going to go back into my app and click Get More Quotes to buy it, and this is a first purchase, so I'm going to enter my password again to confirm the purchase, and 3, 2, 1, you're all set, and I've got all of those quotes now added in. So now if I force quit my app and come back to it, you can see that as soon as I load it up, it will have all of those quotes. And again, if I terminate the app and run it again from Xcode, you can see straight away it has all of the quotes that I've bought, which is brilliant. There's nothing like an upset user who's already paid for the content and isn't getting access to it. Alright, now there's just one last thing that's a little bit niggling, which is right at the bottom here, we've still got that cell that says Get More Quotes. Even though we've already gotten all the quotes, we actually don't have any more quotes to give them. So let's see how we can fix that. Now, we have this function called isPurchased, so we can check to see whether if they've already purchased the premium quotes. And if they have purchased the premium quotes, then we're going to say if isPurchased is true, then we're only going to return the number of cells that quote to show has, and that will contain all 12 quotes. However, if they have not yet purchased the premium quotes, then we're going to return one extra cell, and that of course includes the last cell, which has that Get More Quotes button. And now if we run our app, then you can see that we only have 12 quotes and 12 cells when we have purchased our in-app purchase. And our app has a much less confusing user experience. Now, in the next lesson, I want to talk about the last thing that's important to in-app purchases, which is restoring users' previous purchases. So for all of that and more, I'll see you on the next lesson. Alright, so we've achieved a lot already with not many lines of code. We've implemented our in-app purchase, and we've also given the user access to their purchases for now and forever in the future. Now, there's just one problem. What happens if, say, the user gets a new phone or the user updates to the latest iOS version? Then, as you know, some of the apps gets deleted permanently. And that means that our user defaults for the app are also wiped clean. So how do they get access to their purchased product? Well, that is where restoring in-app purchases comes in. And Apple, when they review your app with an in-app purchase, are very, very militant about the restore purchase button. I've had long email chains with Apple employees just trying to show them where they can find my restore button. So make sure that it's somewhere prominent, or make sure you show them where it is in your app, or tell them where it is in your app when you send it to them for review, because you can end up with long delays. I think it was something like 2 or 3 weeks before the app got approved because it had a slightly hidden restore button. But essentially what Apple wants to do is to ensure that their users get the best experience and they don't get tricked into making an in-app purchase but then not being able to access that purchase when they update their iOS or get a new phone. So for that, we've already included an IB action right at the top of the navigation bar that says restore. So that's pretty clear, and you don't have to make it this clear because obviously it's a little bit too in your face, and you can actually hide it inside a menu or something, and just make sure that you tell the Apple employee when you are uploading it for publishing where that restore button is. Now, when the user presses the restore button, we want to trigger a process of checking their current user ID and checking it against the database on Apple servers to see whether if they've previously purchased this in-app purchase before. And if they have, then we're going to give them access to the product straight away. So the code that enables us to do this is, again, using that SK Payment Queue default object, and we're going to tap into restore completed transactions, which asks the payment queue to restore previously completed purchases. And this hits up Apple servers, checks the user's Apple ID against all of the app purchases they've made before, and if the product with this ID has already been purchased, then it will come back and trigger this payment delegate method, and it will tell us that has happened. So we can catch that using another else if, saying if transaction state is equal to .restored, which is the message that we get sent back when this is successful after checking against Apple servers. And then this is where we restore their purchase. And in our code, that just means trigger show premium quotes. And then print transaction restored, then terminate the transaction just as we did before. So SK Payment Queue .default .finish transaction, and the transaction we want to end is the one that is currently being reported back. So let's hit run and check that out. Okay, so you can see that currently, because the app was previously installed, you can see that I'm not being told to buy more quotes, and I've got access to all 12 quotes. But let's say if I delete this app, so I'm going to long hold on it, and I'm going to delete it. And now, if I run this app again onto my phone, then I shouldn't have a copy of the user defaults. And you can see that it's gone back to the previous state before I made that purchase. So now let's tap on this restore button to trigger our IB action and start restoring. And you can see I've already got printed transaction restored, and I've now got access to all 12 quotes. Now, currently, the only place where we're setting the user defaults to true for our product being purchased is inside this part when a successful transaction, a successful payment is made. But if you think about it, let's say the user buys a new iPhone and downloads this app again. Now, that user default is going to be wiped clean. So even if they restore their purchase, if we don't set this user default as well, then the next time they open up the app, once it's gone into the background, then they'll still have the same problem. So instead of having our user defaults up here inside the block of code when the user makes a successful transaction, we're going to cut it and we're going to paste it into this function, show premium quotes. And we're going to put it right at the top, and especially before we reload the data. Because when we reload the data, we need to make sure this has already been set to true, so that when we check how many cells we need to show, this has to be true in order for us to return the right number of cells without that last buy button. There's just one last user experience sort of tiny thing that we could do, is we should probably remove the restore button once it has been restored. So in order to do that, if the restore was successful, then in addition to all of this, we're also going to tap into the navigation item, and namely the one that we want is the right bar button item. And we're going to set the right bar button item, which currently has that button, which is the restore button. We're going to set it to nil, to remove it basically, to have no right bar button items. And we'll set animated to true. So now when I delete this app and I run it again and I hit the restore button, once it's been successfully restored, that confusing button goes away. So I hope this has been fun and you've learned how to implement in-app purchases in your apps and start generating more revenue for all of the apps that you create. And we've gone through the process of how to restore transactions, how to process transactions, how to set up in-app purchases, how to process in-app purchases, and how to restore transactions. So that's all from me in this module, and I hope to see you on the next lesson.
Subscribe now and press the bell icon. Never miss an update.
Alright guys, in this module we're going to be talking about advanced Swift properties. Now previously we've already seen what properties are and we've been using it throughout the course. Now when we looked at objects and classes, we learned that properties can be a constant or it can be a variable, and they allow us to store data relating to a particular object or a class. So for example, in this case, we've got a car object that has a color property that's equal to red and a type property that's equal to coupe. It doesn't matter if it's a constant or a variable, they're both properties. Now, more specifically, these types of properties can be described as stored properties because essentially they're just a container that can take a value and you can store it inside the container. And when you later need to use this stored property, you can take out the value and use it. Now in this lesson and others in the module, we're going to be talking about a different type of property, and these are called computed properties. And what these allow us to do is to create properties whose values can be calculated on the go by using the code that we write. And that will make it really similar to an Excel spreadsheet. So, for example, if we were trying to work out the area of a particular wall, say in our bathroom, and we actually recorded it wrong, instead of being 1.5 by 2.6 meters, actually that wall height was 2.3 meters. Well, then in that case, the area can auto-update and be calculated or computed based off the change in the height. And this is exactly what we're going to do with our code. And the code that we're going to write is going to be super useful because we're going to use it to solve the biggest issue that mankind has, which is, of course, how many pizzas should you buy so that you can feed everybody who's in your house? This has mystified mankind for a long time, and finally we're going to be able to use computed properties to solve this problem. So once you're ready, head over to the next lesson and we'll get started right away. Now, the first step is we're going to get started with a brand new blank iOS Swift playground. And you can call it whatever it is you want. I'm just going to call it computed properties. And I'm going to save it on my desktop. So first things first, if you've got manual run for your playground enabled, we're going to change it to automatically run because we're going to need it to refresh our values on an ongoing basis. Next, I'm going to delete this first variable and I now have a blank slate to work with. Now, the first thing I'm going to do is I'm going to create a constant called pizza in inches. And this is going to be of data type integer, because usually you don't get 15.5 inch pizzas, and I'm going to set it to equal just a medium-sized pizza, a 10-inch pizza. Now, I've been doing a lot of research on the Domino's website in order to figure out how many slices of pizza you get in pizzas of different sizes. So what they say is apparently if you take the size of the pizza in inches, say in this case it's 10-inch pizza, and you subtract 4 from 10, you end up with the number of slices of pizza. So the next thing I want to do is I want to create a variable called number of slices. And this, again, is going to be an integer that is equal to the number of slices we have in our pizza. So in this case, if we had a 10-inch pizza, 10 minus 4 is 6. So we have 6 slices of pizza to go around. Now, at the moment, all my properties are manually set, and these are both what's called stored properties. They just store a value, and we can then access the value. So for example, if I wanted to print number of slices, we can simply say print number of slices, and you can see that we've got the result printed down here in the debug area. Now, if you find that your Playgrounds does what mine is doing, where it says running computed properties for eternity, and it doesn't actually have anything in the right hand pane or down here in the debug, and it's just getting stuck and it's being really slow, a very easy fix for this is to simply go and open up the right hand pane over here and go into the file inspector here, this one, and change the Playground settings from iOS to macOS. Now at this point it'll tell you that UIKit doesn't exist for macOS because it's an iOS specific module. So you can simply change it to Foundation, and the Foundation module contains all of Swift, so that allows us to test out our code and run our Playgrounds without having it hanging forever. This is a bug that Apple has created, and they've been trying to fix it for months and months, but I'm still not seeing a lot of improvements. So that's just a neat trick if this happens to you. So let's get back on track. So at the moment, our number of slices is a stored property, and in order to change it, we have to tap into it manually and update it. Say now it's 4 slices, right? But that's not really what we want. We actually want it to be computed or calculated depending on the pizza in inches. So for example, if I bought a pizza that is a 14-inch, right, say a large pizza instead, I want this to automatically update to 10 slices. So how can I do that? Well, we can use computed properties to compute the value of this property on the go as its dependents change. So instead of having an equal sign and a value, I'm going to delete that, and I'm going to open a set of curly braces. And this allows me to put in some code inside that block to calculate what the value of number of slices should be. So in this case, number of slices should equal pizza in inches minus 4. And in order to give the value back to this property, we have to use a return. So you can see that this is almost like a function that calculates what the value of this property should be. Now, there's a couple of things to note when you're using computed properties. Firstly is that it has to be a var, it has to be a variable, because if you have a constant, then its value can't change, and it doesn't make sense for it to be a computed property. Now, the second rule is that you have to specify a data type explicitly in order to use computed properties. You can't let Swift infer the data type because it will get very confused when it's trying to calculate what the value should be. So to make it simpler and more explicit, we always specify the data type when we're using computed properties. So now you can see that as I change this value, let's say we bought a small pizza instead, then the value of number of slices updates dynamically without me having to go into it and manually change it. So you can see if we had a lot of properties that were dependent on other properties, say things such as an area that's dependent on the width and the height, or something like volume, then we can use computed properties to save ourselves a lot of work and potentially a lot of errors as well. Now, what we've got here is actually more specifically a getter, because inside this block of code, we're specifying the computation that should happen when you try to get the value of this property. And we're doing that when we're trying to print it, or if we're trying to work with it. Say, for example, if I wanted to create a new constant called a, and it was equal to the number of slices times 2. At this point, we're trying to get the value of number of slices. So at this point, we will tap into our getter, and also at this point, when we're trying to print it, we will also tap into the getter. So the getter is the code here that will run in order to get us the value of this property. Now, some of you might have realized that even if we didn't have computed properties, we could just as easily have created a function, say called calc pizza slices, and this function does something very simple where it simply says the number of slices is equal to pizza in inches minus 4. And this is now just a bog standard stored property, and the number of slices can now be worked out by calling calc pizza slices. So this also works, of course, and that's what we've been doing so far because we haven't yet learned about computed properties. But you can see, firstly, it introduces a lot more lines of code, and so that means potential sources of error and places where things can go wrong. So whenever you find yourself creating methods that don't have an input and don't have an output, and all it does is execute a block of code, then consider whether if you can instead use a computed property to do exactly the same thing without the need for creating an extra method. Now, what we've got here in between these two curly braces is a block of code that programmers will call a getter, because what it does is it will execute the code in order to get the value of this property. So this is in fact a short version of the getter, and if you wanted to write it out completely, then you would write it like this. So inside a set of curly braces that has the get keyword in front of it, we specify the code that will run when another piece of code is trying to get the value of number of slices. Now, in the last lesson, we created what's called a getter, so a block of code that will execute whenever we try to get the value of a property. Now, computed properties also allow you to specify some code that should be executed when its value is set. And this is called a setter. So, for example, in addition to this block for get, underneath it, I can also write a block that's called set. And the block of code inside the set will be executed whenever this property gets a new value set to it. So, for example, inside here, I can simply write a print statement that says number of slices now has a new value, which is, and there's a special variable that we can tap into, which is called new value. And this new value is equal to essentially exactly that. It's the new value that's been given to number of slices. So, for example, if we delete all of this and we simply write number of slices is equal to 12, then you can see right away down here we get printed number of slices now has a new value, which is 12. And that new value comes from this line here. So having this block of code, which we call the setter, allows us to tap into the exact moment when our property is set with a new value. And it allows us to use that new value in computations or various bits of code and to execute it at the exact time when this property's value gets updated. Now, if you don't have a setter specified for your computed property, say if we delete that block, you can see that you get an error here when I try to set number of slices equal to 12. And it says that cannot assign to value. Number of slices is a get only property. So because I only have a block specified for get, then this computed property is now effectively read-only. So I cannot set it to have a new value, but I can use it whenever I need to. So this still works. Now let's get back to our pizza calculator. Essentially what we want is to be able to specify the pizza in inches that we want to buy because of some special offer or because some pizzas only come in certain sizes, whatever it may be. And we also want to specify the number of people to feed. So let's say that this was, I don't know, we had 6 people coming over, right? And we'll also specify another constant, which is called slices per person. So according to Domino's, the world experts in pizza, the ideal slices per person is apparently 3. Now, I like to be a little bit more generous than that, especially for myself. So let's say that everybody gets 5 slices of pizza. So now I want to be able to set all of these variables and then calculate how many pizzas I should buy. So I'm going to create another computed property called number of pizza. And this, of course, is going to be an integer because you can't buy half a pizza, at least not where I'm from. And we're going to create a getter that is going to compute how many pizzas we need to buy whenever we try to access this property, number of pizzas. And this is pretty easy because we can say that number of people fed per pizza is equal to the number of slices divided by the slices per person. And then, in order to figure out the number of pizza we need to buy, we can simply return the number of people to feed divided by number of people fed per pizza. And now our computed property is a read-only property because it only has a getter. It doesn't yet have a setter, but it means that we can simply print out number of pizza for the current settings. So these are 12-inch pizzas that we're buying. We've got 6 people in the house and everybody's going to eat 5 slices of pizza. So down here we've got the result. We need to buy 6 pizzas. Simple, right? So if at a later date we decide to change some of these stats, say we're buying larger pizzas, we're buying 16-inch pizzas and we've actually got a lot more people coming, we've got 12 people in the house and everybody only wants 4 slices because I don't know why. Now in this case, when our code updates, we didn't have to call a method or update anything or, run some piece of code again. Without doing anything, when we try to access number of pizza, the getter gets called and our code dynamically works out how many pizzas we need to buy. Now, what about the opposite situation? Say we have a bunch of leftover pizza in the fridge and we want to know how many friends we can invite over to play Mario Kart. So we can use a setter in this case to work out the number of people we can feed. So instead of just having a getter, so a read-only property, we're going to add a setter as well. And we're going to say let total slices equals number of slices multiplied by new value. So remember that previously we learned that new value is simply the new value that this property is going to be set to. And this is always spelt in this way, and you can't change how it's spelt or how it's written because it's predefined in the setter. So now that we've got the total number of slices, we can change the number of people to equal the total slices divided by slices per person. So now we have to change the number of people to a var so that it can be modified. And we can print the number of people as we change the number of pizza. So let's say that we've got, 4 pizzas left at home. Now at this stage, I'm saying number of pizza equals 4. So I'm setting number of pizza. And this block of code will trigger. And we're going to calculate the number of people that we can feed with 4 pizzas that are 16 inches. And that is 12 people. So I can invite 12 people over with all of my pizzas in my fridge, which is pretty neat to know. So through using computed properties and getters and setters, we've been able to write this pizza calculator in a very simplified way. And you can see that our code updates dynamically whenever we change the values of its dependents. So, for example, if I change the number of pizza, I get a new number of people that can be fed. And this means that all I have to change are these 3 values up here, and everything else I don't need to touch ever again. And that minimizes errors, makes our code more dynamic and more maintainable and easier to understand. So that is the beauty of computed properties. And so essentially all that we're doing is we've basically just implemented a spreadsheet where we change any of the dependent variables, say the pizza size, then everything else will get updated accordingly depending on this change. Now, in previous lessons, we've been looking at the getter and setters for our computed properties. And you can see that the setter code is called the exact moment that the property is set with a new value. Now, if you didn't need to compute the value of a property with a getter, but you just wanted to monitor when the value of a property gets changed, then instead of using computed properties, Swift actually has something else, which is called an observed property, where you can trigger code when a property's value is changed. So, for example, if you wanted to detect when somebody tries to set the pizza size in inches to some unrealistic number, say you try to buy a 33-inch pizzas, well, that doesn't really make any sense because I don't know anybody who sells 33-inch pizzas. If you know somebody, let me know in the comments so I can go and eat those pizzas. But in our code, we don't really want this to ever happen because the calculations that are performed are invalid because this is not a valid size. So in this case, we can actually turn this into an observed property. So for example, let's say that pizza in inches is set to 10 by default, and then we can open a set of curly braces. And inside here, we can set our property observers. So one of these observers is called will set, and another one is called did set. Now, they essentially do exactly the same thing. And what they do is they monitor when this pizza in inches property gets changed. Right before it gets changed, this block of code will trigger, will set, and right after it changes, then this block of code will execute, did set. So let's try it out. First things first, you'll notice that we're getting a warning from Xcode because our pizza in inches used to be a constant, and both computed properties and observed properties have to be variables. So we have to change that to a var. So now inside will set and did set, there are two variables that we get access to, and they're slightly different. So inside will set, we have something called new value. But inside did set, we have something called old value. And so in this case, let's say if I were to set the size pizza in inches to, 8. Now at this point, as soon as I set it to a new value, the will set and did set both get executed, with the will set executing first and then did set coming straight afterwards. And inside will set, we're printing the new value. So that's the new value that the property is being set to. And in the did set, we can get access to this thing called old value, which is the value that this property used to be. Now, if inside will set you wanted to access the old value, then you would simply use the current variable's name. So you can say pizza in inches. And inside did set, if you wanted to get access to the new value, again, you would access pizza in inches. And that is because at the point when will set is called, remember this hasn't been changed yet. It's still equal to 10. So when you print its value, it will be equal to 10. But when you print the new value that it's going to be set to, then that, of course, will be 8. And inside did set, it's exactly the opposite situation. Because at this point, the value of pizza in inches has already been set, then the old value is equal to the previous value that it used to be, and pizza in inches is now equal to 8. So what we can do here that can be quite useful is we can check to see if the new value of pizza in inches, which remember can be accessed through the property name. So if pizza in inches is greater than or equal to, let's say 18, because our favorite pizzeria, their largest pizza is 18 inches. So anything that's larger than 18 that gets inputted here is invalid. So if that happens, then we're going to print invalid size specified pizza in inches set to the largest size, which is 18 inches. And we of course have to do that. So we can now tap into pizza in inches and we can set it to equal 18. So now if I at a later point try to set this property to something completely unrealistic, say a 33-inch pizza, then at this point we will get printed invalid size specified pizza in inches set to 18. And if you try to print pizza in inches, even though it looks like it should print 33, right, because we set it here, actually it's going to print 18. So that is an observed property, and we use it to observe when its value is changed and to perform various bits of code or logic when that happens. Now, in the next lesson, I've got a challenge for you to see if all of this makes sense. So head over there and you're going to build your own calculator using computed properties. So now that we've created a pizza calculator using computed and observed properties, I want to set you a challenge to build your own computed paint calculator. So go ahead and create a brand new playground and delete all of the code other than import foundation. Now we're going to create a variable called width, and this is going to be a float. And we're going to start it off with, say, 1.5. So we have a wall that has a width of 1.5 meters. Now the next thing we're going to create is a variable called height, and it again is going to be a float, and this is going to be 2.3 meters. So we've got a wall that is 1.5 by 2.3. And now I want to be able to work out the number of buckets of paint that I need in order to cover this wall with paint. So let's say that a single bucket of paint only covers 1.5 meters squared area. Then can you use what we've learned about computed properties, create a computed property called buckets of paint, such that whenever I try to print buckets of paint, then it should be able to show me the updated number of buckets I need to buy in order to cover my wall with this width and height. So have a think about how you would achieve that, and pause the video and complete the challenge. Now let's leave this print statement down here so that once it works, then all of the errors will go away. But let's go ahead and define our computed property. Now, buckets of paint is going to be an integer because usually they only sell buckets of paint in entire buckets, right? So inside here, we're going to set the getter for our property, and we're going to first work out the area that we need to cover. And area is, of course, worked out by width being multiplied by height. And now we have our area. Now, previously we said that per bucket of paint, it covers 1.5 meters squared of area. So area covered per bucket to equal a float that is 1.5 meters squared. Now next we can calculate the number of buckets we need by saying let number of buckets to equal the total area we need to cover divided by area covered per bucket. And now we can return this number of buckets as the value of our property buckets of paint. Now there's just one problem, because the number of buckets is an integer, whereas this has been working with floats. So we need to convert this into an integer, and we can do that by just directly casting it. Now there's one other problem that you might have spotted. You can see that from our calculations, the number of buckets required is 2.3. But when we turn it into an integer, our float gets rounded down into 2. Now, that doesn't really work, because if we need 2.3 buckets to cover our wall with paint, 2 buckets will leave some parts uncovered. So instead of rounding down, in this case, we actually always need to round up. So even if we only need 2.3 buckets, we actually have to go and buy 3 buckets. So what we can do is we can use ceiling. And what ceiling does is it will round up a number, either a double or a float. So in this case, between ceil F, we're going to put our number of buckets, which at the moment is 2.3, and that gets rounded up into 3, and that is what we're going to be turning into an integer, and that is what we're going to be returning as the value of our buckets of paint property. So now when we say print buckets of paint, we get 3 buckets printed down here, and if we decide to paint a different wall, say something that is, 3.4 meters by 2.1, then automatically this will get updated and we now need to buy 5 buckets of paint instead. Now, part 2 of this challenge is, what if we had a couple of buckets lying around in the house? And I want to know what is the total area that this paint can cover. So can you pause the video and write the setter for our buckets of paint property such that when I set bucket of paint to say, I've got 4 buckets lying around, I want to be able to print down here, this amount of paint can cover an area of X square meters, where X is worked out depending on how many buckets of paint we've got. So pause the video now and complete this part of the challenge. Okay, so as we mentioned before, at the moment, our buckets of paint is a read-only property, or what they call a get-only property, because we haven't specified a setter. So let's add that in there. Now, when this property gets set, as it is down here on line 21, we want to be able to work out the area that these number of buckets of paint could cover. So let's say let area can cover is equal to the new value that this property is being set to, multiplied by 1.5, which remember is the area that can be covered per bucket of paint. So now we've got another problem. So when we click on this area, it tells us that you cannot multiply an integer with a double. So in order to fix this, we're going to have to change this new value, which at the moment, remember, is an integer, to a double. So we can cast it straight into a double, and now we're comparing like with like, and we're multiplying double with a double. So we now have an area that's worked out from the new value that this property gets set to, and we can now use a print statement to output some text. This amount of paint can cover an area can cover. So now, when I change this value, number of buckets we have lying around, then you can see automatically our setter gets triggered and it tells us the amount or the area that can be covered using the buckets that we have lying around. Now, you can see, even though at the moment we're using print statements and it's kind of a contrived example, but it's not difficult to see how you can output this into a UI element, say a label or the title of a button, and you can use the getter to dynamically work out the value of a property. And this is really, really useful in cutting down on unnecessary functions and methods that you're writing all over the place. And it also makes your code a lot easier to maintain, because in most cases you don't really want to have to go into the getter and setter, and all you need to do is to set or change certain properties in a couple of places, and the rest will get updated automatically. Alright guys, we're on to another module of Advanced Swift. And in this module, we're going to be building a calculator app. So we're going to be using the interface that we designed in our auto layout module a couple of lessons back, and we're going to be giving it some functionality this time. And through the process of building this calculator app, we're going to learn about a number of advanced Swift concepts. So this is what the finished product will look like. So we could multiply numbers, for example, like this, or we could make it into a percentage or divide it by 6, whatever it is that we need it to do. So through the process of building this app, we're going to learn about Swift structures, otherwise known as structs, And we're also going to look at when you would use structs versus classes. Then we're going to look at things such as internal, external parameters and what that underscore actually means in the code that you see, as well as talking about access levels such as private, public, open, internal, etc. And finally, we're also going to introduce Swift tuples. So as you can see, it's a jam-packed module full of more advanced parts of Swift, and this section of advanced Swift concepts is more about making your code more manageable and easier to maintain. So we're not really learning new things in order to be able to do more stuff with our apps, but it's more about making our code base more maintainable so that if we collaborate or if it gets more and more complex, then it's still manageable because of all of these neat tools and concepts that we're going to learn. So as I always say, make sure that you don't skip any of the lectures and that you've already done all of the previous modules before you arrive here. I know that there's a lot of things that would be neat to just look up and quickly learn, but unfortunately a lot of programming builds on top of other concepts, and it's not so easy to just dip in and out of some of these advanced topics, and it's very easy to quickly get stuck. But if you've completed all the modules up till now and everything makes sense, then feel free to continue, and we're going to deep dive into all of these advanced Swift topics. Alright, so you should have downloaded and unzipped or git cloned the calendar project to your desktop, and we're going to go ahead and open it up inside Xcode. So first things first, I just want to show you around the main.storyboard that I've created here. Now you'll notice that the design looks a little bit different from the one that we ended up with at the end of the auto layout module. And that's because I added a few more modifications just to make it look a little bit more realistic and more similar to the version of Calculator that we've got on the Mac. So a couple of changes that I've made are, firstly, I've reduced the space between all of the items inside our stack view. So when you click on any of these stack views, you can see that the spacing is only 1 point between all of these gaps. I've also made the background view black so that these gaps show up as lines outlining each button for us. And I've also split up the bottom part by placing these two items in their own stack view and then stacking that along with the 0 into another vertical stack. So now it distributes equally. And I've also changed the font to a thin font at 50 points, and some of these other ones a little bit bigger as well, System 30, for example. So now that we've taken a look at the design part, it's useful to take a look at what these parts are all linked to. So I've already created IB outlets and IB actions. So the only outlet that we've got currently is the one that's linked to the display label, which is this one up here. And this display label is going to be the one that's going to show up our results of our calculations, as well as the numbers that the user types into the keypad. Now, there's two IB actions. One of these IB actions are linked to all of the calculation buttons, and it's called calc button pressed. And the other one is linked up to all of the number or the digit related buttons, and it's called num button pressed. And we're going to be using these two methods in order to implement the functionality of our calculator. But it's important that you realize which buttons are linked to which methods. So just familiarize yourself with that. So once you're ready, we can crack on and start building our calculator. So first things first, we want the user to be able to tap on any of these numbers and have it show up here in the display label. So as I mentioned before, the num button pressed is the IB action that's responsible to a tap on any of these buttons. So this is what should happen when a number is entered into the keypad. And this is also where we're going to add our code. So previously in the Xylophone app, if you remember, we also had multiple buttons linked up to the same IB action. And in that case, what we did was we gave each of these buttons a different tag value. And by looking at what the tag value of the sender was, we figured out which button was tapped on. Now that's a little bit manual, and it involves you having to edit the tags manually one by one, which is a bit of a pain. So as I always say, programmers are lazy. So what can we do that makes it a little bit easier and less manual? So I want to know the identity of the button that was tapped. And I know that that information is stored inside this object called sender. Now, this sender has a whole bunch of different properties, such as what is the background color? Well, in this case, it's blue. Or what is the size of the button, for example. Now, you can also see that these different buttons already have a title, right? They already have some text in them. And if I could just figure out what the text was of the button that triggered the IB action, then that will be really helpful for me to implement my calculator functionality. So if we tap into the sender object and we use the dot to find all of its properties, even if you just start searching randomly for what you think could be the name of the property, Xcode is very helpful in pulling up all of the related properties and methods. So in my case, I kind of want to know what the title of that button is. So I might say sender.title. And you can see that it's giving me a whole bunch of suggestions. Do I want the title label? Do I want the title for UI control state? And you can see which ones are variables, which ones are methods. Or do I want the title color, title rect? Now, you can see that there's two contenders in this case. One is the title label, and this, as it describes down here, is a view that displays the value of the current title property for a button. So we could go through it this way. But there's actually an even better one if you scroll through this list. There's this one called current title, and the description for this one is the current title that's displayed on the button. Well, that's perfect, right? That's exactly what we need in order to figure out which button was pressed. Now, there's a lot of documentation that you can look up online, and you'll find all the help in the world on Stack Overflow and Google and blog posts, but there's nothing that is quite as quick and easy as just searching for what you want and just coming up with a name that you think is likely and then scrolling through that list for a good contender, just as we did here. So in my case, I want to set the display label's text to the current title of the button. So that means if the user taps 1, I want this to read 1. Now I can do that by tapping into my IB outlet, display label, and then going into its text property and setting that equal to sender.currentTitle. Now there's just one problem. If you hold down Alt and click on current title, you can see that this is a string question mark. So this is an optional string. And if we read through the discussion, the last sentence says that the value may be nil. Well, what if we had a button that didn't actually have a title? Well, in that case, sender.currentTitle will be nil. And this line of code will crash your app. Now, another neat thing that you can see, now that you know all about computed properties, is that you can see that this current title property is a get-only property. So it's read-only. So that means we can't, for example, say sender.current title equals something, something. That doesn't work because, as it suggests, current title is the current title that's in the button, and it doesn't let you to give it a new value by setting it. And this is achieved through making current title a computed property that only has a get defined and no set. So here's a little bit of a practical example of what we've been learning about in the last module. Now, in our case, I don't really want this line to crash. So what I want to do is I'm going to use a iflet, and I'm going to call it a num value. So the number value. And I'm going to set that to equal the sender.currentTitle. And if this sender.currentTitle happens to be not nil, then inside the iflet is where we're going to set the display label.text to equal to that new unwrapped num value. And you can see now num value is just a bog standard regular string as opposed to an optional string. So we can test our app and see what we get. Alright, so here's our simulator on the left here. And I'm going to tap on the 7. And you can see 7 shows up in here. Now, there's a just a bit of an issue with our app, and I'm sure you can already see it now. What if I wanted 2 digits? Well, I can't at the moment. I can only put in 1 digit because I'm setting the display label.text to equal whatever button was pressed through these 3 lines of code. So here's a challenge. Can you figure out a way of appending the numbers that the user keeps on tapping on so that inside this display label we display the entire number that they wanted to put in? So for example, if I wanted to type 150, I should be able to see 150 show up here, and to only set it back to 0 or allow a new number to be entered when I click on any of these other buttons. So this is pretty much classic calculator functionality. You don't need me to go through it any more than that. So pause the video and see if you can complete that challenge. Alright, so basically what we need to do is to append each of these num values to each other and display it in the display label until the user taps on one of these calculate buttons. So a typical case would be, say for example, I'm trying to type in 150 plus 3, right? So when I type plus, then I can clear the 150 and I can start from scratch on the 3. So in order to do that, I need to have some sort of property that keeps hold of whether if the user is done typing the number. So let's go up here and just below our IB outlet, let's create a new variable. Let's call it is finished typing number. This is a little bit wordy, but hey, we've got Xcode auto-suggesting everything, so we don't have to type everything out. So why not make it super clear? So is finished typing number is going to be a Boolean, and it's going to start off in life as being true. So when we first start up our app, then is finished typing number is going to be true. So now we can go inside our num button pressed, and we can check to see if is finished typing number is equal to true. You can either use this full syntax where you have it checking with a double equals, or you can simply just delete that and everything between the if keyword and the open curly brace is evaluated. And if it is true, then this block will be carried out, otherwise it will not. So inside here, if finished typing number is true, then that means we're just starting out and the number in the label is probably 0, or we're just starting out with a new number that we want to type. So in that case, we do want to set the display label.text to equal the num value, so the value of the button that got pressed. So when I first start out the app, the display label says 0, and is finished typing number is going to be initialized to true. So in this case, when I press one of the buttons, then that is the value that is going to go into this UI label. Now, once we've set a number into the label, so the first number is showing up in there, then we have to switch this is finished typing number to false, because we are not done typing the number, right? We've just typed in the first number, and until I press one of these buttons, the orange or the gray buttons, I want my calculator to accumulate all the numbers so that I can type a number that is more than 1 digit. For example, I want to be able to type 150. So inside here, we can define our else case. So namely, when this IB action is triggered and we are not finished typing number, we've just started typing a number, then we should be able to accumulate the number by appending them to the previous number. So in this case, then we can say display label.text is equal to the current text in the display label plus, or rather append, what is currently the num value. So what this line of code will do is it will look at the current title of the button that was pressed, and it will append that value to what is currently inside the display label here. So if I run this code now, you can see that when I type 1, Now, at this point, is finished typing number is set to false. So we're going to go inside this else bracket, and that means that the next button I press will get added or appended to the previous value of the display label, and now I have 15. And if I keep going until 0, I can keep adding numbers and it will continue to append. Now, ideally, when I press any of these buttons, for example, plus, I want to be able to start typing a new number instead of continuing to append numbers. So in order for that to happen, we have to go into our calc button pressed, because remember, this IB action is linked to all of the calculation buttons. And here, I'm going to set that variable is finished typing number to true, because if I've typed a whole bunch of numbers and then I press the add button, then I'm pretty much finished typing number, right? I want to type a new number to add to my last number. So now let's run our app with that minor update. Now you can see I can type 150, and then when I press any of these buttons, say plus, then I can add in a new number, 150 plus 250. Now, none of the equal signs or anything else works because we haven't implemented anything in there. But you can see I've already managed to use our variable is finished typing number and toggling its state to be able to make my calculator accumulate numbers when I need it to, and to forget about the numbers when I need it to as well. Alright, so in the previous lesson, we managed to get our calculators to start accumulating numbers, and we're able to use any of these buttons, say plus, minus, times, or divide, to start accumulating a different number. So we're already on our way to building our calculator. Now, in this lesson, I just want to show you there's one thing that we could do to make our code a little bit more secure and less prone to unexpected errors. And that is by making this variable, which we're using to track whether if the user is finished typing number, to a private variable. And in order to make it private, we just add the keyword private in front of the keyword var, and this variable is now private to its current scope. So what that means is that if you look inside the parent block, so this variable is only accessible between these two curly braces. And if you try to access it from anywhere else, so say, for example, if I was to go and create a new file, let's create a new Swift file and let's just call it test, because we're going to delete it very soon. And inside test, I'm going to create a new class. This class is going to be called test, and we're not going to inherit from a superclass. We'll delete that. And inside test, I'm going to create a new object of our view controller. And this is going to be equal to view controller. So in the init of this class, I'm going to tap into that brand new view controller with a lowercase v, and I'm going to try and tap into its is finished. So you can see it doesn't exist, right? It's not letting me get into that private var at all. But let's see if I delete that keyword private, and make sure that you save this view controller file while your cursor is inside the file. And now if I head over to my test.swift, then I can say view controller dot is finished typing number, and you can see it's now accessible. And again, if I just go ahead and add this private over here and hit save again, then over here you'll see that this will soon turn into black. Then if I hit Command B to force it to build, then you can see that it says is finished typing number is inaccessible due to private protection level. So what exactly is this whole private protection level anyways? So Swift has something called access levels. And a good analogy for access levels is kind of like the clearance level that people working in the government, for example, have. I don't know about you, but I watch a lot of shows that involve the CIA or the FBI or, of course, Jack Bauer. And what you hear very often is something like, you don't have clearance to view this file, right? And there are certain things that are top secret and only a select number of people can have access to it and see it. So, common things are there aliens? Did we actually land on the moon? And all of these things. But this is exactly what Swift access levels do. Now, while most programming languages have different access levels, they're slightly different from language to language. Now, Swift 4.2 and above have 5 different access levels, or 5 different tiers of clearance, if you will. And the first tier is private. This is, as the name suggests, very, very limiting in scope, and it means that when you create a property or a method inside a block of code, then that property or method is only accessible in between the curly braces of that block of code. Now, the next least restrictive is something called file private, and as it suggests, it means that your property or your method is only accessible inside the file that it was declared. So this will be your viewcontroller.swift or your test.swift, and you can't access a property or a method from a different file. Now, the third one is what's called internal. And this means that your property or methods are accessible anywhere inside your current app module. So this is also the default level of access that all properties and methods are given. And it means that if you don't add the keyword private or file private in front of your var or your let, then this is exactly what it will be. It will be internal access. And it kind of makes sense, right? By default, Xcode lets all the files in the app access all of the other properties and methods in the app. Now, the next level is public, and this means that access is granted to other modules. Now, when we were working with CocoaPods, you saw that we had a pod module and we also had our app module. And this is exactly what the public access level was created for. It's when you're creating frameworks or APIs or SDKs or libraries, basically a bunch of code which you want other modules to be able to tap into and use. Now, the final one and the least restrictive access level is called open. And this is basically like public plus, right? This is everything that you get in the public access level, namely the properties and methods and everything can be accessed by other modules, but also it allows your classes and functions to be subclassed and overridden. So it basically means that anybody can do anything they want when you label something as open. Now, for your standard app development, you will only use 1 to 3. That's the only ones that we concern ourselves with. But for developers who are working on frameworks, library, SDK development, then they will be looking into using 4 and 5. And this is because their module that they're working on, their library or their framework, is going to need to be exposed to other developers. And the only difference between these last two levels is that public doesn't allow the class or the function to be subclassed or overridden, while open basically lets you do whatever it is that you want. So if you take a look at, for example, the Klima project that we built previously, and you look inside the pods module, so everything that has a blue icon is its own module. And remember, we mentioned that the internal, or rather the default level of access everything gets is module wide, right? So that means everything that you declare within Klima will have access to everything else that is inside Klima. Now, in this case, when we're using pods, we actually have 2 modules now, right? Pods and Klima. And inside the pods, one of the ones that we've incorporated is Alamofire. And if you look inside the Alamofire code, you can see that there's public all over the place. Literally all of the methods that are needed when somebody incorporates the Alamofire pod is going to be marked with public to allow this module to tap into this file and these methods. So coming back to our code, the best practice when you're thinking about access levels is to, by default, just give everything a private keyword. Whenever you write a var or a let or a func, so any of your own properties and methods, just write a private in front of it as well. Now, in a lot of cases, it can't be private because you need to use it somewhere else, outside its current scope. But if you start off with private and you level up to file private or to internal, then that means that you are starting out by being extremely restrictive and extremely safe, and you only expose your properties and your methods a little bit more as and when necessary. So what are the advantages of marking something private anyways? Well, it means that you can't accidentally modify something that is not meant to be modified by a different class or from a different place. So inside test that I created earlier on, let's say that I try to change is typing number to true. So now, if we didn't have this variable marked as private, then this other class, test, could legitimately modify this property, is finished typing number, to true when it's initialized. And this is definitely not what you want, right? We don't want this tracker to be modified by anybody else, because nobody has any business in messing around with the state of this Boolean. It should only be accessed by this current class, and only when the typing is indeed done. So for example, when the calc button is pressed or when the calculator is initialized from scratch. So this should be something that is completely private to this class, and so we should, in fact, mark it with a private to prevent accidental modification by other classes. Now, this can happen accidentally. So say you forget that, what was the purpose of is finished typing number, or in another case, if you're working and you're collaborating with other developers, they might have used this name for something else in a different class and they accidentally modified the one in the view controller class. All of this can happen accidentally. So to prevent that and to make your code safer, try to use access levels by starting out with private for all of your vars and lets and methods, and leveling it up only when it's necessary. Alright, so let's go ahead and delete that test file because we won't need it from here onwards. And I've got a challenge for you just so that you can play around with the code so that you can better understand these ideas that we've talked about in this lesson on Swift access levels. So this is a Mac command line tool that I've created, and it's got simply two files. One is called a file, and inside a file there is a class, and there is also another class in the same file. You can see what I'm getting at. Now, there's also another file which has a class called another class in another file. And inside a file, I've created a private var, file private var, and a normal var, which, remember, is going to default to internal. Now, just for comparison, I've also created a local variable, because remember, when we're adding access levels, we're only able to add it to our class properties, which are in fact global variables. They're not the same as local variables. So I want you to go through these steps 1 through to 10 and try to complete all of the instructions. Now, in order to do this, you're going to need to initialize some objects, you're going to need to call some methods, but essentially, through completing these 10 steps, I want you to be able to see for yourself just what these access levels do. And the ones that we're going to be exploring are the ones that you're actually going to use as an app developer. So from private, file private, internal, and local. And once you've completed this exercise, you should have dissected the differences between all of these and understand exactly how they work and what their scopes are. So let's go through step 1 together, just so I can show you how to do this. So step 1, the instruction is try to print a local variable here. So you can see I've already created a local variable as a var inside method A, inside a class. So in order to print it here, all I have to do is say print. Now in my print statement that's going to get sent to the bottom of my debug console, I want to know where it came from. So in addition to simply printing my a local variable, I also want to say a local variable printed from method A in a class. So now here's my print statement, and I have to make it work now. I have to make it actually run. So if you remember from previous lessons when we dug into intermediate Swift, we can use the Mac command line tool by calling commands inside this main.swift. So in order for this method A to be carried out, I have to initialize a new object from the class A class and then call the method A on that object. So I can do that by saying let a class equals a class, and we'll initialize a new object from that. And then I'm going to tap into that lowercase a class object that I just created, and I'm going to call the method A on it. So now what should happen is once I run this command line tool, it should go in and try to create a new object from this class, and then it will run all the code inside method A, which should hopefully print a local variable to the debug console. So let's give it a go. Alright, great. So it says local variable printed from method A in a class. Program ended with exit code. So that's the end of our execution. And that is exactly what we wanted to happen. So step 1 succeeds. So next to it, we'll mark that it is possible to print a local variable within method A within a class. And now I'm going to go ahead and either delete or just comment it out so that you take it out of the functioning code, because if we get loads of these print statements, as you can see, we've got steps 1 through 10. It'll get very confusing in the debug console. Now, this is completely up to you, whichever way you find easier, but I find through testing that students get a bit confused when there's like 10 print statements. So just go ahead and comment this out if that helps you. Now, in the next lesson, there is a quiz where we'll test to see whether if you've actually managed to make all of these work, because some of these steps are indeed possible, and some of the other ones, because of the restrictions in access levels, are not possible. So the idea here is that before you start executing the code and running it to prove to yourself whether if it's possible or not, I want you to go through this step by step and try to predict whether if they should be possible or not, because as always, I think the best way to learn programming especially is to predict what should happen and then run the code and see what actually happens, and that difference between your prediction and the actual reality, narrowing that gap and trying to make it so that there is no difference between your prediction and reality is how you really level up as a programmer. So step 1 of completing this challenge is go through these steps 1 through to 10 and see what they're trying to ask you to do, and then using your knowledge of Swift access levels, try to predict whether if they are possible or not in the locations that they have been specified in. And then the next step is to go through steps 1 through to 10 and try to carry out the instructions to print whatever it is that you need to print at the location where you're asked to print it. And then you might need to initialize objects or call methods in order to make it show up in the debug console. So as we're in the advanced Swift section, I'm not going to give away any more solutions, and it's time for you to mess around with the code and really learn through doing. So pause the video now and download this file from the course resources list and go ahead and try to complete it. Once you're done, head over to the next lesson and complete the quiz so that you can check to see if you've got all the answers right. Alright, so have fun. Go ahead and do that now. Alright, so we're going to continue building our calculator, but firstly, make sure that you've deleted that test.swift file if you were following along with me and you created it as well. We don't need it, and we definitely don't want it modifying our isFinishedTypingNumber variable. So currently our app works, namely that it can accumulate numbers, but it doesn't actually do anything, right? When I say something like, 12 plus 3 equals, nothing happens. It doesn't do any calculations yet because we haven't told it to. So let's go ahead and add in that logic and that functionality to make our calculator work. So if I pull up the calculator that's on my Mac, you can see that we've got 3 buttons up here, and the first button simply clears the board. It turns everything to 0. The second button will turn whatever it is that I've got in the display to the negative version of it. So if it was 2, then it becomes -2, but if it was -2, then it becomes 2. And the third one turns everything into a percentage, so it divides it by 100. So 90 will become 0.9, etc. So these are a little bit simpler because they only need one number to be able to execute the functionality. Whereas these four are a little bit more complicated because we need to be able to say 5, then we hold that number in memory and we press one of these buttons, 5 plus. Then now we've got somewhere which has got 5 stored, we've got the operation plus stored, and we now have to add another number, 2, and then we press the equal sign and it does all of that calculation. So these 4 are a little bit more complicated than these 3. So let's first tackle these 3. So the place that we want to do this is inside our calc button pressed IB action. Because what we want to happen is to say, for example, if I typed 10, and then I pressed the percentage sign, then this IB action will get triggered, and I want to be able to turn that 10 into 0.1, so divide it by 100. So first things first, I need to get the value that's inside my label here as a number, as a double ideally, because we'll be working with decimal places later on as well. So let's say let number equal to display label dot text. So now I'm taking whatever is currently in the display label when I pressed one of these buttons, and I'm saving it to a constant called number. Now, this number is a local variable at the moment already, so it's only accessible inside the scope of the calc button pressed, so I don't have to also add a private in front of it. However, if I was creating this in the global scope, so if you are confused about global and local, make sure you have a look back at the video on scope where we spoke about this in more detail. But essentially, we don't have to turn any local variables into private vars because it's already limited in scope and only accessible inside the block where it was declared. So now that I've got that number saved, I want to be able to turn it into a double. Because currently, if I hold down Alt and click on number, you can see it's just a string, right? Because it's set to the text that's inside the display label. So this will be currently equal to, essentially, the string 3. And I want to turn it into the double 3.0. So I can do that by just doing a simple cast. So I can say double, and then I can wrap whatever it is that I want to cast into a double inside some parentheses. So now if I check number again, you can see it's now a double. But it's not just a regular double, it's actually an optional double. And the reason for that is because if I'm turning text into number, there's a lot of cases where that's not possible. So for example, if I try to turn the string A into a double, then what is that going to be? I have no idea, and nor does the computer. So that's a case where this could fail, this casting process. So that's why when you cast a string to a double, it will always produce a optional double. Now, the opposite case, let's say we try to create a string, right? And we set that to equal string casting, something that was a number, say 12. This is going to produce a normal string, a bog standard string, because when you cast from number to string, it's always possible. All it does is add some quotation marks around it and bam, you've got a string. But the opposite fails occasionally. So now we have this optional number, which makes it very difficult to work with. So we want to either unwrap it or we have to do something with it, right? Now, one option is to simply unwrap this by putting an exclamation mark at the end of this group. So now what this says is that I'm definitely sure that there is text inside the display label. And that makes sense, right? Because even if we don't put in numbers, it's still got a 0 in there. So that's a valid unwrap. So next, we're turning it into a double, and we're saying that it's always going to work. Namely, whatever is in here is always going to be able to be turned into a double. And this is also a valid assertion, because where does the number here come from? Well, it comes from whatever I do in here. And all of this code only tries to put the num value, which is the current title of the sender, so one of the number buttons, any of these ones, into here. And they can all be turned into a number. So if you were to force unwrap this, it's also not exactly wrong, because the logic is kind of valid. Now, the only problem is if you screw up on your linkages, so your IB outlets and your IB actions. So there's many ways in which this can actually fail. Now, failing and crashing your app is not necessarily a bad thing, because it allows you to figure out what are the things that are unexpected, and for you to test your app, and also for you to address all of these unexpected scenarios. Now, what you don't want is to, say, use an if-let and just not catch this error if it does happen, because it'll skip the code instead. So let's say that if instead of linking all of the number buttons to this num button pressed, I accidentally also linked one of the text buttons to it. So let's just delete the current linkage to calc button pressed, and let's add in a new link to num button pressed instead. And now this IB action is linked to all of the numbers as well as this button. So that means that when I press this button, it's going to try and put that into the display label, and then later on it's going to try and turn that text into a double, which will fail. So let me show you what will happen. So at this stage, when I type numbers and I press any of these calc buttons, nothing happens. It's all working fine. But if I press this button and this string gets put into the display label, when I press any of these calc buttons, our app is going to crash, and it's going to show us that the line that caused us to crash is this one. And the problem is a fatal error, unexpectedly found nil while unwrapping an optional. Now, the optional here is this one, double question mark, and it's unwrapped because we assumed that it would always be possible to turn this into a double. Now, because of what I've just done just now, my little mishap, well, that's not possible anymore. Plus/minus does not become a number. So you might think, well, that means that we should never force unwrap anything because it's always bad. And instead, we should use maybe something like optional binding, right? Use an if-let. Well, I would argue that actually using an if-let is not always the best option. And sometimes you do want your code to crash, especially when you're testing it and when you're developing it. And the reason for that is because when it crashes, it alerts you and you are forced to figure out why it crashed and what caused it. Now, let's say I didn't want to force unwrap this. What are the other options that I have in my arsenal? Well, let's see. Let's try and use this optional, right? Let's try number +2, and I'm going to use Command B to build. Now, I'm going to get a build failed. And if I click on this little button here, it tells me that value of optional type double must be unwrapped to a normal double in order to use it, for example, in this calculation here. Now, there's two options that it's giving me. One is to force unwrap using the exclamation mark, which is what we did previously. And if you click on this fix, you can see that it will force unwrap this number, or you can also force unwrap over here. Now, the other option that it's giving me is to use what's called a nil coalescing operator using 2 question marks to provide a default when the optional value contains nil. So in this case, what I can do is if I can't turn this string into a double, then I can put 2 question marks and say, well, in that case, instead of giving back nil, let's just give 0. So now let's retest our app. And again, I'm going to put the +- sign into the display label. I'm going to press one of the calculation buttons, and you can see nothing happens. My app doesn't crash, and it just continues along as if nothing happened because I managed to set that number to 0. So I would argue that this is actually worse than if you actually let your app crash when it's doing something unexpected. Now, when we leave this as a forced unwrap, it can be a little bit difficult to figure out why it crashed when our string can't be converted into a double. So an alternative here is to instead use a guard. So we're saying guard let number equals double, and if this conversion process from string to double can't happen, then we're going to say else throw a fatal error. And there's two types of fatal error, where you've got the simple fatal error, and it stops your app from executing, namely crashes your app, or you can have the one where you can put in your own message. So that's what we're going to use. So if we can't convert our display label.text to a double successfully and turn this into a non-optional double, then we're going to say cannot convert display label text to a double. So now when our app crashes, we will get a far more explicit error message, and this means that 3 months down the line, when we can't actually remember what anything does in our app anymore, then if we typed this into the display label and tried to convert it into a double, then our app crashes, and also we get a fatal error, cannot convert display label text to a double, which should hint to us that, oh, this must be related to this part, right? So now that we've tested this and we've fixed it, let's make sure that we don't persist this error. So let's delete that connection to num button pressed, and instead make sure that we connect it again by holding down the control and clicking and dragging, and we're going to connect it to calc button pressed so that it will be addressed in the calc button pressed IB action. So now that we've managed to safely convert whatever text is inside our display label to a double and store it inside this constant number, then the next step is to use that number and perform the calculation that triggered this calc button pressed. So we can figure out the calculation method by tapping into the sender.currentTitle. So this will be the string that corresponds to whichever of these buttons were pressed. And remember again, current title is an optional string, so we're going to use optional binding again to say if let calc method equal to sender.currentTitle, then we're going to say if the calc method is equal to the text of the button, that is plus/minus, then in that case, we want to flip the sign of the number. So we're going to set the display label.text to equal our number that we've converted over here, and we're going to multiply it by -1. So that means that if the number that we entered was 8, then when we press this button, it should turn it into -8 by multiplying it by -1. Now, the maths work out, but we have an error here that says cannot assign value of type double to type string. So this right-hand side of the equation is going to be a double because it's a double multiplied by a double. And the left-hand side, however, is expecting a string. Because it's the text for the display label. So in this case, we're going to have to cast this double into a string. And as we mentioned before, this never fails. You can always turn a number into a string. So now if we run our app and test it, you can see that if I type a number, say 89, and I press this button, then it becomes -89. And if I press it again, it becomes +89 again. So now that we've got this working, here's a challenge for you. I want you to make these other two buttons work. Remember that whenever I press the AC button, it should revert the display back to 0. And whenever I press the percentage button, it should take the current value and divide it by 100. So once you're ready, pause the video and try to complete that challenge. Okay, so now that we've really got one of these methods established, it's not so hard to write out the code for the other ones. So let's add an else if and say if the calc method is instead equal to AC, then that means that we actually want our display label.text to simply just read 0. So we're going to add a string that is 0, and that already sorts out that particular case. Now finally, if we have another calc method that was equal to the percentage sign, then in this case, we simply want to divide the number by 100. Or alternatively, if you wish, you can also multiply it by 0.01. It does the same thing. So in this case, we're going to set the display label dot text to equal number times 0.01, and we of course have to turn this double into a string. So now let's run our app, and let's say 89 as a percentage is 0.89, and then if we turn it into a negative and we press the AC button to clear our screen, and you can see everything is working. So now we've sorted out these top 3 buttons. Now there's just one slight problem. You see we've got this decimal point here, and if I wanted to write 2.3, then this becomes a double, that is 2.3. But I can also press this button again, and I've got 2.3.6, which is not a mathematical number. I don't even know what that is. So we have to ensure that this doesn't happen, and that is what we're going to address in the next lesson.